And we're live.
Yes.
Hi there. Good morning, good afternoon, good evening, wherever it is that you happen to be in the world. Thank you for taking part of your day out to join us. This is introduction even to programming using Python. Today we're very pleased, very thrilled actually, to be joined by Susan Ibach. I am Christopher Harrison. What we're going to do is introduce ourselves. We'll go ahead and talk about what we're going to talk about, and then roll on into Module 1, where we'll start digging in a little bit into the concept of becoming a developer and using Python for that. So Susan, if you want to go ahead and introduce yourself.
Sure, yeah. My name is Susan Ibach, and I am a technical evangelist at Microsoft Canada. And I've been coding for more years than I care to admit. As I like to put it, it's remarkable of a number, given the fact that I'm 29, the fact that I have over 40 years of coding experience.
That's pretty impressive.
Right.
Yeah, that's. I'm no math major, but that doesn't seem to work out quite right to me.
Maybe I'm mixing decimal and hexadecimal numbers.
Okay, there we go.
But anyway, so I'm from Microsoft Canada. I've been coding for years, and I spent a lot of time showing people how to code and teaching people how to code. So really, in this course, what we're going to be doing is really taking people through the basics so they can get comfortable with the world of programming.
Absolutely, absolutely. And as for me, I am Christopher Harrison. I'm a longtime MCT, and recently took a job here, actually just over 3 months ago. Which
wow.
It's flown by. It's pretty crazy. It seems like I just went through orientation like about 2 weeks ago. But in any event, they hired me in to do content development. I've done a good handful of MVAs. I've been programming since my father brought home a VIC-20 and Commodore 64.
Oh, see, now I had a TRS-80.
You had a TRS-80.
64K expanded memory.
Whoa!
Yeah.
Wow.
And I ran out of memory on my program that basically said you are entering a hallway. Will you turn right or left?
Yep.
You know, you turn right. Do you see the monster? You turn left, you found the treasure. And I actually ran out of memory with that program.
That's crazy. There was a day I remember punching in one little basic program where the shortcut for print was question mark, which you still see in certain places. And you had to use question mark because otherwise, again, you would run out of memory.
Yep.
So yeah, pretty crazy. But with that level of experience that we have between the two of us, this is why we're so excited to try and bring more people into the world of programming. I would also mention, just kind of as a real quick aside, and you'll notice it down at the bottom periodically, is that Susan's Twitter handle is Hockey Geek Girl, and my Twitter handle is Geek Trainer. You can actually see that right
cool.
down
Here we
there.
go. Yeah,
right down there. Yep. So there may or may not be spaghetti.
Can I do pinch and zoom? It's not a touch. It's not connected by Connect.
Quite,
right.
Yeah.
All right.
Yeah. In any event. So, but yeah. So what do you say we kind of roll on into it? I think we've sort of introduced ourselves and our personality a fair amount there. So let's go ahead and talk about what we're going to talk about. So if we, take a look at our course topics here. Module 1, getting started. So one of the big things, and we'll talk about this in Module 1, is the experience level that we're going for is none, no experience.
Yep.
And so we want to talk about kind of why you should get into programming, why Python, etc. And then we're going to start off with the basics in Module 2 of displaying and manipulating text, which is probably the biggest thing you're going to be doing on a day-to-day basis.
It comes up all the time. And the other thing I really want to show is as we do each one of these modules, you'll be able to do something you couldn't do before. And we want you to have fun as we're going. I mentioned that first program I wrote was a sort of choose your own adventure, where you're going down a hallway, do you turn right or left? I enjoyed coding because I was having fun with it. So we really do want to have some fun along the way, but have you literally feel that at the end of every module you go, okay, wait, I can do something more with my code than I could do before. So even if you're starting from complete scratch, at the end of each module you're going to go, wow, okay, I couldn't do that before, and you'll see yourself progressing as we go along.
Exactly. Yeah, take that next step, take that next step, take that next step. And so speaking of taking that next step. The next step after displaying text is starting to work and manipulate string values and variables. So we'll introduce how you can actually store a string and also how you can manipulate it, work it, tweak it, and make it do kind of what you want it to do.
Right, and then we'll jump into numbers because a lot of the things we need to do with code when we're trying to solve problems and things do require some number crunching. So we'll get into numbers after that.
Yep. And then from there, since we've done numbers, dates is sort of the next logical one. So we'll take a look at how to get in and play around with and deal with dates and deal with how to enter dates.
Oh, yeah. Well, let's worry about that when we get there, okay?
All right. We'll worry about that later.
You'll learn why all programmers have a love-hate relationship with dates. Decisions with code. That little choose-your-own-adventure program I wrote all those years ago. You are in a hallway. Do you turn right or left? If they choose right, then have them go battle a monster. If they choose left, then show them the incredible treasure they found. That's decision-making with your code. So we're going to cover a module giving you an understanding of how you can branch off and follow different paths in your code based on decisions you need to make.
You realize at some point here today I'm going to wind up downloading Zork. And,
we may need to do that.
Go north, go north. In any event, the last module that we're going to cover today, and this is a very big point here, is that this is going to be a 2-day event. So we've got 14 modules, 7 a day across 2 days. So you've got us for 2 days of Python goodness here. The last module that we're going to finish out with is what we're calling complex decisions with code, which is really just taking your if statements kind of to the next level, adding in, well, if they did this, okay, well, maybe I want to do something, but if they did something else, then maybe I want to do something different. So we can go in and see how to do that with our complex decisions in code.
Yeah.
And that will close off day 1.
Yeah, exactly.
And then day 2, we'll keep digging in. So in day 2, we'll take a look at repeating events, aka loops.
Yep.
And we'll take a look at the different types of loops that are available. And again, just like with our if statements, our conditional code, we broke that across 2 modules. We're going to break our loops across 2 different modules and how to go through a list, which will actually lead us perfectly.
Yeah, because
Module 10.
Absolutely, because Module 10 is where we're going to talk about sometimes we need to deal with a lot of information, and you don't just need to keep track of one thing. You need to keep track of think of it like a shopping list. You know, you go to the grocery store. You don't carry 10 pieces of paper each which has written on it one thing you need to buy at the grocery store. You make a list. We do the same thing when we're writing code. So we're going to talk about that, and then we're going to talk about and again coming back to the shopping list analogy. Shopping list is only useful if you can write it down and bring it with you to the grocery store. So we're going to talk about how do you save information so you can look it up later in Module 11.
Yep.
And in Module 12, we'll talk about once you've saved that information, how do I look it up again when I need it?
Yeah, which is sort of perfect. And again, kind of going back to the point that Susan made earlier, that we really do want to build this in a way that you can feel like you're making the next step, making the next step, making the next step. You'll notice that we're going to start with, hey, this is how you write to a file.
Yep.
So that way you've learned how to do that. And then we'll come back with reading from that exact same file. So that way you can see both sides of that and build into that. The next module after working with files is going to be Module 13, which is functions, which is basically how you're going to take blocks of code and give it a name and be able to call it over and over and over again, which is going to help simplify your code and really simplify your life so that way you're not just constantly copy, paste, copy, paste, copy, paste.
Though having said that, let's be honest. As a programmer, I promise you will do a lot of copy, paste, and copy, paste, because if you are going to be a true coder, you need to be lazy. And
we'll teach you how to be lazy.
We will. We are going to show you all our favorite lazy coder programmer tricks.
Absolutely.
Yeah.
You're dealing with 2 lazy people here.
Yes.
We're going to teach you how to be lazy.
Yeah.
And then last but not least, now granted, Susan, maybe you're a little bit different than I am. I know I never make mistakes.
Oh, no. I type everything perfectly every time.
Perfectly.
Oh, yeah.
Yep.
Never make mistakes.
Exactly. But on that rare time.
I'm just moving while the lightning strikes.
Yeah, exactly. But on that rare moment, when something does happen, we'll talk about how you can deal with that and how you can handle those errors.
Yeah. And then we'll actually have, we won't get into the detail of it here, but we're going to have sort of one of the most important things about coding as you get into it is to practice it, to try it, and to try and solve different problems. So we're going to give you little challenges to do after each of our modules. And then when the whole course is over, we're going to throw you a doozy. and say, here's one for you to go try.
Yep.
And we're not going to go through the whole thing here and show you step by step that last final challenge, but we did give you a copy of the solution in GitHub later. So if you get stuck, you have somewhere to look at it. So we're going to give you homework as we go through this and when the course is over, so you can keep practicing and trying things out, because that really makes a difference. You cannot do it unless you practice. It's like learning a spoken language.
Exactly.
You want to learn Italian or German or Chinese. If you don't practice it, you lose that ability.
Exactly. Yep. Yeah. I always like to say that I took 4 years of French in high school, and not that I would expect to be fluent after 4 years of high school French, but I'd like to think I could at least carry on a broken conversation, and I can basically, ma grammaire est flambée et le singe est disparu.
Très bien.
Yes. Yes. Go. Yeah. My grandmother's on fire and the monkey has disappeared.
Very useful.
Which, yes, doesn't get you very far. And the reason that all of that went away is because of the fact that I didn't use it. I didn't practice it. So that's going to be one big thing that we're going to talk about throughout all of this, is you have to get in, you have to play with it, you have to practice it, you have to get your hands dirty.
Yeah,
that's really really the key.
Absolutely.
Yeah. So with that, let's talk a little bit about you. I mean, we've talked an awful lot about us. We've talked an awful lot about what we're going to be talking about. Let's talk a little bit about you, about expectations, and kind of who this course is geared towards. So if you take a look at the slide, what you're going to notice, and I want to highlight that first little part there. If you're new to programming, you're in the right place.
Yes.
If you're a student,
sure,
who's maybe kind of looking around and going, I'm trying to figure out what I want to do with my life.
Or I meet lots of business students who
Yeah.
have they're not taking programming courses, but they have an interest in getting into coding.
Exactly.
Or, people in a computer science program, they're going to get lots of this material, but there's a lot of people who aren't in a computer science type program, but still have an interest in getting into coding. They want to learn how to be better in Excel. I mean,
yes.
do you need tricks in that?
Absolutely.
Yeah.
Or maybe you're kind of going, hey, I want to start figuring out what all of this coding stuff is all about, and I'm looking for a new career.
Yep.
Or maybe you're an IT pro.
This is true. This is one of those ones where, there was a time where the people who were administrating our systems, they would be, managing things and they never touch code. That line has really blurred.
It really has. Yeah,
PowerShell and scripting is
Exactly.
really fitting into things. And even I was looking at some new tools in Visual Studio for release management to help you manage releasing code from one place to another. And I've had this discussion with developers is who writes the scripts to migrate code from place A to place B? Is that the developer because it's code, or is that the administrator because they know all the servers and where things are moving around?
Right.
So that line between who's an administrator and who's a coder is really blurring.
It really is. It really is that basically everybody, if you're going to be in some form of a tech field, you need to be able to write some level of code.
Yeah.
And Python's a great place to start. And which sort of closes it all off with anyone that has an interest in learning to code.
Yes.
So you'll notice here as we're setting our target audience, there's one consistent theme throughout all of this. No experience required. That is what or who this course is built for. So if you've never written a line of code, you're in the exact right spot.
Yes, though I do want to point out, if you're someone who's looked at the course and said, oh, well, I've done some programming in another language and I'm fairly comfortable with coding, and I came to this course to learn Python specifically.
Yep.
One of the things you can do is all the challenges we created and all the slides are up on the GitHub.
Yep, and we'll show off how to get to that in a couple of minutes.
Absolutely, we'll show you how to get there. So one of the things you can do, if you want, feel free to stick around, follow along, review some of the basic concepts, you'll see all the syntax. But if you find yourself going, oh, wow, I know all the concepts in this module, I just kind of want to jump ahead. Hey, you know what? We're being nice. We've thrown all the slides, all the challenges. We've even created a Word document, which is just sort of summarizes every command we're going to cover.
Exactly.
So you can take an accelerated version at home if you prefer, because you find the pace is too much reviewing what you already know.
Yep.
But by all means, feel free to stick around, review some of your basic concepts, and you've got that option as well.
Yeah. Now, if you are looking to follow along, because of course, if you're going to do code, you've got to, do code.
Practice.
Yes.
Practice. How do you get to, what is it, Carnegie Hall? Practice.
Yep. Yeah, you got to get in and do it. So if you are wanting to follow along, you're going to need some form of a tool with which to create and work with your Python code. And in theory, I suppose you could fire up Visual Notepad, bring back VI, and do it that way. But the tool that we're going to be using is Visual Studio. Studio and the Python tools in Visual Studio. So you will want to go off and install those. We will be talking a bit about how to do that in an upcoming slide. And I would also mention again on this mystical magical GitHub that we're going to talk about in a few minutes, that there is a Word document that Susan put together that will walk you through where to go to download and install everything. So that way, if you are hopefully wanting to follow along, then you can go off and grab those tools.
Absolutely, yeah. pytools.codeplex.com is where you find. You can also find a number of instructions and information about the Python tools for Visual Studio, which we'll be using inside this session.
Exactly. Yep. Which leads us into a little bit of kind of interacting. So two big things that I want to mention. Number one, of course, the MVA community. Over 2 million registered users, which is pretty amazing. You can get 50 points for watching this event. You'll notice the little link there, aka MVA.
Did you have your coffee this morning?
I swear, I probably need a bit more coffee.
Okay.
But in any event, and then you'll notice the little code there, and then the expiration date. It expires on the 27th of October. And again, that whole dates and all of that. But
we'll get to that.
We'll talk to that. All right. Yeah, and then the last thing that I do want to mention here is you are going to notice that there is the live Q&A window. Susan and I are here. I just want to mention that that this is live. So it is the 23rd of September. It is presently 9:19 Pacific time. So again, this is live, being recorded live. So that Q&A window, we're going to try our best to answer as many questions as possible.
But it's us answering.
Exactly,
so
yeah.
If you see us talking, then we can't be answering. So
exactly.
We'll check on some breaks and things like that and
Yeah.
try and come back. But please do be patient if we don't answer questions right away.
Yeah, we're sort of outnumbered here on the Q&A. There's a couple more people out there watching than are here. So just be cognizant of that. But we will answer questions. We will periodically incorporate questions, and we really want that dialogue.
Absolutely.
So yeah, absolutely. Cool. Well, hey Susan.
Yes.
What do you say we get started?
Let's get started. I like it. That sounds like a good plan.
All right.
All right.
I'm going to let
driving
no, I'll
slides
let
or my
you drive
driving slides? All right. Let me take over the slides then here. So let's get talking a bit about why you would get into coding and how you get started coding with Python, and specifically, since that's what we're doing here. Mm-hmm. So, I mean, why does someone learn to code? Really, it's because of what you can do with code. It's not that I have a complete and utter fascination with this weird syntax and these strange commands.
Well, maybe a little.
It's what I can do with the commands that makes it powerful.
Yep.
And really what it is, it's problem solving. Coding is just problem solving. That's the basic premise of what we're trying to do. So really, it comes down to what do you want to do? Mm-hmm. Whatever you want to do, whatever field you're entering or working in, coding can affect and help it. Yep. I've seen it in healthcare. I've seen it in physiotherapy. I have seen it in entertainment industry, sports, everything. There's not a field out there that isn't touched on by technology. So whether you want to build a phone app to help you find directions to the nearest coffee shop if you need that coffee, Christopher.
You're going to notice a caffeine theme here today.
Whether you want to calculate how much money you need to buy a car. How much would a payment be if a $20,000 car or a $5,000 car over 5 years. Or maybe you have a small business and you're trying to figure out what people are saying about your business on social media. You could write your own code that would go out there and sort of collect tweets and get summaries and things for you. It's incredible how much you can do with code. Or I've actually seen applications where somebody used these new wearable devices that are out there now, this Internet of Things. So you could program some sort of wearable device so it tweets you when it's time to reapply your sunscreen.
Yes.
That's all doable.
Yeah.
I've actually seen premises of, devices that'll tell you when to put your sunscreen on.
Exactly.
Really
Cool. Automatically pick up the fact that you went for a run and automatically upload that to Facebook.
All those things comes back to problem solving with code.
Yeah.
Now, why Python in particular? The reason we chose Python for this particular session is because there are a lot of programming languages out there.
And it's funny, I'm looking through the Q&A right here, and there's 3 questions about why Python? Why Python?
Yeah.
See?
There we go.
There you
All
go.
Right. Well, I'm so glad you asked.
Yeah. Funny you should mention that.
One of the reasons is Python is one of the easier programming languages to learn. It's actually becoming very popular. If you look at introduction to programming courses all over the place, you're seeing Python popping up more and more often. Some programming languages are extremely picky about syntax. And when you're just trying to learn the concepts and the basics of programming, You've got enough to deal with without having to worry about every single space and comma that you put into the code. So Python's a little more forgiving than some of the other languages. The other advantage, lots of free tools out there you can use to code or learn Python. Yep. We're going to use Visual Studio with the Python tools for Visual Studio, specifically Visual Studio Express 2013 will work, so you can absolutely do it for free with the same tools we have here. But the fact that it's free, right? Because you don't have to make an investment. You can start learning coding with Python without any cash investment. Lots of tools out there to do it. And a lot of different ways you can use Python code. It's got a lot of different applications.
Yeah.
I was really quite amazed. I actually started doing a little bit of research. I mean, I'd poked around with the Python stuff, but I hadn't really appreciated how much you could do with it. And the other thing I want to make clear is even though we're focusing on Python here, once you learn the basics of coding, you'll be able to reapply those concepts in all programming languages.
Exactly.
Whether it's C# or JavaScript or C++ or Perl, any programming language you learn in the future, those fundamentals are just going to reappear over and over and over again.
Exactly. Every single programming language has variables. Every single programming language has an if statement. And that could be something like PowerShell. That could be something like Perl. That could be something like JavaScript. It could be, they all have the same thing. And so once you learn those concepts, then it's just a matter of, oh, okay, here I have a curly brace, or here I have an end if, or whatever it is that it happens to be for the language. But now all you're doing is you're just picking up a few keywords. You already understand the concepts. So that's really one of our main focuses is going to be on those concepts.
Exactly.
Yep.
Now, I do want to make it clear, though, teaching you Python doesn't mean you're not learning a language that's useful unto itself.
Right.
You can do a lot with Python itself. I
Yep.
said I was actually doing a little bit of research and discovered Industrial Light and Magic, who made the the Star Wars movies and so on.
Yep.
They actually use Python to help with their image processing when they're adding lighting and special effects.
Right.
So that's actually done using Python code.
Nice.
Forecastwatch.com uses Python on the back end to collect the information and to provide the information to provide a weather forecast. So that's done with Python. DevNet is one of those news sites, and they actually use Python to go out and collect different news information from different locations,
Yep.
aggregate that information together, and
Aggregate,
provide
good
it to
word.
somebody through Python.
Yeah.
And this one I thought was the most amazing one. There was actually a student in England who was having some fun. There was a class of high school students. They were learning how to code using Python. And they set up a dinosaur and installed a little speaker in this plastic dinosaur and set up a Python program. So every time you tweeted a certain word, the little dinosaur would light up and roar.
Yeah.
You got to have fun with coding.
Absolutely. You got to have a good time.
And if you do download the deck and you click on that link, you can see a video of the little dinosaur roaring.
And actually, one little thing to kind of keep going with all of this and go back to the, why Python, and you touched on it real briefly, is, Python, one of the nice things about Python is there's a lot of things that it can do for you very simply, and there's a lot that you don't have to worry about. That there was a couple of questions in the chat window about dealing with things like memory management, and yes, there's going to be a day and a time where you'll have to go in and start worrying about all of that. Today's not that day. Right now is not that time. And the great thing is with Python, we really don't have to worry about that, or at least not for what we're going to be doing.
No, not.
So we're really trying to keep this as simple as possible. And kind of lower, eliminate barriers.
Yes.
Lower
the barrier.
Exactly.
It is lowering the barrier.
Yeah, lowering the barrier to entry. That's really our big goal here.
Yeah. So I do want to make one thing very clear. If we can just go back to the slide for a second. You aren't going to learn enough in this 2-day course to start adding special effects to the next big superhero movie.
Now you tell me.
Yeah, I'm sorry about that. But you will learn enough to be able to start solving real world problems with code. So that you will do. So, and hopefully you'll start having fun because that's why we code.
Yeah.
I chose it as a career because I like coding. It is actually kind of fun once you get into it. Yes, there are moments you kind of want to bang your head against a wall because you can't figure out your little typing mistake. But, you step away, you come back, go find a coffee if you need to.
Yes.
Yeah. So let's get into some straight logistics.
Yes.
How do I actually get started?
Yep.
We're going to use Python tools for Visual Studio. First, you are going to need to install some software on your PC or laptop. There are a lot of different tools out there you can use to write Python code. I saw a couple of comments in the window of people running on operating systems where they couldn't install Visual Studio 2012, 2013. Yes, you can go find, there's, all kinds of tools out there. We're doing it with Visual Studio. You can by all means download another tool if that's not going to install on the operating system that you have in front of you.
Right.
It just means your interface is going to be a little different than ours. But what we're going to be doing is
the concepts will be the same.
The concepts will be the same. The code will be the same. Just difference in terms of what button you press to make it run, what button you press to create a new program.
Yep.
But what we're going to do is we're going to use Visual Studio and an add-on that was built by Microsoft called the Python tools for Visual Studio, which is a really sweet set of tools. And the nice thing about using Visual Studio for this is if you do decide to learn other programming languages, you're not going to have to necessarily learn another tool. If you decide to learn C# or C++, or you want to start building websites with HTML, you can do all of that inside Visual Studio. So that way you don't have to install 6 different tools on your desktop. You don't have to learn all these different interfaces. You can keep working in the same tool. So that's the other nice thing about using Visual Studio is once you've got that up and running, you can use it for a lot of different programming languages.
Yeah.
So how do you install it? And there is a Word document on the GitHub, and I'm hoping we've got a slide or something.
I can actually show right now.
Why don't you show the GitHub now, because that might be useful.
Yeah, so if we kick over to my screen here, up there on the notepad, and I'll throw this into the chat window as well momentarily, you'll notice that it's going to be on the break slides, is this little shortcut URL, so AKAMS/intro Python code.
So, okay. So aka.ms/intro Python code.
Intro Python code. Yep. And again, we'll put that into the Q&A window here momentarily. And if you follow that, that will take you over to the GitHub, which is where we've uploaded all of our files. And the one thing that I would mention here is GitHub, for those of you who are not familiar, is a code repository. And this is where a lot of developers will go ahead and upload code for either sharing with other developers that they're actively working with, or for sharing with the general public, which is exactly what we're doing. So if you haven't necessarily played around or worked a whole lot with GitHub, don't worry too much about that. This is certainly a tool that you're going to be using in the future, if not necessarily right now. But this is just a very easy way for us to go ahead and share everything out. Now, if we kick back to the screen here, what you're going to notice right there, I've got my little download zip. And so if I just click that, it will say, hey, do you want to open or save? And I'm just going to go ahead and click open. Give that a second. And sure enough, there's the zip file with everything. Now, the couple of things that I want to highlight inside of here, number one is the solutions. And this is, and actually I'll kind of go back, and I didn't launch Zoom it.
Those are the solutions to the various. We mentioned there's going to be different challenges that you get to try after the individual chapters. So in that solutions directory, you're actually going to find the solution files for each one. So if you do get stuck on one, you can go take a look and see how we solved it. And then if you cheat and look at the solution, it's not really cheating. Many of us do it.
Yeah.
What I would suggest is look at the solution, then minimize it, and then try and write the code yourself.
Exactly.
Yeah.
Yep. Yeah. So that's where all of those are going to be. And then inside of Office Docs, this is where 2 big items are. Number one is all of the slides that we're using. Now, keep in mind, we're just like typical presenters. These things may change as we go through today and tomorrow. It happens. So, you know, they may change a little bit. But where in the world? Why did you not sync? Ha, that's funny. Of course. Our first little, yours. Yeah, it's probably on my end. I haven't synced it. But what will be up there momentarily, I can just show this right now, is the how to install Python tools. Yeah, that's it. I just didn't sync.
Yeah.
And this has the links that Susan was highlighting in the slide. So Visual Studio for desktop and Update 3. And the big thing here is you do want the desktop apps version for Visual Studio. So make sure you grab that. Again, you want Update 3. Install the Python tools that you can grab from there, and then the interpreter, and then away you go from there. So you will need all of those. If you're going to be doing Visual Studio, if you do want to use another product, you're, of course, free to do that. We're going to be doing everything with Visual Studio.
Yeah. I saw a couple of questions in the Q&A window about Visual Studio 2012 or earlier versions of Visual Studio. So just to be clear, you can use Visual Studio 2013 Express. That's the one we actually have a link to in the PowerPoint slide. If you are using Express, you have to have the most recent Visual Studio updates applied. Otherwise, you're not going to be able to use the Python tools for Visual Studio. You can run, if you happen to have Visual Studio 2012 Professional, one of the actual full versions of have Visual Studio, yes, you can install Python tools for Visual Studio with Visual Studio 2012. It will not work with 2010 and those earlier editions. So if you are running 2010 Professional, you're going to want to download 2013 Express for desktop, and the updates for that to make sure that you can use the Python tools for Visual Studio. So hopefully that helps with a few of you who are having some problems. So first thing to check is make sure you have the updates to Visual Studio. You're running at least 2012, and if it's Express, it has to be 2013. Then you install the Python tools for Visual Studio. And then after that, when you you will also need to install an interpreter, because Python is a language that has to be converted to machine language by an actual interpreter. So when you're writing Python code, the computer doesn't understand Python code. The interpreter basically translates the Python code into a language the computer speaks, and that's what the interpreter is doing.
Exactly. Yep.
Yeah. All right. Now, I did want to throw in one little,
yes.
One of the fun things about being a coder, well, okay, maybe this says something to our personalities, but we learn to speak geek, so you can understand the conversations people are having. So when you start exploring more of Python, you're going to start seeing stuff about CPython and IronPython and PyPy and Jython and so on. There's actually a lot of different variations on Python. The basic syntax concepts we cover here apply to all of them. There might be some slight differences in syntax, but really everything we cover here is going to apply. So we're going to be using, for the record, so you can impress your friends, while I was learning CPython with the Python 3.4 interpreter. So that's the version we're working with.
All right.
Yeah, if anybody was to ask you, you're learning IronPython or PyPy, you're learning CPython specifically. And why that's significant and why that's going to affect you is, let's say you're a lazy programmer, like certain people you might meet today.
Nobody at this desk, though. Nobody here. No.
So if you are a lazy programmer like I am, one of the things you find yourself doing is you'll discover that chances are whatever you want to do, someone's already written the code to do it.
The best code in the world is the code that's already written. There's a friend of mine that likes to say we're not launching rockets here, and what he means when he says that is that whatever it is that we're doing, somebody else has already done. Yeah. Feel free to take advantage of that.
Yeah, and programmers are actually incredibly generous about sharing the code they've written. There'll be blog posts with examples of how exactly do I do the following. And so you'll go and you'll start searching around for how do I send a message to this wearable device to make my dinosaur roar.
Yep.
And you'll go search it and you'll find the result, and somebody will have posted a sample of code that does what you want to do. Now, it's possible when you take that code and you try it, it's giving me errors. Now, it may be that the code they posted has mistakes in it. That's been known to happen. But it might be they're working with IronPython and you were doing CPython. So you might find some slight syntax differences when you're looking at Python code examples because of all the different variations. It's not going to be huge differences.
Exactly.
It might be that a method name is different.
Yeah.
But just a heads up, if you're copying and pasting someone else's code and it doesn't work, wait a second, you're using CPython, what were they using?
Yep.
You might find some differences.
Exactly.
So then you get to search for what's this command in JPython or IronPython, what's the equivalent in CPython?
Exactly. Bing is your friend. Stack Overflow is your friend.
Oh, yes.
By the way, one real quick thing, I just want to kick back to my screen again, just because I want to highlight this just one last time. Sure. Again, the URL, and it is in the chat window, and I'll throw it in there a couple more times, and it is going to be on the break slides as well. But I do now want to highlight that I did do my last sync. So if I go back in, remember it's download zip, and I'll kind of zoom in on that. Yeah, download zip. That's going to give you all the files inside of there. And if I click open, and now if I go into the Office docs, there are the ones that I was talking about. So I just needed to sync those up.
Yeah.
And I'll also mention that this is going to be the repository where Susan and I will be uploading all of our sample code so that as we do our demonstrations, and by the way, we are going to be doing our demonstrations live. Here's our apology. Something's going to break. I said it.
Yep.
Just get it out of the way. But as we go through this, periodically we'll be uploading to GitHub and make it all available up there.
Yeah, so any code you see us doing here, we'll try to make sure that's all available to you later. So if you want to go back and look at it and go, wait a second, I know they did that, it'll be there for you.
Exactly. Yep.
So now, Christopher,
yes.
I believe I have everything set up on my computer.
Okay.
I have installed Visual Studio 2013.
Yep.
I have installed the most recent updates.
Okay.
I have installed Python tools for Visual Studio.
Okay.
And I've installed the interpreter.
Okay.
Now,
Yep.
You've learned the occasional programming language in the past.
Yep.
How do I make sure I've installed everything right and it's going to work?
You write hello world. You make your computer display hello world. Now, while Susan's getting Visual Studio up here, I'll just kind of mention for those of you who are new to developers, this is sort of the initiation that the first program that you ever write in any language or in any environment is, by tradition, hello world. And actually, if you head on out to Bing, you'll notice that there are websites that will show you how to do hello world in basically any programming language. This is just sort of, this is the way we get people in.
It is like an initiation, but it's also actually really, and it's sort of silly, and we kind of, it's almost a running joke amongst programmers. Oh, we're going to write hello world. But it really serves an important purpose, because it's a way of just making sure that, yeah, you have got the tools installed correctly, and you can write a line of code and it will run. Because if hello world doesn't work, and you start trying to write a really big complicated program and it doesn't work, you won't know, is the error coming up because your code was wrong or because things aren't installed correctly. So once you see that hello world up and running, you get to give a little, yes, victory moment.
Absolutely.
And say, okay, now I get to start having fun, because now I can start writing cool code.
Yep.
So how do we do hello world? So if we can just go to my machine over here, I have Visual Studio up and running on my computer. And when you're doing this at home, you are going to go to File, New Project. And when this pops up, you're going to see a number of different project types you can create. Visual Basic projects, C# projects. As I mentioned, Visual Studio, one of the cool things about it is you can actually do a lot of different programming languages. But we're focusing in on Python today. So if I select Python, then on the right-hand side, you see a number of different types of projects. As I also mentioned earlier, Python can be used for a lot of different things. So you can actually do IronPython instead of CPython if you want to in Visual Studio. You can use it for web applications. You can use it for Windows Forms applications. So there's a lot of different ways you can use it. The project type we're going to use on this particular MVA is Python application. So that's the project type you're going to want to select. And then what becomes important is you're going to want to go in and type in a name for your application. Got a suggestion for a name, Christopher?
Oh, let's see. We're going to have the screen display hello world. Let's go with hello world.
Hello world. All right. So let's go with hello world as our project name. And then you pick a location where you want your file to be stored. You'll notice mine saves to this little repository. That's because it's saving everything I'm doing to GitHub so you guys can access it later. So you save it anywhere you want on your machine so you can locate it when you want it. And once you have that done, you can go ahead and say, OK. And Visual Studio will go off and it'll actually create a project. And on the right-hand side over here, I'm just going to zoom in a little bit over here and show you a bit around the Solution Explorer. And what you're going to see inside there, what is it, Control-Shift to, I got to remember how to do this. Christopher's better with zoom it than I am. There we go.
There you go.
So one of the things you'll be able to see in there is this Python file called helloworld.py. The files with the .py extension are the files that contain your Python code. So that's the most important file for you to work with. And that file there is actually, just get back, is actually the file I can see open over here. This is my code editor window where I write and modify my code. And I think the guys who created the Python tools for Visual Studio had a sense of humor, because by default, when you create a brand new project in Python for Visual Studio, it actually gives you the code for Hello World. So I don't even need to type. They must be lazy programmers like us.
Exactly, yes. They realized that you were going to do this demo and decided, you know what, we're just going to make Susan's life easier. Just here, have some code, Susan.
Exactly. So print hello world is the command that will print the message hello world on the screen. So all I need to do is figure out how to run it. So if we go back to Visual Studio, there's two different ways that I can run this code. If you are a keyboard person, and the more you get into coding, the more you're going to get fond of keyboard shortcuts. There is this start debugging will launch your program and start it executing, or you can say start without debugging. So the F5 key or Control and the F5 key will launch your program. So if I just hit the F5 key, up pops a window saying hello world, press any key to continue. I have successfully run a hello world program.
Mazel tov.
Woohoo! Now, if, on the other hand, if you're a mouse person, not a keyboard person, there is a little button at the top of the screen up here. And if you take a look there, you can actually see, there we go, there's our little start button. So you can also click on that start button to launch your program as well. Just depends what you prefer. Just pick the method that you find easier. You may find I might switch back and forth. I'm not necessarily consistent. Sometimes I'll use the function key. Sometimes I'll press that start button. Once you do launch it, it's up and running. Now you need to know how to shut it down again. And once again, there's a few different ways you can do it. I love the fact it gives you a hint right on the screen.
Press the any
Press
key.
a key. Oh, look, it shut down the program. The other option is you can close the window. Just like if you were in Word or Excel, right? Close the window when you're done. The other way of shutting it down is inside Visual Studio. If I go over here, you'll take a look, and once again, you can see a little button there, the stop button. Think of it like a VCR. Play to start playing your program, stop to stop your program.
VCR?
Oh yeah, DVD player, sorry. I'm dating myself again. So you can hit that stop button to stop executing as well. Now this is actually a little Visual Studio coding world tip that helps you out. Is once in a while, you might have this window open and then you do something like go checking your email. And you forget that the program is still running.
I have done this so many times.
So you start going here and making changes, and maybe something's not acting, because it will actually let you modify the code. That's actually one of the neat features of Visual Studio, is you can actually make modifications while your code is still running, which is kind of freaky when you think about it. But it's really, actually, you'll learn to love that feature. But every now and then, there might be certain changes you're making, and it'll say, well, what are you trying to do? The code's still running. And you'll be going, why am I getting that error message? Now here's the thing. There's a cue that can help you remember your code is still running. So if we return to Visual Studio one last time, look in the top right corner up here and see how that stop button appears. That only shows up in red if your code is actively running. Once you hit that button, it's gone. So once you stop executing the code, aha, I know that my code is not running right now. So if you see that stop button, if something weird is happening, take a glance. See if you see that little stop button, go, oh, my code's still running. Hit the stop button. We'll probably do it at some point during this MVA.
Yep.
It'll hit us sometime.
Yeah.
So don't panic. Just check and see if your code's still running.
Exactly.
And we now have our hello world.
Yes.
So we've basically created our first application.
We have. Well done.
Yeah. And I think that just brings us to, maybe you want to mention, we should mention a couple of best practices, because I think it's really important to get into good habits right away when you're coding.
You know, whenever I'm doing any form of an intro to fill-in language here, and this could be SQL, C#, Python, anything like that, I probably spend a good third of the time just talking about best practices. That to go with a golf analogy, that if you're ever going to go learn to golf, and basically don't do what most people do, including myself, which is decide, hey, I'm going to take up golf and just head out and just start whacking on some balls. The problem is that you're learning bad habits right from the get-go. And so when you're under stress, what's going to happen is you're going to revert back to those bad habits. And the exact same thing holds true here, that this is the perfect time to start to develop those good habits, because the habits that you develop now are the ones that are going to follow you throughout the rest of your career.
Yeah.
Yeah.
So one of the good habits we want to pick up is the idea of commenting your code.
Yes.
Have you ever had a situation, Christopher, where you wrote a program and then you had to come back to it maybe 3 months later to make a change, and you found yourself going, what was I doing?
3 minutes later. I always like to say I have a great memory. It's just really short. The number of times where I've written something out and then go back to it later and I start to go, why in the world? Or the other one that gets me is I'll go in and I'll look at my code and I'll go, why did I do it that way? It would have been much easier if I would have done it this way. And I'll go back in and I'll start recoding it, and I'll get about halfway through, and all of a sudden I realize, oh, that's why, because whatever the reason was. And so if you throw in those little comments, those kind of messages in a bottle, it makes it that much easier to remember later on exactly what it was you were doing. On top of that, I would also say this, for those of you that are brand new to Python, this is a great way to take notes.
Yes.
So that you go ahead, you write out a little bit of Python that does whatever it is that it does, and then right on top of it, you put in a comment that explains what that code is about to do.
Yep, that'll help you reinforce things.
Yep.
And the other advantage to it is, one of the other things that'll happen the more you get into coding is you may find yourself coding and someone else is coding and you're looking at someone else's code or someone else is looking at your code. And I can tell you, I have yet to meet a program that somebody handed me that had too many comments. When I'm trying to, and it's bad enough that I have trouble reading my own code 6 months later. When I'm trying to understand someone else's code, that can be really remarkably difficult to try and understand and follow through what someone's done. And you're going to notice this very quickly. You're going to appreciate those code examples which have comments. So
yes,
let's try and create another generation of people with who do put comments in their code. You'll hear about the principles of self-documenting code. People who argue you don't need comments. I like comments. Please put them in there for me. I appreciate it.
Yep.
So
yeah.
So you can put in information about what your program does, what a particular command does. You might have written a little note saying, hey, I used this command instead of that command because I discovered the following.
Yeah, that's the big one, yeah.
And also said anything that would help someone understand why you did something the way you did. And the syntax in Python for using comments is the pound symbol or a hashtag. So anything in Python where the line starts with that pound or hashtag is going to be completely ignored when the code is executed. It's basically going to say, oh, those are just notes for you. OK, fine, I'll ignore those. Yep. So if I go back to, let me go to Visual Studio again, and let's just do a little example. So we go here, and I can add a nice little comment here saying this is a comment.
Ooh, pretty color.
And, whoops, and I can add lots of comments.
Yep.
And you brought up the point of the color. That's a really good point there, Christopher. One of the other nice things about Visual Studio is it actually uses color coding to help us keep track of what we've typed in. So when you look at this code here inside Visual Studio, you'll notice that the comments are all in green. And some of the other sort of neat things that you've got going here is you've got, if we take a look here, I'm going to try this sort of, nope, touch isn't working for me. Let's do it this way. So you can actually see that the string, so the string of text that's going to be displayed shows up in red. That's Visual Studio's way of saying, hey, I recognize that's a string of text. The word print here, actually shows up in black. That's a way of saying, oh, that's one of your commands that you're using. Yep. That color coding you'll find useful at helping you find those occasional mistakes that haunt programmers.
Yeah, occasional.
So you'll find that really useful, that different sort of color coding. Now, here's a cool little geek tip, because we've got to have some fun, show you some neat little things so you can impress your other geek friends. If you don't like the colors, I actually find that green sometimes a little bit hard to read for the comments.
Yeah, that's a little light.
In the very top right corner of Visual Studio, there is a little box, and it's called the Quick Launch. And if you go there and you type the word font, it'll actually bring up a pop-up menu. And what this does is actually searches the tool itself and tells you where in the tool you can change a setting. So I can go here to find out how do I change information about the fonts and the colors of my code editor.
Yep.
So I go, oh, look at this. Under Options, I can change environment, fonts, and colors. If we click on that, I'm going to zoom back out again here. You'll see that I can change things like my font size. So if you want the text to be bigger, I've got it set to 16, a little bit large, but that's because we're doing a presentation. You probably have it something smaller at home. And I can do things like I can go down and I can say, you know what, for my comments, I would like the default color to maybe be purple instead of green, because maybe that's a darker color and easier for me to see and distinguish. And you can make it bold if you want to, and you can give it a lovely yellow background, and that would be quite hideous. By the way,
let's not do that.
Yeah, let's not do that. But really, and it gives you a sample of how it would appear here. But it's wonderful that you do have that ability to customize it, and I'm going to set it back to the default for now, which is green, just because I don't want to mess you up. I want to match what's on the slides. But you can change it to anything that you like. So you really can customize that look and feel inside Visual Studio. It's one of the nice features of the product. And I think, as we do that, so we've talked about the colors.
Yep.
You know what? I think if you have got that working, you are now a coder. Once you see that hello world appearing on the screen, add a comment, you are now a coder.
And I do want to just real quickly here, first of all, let's not downplay this. Number one, congratulations. If you get something to print out on the screen, you're a coder.
Yes.
You know, it's like Susan and I both run, you know, sometimes people will say, oh, I'm not really a runner because I haven't done fill-in distance here. If you run, you're a runner.
Yes.
If you write code, you're a coder. It's very simple. There is no, nobody's like, asking you to bring in a portfolio to, confirm that you are or are not a coder. I mean, if you're going for a job, but that's something completely different, But as far as whether or not you're a coder, hey, you're a coder. Yes.
So.
The other thing I do want to mention real quickly here, just because there's still been a fair amount of questions in the chat window, I just want to throw it up one more time. There's, again, the URL. And, again, the big button here that I want to highlight is this button right here, Download Zip.
That's the easy way to get everything.
That's the easy way to get everything.
Yeah.
So, like I said, periodically, this is going to be, we're going to go in and update all of this. All that you have to do when you want to go get the latest files that we've played with, just click Download Zip, and that will go get everything for you. In fact, I actually did make one little change. There was one mistake in the Word document, the link to download Visual Studio.
Okay.
So I just went in and updated that. So, again, that's the easiest thing to do. Don't worry about syncing or anything like that. If you are curious, I have to do this.
Okay.
We do have an MVA on using Git and Visual Studio that you can go check out, but that's so far beyond what we're going to be doing. This really is just simply hit Download Zip down there at the very bottom, and that will give you everything that you need.
All right, so I think we have come to an end of Module 1.
Yeah, we have coders.
Yes, excellent.
Yes.
Congrats, folks. You're
Yeah.
coding.
All right, so what do you say we take 10 minutes, we'll come on back, and then we'll start to take that first step beyond Hello World.
Now we'll start solving problems with our code.
Yes, excellent. We'll see you guys in 10 minutes. All right, well, welcome back to everybody. For those of you just joining, this is Introduction to Programming. We happen to be using Python. Alongside Susan Ibach, I am Christopher Harrison. One thing that I do want to mention, kind of again, we are seeing a lot of great questions in the Q&A.
Yep.
We're going to do our best to try and incorporate some of that. We're going to do our best to answer everybody as we go through this. But one of the things that is worth highlighting is that there's really only two of us, and a couple of other support people as well. I shouldn't downplay, like Kristen, and I think Matt might be listening in as well.
But the technical questions are really on us.
Exactly. So we're sort of outnumbered up here. We're doing our absolute best, but we're outnumbered and we're a little busy. We're doing this live broadcast here. Again, it's 10:05 Pacific on the 23rd. So kind of bear with us, but we are doing our absolute best. We appreciate all of the interaction that's going on there. That's fantastic. Now, we left off getting our screen to display Hello World, which, again, is that standard stock, hey, congratulations, you're now a coder. But now let's take that next step. So now let's take a look at how we can display a bit more out onto our screen. It's my first day with the language. I can't speak French. I can't speak English.
You're talking about how you have to practice, Christopher. You maybe you need to practice some of the English as well as the coding.
Would you believe I'm a professional presenter? I know I don't show it all that often. But in any event, why don't you lead the way and show us how we can do something else beyond just Hello World?
Yeah, absolutely. One of the things what we're going to get into now is the types of things we can display on the screen, getting into displaying some text on the screen. Because if you think about what we use computers to do, we use computers to read ebooks on planes.
Yep.
Look up movie reviews.
Yep.
I saw a movie yesterday. I was looking up information on the movie because I was like, I think I read a book that was based on. So I wanted to see if that was in fact based on the book I had read. Reading instructions on how to clean crayon off your walls. I had to look that up once. Yes, I am a mom. The kids were quiet in the basement for a little while, and when I went downstairs, they had been happily coloring all over the walls. And by the way, the answer to that question is WD-40, in case you ever need to know.
Oh, okay.
Yeah, apparently the oil breaks down the crayon. So.
Huh.
Very useful fact for the day.
Interesting. In my case, because we just have a dog, and he's yet to actually pick up crayons and draw on the wall. And honestly, if he picked up a crayon and drew on the wall, that really wouldn't be a problem. I would be rich. I have a crayon-using dog.
You would be taking a YouTube video and,
yes,
and posting it most
exactly.
likely.
Yes, I'd be celebrating.
You'd be posting videos, I'm sure. Or maybe you want to learn all about the capybara. You know.
The capybara?
Okay, well now I know what my coding example is going to be. I'm going to teach you all about the capybara. It's a fascinating creature. But really what I want to get back to is the idea that a lot of computer programs, what they do in terms of the problem they solve is they provide information to the user. And so what we're going to look at is one of the simple things we have to be able to do if we're going to write a program that's going to provide information to a user, and that's the ability to display text.
Yep.
So in Python, we do that with the print command. Very simple, basic command. So if you go take a look, you've got the, you've got a print statement there that allows you, and the print statement is a command, and then you have parentheses surrounding. So these parentheses are essential. You have to have parentheses surrounding the statement or that you want to print on the screen. The other thing you're going to notice here is if you take a look, you're going to see quotes around the string. So that indicates that we have a string of text. So you have to have a single quote at each end of your string to indicate the text you actually want to display on the screen.
Makes sense.
Yep, pretty straightforward, hopefully. Go away. I accidentally just, I hit the wrong key to get rid of my little things all over the screen. Yeah, exactly. Wrong tool, using the wrong thing to get my little pen marks all over the screen. Now, I was mentioning that Python's a fairly forgiving language. And one of the things that's really nice about it is the single quotes that I was showing you there. Python also allows you to do a print statement with double quotes if you want. So if you take a glance at the slide, you can see I can also use double quotes to enclose the string I want to display on the screen.
Okay.
Python doesn't care. So if you like single quotes, go with single quotes. If you like double quotes, go with double quotes.
All right.
Nice and simple. So let's just do a little example. Let me tell you all about the capybara, Christopher.
Yes, tell me about the capybara.
All right. So I'm going to go and I'm going to create another project. File, new project. I'm going to select the programming language Python, project type Python application, and this is going to be our module 2, displaying text. So I'm going to
displaying text. Okay.
I'm going to save that in there so that way if people want to see these code examples later, it's easy for them to find it.
Perfect.
And I already have a basic print statement here, but we've already done hello world. So I'm going to change that statement to say the capybara is the world's largest rodent. I don't know if you're aware of that fact.
I did.
It is.
So it's an ROUS.
A rodent of unusual size. Excellent Princess Bride reference there, Christopher. And
thank you.
Score 1, I actually recognized one of Christopher's movie references. And then I can the capybara likes to live in groups.
Okay.
Yeah, so live in groups. See, I'm making typing mistakes already. Now, I did mention you could use double quotes if you prefer. So I could also specify that the capybara can swim. So it actually goes on water and land.
Right.
So once I have my print statements, like I said, I can use single quotes or the double quotes. Then I go ahead and I launch my program, and we can see the output displayed on the screen to the user. So,
okay.
Nice and hopefully nice and straightforward. Okay, so that's how we print basic text. Now, one of the things you'll notice is I did print out multiple lines of text. You can see that, first of all, oops, I think I went ahead one. That's strange. I seem to be missing a slide. But you can see I can use multiple print statements to print text across multiple lines. Now, the other question that comes up is because I can choose between single quotes and double quotes, does it matter which I use? What do you think, Christopher? Does it actually matter if I use single or double quotes?
Well, you're asking me the question, so I'm going to go with a yes there.
Well played, my friend.
Thank you.
Let's take a look at this example on the slide here. What if you want to print a string that says, it's a beautiful day in the neighborhood? Well, here's the interesting aspect of that particular string. If you were to enclose that string inside single quotes, then the problem is it has a single quote in the string. So what ends up happening is when you are using the tool is Python is going to think that the string ends here because it sees that quote.
That's not a good thing.
No. So in this situation, because I'm actually using a single quote inside the string, I have to use double quotes to enclose it.
Okay.
If I had a double quote somewhere inside the string, then I
Right.
would use, go for it, Christopher.
Single quotes.
Correct.
Yes.
If there's a double quote inside my string, I'm going to use single quotes to enclose the full string. So that's so I can choose that one either way. It's going to erase my ink. There we go. All right. So if there's a string you're displaying and it contains a single or double quote, that is going to force you to choose one or the other. But otherwise, I would say, and we were talking about good habits to develop, pick one and stick with it. Don't write half your program with single quotes, the rest of your program with double quotes, because somebody's going to come and look at your code later and go, well, is it significant that here you use single quotes versus double quotes? And it can be confusing for yourself when you're trying to remember later, or for someone else who's trying to understand your code.
Exactly.
So do generally pick one and stick with it. All right. Now, here was my slide. I was looking at what if I want the text to actually appear on multiple lines. You can use multiple print statements.
Actually, it's funny. We just had a question about that. So it's
oh,
perfect
did we?
timing.
Awesome. Yeah. So I can use multiple statements, do one print, another print. Or another way of doing it is I can actually insert a /n. This is a backslash. And this backslash symbol is a special character that Python recognizes. And it basically says, hey, I've got a command I want to sneak in here.
Right.
And /n means I want to insert a new line. There's also a /t, which would insert a tab if you wanted to indent something.
Okay.
Also can be useful. So if you prefer to type everything on one line, you can just insert that /n in the code, and that will insert a new line right in it. So if you take a look at the slide here, you can see that my output, hickory dickory dock, appears on the first line,
right.
And in the output, the mouse ran up the clock shows up on the second line. And there is another really funky trick, and I have never seen this in any other programming language. Python actually allows you to enclose a string inside triple quotes.
Okay, then.
Ever seen that one before, Christopher?
I have not. That's relatively unique.
It is, but the triple quotes, and it can either be triple single quotes or triple double quotes.
Okay.
But when you do this, you can actually write your print statement over as many lines as you want inside Visual Studio, and it will appear on the output the same way you typed it into the editor.
Okay.
So kind of interesting.
Yeah.
So let's take a look. I'm just going to do a couple of examples inside Visual Studio of how that would work. So I can say print. Apparently, if I can type print. So let's try the new line approach. Let's see. The capybara lives in /n, and it's the backslash, not the forward slash.
Backslash, so yes. Upper left, lower right.
Yeah, America. So it lives in South America. Oops, I can't mix up single quotes and double quotes in one line of code. That would be a bad idea.
By the way, so one of the things that came up in the chat window is what would happen if I wanted to print out a string that had both a single quote and a double quote.
Oh, okay. Let's after we get this, let's try that.
Okay.
We'll solve that little problem.
Okay. All right.
That's an excellent question, but we will take a look at that.
Okay.
So here I can see the capybara lives in South America. You can see that going across for 2 lines.
Okay.
So we've got that successfully working. And just as an example of this is the strangest way to print over multiple lines I know, which is this mysterious triple quote system. So it's perfectly valid. It does work, but it's a little unusual. It's not typical of most programming languages. Most of them will use either an escape character like the /n, or use multiple statements to print over the multiple lines.
Right. Now,
there was a question you said about how could I print something that contained a single quote and a double quote in the same line? All right. This is a little sneak peek at what we're going to see in the next chapter. Because one of the things you can do is you can actually, here is a string, and you can use a plus sign to take 2 strings and stick them together.
Okay.
So here is more. So I can actually use a plus sign to take 2 strings and treat them as one big long string. So now I can see that all appears as one big long string. So what I can do, and I have an extra space, so I'm going to get rid of that. So here is a double quote. And since that's a double quote, I'm going to put that inside a string that is single quotes.
Okay.
And then I'm going to say here is a single quote, which is there. And I'm going to take the string that contains the single quote and enclose that in double quotes.
Okay.
So just a little creativity. And then I can get a double quote and a single quote appearing in a single line.
Okay. And, you know, and I know you're going to get into this kind of momentarily, but there's always multiple ways to do something.
Yes.
And one of the nice things about doing it that way, if we go back to Susan's screen here, I'm just going to kind of use Susan's screen to talk to, is that you are kind of breaking it down maybe into smaller bite-sized chunks, which can certainly be helpful. But one of the things that you could actually do with that backslash is you can use that to escape a quote, so that if you kind of backed out the, yeah, there you go. Just say print, and then say, or you can, and then just do this, backslash, double quote.
Yep.
And then hit a space, and put something right there. Yeah. There you go. Perfect.
All right.
And now let's go ahead and run it again. And then now you'll notice that you've got the double quote in there as well. So multiple ways that you can do something, which we should talk about that.
We should.
Yeah, we
will.
should. Okay.
So the backslash character, so it's a special character. It has special meaning to Python.
Yep.
And it's a way of saying, hey, don't treat this quote the same way. So it's a way of saying, just display this quote. It's not actually ending the string. So
Okay.
that's another neat trick. So
Yep.
a couple of options there in terms of different ways to solve that problem. So, I seem to be stuck in the drawing mode. So same problem, multiple solutions. So Christopher, I'm going to ask your opinion on this one.
Okay.
We have 3 different ways of printing text over multiple lines. Which do you like best?
So kind of going back to, that whole, so we've got multiple ways that we could do something. What's the best way? You know, for me, I really like that first one there, just that print, and I know that gets maybe a little bit more verbose.
Yep.
But you know, that just seems to make more sense to me.
Yeah, it's easier to read when you come back to it later, isn't it?
Exactly. Yep.
Yeah.
Yeah.
I have met people who seem to make almost a game out of seeing how much code they can fit into a single line. I have met coders who just live for cramming as much as they can into a single line. They're going to absolutely go for the option of using the \n to save on having to hit the return key. I mean, I guess maybe that's their way of being a lazy programmer. I respect everyone's right to be a lazy programmer their own way, but still include your comments.
Yep.
I would stay away from the triple quotes one just because it's not common. And that way, if somebody's coming from another programming language or you're going to another programming language later, you're not going to be able to keep that pattern.
Right. Yeah. And this is, you know, sort of going back to the very beginning that, you know, when we first kind of pitched all of this, the whole goal here is to help you get into programming. So not necessarily get into programming Python, but get into programming. And a lot of the concepts that we're going to be learning, you know, loops and if statements and all of that are consistent across every programming language. Will allow you to store a variable. There will be different ways that you can do that, but you are going to notice that every language has its idiosyncrasies, has its own little quirks, and as a result, you'll want to kind of pay attention to those. And I don't want to necessarily always say steer away from those because a lot of times those idiosyncrasies can be quite helpful.
Sometimes they allow you to do things that would be very difficult to do in another language.
Exactly.
But in this case, we have easy alternatives that
Yep.
are more common. So stick with the more conventional way of doing it, I would recommend in this case.
Yep.
Yeah.
A lot of people love the triple quotes, though.
It's neat.
Yeah,
I'm getting
a
funky
lot of
trick.
comments here. Yeah, love the
Yeah,
Yep.
it's funny you said, but it's a neat, funky trick. I'd never seen it before I saw Python.
Yep.
There's another one that said, and that really is it. As a coder, one of the things you want to be aware of, there's often more than one way to solve the same problem.
Yep.
And a lot of times, it doesn't matter whether you use the /n. In the end, if the code works, you've done it. Awesome. Celebrate.
Yeah.
And I don't, in the end, that's what matters. Did you solve the problem? Does your code work? And
Exactly.
if you've used an unconventional way of doing it, that's all right.
Exactly. You know, a lot of people really get kind of just very, it has to be done this way. And I don't really have time for those types of arguments. If it's clean, if it's easy to read, you know, that's really it. And even to kind of go one step further, maybe make this a little bit more advanced, a lot of times people start asking, well, you know, what about performance? And if I write it this way, will it perform better than if I write it this way? And 99 out of 100 times, and in fact, probably 99.999% of the time, it's not going to make a difference, or it's going to make such a minuscule difference that, quite frankly, it doesn't matter.
Yeah.
So really, write the code that makes sense. Write the code that's clean, and go from there. So if we go back to the slide, do you still have your slide up, the one prior?
The Geek Tips or the
that
print
one there.
options? Yeah.
Yeah, choose the one that makes the most sense to you. Choose to me, it's print and print. If you like the backslash, then go with the backslash n. Then go with the.
And if you really like the triple quotes, go for it.
Exactly.
It's your code.
Exactly. So, and if I can steal just one last second, only just to kind of answer a couple of questions here. That backslash is an escape character. So for quotes, those have a special meaning. If you don't want it to have that special meaning, put a backslash in front of it. So backslash single, backslash double. If you want that new line, again, backslash n, that tab, backslash t. What would happen if you wanted a backslash?
Let's find out. Let's try and write.
Let's do it.
Let's try it. That, you know what? And this is actually one of the other truths of coding.
Yeah.
Sometimes you don't have the answer to everything. You can't find it. Sometimes the easiest way to find out the answer is to try it. Can I just print a slash on the screen? Because, if that's a special character, is that going to do something weird? Is that what you want?
Yeah, go for it.
All right, let's see what happens. No problem.
There you go.
So no worries. If you want to print a slash, just put a slash in the string.
Put a slash in there.
Smart. It's actually Python, as we mentioned, is a fairly forgiving language. There's other programming languages where you'd actually have to go backslash, but not in Python.
You are going to notice at times you have to do that.
Yeah.
Yeah, you will notice at times you are going to need that double backslash.
Yeah,
but if you want, just in the middle of a, two spaces, just go ahead and do that. Otherwise, you would need the two backslashes.
Yeah.
So
The challenge that you're talking about would be let's talk about.
Yeah, like a file path.
But what if I want /n to appear
there you go.
on the screen.
Perfect.
/news, like I'm putting maybe a URL for a website.
Yeah.
Right, that I'm displaying. Someone go to this website, and the website happens to start with N.
Yep.
Oh, wait. Gee, could that possibly cause a problem?
I'm predicting an
ooze.
See, ew.
It's like I planned it, but I didn't. So there is a situation where the slash was misinterpreted. It took it as a /n, but I actually wanted to print the /n. But how do we tell it? Don't treat it as a special character. What do we do with the single quote?
Put it in a backslash. In front of it. So we'll put in another backslash.
Which looks a little weird. You're looking at it, and this, you know what? This is a good time for a comment. I am inserting a // so the slash appears correctly in the string. So that's a perfect time to take a little note to yourself, because you're going to come back later and go, why do I have // And now when I run, there we go. Now I can get /news.
Backslash. Yep, there you go.
Cool. So great questions. Keep those things coming, because those are exactly the kind of things that catch you when you're trying to write your code later. That's why practice is so important, so you can encounter these odd little problems and gradually learn how to solve them. Okay, when good code goes bad, there is another really, really important programming concept you will need to learn as well, and that is the fact that it's okay to make mistakes in your code.
Right.
You will make mistakes in your code. We will make mistakes in our code today and tomorrow.
Promise.
Yes. So don't panic. Sometimes people, when they're writing code, they're like, oh, it's not working. I'm a terrible coder. No, you've just made a mistake, just like the rest of us do. When I'm trying to learn another language, again, spoken language versus versus a programming language. I was going to say unspoken language, doesn't sound quite right. And I try to say something in German. Ich habe einen Schneeball auf meinem Kopf, which it means I have a snowball on my head. Useful phrase. I'm pronouncing that.
Flambe.
Yeah, I'm sure anyone out there who speaks German just cringed at my pronunciation. But I can't learn if I don't practice. And when I practice, yes, I'm going to mispronounce some words. Yes, I'm going to misconjugate some verbs. When I'm speaking in French, I'm going to get my masculin, féminin mixed up, those kinds of issues.
That was the thing that threw me.
No, it's the verbs in French.
Okay.
Verbs in French are brutal. I am from Canada. I am actually, je suis bilingue. Je peux parler en français si c'est nécessaire. So I can speak French. I've spent a lot of time with my bécherel. Anyone who's learned French knows what a bécherel is. But it's okay to make mistakes. Don't stress out over it. In fact, it's quite funny. Sometimes when I make a mistake in my code, it might be 2 lines of code and I can't figure it out. If you get really stuck, walk away and come back. retype the line.
Yep.
Or if you have a friend nearby, it's amazing how often, if you look at someone else's code, you can see their mistake. And if they look at your code, they can see your mistake.
You know,
it's the weirdest thing.
It's one of those things that, you know, when you're focused in on a problem, you just get, you know, tunnel vision. Yeah. And you keep thinking, well, it's got to be here. And having that fresh set of eyes can be extremely helpful. That one of the things that would happen quite frequently when I was in the classroom, and the same happened to you, is somebody would have a problem. You'd walk over, you take one look at their screen and immediately know, oh, okay, well, that's where your problem was. You would be able to immediately spot it. And it's not necessarily because we knew anything more than the student did, or than the person that we were helping. It really was just simply that fresh set of eyes. And one of the things that I'll frequently do if I'm having a problem that I can't quite figure out is I'll just go for a walk.
Yep.
You know, I'll just go get a coffee, I'll go to lunch, and then I'll come back with kind of, you know, a fresh mind, a fresh set of eyes, and then usually I'm able to spot it just that much faster. So that fresh mentality, that new set of eyes really helps out quite a bit when you're trying to track down a problem.
You know, it's funny, when I used to teach programming courses and I would go around and a student had a mistake somewhere in their code and they couldn't find it, I would come over and, as you said, quite often I would find the mistake very quickly. I used to explain to the students, the reason I'm so good at finding mistakes in your code is because I've made so many. So the more mistakes you find in your code and make, the better you're going to get at finding mistakes in your code. So don't stress it. But we have to start practice, right? We talked about how do you get to Carnegie Hall? You practice. So I'd like us to try practicing finding mistakes.
Okay.
So,
well, you're going to have to make some mistakes. Oh, you've got mistakes.
I have some code here that would actually, every one of these lines of code has a mistake in it, Christopher. Do you want to take a shot at where the mistakes are?
Well, you know, before I do that, I want to point something out there is I'm noticing color differences.
Yeah.
The colors aren't the way that they're supposed to be. So I'm noticing print hickory dickory dock, but that hickory dickory dock, it's all black. So it's looking to me like Visual Studio, if this was Visual Studio, isn't picking that up as a string. So I'm going to say that you probably forgot the quotes there.
Exactly. We should have some quotes around the string, and because we left those quotes out, it's confused, it thinks that's a command. So you're right, the colors can give you a hint.
Yep.
All right.
Okay.
How about the next line? You got one.
I got one. All right, well done to me. And again, I'm noticing wrong colors. So I'm noticing it is red, but at the very end, you know, then small world is all in black. And then towards the very end, that closing paren is back in red again. So obviously, again, there's something that Visual Studio isn't quite picking up. And it's looking to me like you've got that single quote on its.
Yes. So how do I fix it?
Well, you could do a few things. You could change double on either side.
Yep.
You could also do a backslash single quote as well if you want to keep that. Now, in this case, I'd probably go with the double and then the single in there. But either way would actually work.
Yeah, you could use a backslash as well. All right, 2 for 2. All right, keep going.
And again, noticing the color is that closing paren is red, and that shouldn't be red.
Yep.
So now I know that it's not picking up the end of the string, and if we take a look, I've got a double at the beginning and a single at the end.
Yes, so I've accidentally mixed up double single quotes in a single string. And this is, again, one of those reasons you want to get in the habit of always using one or the other, because if you mix them up, this is the kind of typing mistake you'd make so easily.
Exactly, yeah. That, you know, kind of pick one thing and just go with it. Yeah, it's just going to make your life that much easier.
All right, I have one more typing mistake for you to find, Chris.
All right, let's see it. Yeah, right at the very beginning there, last I checked, it was INT.
Yes,
there
I actually,
we go.
And you know what? It's funny, the color coding still can help because it didn't recognize it as a command.
Exactly.
So the text showed up in a different color. So let's see how you did. Sure enough, yes, well done.
Woo-hoo.
All right, high fives.
4 for 4. All right,
there we go, good man. All right. So yeah.
I get to keep my job. I could get to stay here for the rest of the day.
Yes, exactly.
All right.
You're allowed to stay. It's all good.
Excellent.
So now, that brings us to the end of the new syntax we're going to introduce inside this module. You now know how to display text on the screen, which we talked about. You can now basically tell someone a story, you can tell someone a poem, you can give information about the capybara, and now everyone knows all about the capybara, the large South American rodent.
Yep.
So your challenge, should you choose to accept it, is to write a program that will display the following poem on the screen. See, I was feeling creative. There once was a movie star icon who preferred to sleep with the light on. They learned how to code a device that sure glowed and lit up the night using Python.
Okay, we have our first limerick of the day. Fantastic.
So you want, obviously this is text, it's going to appear over multiple lines. So basically it's just practice. You're looking at this going, hopefully saying, I can do that. Well, that's the goal.
Yep.
Right? So now you can do this over multiple lines. Experiment if you want to try including some slashes and things just to try it out. Try it. Go ahead. Explore.
Absolutely.
If you get stuck, the GitHub, when you download that zip file, in there you're going to find a folder called Solutions. You'll actually find a suggested solution. But it is only a suggested solution because you could solve this a lot of different ways. So if you come up with a solution and then you look at our solution afterwards and go, oh, I did it wrong because theirs code isn't the same as mine. No.
Nope.
That doesn't mean you did it wrong. What that means is you came up with a different way to solve the problem. And that's, again, score as a congrats, you are a coder kind of moment.
Exactly.
So
that's
congratulations. You can now write a computer program that will actually share information with the user.
Yeah. Yep, absolutely. And along those lines, just kind of real quick, because we're getting kind of a lot of questions about, hey, well, if we wanted to put together a variable.
It's like, well, guess what's covered in the very next module?
We are absolutely going to get into that. I'm also seeing things, like about this being easier than another language or about the lack of semicolons, definitely there. And the big thing, again, that we want to point out is the goal of this course is really to help you become a developer. So
and get comfortable with it.
Exactly,
It's not that scary.
Yeah, exactly. You're going to notice here that we're not going to really get into like databases. We're not going to get into object-oriented because that's not the goal here. The goal here is to help you get your feet wet, to help you get into programming. There's going to be plenty of time to get in and start doing object-oriented programming. There's going to be plenty of time to get in and take a look at how to create web apps with Python. But today, tomorrow, it's really about, before we can run, let's walk. And that's what today, tomorrow are all about, is just kind of those first steps into becoming a developer and inside of Python.
Absolutely. No, you've got to start with the basics, and that's what we're going to cover here. So I think that takes us to the end of this module. Let's take a little break, and we'll be back in another 10 minutes.
Yeah, that sounds perfect. All right, we will see you guys in 10. All right, well, welcome back to Introduction to Programming with Python. Alongside Susan Ibach, I am Christopher Harrison, and where we last left our hero, which was much more difficult for me to say than it should have been, what we did was we displayed out string literals. So what happened was Susan was doing the demos, she typed something out, she put it inside a print, and it printed out on the screen, which is certainly something that you are going to be doing, things like error messages, prompts, and the like. But at some point, we want our program to be interactive. At some point, we need to get something from the user that if I just simply go in and hard code that this is always going to display this, I'm sort of limiting the reusability of that program. So now we want to get into working with input from the user. We want to get into actually making things a bit more dynamic. And that's exactly what we're going to do with Module 3, which is going to be string variables, variables in general, and getting the user to input in a value.
Yeah, absolutely. We can be a lot more interactive when we've got a user telling us things as we go.
Exactly, yeah. Two-way conversation. We're having a two-way conversation. See how that works? It allows you to do more. So then that way, if you want to be able to handle payment information on a website or put in your address so that way people know where to ship your products, they can go ahead and do that. If you're dealing with information about insurance policies, if you're looking to set up really any form of calculation, where is it? I should go ahead and grab it here. There we go. Go ahead and grab. I love this thing.
Cortana.
Yeah. ask Cortana to tell you a joke. By the way, for those of you who do have Windows Phone 8.1, ask Cortana to do an impersonation or to do an impression.
Well, I haven't. Oh, really?
Yeah.
I've asked Cortana where Master Chief is, and I've asked Cortana for a few jokes and had a few good ones. My personal favorite Cortana joke, a Roman walks into a bar and holds up 2 fingers and says, 5 beers, please. All right, on that
folks,
note,
yeah, so
back to
moving
the code.
right along. All right. So the question is then, how do we get input from the user? So for right now, again, we're kind of keeping things relatively down low. And so you're going to notice that we're not going to be building up web pages. We're not going to be doing voice recognition or anything like that. But the principles still stay the same. So regardless of where the user is actually entering in the information, be it on a touch keyboard, be it via voice, the fact of the matter is that you're still going to be getting textual data in from a user somehow. So a lot of the concepts that we're going to be going over are still going to apply regardless of where you are. That being said, we are going to stick with the command line, and I think that's always a great way to learn a programming language.
Just one less thing to worry about in the short term. Exactly.
I don't want to set up a button in an event handler in a text box, and you know what? Just let's keep it nice and simple. When we're focused on the language syntax, let's do that. And so that's what we want to do here. So the question then becomes, well, how do we ask the user for information? So let's take a look at my slide here. And right here is a little bit of a basic command. So I'm going to highlight that first part right there, that little input. And input is the command that you're going to use to get information from the user. So you can almost think of this as the opposite to print, that if print is displaying information, input is how you're getting input from the user.
Yep.
Now, the way that input is going to work, and we'll see this when I get in and do my demo here in a moment, is you're going to notice right here that we've got the opportunity to display a prompt. That if all of a sudden we just simply said input, and I'm just looking at a blank screen with a cursor, not going to exactly know what it is that I'm supposed to type. So fortunately, input allows us to add in a prompt. So we can go in and say, what is your name? What is your quest? What is your favorite color? Whatever it is that we want to put into there, we can now prompt the user for that. So I'm going to break this down again into kind of 2 parts. Part 1, input, that's the command. Accept information from the user. And then part 2 is going to be that little prompt, and that's what's now going to display out to get something back from the user. Now, there's also this little thing right here, name. Now, let's kind of go with English here. Name in English, of course, means, well, name.
A person's name?
Yeah, a person's name.
Or a thing's name?
A thing's name. It's how you're going to identify something. So you're going to notice, if we go back to the code here, what is your name? Well, we'd obviously expect somebody to type in their name. So we've got this little thing over here called name. Now, we're going to talk about what this thing is in a minute here. For right now, though, let's treat that tantamount to magic. Let's not worry too much about that. Trust me, this is one of those things where you just have to kind of go with us here. Promise. We will, absolutely will explain what all of that means. Promise you. We're just not going to do it quite yet. So for right now, we're just going to focus in on that part right there. That's all that we're going to focus in on. So again, that input function allows us to get information in, and it's going to give us back whatever it is that the user typed in. So whatever the user typed in, that's now what we're going to get back. And then you are going to notice that we can use a variable to remember what was entered in. Again, we're going to talk more about variables here in a couple of minutes. So kind of just
we'll get into that.
Stick with us there. Now you are going to notice that we could call it whatever we want. So if you wanted to go in and maybe just call that, for example, Wibble instead of name, you could go and do that. It'll work.
It'll work.
Won't make any sense, but it will work. So you're going to notice right here, we're already teaching you a bit of a good programming style here. Use names that make sense. So if you look at a name of something and you're going, I don't know what it is that that's supposed to do, take another look at the name that you've got, because you've probably got a bad name there. Okay, so let me go to Visual Studio here. Let's go in and take a look at a demo, get out of my slide deck here. Okay, so let me go in and create a brand new project. So just File, New Project, Python application, and module 3, and this is going to be strings and variables. There we go. And then let's go ahead and hit OK. All right, so again, we've got that little print hello world. I'm going to get rid of that.
Yep. Don't need that right now.
Exactly. And I'm actually just going to use the code that was on the slide there. So I'm just going to say name equals, and we'll say input. And, ooh, that looks kind of cool.
Yes.
We'll get to that.
Oh, yeah,
all right.
Absolutely.
In the meantime, what is your name?
What is your quest?
Exactly. All right. Now, what I'm going to do, so now we've got the what is your name here, is I'm going to kind of do this in chunks. So I'm just going to click Start up here. And sure enough, you're going to notice my screen prompts me and says, what is your name? Well, my name happens to be Christopher, so I'm going to type out Christopher. I'm going to hit Enter, and it just simply says, press the any key to continue. Not very exciting.
Yeah, but you know, maybe it took the value, but it did prompt you. You got to type something in.
I did get, yay, I got to type something in, yay! There was much rejoicing, yay. But yeah, so it at least prompted me for that, but you know, it didn't really do anything else with it. So I'm going to actually go one step further here just to kind of show that it did in fact store this. Let's go in and say print, and for right now, I'm just going to say name.
Sure.
And now, once again, we'll go ahead and hit Start. I love these little touch screens.
Yeah.
And let's go in and say Christopher, Enter, and sure enough, it prints out Christopher.
Cool.
Fantastic.
You know, there was a neat little trick that somebody showed me with this that I thought was kind of cool. And the way, you know how it shows the, you know, what is your name, and then the cursor's right after it? I ran into somebody who actually wanted the cursor to be on the next line.
Okay.
And I was like, that's an interesting little question. Like, how could I get the cursor to appear on the next line? And what they did is they actually used a print statement to say, what is your name? And then on the next line, they just said input nothing.
There you go.
So it put that way the cursor was on the next line. Kind of
nice. Yeah, I like it. I like it. Yep. All right.
Creative coding.
Yeah. Exactly. And again, you know, it's one of those where there's certainly going to be numerous ways that you could do that. I suppose you could also do that with a backslash. And, you know, so again, multiple ways to solve the exact same problem. So, you know, but I do like that sort of print the display and then input separately.
Yeah. Yeah. Make for a cleaner screen sometimes.
Exactly. Yeah. Yep. Cool. All right. So now, I did tell you there was a little bit of magic there. We just simply had that little, you know, NAME equals and input and blah, blah, blah. That's what we had. We should probably define a little bit better what that name was. Well, what that name was is what we as developers, as coders, which is now all of us, all of us, we like to call those variables. And Susan actually put together pretty much all of these slides, did a fantastic job with them. And I love the analogy that Susan has here, is that it's a box. What's a box? It's a container. It's something that I can put something else into. I can store something into it, so that way I can come back and get back to it later. So whatever it is that you're looking to store to use later, that's exactly what a variable is going to allow you to do.
Yep.
So, you know, I always like to go with a slightly different analogy. So I'm going to go with my analogy here, but I do love this one. I always like to go with a math analogy.
Okay.
I forgot to warn everybody there was going to be math today. I know.
You're asking a lot.
I know.
Right. Some of these people are in time zones. It's getting late.
I know, but I'm on my second cup of coffee, so I'm all set.
Go with the math.
Go with the math. So if we come back to my slide here so I can kind of draw my screen, remember back to algebra class where you had something like 206 minus x equals 42?
Yeah, yeah, absolutely. Basic algebra, 206, and you had to solve and figure out what x was.
Exactly. What was x? Well, x, as it turned out, was really nothing more than a placeholder. That's all that it was. It's just a placeholder. So you would go in, you would do your math, and don't worry, I'm not going to do the whole math, and you would determine that x in this case is going to be 164. 164. I'm double checking my math.
Okay.
Okay, yep.
Yeah, you picked a tough one. But I see that the answer was 42, and that's important.
Yeah, exactly, yes. Yeah. Yep, the answer is always 42. But in any event, so right here, what you're going to notice is that x is a placeholder. So what's a variable? It's a placeholder. It's a box. Whatever analogy it is that you like there, whatever it is that's going to help make it stick for you, I want you to go with that. So it's something where you can store it and come back to it later. Now, needless to say,
Yep.
by the way, why is it that people say needless to say and say it anyway?
I don't know, but I have a feeling you're about to.
I am. Needless to say, and I'm going to say it anyway, you can have multiple variables. And in fact, you're very rarely going to be able to write any level of a program, of a script, or anything that goes beyond kind of a basic hello world without having some level of variable usage. And so what you're going to notice is that you can go in and create multiple variables as needed and give them essentially whatever name it is that you might want. Now, how can you then go in and access it? Well, just use the name.
Yep.
Now, let's kind of break this down a little bit. So we already saw name equals input. Now, what is input going to do? Input is going to prompt the user for a value, and whatever it is that it gets back, it's going to put into that little placeholder. So if I had on my screen here that little input, and I typed in, for example, Christopher, T-O-P-H-E, it looks like one of your kids grabbed a crayon there. So in any event, if somebody wrote out or typed in Christopher, what's going to happen is this is now going to wind up inside of that name variable. So everywhere that I go in and I use name, that's now going to be, in this case, Christopher.
Okay, makes sense.
So this line of code right here would be equivalent, and I'm going to do it with Zoom It because it'll be a little bit easier for me to do. This would be equivalent to me typing out print Christopher.
Yep.
Those two lines of code are equivalent. Why? Well, because again, name is simply that placeholder for, in our case, Christopher, because that was what the user typed in. Cool. And now I need to kind of clean up my screen there. All right.
Getting a little cluttered.
It is. And there's a little screenshot. When you did this, you used a shorter name of
Bob.
Bob. Yeah.
Yep. I'm a lazy, I told you, I'm a lazy coder.
Yep.
Even my test names are lazy.
Bob. All right. Now, like we mentioned before, a variable is a box. It's a placeholder. And so if I take, for example, that little box, and I dump that box out, what I've got now is an empty box. So could I take that empty box and could I put something else inside of there? And the answer, of course, is absolutely. So if I take that box, I empty it out, and I put something else inside of it, now what's going to be inside of there is going to be whatever that new value is. So if we come back to the slide here, what I want you to notice, I'm going to do it with Zoom It. That's a little bit easier for me. There we go. We'll go with blue. So what you're going to notice here is that we said name equals input, and then they typed in the name. By the way, one real quick side note here. You are going to notice that we don't need a declaration in front of that variable.
Yeah, and that's one of those ones, and you can open up a whole can of worms of, oh, but you have to be able to declare your variables. Let's not get into the great debate, or is it better to use a programming language that requires you to declare variables or not declare variables? Remember, we said Python is a very forgiving language that is trying to make it easy for you to get going with code. So no, you do not have to declare your variables before you use them. If you use a variable name in a line of code, it goes, I've never heard of name, I'll just make it now.
Yep, exactly. Yeah.
There's pros and cons, but yeah.
And yeah.
It is what it is.
and this is a debate that we could get into for the next 4 hours, but we're not going to do it. So there it is. So it will just let you declare your variables right there on the fly, and it will try to figure out what it is that you're doing. One of the things that we'll see over the next couple of modules is that this does sometimes wind up causing a little bit of problem when we're trying to deal with numbers and things like that. But for right now, with strings especially, it will just kind of roll with the punches.
It is what it is.
Exactly.
Yep.
There we go.
Every programming languages has things you will like about it and things you will not like about it.
Yep.
So, but anyway, it's good to just be aware that no, Python does not actually require you to declare the variable before you use it in your code.
Yep. Okay, cool. So what you're going to notice here is sort of the same demo that we had before. So what is your name? And then print, and then whatever the name is. And then what you're going to notice here is on the next line, let me just change my color here. We said name equals Mary. Now, one of the things that I always like to do whenever I'm kind of doing demos is I always like to show you based on what we've already seen. So what did we already see? How do I take something and put it into a variable? That little equal sign right there. So that little equal sign, let me just clear out my screen here, kind of make it a little easier to read. That little equal sign, that's what told Python to take whatever it was that came back from here and put it there. It was that equal sign.
Yep.
So if I use that equal sign again, and I say just hard-coded string Mary, and I use that equal sign, and I put that right there into name, what do we think is now going to happen?
I'm thinking that maybe the contents of name have changed.
And I'm thinking you're right.
Awesome.
So again, keeping with that box analogy, we took the box, dumped it upside down, and then we put Mary into it. So down at the very bottom, you're going to notice that we print out the name. So if we take a look at the results here, kind of a little sample down here at the very bottom, what you're going to notice, and I'm thinking yellow is going to show up really well here, you're going to notice that we typed in Bob. That was the initial name.
Yep.
And so kind of going back to before, what we did was we took that input, we printed that out, so that's why we got Bob.
Yep.
Then on the next line, we updated that to Mary, and then we printed that out. So when we go to print that out the second time, now what you're going to notice is that there is Mary the second time.
Awesome.
Yeah. All right. So with that, let's go in and demo this here. So let me kick out of my slides. Discard, and I want to be there. There we go. Okay, so we're going to keep on keeping on here. So what I'm going to do, I'm going to throw in a real quick comment here. Collect a name from the user.
Yep.
And let's just go ahead and display the name.
Excellent habits, commenting your code.
Absolutely. Yep. And then now let's go ahead and update the value. And let's go ahead and say name equals, and let's say Christopher Harrison, for example.
Picking a name at random.
At random.
Yes.
Exactly. And now let's go in and say, we'll say print name. Beautiful. So now, one more time, I'm going to click Start. There we go. So what is your name? I'm going to put in Susan there.
All right.
And then I'm going to hit Enter. And now what you're going to notice is that it prints out Susan the first time. So again, let's go with a better color. There we go. Yeah, you know, one of those things, the tool that we're using to draw on our screens when we're not in PowerPoint is a little tool called Zoom It. You can fire up Bing, do a search for Zoom It, all one word, and it'll be like the first link there, download it. It's available from Microsoft. It was a tool that somebody named Mark Wasinovich put together. It's a fantastic presentation tool. If you're doing presentations, can't suggest it highly enough. But every now and then it just wants to go, well, you probably meant a straight line. I was slightly off, so it said, well, you probably want a straight line, and that's why I'm slightly off down there. But in any event, so you're going to notice print name. There we go. And then what you're going to notice right there is, once again, print name and then Christopher. So we took what was in name, got rid of it, and then put something else inside of there. Cool. All right. Now, something tells me that there is some form of rules around naming variables.
I mean, I can't just come up with any name I want for my variable? I mean, are you going to be picky about this?
I think so.
All right.
I think so. So let's break it down here. So let's talk about some variable names here. And let's highlight the rules first. So first of all, number one, the rules are cannot contain spaces.
Makes sense.
So got to have, all one word.
Okay.
Because really, if you put in a space, now Python is trying to figure out, okay, well, did you mean a space because you were going on to the next thing, or did you mean a space that's going to be part of this?
Yeah, or is it two variables, or
exactly.
Yeah, it is confusing.
Yeah.
Space is meaningful in Python.
Yeah.
There are some programming languages where having spaces in one place or another doesn't affect your code at all. Python is actually, there are situations we'll see later today where adding spaces or removing spaces can actually change the way your code runs.
Yeah.
So you do need to be cognizant of spaces in Python, and in variable names, it's just flat out not allowed.
Exactly. Yep. Can't have spaces. Number two is it is case sensitive. And if I
That's a big deal.
It is. If I was to say the number one question that I get whenever I'm teaching any language to a group of people that are learning this for the first time, the most common question, probably the first question that I always get is this case sensitive? Now, my answer to this is actually not to answer the question. That my answer to this is treat everything like it's case sensitive. Because if you treat something like it's case sensitive and it's not, you're fine.
That's true.
But if you treat something like it's not case sensitive and it is, you wind up running into problems. And one of the questions that kind of come through on the chat window have been things like databases and so forth. So obviously we can start working with other external systems. Well, one of the things that you find from time to time is that you might be programming in a language, let's say like PowerShell. And PowerShell is not case sensitive, but PowerShell is going to be accessing other things, maybe like SharePoint. And SharePoint is case sensitive all over the place. So if I'm treating PowerShell like it's not case sensitive, now all of a sudden I'm going to run into a problem because I typed something in that's going to be passed into SharePoint where it is case sensitive, and now all of a sudden something breaks. So treat everything like it's case sensitive because it's going to help you avoid those kind of what I like to call mixed case scenarios where it's case sensitive here and not case sensitive here. And really just in the long run, it's going to make your life just that much easier.
So this is just one of those best practices we were talking about earlier, right?
Yeah.
So every now and then, you just want to make sure that, said as a best practice, just assume that an uppercase N and a lowercase n does not mean the same thing.
Exactly.
And you're talking about it here in variables, but it's also important to be aware that that's true of commands as well. There was actually a comment earlier inside the questions that said, hey, I typed input with an uppercase I, and it didn't recognize the command. It gave me an error. Well, those commands are case sensitive as well. And I also just want to quickly mention with the Q&A, something's going on with the Q&A display right now, so I can't see the questions you're posting at the moment. So if we're not answering, we're not ignoring you. We just aren't seeing the questions. So we'll try and get that sorted during the next break. But so the commands are case sensitive as well as the variables.
Yep, exactly. Exactly. The other last rule is it cannot start with a number.
And that's one that people don't expect.
Yeah, exactly. Yeah, and this is something that's kind of common. But if you're brand new, yeah, exactly. You're like, why can't I call this, 3 names? And I'd be storing 3 names inside of there and just use the number 3. It's just it is one of those things where the programming language, if it sees a number, it's expecting number. Now that's not to say that you couldn't do name and then the number 3. That would be fine.
Yep.
But you can't start with a name.
Yeah, that's just one of the rules.
Exactly. Now let's keep on keeping on here with our variables, and let's talk about some guidelines here. So this is a big one for me. Should be descriptive.
Oh, the number of times I have seen code where the variable name is A or X. And I'm like, well, the thing is, when you start writing code that has 26 different variables, you start going, what was an X again? Where did I store that? Did I store that in X or A?
Exactly.
Yeah.
And if there's, there's a
Spit it out, Christopher. Spit it out. You can do this.
I'm going to get there. So there's a book out there, refactoring code, and it's kind of written for Java, but it's put together by Martin Fowler and a couple of other people, and it has this great concept in there called smells.
Okay.
That code can sometimes have smells, which it's sort of like, you go to the fridge, you open up the carton of milk, you give it a whiff, and it smells a little off. Now, just because it smells off, does that necessarily mean that the milk is bad? No. It means that it might be bad, but you're not going to know until you taste it. And I always love this concept that I'll go ahead and, I'll take a swig. Oh, that's awful. And then I immediately, hand it to somebody else. Here, try this. And, it's not so much, I almost kind of understand the concept of, getting somebody else to test that. The part that I can never understand is the person who's now accepting this. You were just given information. This milk is bad. Here, try this. And of course, what do you do? Okay.
Duly noted, Christopher. The next time you hand me a glass of milk, I'm not drinking it.
Exactly. There you go.
But you're right. But you're right. Sometimes you look at code, and when there's a sense to it. This, you look at the code, and instinctively your reaction is, I can read this, I can follow it, it's clean and easy to understand, or, okay, this may work, but I'm having real trouble understanding it.
Exactly, yeah, and it's not necessarily that it's bad, it just doesn't look quite right. There might be something off there. And so there's that little concept called a smell. And one of the smells is, and I know this is going to contradict us a little bit here, is having comments in your code. Now, that's not to say don't put in comments. Comments are wonderful. But if you have a comment and it's having to explain a line of code, you really should stop and take another look at the line of code that you've written and make sure that the line of code is as readable as possible. And sometimes there's nothing you can do. Sometimes it's just, some little library, or that unfortunately the way that something is built is just a little clunky, and that's just the way it is, and that's fine. But there are times where what you're doing is you're using that comment instead of just writing code that's easy to understand. So if you have a comment saying X is used to store the user's age, that's a problem. That instead of using X, you should be using user age.
Yeah, it's very good to have descriptive names. It makes a difference. And I strongly recommend, if storing a date, or if you're storing a date in particular is a great one. Don't just call it date. First of all, that might be a reserved word that you're not allowed to use in certain programming languages. Call it birth date. Call it expiry date. Be specific about what it is. But yet again, you don't need variable names that are 82 characters long, because that's going to take you a long time to type, and we're all lazy coders. But even though I'm a lazy coder, I do use meaningful names for my variables.
Exactly. The other thing is about casing. So let's kind of take a step back here. And remember, again, case sensitive. So you do want to choose a scheme, if you will, which is basically just make this decision and just always do this over and over again. And so I've given you the two common ones, which is Pascal casing and camel casing, which are written exactly the way that they're set up. So Pascal casing starts with a capital letter, and then every word thereafter, no underscores or anything like that, it's just simply appended right in. And then there's camel casing, which starts with a lowercase letter.
Which is, if you look at the slide there where it says the word favorite sign and your favorite sign, the horoscope, those are actually examples of camel casing.
Yeah. And in Python, camel casing generally is the way to go. Guess what day it is? Sorry. There's a handful of people that will have gotten that reference.
I didn't get that reference at all, Christopher, just for the record.
That was a US-centric reference.
If there was someone else out there who didn't get it, I'm right there with you. All right, moving on.
That was a US-centric one. I apologize.
Just keep going.
I'm just going to keep going. All right, so back over here, then let's go ahead and take a look at some of the different variables that are there, and let's go ahead and highlight the ones that are good. Well, starting up at the very top, we've got variable 1.
So variable 1, that should be valid.
It's valid.
It's got a number inside the name, which is okay.
But it's at the end.
But it is kind of a weird name for a variable. It's not very descriptive.
Yeah, exactly. Like if I look at that, I don't know what's inside of it. So I'm going to highlight that one in red. That one's not really good.
Now, first name, there's a definite problem with the first name, because I've got a space in the variable name, and Python's going to get confused by that.
All right, so we can't use that one.
Date, that's one Python would probably work if I use that as a variable name, but the problem with that is it's not descriptive. It said, what date are you storing in there? We often work with a lot of different dates: start date, end date, birth date. Be specific.
Okay.
3 name, that one's, Python won't even let me do that. It's going to give me an error because I'm using a number at the beginning of the variable name.
Okay.
DOB, that's an interesting one. It's a valid name. I said Python's not going to give me an error because I've done that. But at the same time, it's a little confusing. I think it might depend who I was writing the code for. Like, you know what? 3-letter acronyms exist everywhere.
They do. TLAs, three-letter acronym.
Yeah. And if it's an acronym, but everybody in that organization knows and uses every day, then it's okay to use an acronym for your variable name. But,
exactly.
So if I'm working at a hospital and I'm storing date of birth and everybody refers to it as DOB, then I think that's fine.
Exactly. Yeah.
But if it's not a commonly used acronym, I would stay away from it.
Okay, so we'll put that one in yellow. How about date of birth?
I'm good with that. I like that. Date of birth, it doesn't have any spaces of a name, no numbers at the beginning, and it's descriptive. I think that one's good.
Okay, and then how about your favorite sign in the horoscope?
Again, descriptive, doesn't contain any spaces, doesn't have a number, but I'm lazy, so I would just find that really long to type. So that would be the only reason I would avoid that one.
And going back to something that you mentioned before, context is key. Context is king. So if I'm writing a sign a program where I need to know somebody's favorite sign, I know what we're going to be talking about there. So if I was doing something that involved horoscopes, I'm going to know that's what I'm writing. So if I say sign, I know that I'm not talking about a street sign.
Yeah.
I know that I'm not talking about a neon sign. I know that I'm already talking about horoscope. So I could handle this without writing out in the horoscope in that type of an application. So context is key. And again, kind of going back to DOB, is that are abbreviations bad? Abbreviations are a smell. That it can be bad, but not necessarily. Context is king. So if this is something that you would absolutely need to know in order to work in your industry, in order to do your job, then it's perfectly acceptable to use it. If everybody knows exactly what that is, perfect. If it's something where you're having to define it, again, that's a smell, might not necessarily want to go in and do that.
Yeah.
Okay. Now, prior to that little spot, what we did was we took the box, we dumped it out, and we put in a brand new value.
Yep.
How about taking the box and adding something to it?
All right.
Or working with the value that's already there.
Okay.
Well, this is where manipulating our variables come into play. So why not have the ability to just simply use the plus sign to concatenate things together? So we'll grab somebody's first name, we'll grab somebody's last name, and then we'll go ahead and concatenate all of that together.
That's a really useful thing. You want to, because a lot of times when you're displaying output on a screen, it's going to be a combination of information you have in variables and static text that you want to display. So that's very practical.
Yep, absolutely. And sure enough, you're going to notice, and pen, and there we go. And there, of course, down below is my little hello, John.
So I got to say, that's it worked, but it's kind of, well, I don't have any spaces or anything between them.
Yeah, that'd be a good variable name, I guess.
Space?
Well, no, see, hello, John Doe,
Hello,
because
John.
there's no space in there.
All
right.
Okay.
But seriously, folks, so you're going to notice that we do have the ability to add in those spaces as needed. So if you want to put in spaces, feel free to put in spaces. So whatever, string concatenation it is that you want to do, whatever combination of strings that it is that you want to put together, you absolutely have that ability. And so now you're going to notice that's a much better display. I've got my spaces between hello, John, and Doe.
And we were talking earlier about coders make mistakes. I can almost guarantee that somewhere along the way you're going to be doing something like this and you can either have too many spaces or not enough spaces. So just get used to whenever you're doing that, take a look at the output and then go back and fix the spaces afterwards.
Exactly.
We all do it.
Yep. Okay, so let's go back to my Visual Studio here and let's take a look at a demo. So what I'm going to do is, real quick, I'm just going to comment out those little spots right there. And this is one of my favorite little things to do is a lot of times, especially when you're like debugging or just kind of playing with things, you want to turn off, if you will, a bit of code. Well, you can just go ahead and comment that little bit of code, and it's treated just like normal text, or normal text comment, I guess would be a clearer way to do that. So you're going to notice that I can just put comment, comment, and now both of those are gone.
Yep.
So now, and I'm just going to leave those down at the very bottom there. There we go. Let's go ahead and say create a friendly output. And so what I'm going to do is I'm going to say print, and we'll say name plus, whoops, let's go the other direction. Let's say hello, and then plus, and then name, just like that. Yep.
Perfect.
And so now let's go ahead and hit start. What is your name? Christopher. Hit enter. And now you're going to notice that I've got hello, Christopher. I still had the one little one from before. Let's just comment that. Come here. There we go. All right. Perfect. And now let's start. What is my name? Christopher. And then hello, Christopher.
Fantastic.
Awesome. OK. So now, oops, I want to be here. I'm going to go back to my slides. Now, you're also going to notice that you could go in and kind of do whatever you want. So, little storyteller, kind of a Mad Libs, if you will, here.
Yep. And you know, it's funny. It seems so simple, but I have seen an entire business based off this basic functionality. I recently had a friend who got married. Mm-hmm. And I was trying to find a suitable wedding gift for them. And I discovered that you can order personalized romance novels. You provide the names of the characters, their hair color, their eye color, and it inserts their names into the story. So, so it says, Christopher spotted his wife Karin across the crowded room.
Sure.
Her blonde hair flowing in the wind inside the room because the window was open. But the neat thing is, really, if you think about how the code was implemented to do that, in the end, all they did was the print statement was an entire book. Mm-hmm. And everywhere the name appeared in the book, they just replaced with name typed in by user.
Yep.
Eye color replaced by eye color entered by user. And they have built an entire business off that functionality.
There's your $1 million idea.
Yeah, well,
and away you go.
Yeah. So I have a friend who was asking, would like crime writer version. So if you're really mad at somebody, you could, have them write them into a mystery of some sort.
Perfect. All right. So you'll notice that you can do kind of all sorts of really complex string concatenations as well there. Now, one of the problems with dealing with strings is that the user can input whatever it is they might want.
Yep.
And sometimes I'm going to take whatever it is they've given me and I need to tweak it. I just need to make sure it's uppercase or lowercase or otherwise. And so wouldn't it be nice if we had some way to go in and manipulate those things? And so sure enough, you're going to notice that we've got that capability. We have a little example right here where we go ahead and we say message equals blah, blah, blah. And then you'll notice that we can do lower, we can do upper, we could do swap case. I wonder what those are going to do.
Yeah, those are lower. I think I might be able to guess. I think lower is going to take the phrase and convert it to lowercase, whereas upper is going to convert it to uppercase. Okay. Not too sure about swap case, though. That's an interesting one.
Well, something tells me if I go like this, there you go.
Oh,
there's our little output.
It took everything uppercase, made it lowercase, and everything lowercase made it uppercase. So it swapped the casing.
There you go. So there's our lower, there's our upper, and then you'll notice on the swap case, and let me kind of highlight that little hello right there. What you're going to notice is that little hello, let me zoom in on it, that first little Y there is now lower, whereas when we initially had it, it was upper. So we took all the cases and just, swapped them out.
Neat.
Perfect. Well, let's go in and kind of demonstrate that.
Yeah, because that's very useful because sometimes people type things in. I'd be working things where people maybe typed in an abbreviation for a country, and you want a 3-letter abbreviation, and some people type it lowercase, and some people type it uppercase, and some do like the first letter uppercase and the rest in lowercase. But you kind of want it consistent when you're keeping the information or storing it in a database or something later. So being able to take the data they've inputted, switching it to uppercase, so even no matter how they entered it, I wanted an uppercase, that would be awesome.
Yep, yeah, consistency in a database. A lot of people have been asking database questions. Yeah, consistency in a database, that's a big thing.
Yep.
All right, so let me come back over to here, and I'm going to just kind of update my code, and I'm going to say country equals input, and let's go what country do you live in? And we'll go ahead and do that. And then I'm also going to say country equals country dot, something cool is happening.
Oh, yes. Oh, yeah, later? Okay, that little box is cool.
It's kind of cool. Okay, all right. So in any event, I'm going to go and I'm just going to say upper like that. So what that's going to do, and this is, kind of a little bit complex here, but I want to talk through it. So let's kind of go how Python's going to read this. So what Python is going to do is it's going to read the right side first. Now the reason that it's going to read the right side first is because it's seeing an equal sign. So it knows something's going to be coming into country here. What is it? Well, it's going to be whatever's over here, so it's going to run that side first.
Okay.
So what it's going to do is it's going to run that side first, which means that it's going to convert that into uppercase letters. So if I had typed in FR for France, it's then going to convert that to capital F, capital R.
Yep.
That's going to be the first part. So this is now what we have, and then it's going to replace what was in our country box with that new value. So what was in there before is now going to be gone and replaced with something else. So again, just to kind of beat this analogy into the ground here, basically imagine, if you will, that you had, let's say, two pieces of bread inside of a little box.
Okay.
Keep going with me here.
I'm waiting for it.
Okay,
Yeah.
so I had two pieces of bread inside of a box. What I did was I pulled out those two pieces of bread, and I then put peanut butter and jelly on those. And then I put it back into the box. So what I did, that box is still the exact same placeholder, but I just simply modified the value that was in there and made it something new. So instead of just two pieces of bread, now I have a peanut butter and jelly sandwich.
Very nice.
Yes. So what I've done is I've modified what we had and put it back into that box.
So now if you display it on the screen, we should actually see the country in uppercase, regardless of how someone's typed it in.
Exactly. So let's go in and say, hello name. And by the way, I realize that I'm sure that the chat window is abuzz with people yelling at me for this. So let me just kind of go with single quotes here. I kind of went back and forth a little bit on single and double, so I'll just go with single.
Trying to be consistent.
I am.
Good habits. Good job.
Yep. All right. So see, kind of going back to, learn good habits right away. That way, you don't do things like that. Here we go. You live in... And let's go in and say country.
Awesome.
Waiting for my red squigglies to go away. Perfect. So now let me go ahead and hit start. What is my name? Christopher.
Yep.
Enter. What country do I live in? US. Whoops, we'll do it in lower.
Yeah.
There we go.
Yeah. Okay.
We'll do it lower. Actually, I'm going to go with FR, even though I don't live in France.
Okay.
But I'm going to go with FR just so we can see the casing a little better, because a big U, big S isn't
that's fine.
as clear. So now I'll just go in and type that in.
Very nice.
And sure enough, it says, hello, Christopher, you live in FR. Perfect. Okay. I also want to do this. I'm going to put in a line break right at the very beginning there, just to kind of make that a little...
Make it look nicer by putting it onto a nice, tidy new line?
Yep.
There you go. Makes a nice little space in front of it.
There
Very cool.
Excellent. All right. So let me go back to my slides here.
I like how you're starting to put it all together. Taking what we learned in the previous module, using it inside this module, and that is how coding tends to work. You pick up little things, and what you picked up earlier, suddenly you use later on in your code.
Exactly. Exactly. So now let's go ahead and talk a little bit about some of the different things that are available. So lower, upper, swap case are different string functions. Ooh, function.
Yeah.
So function, just again, is something with a name that will do something for us, like print and input, upper, lower, all functions. They will do
things for
something. Exactly. Now, because of the fact that we're storing that string inside of a variable, we can use any of those string functions to manipulate those strings. Awesome. All right. Speaking of awesome.
Yes.
What in the world was that little pop-up list?
That is one of the most awesome things that I love about Visual Studio, and there are other coding editors that have it too, but it's called IntelliSense. And what IntelliSense does for you is when Visual Studio knows you're working with a string variable, when you hit that little dot to type in upper, it actually is intelligent enough, hence IntelliSense, to know, oh, wait, you want to call one of the functions to manipulate that string.
Yep.
And Visual Studio knows all the valid functions. So it will actually pop up a little box for you that lists every single function you can choose from. So this is great. So you don't have to remember exactly how something's typed or the exact spelling. Like, was that case swap or swap case, or was that to upper or upper? Little details like that, it'll be right there in the IntelliSense. So that basically, and it's great for lazy coders because instead of having to type the function name, I can just select it from the list.
Exactly. Yeah. And in fact, here, let me, I think the best way to sort of see this is to go in and do it.
Yeah, I think a demo is good for this.
Exactly. So let's just kind of go right back to country.upper, and I'm just going to eliminate that, and I'm just going to do it again. So we'll just go ahead and say country equals, and let me go ahead and say country, and then you'll notice that if I hit my dot here, now what you're going to notice is that I get that little list of available methods or functions that I can now use. So what I could do is I could say country dot, and then you'll notice that as I start typing, it'll automatically start highlighting what it thinks I want. So since I typed the letter U, it's thinking I probably want upper. Makes sense. Now, you'll also notice dot U. Ooh, something cool happened. Let's do that again. So I hit a dot, typed U, and you'll notice that upper was highlighted.
It was.
Now, I could double click.
Yeah, if you're a mouse person, that's how you're going to do it. You're going to click the value you want from that list. But if you're a keyboard person, because some people like to do everything with the keyboard.
Exactly. So if I say U, and if I type the next special character, like a parenthesis, like a dot, that I want after that, it will automatically complete that.
Cool.
So you'll notice that I went paren, and it automatically completed that.
So you typed, so after the U, you typed an open parentheses.
Yeah, exactly.
Okay.
So I can go in and I can say country equals country dot U, or dot U, open paren, close paren. So right there, I've saved myself from having to type out PPER. I've saved myself 4 whole keystrokes there.
And score points for the lazy program.
Oh, absolutely.
You can use the Enter key as well, though, can't you?
You can use the Enter key. So you can say U and then hit that. But it just won't give you that paren.
The open parentheses, okay.
And you also can say tab as well, and that will also work.
Enter key, tab key, but the advantage of the parentheses is that it gives you the opening parentheses.
Exactly.
So. Okay, that's cool.
Yeah. Yep. Yeah. All right. So with that, you're going to notice here that we've got a list of some different functions here. And
all right. This is interesting.
What it is that they do. And what I'm going to do is I'm just going to kind of leave it there, and I'll skip right to the answer.
Oh, you're going to the answer. Okay. So we're going to reverse engineer.
Well, sort of. Doing? Yeah. So the first big thing that I want to highlight is we're obviously not going to go through every single function that's available.
No, that would take a very long time.
We'd be here a lot longer than 2 days.
Yes.
The second thing is, and this is really the main goal of the slide here, is you're going to notice that a lot of this is intuitive. So you're going to notice, for example, something like replace. What does replace mean in English?
It means replace one thing with something else.
Yeah, it means swap it out. Yeah, exactly. So you're going to notice that we said replace hello, come here, with hi. And so sure enough, when I go in and I take a look, that's exactly what happened. Now, you're also going to notice that we've got capitalize, which would have put in that capital H there, which we happen to already have. So that's why we're kind of getting that little display. It hasn't changed, but it would capitalize, put in that first little H. You're also going to notice that we've got count, and let me escape out just to clear out my screen here. And so count, of course, is going to count the number of O's that happen to appear.
Okay.
Now, the one that's maybe a little bit different than what you would expect is find. Now, find, of course, is going to, well, find something. But the question then becomes, well, what's it going to return?
Yeah, how is it going to tell me if it found the word world inside that string?
Exactly. So let's reverse engineer here. Let's take a look at the number that we got. So the number that we got was 6. All right. Well, what's the significance of 6? Well, you're going to notice right up here, 1, 2, 3, 4, 5, and 6. So you're going to notice that there was 6 characters before world.
Okay.
So it's telling us the number of characters that came before whatever it is that we tried to find. Now, the other thing to keep in mind, we got counting based on zeros, so it's really 1, 2, 3, 4, 5, and so forth, and
I was
6.
going to say, it's actually telling you it's a nice way to remember it, though. In fact, it's telling you the number position of the first letter of the string that's returning.
Exactly. Yeah, that, in fact, if I go back and I do this again, and I started with the 1, 2, 3, just to try to keep it a little bit simpler. But counting in Python, like in most programming languages, starts with 0. So you'll notice that it's actually 0, 1, 2, 3, 4, 5, and then finally 6.
Right.
So what it's giving me is it's giving me the position,
Where
the starting position,
where what it was searching
where
for.
that word world is. Now, that's something where you might look at that and you might kind of go, well, all right. But you are going to notice that that is pretty consistent throughout every programming language.
Yeah.
That if you're working on a lot of curly-based languages like C# is like this, where it's got index of works just like find here. So again, going back to something that we mentioned before, that what we're trying to do is really kind of teach you these concepts. And so find, like index of. Now again, we're not going to memorize everything.
Yep.
So how do we go in and find them? IntelliSense, and honestly, that's
IntelliSense is great.
probably the best. When in doubt, type the name of the variable, hit dot.
Yep, and see what pops up.
Exactly. There is documentation.
Yep.
F1 can help you. And then, of course, internet searches.
Absolutely.
Stack
Nothing
Overflow,
wrong.
Bing, yeah. Just www.bing.com, type in whatever it is that you want.
I want to convert a string to uppercase and see what comes back on your internet search. And make sure you specify the programming language.
Yes.
I am a Python, how to convert string to uppercase. And you will find a link to documentation or a blog post or something in Stack Overflow with some suggestions.
Exactly.
Almost every time.
Yep. Yeah. That's really the way to go. So with that, let's talk a little bit about something like, what happens if they entered in a postal code and we want to convert into uppercase letters.
Because in Canada, postal codes follow a pattern of letter, number, letter, number, letter, number.
Yep.
But they are supposed to be all uppercase.
Yep. And so sure enough, you're going to notice you can just simply do that that to upper, and we've actually already done a demo
you've done
on
that
to
demo.
upper. Yeah. So I think we're good there. And you are going to notice that every now and then IntelliSense doesn't appear.
And that's annoying. You start relying on it, so when it doesn't appear, you're like, where's my IntelliSense? Bring it back.
And there can be a lot of reasons for this. Sometimes it's because you've got a bug earlier on in your code, you mistype something. And sometimes, and we talked about this earlier, that with variables, you can just simply declare them on the fly. And when Python runs, it will figure out what that variable type is, which is fantastic, when it runs. But unfortunately, at that moment, Visual Studio can't always figure out what's about to happen. And you see this with Python, you see this with JavaScript. And so sometimes what you need to do is just sort of seed, if you will, Python.
Give it a hint.
Yeah, exactly. Kind of tell it what it is that you're doing. And so you'll notice right here that what we did was we just went in and we said postal code equals, and then an empty string.
Yep.
Or put a space in it. Either way would have worked.
Would have worked, yeah.
But, just put something in there that's a string, and so then from there on forward, it will know that it's a string. So you kind of told it right up front, hey, this is going to be a string, and then it was able to go in and treat it as such.
Yeah, that actually came up earlier in the Q&A. Somebody was like, hey, my IntelliSense isn't popping up, and I'm not sure why. Said, if you have a variable name, and you hit the dot to try and bring up the functions to manipulate the contents of that variable, to work with that variable, how can Python know if you're working with a string or a number or a date?
Exactly.
You have to give it a hint.
Yep.
So if it's not popping up and you want that IntelliSense, you might, one of those good habits, you may want to declare your variables ahead of time or create the variables ahead of time with the correct data type. So later in your code, when you're accessing the functions, you get that IntelliSense.
Exactly. Yep.
Cool.
So I've got good news and I've got bad news. Good
All
news
right.
is functions are very powerful, can help us out.
Yeah?
Bad news is gives us new opportunities
Oh.
to go in and make mistakes. So you are going to notice that each little line there does have a mistake. And if we just kind of kick through them here real quickly with hello world, what is it?
I think you're missing quotes around the string hello world.
There you go. And with the next one,
The variable name 23 message is not a valid. We cannot start a variable name with a number.
yep. And then on the next one,
A variable name, I think that's intended to be a single variable called new message.
there you go.
And so you can't have a space in your variable name.
All right, I'm going to skip the next one, and I'm going to go down to item 5 there.
That's a sneaky one, and it's the kind of thing that gets you. I forgot an S in my variable name. And so there is no variable MESAGE. That should have 2 S's.
Okay, and next.
This is a sneaky one. You know what it is? Because the syntax looks good, but the count function expects me to tell it what character I want to count. So I forgot to pass it the value that I want to look for and count.
And you're also going to notice right up here, along those same lines, kind of a sneaky one, you're going to notice no parentheses are there. And that's what that problem is.
I make that typing mistake so often in my code. That's probably one of my most common mistakes, is I forget to put the open close parentheses, and you get these weird error messages, and you're going, why is it complaining about line 6 of my code? And on line 5 of your code, you forgot the open and close parentheses.
Exactly. Yep. So let's kind of come back right over here to my system. So kind of a couple of rules here. Number one, if you're using a function, you must have parentheses.
Yep.
That's number one. But number two is I'm going to go in and I'm just going to type out count. And what you're going to notice is that when I go in and I open up that parenthesis, you're going to notice that I get a little bit of inline documentation as well. Now, unfortunately, it's not always as clear as you might want. You're going to notice that it says return the number of non-overlapping occurrences of substring in string s start end.
That's clear as mud.
Okay,
meaning not clear at all.
Yeah.
But it does at least give you a hint that I have to enter a value.
It does.
This is the point where if I wasn't sure what to do, I'd go and I'd do an internet search and I'd find some code examples where someone had written me a nice blog post explaining what it did.
And that's really it. Yep.
That's what we do.
Exactly. Okay. So, what do you say we close this off and give everyone a challenge here?
Yes, we need a challenge.
So your challenge is create that program that allows somebody to personalize a story. So take a page from a book or just make up a story. You know, blank ran up a blank with a blank.
Yep.
There you go. And then prompt people, kind of, you know, old little school where you filled in the little blanks there. Go ahead and prompt people to punch in a name, a noun, an adjective, a verb, whatever it is that you want, and then display that story out. And then again, for extra credit, you could go in and try to correct things like casing and so forth. But I would really say kind of focus in on that top one, those top two bullet items right there.
That's just said. It is extra credit. If you once you get that working, then go back and see if you can add the extra functionality.
Exactly. So, and again, if you get a little stuck, you know, feel free to go ahead and grab the solutions that we have inside of
But remember, our suggested solution. You may come up with a solution that is even better than ours, and that's all good.
And that's it. So congratulations. You can all now write a program that's going to interact with a user.
Yes. Congrats.
Excellent. So what do you say we take 10?
Yeah.
And then let's come on back and let's talk about something other than strings.
Yes. Because I think when we want to get to the next level of power, we need to work with numbers and we need to figure out what we can do with those. So we're going to take ourselves to the next level and start messing with some math. All
right. We'll see you guys back here in 10 minutes. All right, well, welcome back. This is, of course, Introduction to Programming using Python. I'm still joined by Susan Iback. I'm still Christopher Harrison. And we last left off playing around with variables, playing around with strings, but not everything.
No,
is a string.
No, we talked about how the purpose of programming is really to allow us to solve problems. And a lot of the problems that we face day to day involve numbers.
Yep.
So one of the things we need to get into is how do we start dealing with numbers inside of our code?
That's a great question. How do we start dealing with numbers inside of our code?
I'm so glad you asked.
Well,
All
thank
right.
you.
So let's.
It's like I knew the module that was coming.
It's like you read the agenda.
Hey, you know.
So a lot of the problems we do encounter when we're working with code do involve working with math. You might need to calculate how much you're going to pay on a mortgage. You know the total cost of a house or total cost of a car you want to purchase. You want to pay it off in 5 years or 30 years. And you need to calculate, well, what would the monthly payment be? So you can figure out if you can afford that car or that mortgage. Or maybe you're trying to figure out how much something is going to cost when you add taxes. Because that's one of those fun things, in Canada, oh my gosh, it's great fun. Different provinces have different tax levels. There's a federal tax, there's a provincial tax. Some items are taxed, some aren't. How much should I leave someone as a tip at a restaurant? How much milk do I need to use in this recipe if I double the recipe? There's so many different scenarios where math is required to solve the problem.
So there is going to be math today.
So I'm afraid there is going to be math today.
Okay.
My apologies. But I promise we'll take a nice long break after the math, a nice meal break there, so that everybody can recover from the math.
Okay, excellent.
So it's very important that when we're working with our variables, that we can store numbers in the variables as well as strings. And if you actually take a look at the slide here, you'll notice it just says, I've got a variable called age, trying to stick with those meaningful variable names like we were talking about last module. And I've just set it to 42. Now, one of the things about this is, how do you think, and I'm going to, maybe Christopher, I could hit you up with this one. How do you think Python knows that that value age is a number and not a string? So if you look at the slide, what's different about that code?
No quotes.
Bingo. That is key. If you put quotes around 42, it is now a string that contains a 4 and a 2.
Yep.
But when you store a value but has no quotes around it, then if it's a numeric value, you're now basically creating a numeric variable. And you can print it out. You can store a width. You can store a height. You can do math with it. So you can multiply a width times a height. Now, a lot of the symbols you work with when you're doing math are very similar to what you normally work with. If you notice here, I could do addition and subtraction, but you might notice here that I've got, that wasn't quite what I meant to do. Sorry about that. Fix that. I meant to use a highlighter. That was my mistake. There we go.
I do that constantly.
Yeah, so you've got this asterisk symbol here between the words width and height. In programming languages, Python is no exception, most programming languages use an asterisk for multiplication, even though I know when we were learning math in school, they used the little X symbol for it. But the problem is X is a letter and it causes confusion. So we use the asterisk to indicate multiplication inside Python. You can combine addition and subtraction. Addition is just a plus symbol. Subtraction is just your standard minus symbol. You can use parentheses to indicate the order of operations in your math. So I can calculate a perimeter by taking double the width and adding that to double the height. Or I could say double the width and the height added together. I mean, it's the same end result. So I can do basic math using these different numeric values. The most common math operations you're likely to work with, you're definitely going to end up doing some addition and subtraction. Nice thing is the symbols on those haven't changed, so you already know this.
Plus, minus.
Plus, minus.
Fantastic.
Division is the same slash you're used to. Multiplication is the one that's going to confuse you. Instead, it's an asterisk, not an X. If you want something to calculate a value, you want it squared, or you want it cubed, or to the power of something. The exponent is actually asterisk, asterisk. So that's one of the more confusing ones there, is the double asterisk. So if I take 5 and I want the number value of 5 squared, then it's going to be 5 asterisk, asterisk 2 gives me the squared value of 25. So that's 5 times 5. And here is the strangest one, modulo. You're going, what on earth is modulo, and what does that percent symbol mean? That does not return, and it's important to realize that it is a percent symbol, but it's not a percentage. This is not going to take a value of 0.01 and say, oh, 0.01 would be 1%, and 0.25 would be 25%. That's not what this is doing at all.
Yep.
If actually, what I'm going to do for this one is I'm going to sort of flip up a little whiteboard here. I think that's the easiest way to do this. Whoops, not that slide, thank you. And if I go here and I give myself a little pen, except I don't want a red pen. I think we need a better color so we can see a little better. Nice red pen. I want you to think back to when you learned long division. And for a lot of us, this was a long time ago, and we rarely do long division anymore.
Do we have to admit how long ago it was?
No.
Okay.
I already explained I'm 29.
Okay,
so
right, yes.
It can't be that long ago when I learned long division.
Because you're 29.
That's right.
Yes.
So let's say I've got a number, I've got the number 5. And I want to... and apparently my fingers aren't as good at drawing as Christopher's, so I'm going to have to use a mouse here. So I've got the number 5, and I want to divide the number 43. I want to divide it by 5.
Okay.
And you think back to how we were taught to do this. You would say, well, 5 goes into 43 8 times.
Okay.
So we'd write the number 8 up here.
Yep.
And we go 8 times 5 equals 40, which leaves me a remainder of 3.
Okay.
Now, that remainder... if I can just get my little highlighter going, this remainder, that's what's returned by modulo.
Okay.
So modulo actually returns the remainder of a division.
I could see that being very helpful if I'm looking for like striping, or if I need to do something every like 5th time. I could see that being very helpful for things like that.
Well, if you've ever been looked at a really big report, and when you look at a big report, or sometimes even on an Excel spreadsheet, and you've got a lot of data displayed on the screen, have you ever noticed that sometimes some of the options for formatting your table allow you to highlight every second line? Well, the coder had to have some way of saying, how do I know I'm on the second line, the fourth line, the sixth line? Modulo is a programmer's trick for detecting, do this every second time, or do this every third time, or do this every fourth time. Because if you do let's say you want to do something every second time. Basically you say, if the modulo is 0, if modulus 2 returns a 0, so if the remainder is 0 when I divide by 2, I'm on the second time, or the fourth time, or the sixth time, or the eighth time.
Yep.
I know some of you are out there going, whatever you say, Susan, I'm totally lost. Just to say, you will encounter situations. It's a programmer's trick for detecting a frequency of something, to do something every second time, third time. It's also a security feature that's used in a lot of number generation. Your credit cards, a lot of times use modulo behind the scenes. Employee numbers, what they'll often do is to see if a credit card number is a valid number. So you can't just type in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I guess that'd be 9, 10, 1, 2, 3 as a credit card number and hope that somebody out there has that credit card number, so hey, I can buy this book with that random stranger's credit card number. What they actually do is they use a modulo and inside a formula to generate credit card numbers. So your American Express or Visa or MasterCard number, the way it's generated is they take a number, they multiply it usually by 11, and then they add 50 to it or 100 to it. So anytime they get a credit card number, they go, if I can subtract this 50 and divide it by 11, and that gives me no remainder, I know it's at least theoretically possible that's a valid credit card number. So, as I said, don't get too stressed out over it. I don't expect you to be coding things with modulo in the next 30 minutes, but I just want you to be aware that this is a function that, although we don't use it a lot day to day in our lives, it comes up remarkably often in certain scenarios when you're writing code. So that's just something to be aware of. And it's the percentage symbol is the way we do it in Python. It's one of the ones where the syntax really varies from programming language to programming language.
Yeah, sometimes it's a backslash.
Some of them have functions.
Yeah, it really just kind of depends.
So Python, we do have it. It's the percent symbol. Now, the other thing we have to remember is the rules for math haven't changed since we were in high school, or back, not necessarily high school, but since we were in school. When you're doing mathematics, there was always an order of operations. Whatever you had in parentheses would be executed first. Then anything to the power of will be executed next.
Yep.
Then multiplication and division, then addition and subtraction. These basic rules apply when you're writing formulas in your programs as well. So if you write a formula that combines addition and subtraction, multiplication, you need to remember your order of operations or you may get some unexpected results. And I don't know about you, Christopher, but when I'm in doubt and I can't remember, I actually, when in doubt, just put the parentheses in there anyway.
Yeah.
Sometimes, even though it's not required, sometimes logically the way I approach the mathematical formula is I think of it as you do this and you do this.
Yeah, exactly. You know, and it's one of those where I sometimes call this cute code or maybe, you know, trivial code because everybody knows. I mean, I do remember something about my dear Aunt Sally, but that's the mnemonic multiplication, division, addition.
I didn't know that.
Yep,
so,
my dear Aunt Sally. So I remember that, but even then, you know, it's like, okay, that's right. So this is, you know what I do remember? And you know what you, Susan, remember? And you know what everybody else remembers that's listening to me? Everybody remembers parentheses go first. So even if as you're typing it out, you know that the division is going to go before the subtraction or whatever it is that it happens to be, if you put parentheses around it, now what you've done is you've made it crystal clear and nobody else that's coming along and reading your code then has to remember that.
Yeah, it comes back to that idea of making a code really easy to read.
Exactly.
And so that you can remember later, and it's as easy as possible to understand your code for somebody else. So when you have a really long formula, even though it might not be required to include the parentheses, you might include it for readability. So it's easier to follow what you're doing inside your code. So it doesn't hurt to have extra parentheses. But the rule, the good news is, you don't have to learn any new math rules when you're writing math inside your code. They're the same rules you learned when you were in school.
Yep.
So how do we get a computer to do our math homework? Let me bring up Visual Studio here and get Visual Studio to do some math for me. So I've created a new project, and I'm going to declare a variable. Let's see, what am I going to do math on here? Let's work on calculating the area of an object.
Okay.
So, and initially, it's just going to be equal to 0.
Okay.
Because maybe there's some cool functions I'll want to use later. So we'll start off with...
So just going to tell it right away,
Yeah.
hey, you're a number, kind of,
Yeah.
all right, seed it. Yep.
Exactly. So setting up a variable, telling Python it's a number by giving it a numeric value initially. And then I maybe have a height, and our height is 10, and a width, and the width of our object, maybe it's a rectangle, and the width is 20. And then I can say that area is therefore equal to width times height. If it's a rectangle, that'll be true. Of course, if it was a triangle, I'd have to then take that result and divide it by 2. Isn't that, I think, was half base height? I'm having a real hard time. Now I'm having to remember geometry as well. This is hurting my brain. So this is the, I better put in a comment here. Calculate the area of a triangle, because otherwise everyone else is going to go, why on earth is she dividing it by 2? And then I can just print that output onto the screen.
Okay.
So if I execute my code, it goes off and it comes back with a value of 100, which is 10 times 20, 200, divided by 2, 100. So it's successfully gone off and done my math homework, and it was geometry homework, I guess, this time, and calculated a result for me.
Yep.
Now, this is where the fun starts. You know, you're displaying a value on the screen, but sometimes you're going to want to format that output. Now, I can, so let's say instead of just printing area on the screen, I want to say the area of the triangle would be, and we saw in the last module how you could use that plus symbol to concatenate strings together.
Right, okay.
So it's used in math. It's also used to concatenate strings. So I say the area of a triangle would be, and I say specify the area, because this will make it, you just see 100 appearing on the screen. Well, what is that 100 telling me? So I want to have some context of the significance of that number. And I go and I run the code and crash and burn.
Oh, that's not good. Can't convert float object to str implicitly.
Yeah, so I get this lovely error message here. Exactly. Can't convert float object to str implicitly. Again, a very crystal clear error message. By the way, word of warning, not all error messages are going to make a whole lot of sense. In this case, though, the nice thing is I actually have an idea of what the problem is. It was mentioning something about a string. str is short for string. I mentioned the plus symbol can be used to concatenate 2 strings together, but area isn't a string. Area is a number. So now I have a problem because it won't concatenate a number to a string. That gives me an error message because the plus sign is expecting me to either add 2 numbers together or to concatenate 2 strings together. It says, what do I do with a string and a number? Okay, but I want to do this. And that's why we have the ability to do some nice formatting. Where's that? Just find my little slide, sorry about that. So one of the things you can do is you can specify in your actual print statement within the string, you can put in a placeholder for the numeric value you're planning to display. So if I specify that I have %d cats, for example, right here, a little %d symbol, I can tell that I'm basically telling Python that where you see the %d, that's going to be a decimal number. The d is actually short for decimal, so it's going to be a decimal number I'm going to display. And then after I specify the string, I specify a %sign, and then I specify the value to replace. So let's just try that as a nice simple example. So the area of a triangle would be %d, so that's a placeholder for the value. And then instead of a plus sign, because plus is used to concatenate 2 strings, I'm not concatenating 2 strings anymore. I'm actually saying, hey, the area of a triangle will be, decimal value goes here. And then I have to say, oh, here's your value. And I do that by saying %area. Now when I run, hopefully I get rid of that nasty error message. Ooh, hang on, I totally messed that up, apparently. That's a big, ugly, the area of a triangle can't convert float object to string implicitly. Well, that's fun. Okay, so I'm going to cheat a little bit because I'm going to touch about that later, and I'm going to change it to be a %f instead of a %d.
Okay.
And %f just means it's a float number, not a decimal number. I'll talk about floats and decimals in a few slides, actually, but just for the sake of showing you that this logic of put in a placeholder and then say here's the value for the placeholder works, I'm just going to change it to an f. And now you can see it says the area of a triangle be 100.000000. So
0, 0, 0.
0, 0, 0, yeah. So F just stands for float, D stands for decimal. A float is usually what we will use to hold a value which has decimal places. Typically the D is what we'll use for whole integers and just straight numeric values that don't have decimal places. And as you can see, it's very particular about what I'm passing in. So I said, and I will show you another way to get rid of that error message a little bit later, some useful tricks when you start working with numbers and start getting those kinds of big nasty things that say float should be string, string should be deck. That's part of what I want to help you solve in here, is because these error messages do pop up. So I can specify that the area of a triangle will be %f, but it was really ugly seeing those 100.00000 kind of looks ugly.
0, 0?
Yeah, so one of the things you can do, if we go back to the slide, is you can see that it's possible to specify, if we sneak down to the bottom, where I have some examples using floats, you can specify the number of decimal places you want. So I can go ahead and say, all right, the triangle will be %f, 0.2. So
Okay.
I'm specifying put 2 decimal places, or 2 positions after the decimal place. So now when I display it, oh, really? I'm telling you, I'm having a great time here. It is, I've got my 0.2 in the wrong place. I did promise we would get through this entire module, this entire course without making any errors, did I not? All right, so it's 0.2f, not f.2. And now I get the output I'm actually after. So now I've got the area of a triangle would be 100.00.
You know, I have to say the format strings, and you know, you're going to keep talking about it, and I'll of course come back to this when we get into dates after we eat. But those format strings, they get me every time, because it's one of those things where, you know, it's not always clear as to what it is that you're supposed to do, and it really is. It's not something that comes up every single day. It's something that comes up frequently, but it's not something that comes up often, I guess would be sort of the best way that I can describe it. And so honestly, whenever I need a format string, I'm typically just, okay, real quick, you know, fire up Bing, let me go look up, okay, this is what I want, then copy and paste and away I go. So yeah, it happens that format strings in particular, all the time I have to go look them up. Yeah,
and in fact, one of the nice things we've done is in that GitHub, where we've put copies of all the, we're keeping the copies of the code and the slides, there's also a Word document created, which is every single code example from the course. So that'll be an easy place for you to go search for some sample format strings and syntax and a whole bunch of different commands. So created sort of a little reference guide for you to use when the course is over, because yeah, why am I struggling with this? Because I don't write these every day, and it's a really odd syntax. Of course it's going to be %.2f.
Yep.
That's very intuitive. No, it's not. It's just, unfortunately, though, the way it works.
Yep.
So
and
there's a lot of different examples you can play with and try it out. But yeah, don't ever hesitate to go look it up if you can't find it.
Exactly. And right along those lines, and somebody just asked this in the chat window here, you know, how do I get a little bit of help on some of those error messages? Here's what I do. Are you ready? Copy, www.bing.com, paste. And I would say probably about 80% of the time, in that first 2 or 3 links, it will be right there of what the actual problem is. Sometimes you have to seed it just a little bit, maybe so Python space, and then, you know, whatever your error message is. But that's really the best way to figure it out. So if you see an error message, you don't know what it is, fire up search engine, type it into there, hit enter, and away you go from there.
Yeah, I guarantee you aren't the first person to hit that error message. And whoever hit that error message before you probably already went to a discussion forum and said, help, I got this error message, how do I get rid of it? And so when you do a search with the exact same error message, you'll find the conversation where somebody posted, hey, I'm getting this weird int to deck message here, how do I fix it? And underneath you may find the exact solution to the error message that you encountered. So that is something that all of us do when we see an error message, we have no idea what it is. It's a great place to start. So I just want to show some other basic examples. You can specify for the float, you could see that the default value, if you specified a float placeholder, was you would get 6 decimal places. You can specify the number of decimal places if you prefer. I do want to do an example with some decimals as well, because there's a couple of interesting syntaxes I like to play with in there as well. So this is printing formatted float value with 2 decimal places. And here's another one of those places. Not a bad idea to put in some comments, because I'm never going to remember what %.2f was later. But let's say I want to print my favorite number is 42, my Hitchhiker's Guide to the Galaxy reference. Again, if I try and run this code as is, I'm going to get an error message because it sees a plus symbol. It either thinks I should be adding 2 numbers or concatenating 2 strings. You give it a number and a string, and it goes, I don't know what to do. What is 42 plus the letter A? So what I do is I put in a placeholder.
Don't ask me to do hexadecimal.
Yeah, %d, what is, and I specify a placeholder, and then I say the value for that placeholder is 42. So now when I run, it goes off and runs, says my favorite number is 42 successfully. In this case, it's a decimal value this time, not a float.
And the reason for that is this time around, you didn't do math with it. You just simply said 42, here's the number, and away it went. You didn't do math with it.
Yes, because I had done math with the numbers, it converted and it created a float value.
Exactly.
Good catch. Good point there, Christopher. Now, the other thing I can do is there is some syntax I can use to format that decimal number. I can specify that I would like the number to be 6 digits long, and hopefully I put it in the right place on the first try. And then what it'll do is it'll actually make 6 spaces, and the 42 appears at the end of the 6. Now, you look at that initially and go, well, that's hideous. Why would you display it that way? But there are times inside reports and things where you sort of want numbers to be right justified.
Yeah.
A lot of times with monetary values. I'll find, you $1.25, and then some values are, if you're displaying 8 different lines, and every line looks the same but has a different price, having the price always take 10 characters, so it's always pushed to the right, just looks tidy.
Easier to read, yeah.
Yeah, so it's being nice to your user. A lot of times we think of numeric numbers as being right justified, so being able to specify a fixed width for a number, regardless of how many digits it has, just can make for a nicer formatted output. Great for those of you who are detail-oriented in terms of how you display information to someone else. Another one that comes up occasionally with numbers is the ability to insert a 0. So some people prefer to show leading zeros rather than spaces when they have a fixed width. So if you just insert a 0 there, 06D, then what I get back is it takes up a total of 6 digits to display the number 42, but instead of putting spaces in front of it to fill it out to 6, it now uses zeros to fill out that extra space. So I've got some interesting options here, and I'm just going to add a little comment here. Printing the formatted decimal number with right justified to take up 6 spaces with leading zeros. So that's what that %06D is. And again, are you going to memorize this? No, you're not going to memorize this.
It's going to be a pop quiz tomorrow.
You're going to be able to look this up when you need it. I'm glad there's no pop quiz. Don't scare us.
No pop quizzes, I promise.
You had me nervous for a second there. Now, that's one way of doing formatting in Python, but we saw even in some of our first modules when we were just learning how to print things on the screen, there's often more than one way to do it. And it turns out, this was how you did in the earlier versions of Python, this was how you would format values, but in the more recent editions of Python, they've given us another way to print and format numeric values. And I just want to expose you to both the methods for a couple of reasons. One, you can use the one that you like and makes more sense to you. And the other reason is because when you're going off and doing searches and you're going, oh, how do I display a decimal number again? Some of the answers you see are going to use this format, and some of them are going to use the other format.
Yep.
So at least this way you've been exposed to both methods, so when you see a code example that uses one method or the other, you'll go, oh, that's right, I remember seeing this. Because you might get in the habit of doing it one way, and then one day you find a code example that does it the other way. So at least you'll have some idea of what's going on, even if you don't remember the exact syntax and have to look it up.
Yep.
So the other way of doing it, you still use a print statement to print a value on the screen, and you still have a concept of including a placeholder. So I specify, but my placeholder, the syntax is a little bit different. I have this placeholder 0:D. Okay, now what's nice about this is if you look at the D, 3D, 03D, F, 2F, that looks the same as it did on the previous slide.
Okay.
So I can specify it's a placeholder for a decimal.
Yep.
It's a placeholder for decimal, and I want a minimum width of 3 characters. And it'll fill with white space if I don't have at least 3 characters. I can specify 03D, which means I want a minimum width of 3 and lead it with zeros if it's not at least 3 digits long. I can specify it's a placeholder for a float. I can specify it's a placeholder for a float and not use the default number of decimal places, which is 6, and say I want 2 decimal places, not 6. What's different is this curly brace syntax. So instead of a %, I have curly braces. And the other thing that is also different here, if we just pick a slightly different color, is this 0 and colon, which I have everywhere.
Very similar to .NET. There's a couple of people that have mentioned, very similar to .NET there.
Yes, yep. Definitely some similarities. This is more consistent with other programming languages, which is nice because it means when you go to another programming language, you don't have to relearn it.
Exactly. Yep.
So what the 0 is indicating is if you have, when you're going to pass it the value to display. So in this case, the number 6 is actually the number I want to display on the screen. I want you to give a flashback now to the last module when Christopher was talking. And he was doing things like, let's say I had a list of values, number 6, number 8, number 9. We were counting strings earlier. Mm-hmm. And you had the word world, or, you had a word. And we were searching, and you said, oh, the letter W is in position 0. Yep. The letter 0 is in position 1. The letter R is in position 2, and the letter D is in position 3.
So counting starts with 0.
Counting starts with 0. Well, when you're specifying a string to display on the screen, you might have more than one number to show in that string. You might be showing the whole formula.
Right.
The result of the calculation, width 6 times height 8, equals an area of 48. So now you have 3 different numbers you want to show in that string. So when you're using this syntax, you might have 3 numeric values you have to pass in. So if we flip back to our slide for a second here, so maybe I pass it a 6, an 8, and a 9 of the 3 numbers I want to display. 6 is in position 0, 8 is in position 1, and 9 is in position 2.
Okay.
That's where this 0 thing comes in. I'm specifying when you get the results over here, this 6, this is the first number I'm passing in. The first thing in a list is in position 0. So I'm saying take the first argument, position 0, plunk it in as this placeholder.
Okay.
Confusing syntax? Yes. But actually quite powerful because it allows me to specify as many numbers as I want. So if I had another argument, it would be curly brace 1:D. Yep. And the next argument would be curly brace 2:D. And that's how it accesses each of the different numeric values to include them all in the string. So a little bit different. I'll just flip over to Visual Studio and do a couple of examples with this format so you can see how it works. So, and then let's do the same thing with the .format syntax to include numbers in, numbers, almost typed bears, numbers in our output.
Hooray, bears.
Yep. And what we're going to do and apparently I'm starting to, it's a good thing we're getting close to mealtime, the typos are increasing. I think my blood sugar is dropping. So what I'm going to do is I'm going to say print the area of the triangle would be, and remember my placeholder is different, it's going to be open curly braces, first argument, which is a float, and then instead of a % symbol, I say .format, and I pass in the argument the number that I want to pass in, which is going to be my first argument. That's why it's position 0. And in this case, that is the variable area. All right, let's make sure that works. So there we go. The area of the triangle would be 100.0000000.
0,
right.
0.
All my extra zeros because
Yes.
it's a nice float number there. Awesome. And if I want to do something with decimals, I would simply say my favorite number is, and my placeholder is simply open curly brace. First, I want to take the first argument. It's going to be a decimal value, colon decimal value. And let's make it, I'll just make it a straight decimal in this case. And then, again, dot format to say, here's the value I want to put inside that placeholder, and I'm going to put in the value 42. And then just close braces. One thing to watch out for, it's a little sneaky. You'll notice I got 2 closing brackets, one after the other.
Ah, yes.
Yeah, we're starting to nest functions inside each other, right? Because I need brackets around the 42.
Yep.
But I also opened a bracket for my print statement, and I need to close that bracket. That can kind of get you. One thing that Visual Studio does help you with on that is you'll notice if I highlight one of them, it's kind of hard to see sometimes, but it will actually, there's a slight, if I zoom in a little bit, you might be able to see there's a bit of a gray highlight on the closing brace.
It's subtle,
but it is there.
Yeah.
When you start having 4 nested functions, you might find that little subtle gray can help you, because I've literally sat there counting my opens and my closes to make sure I had them all in there.
We've all been there.
Yes, so that's just one of those fun things about being a coder. All right, so let's run this code. And now we have the same output, just chose some different formatting options, different syntax, same end result. So which one do you want to use? Whichever one makes sense to you. I'm not going to force you down one path or the other. If you are confused by both and you want some, and you're going, well, if I have to choose, which one would you suggest? I would suggest using the dot format. It's the more recent addition to Python, and it is more consistent with other languages. So that's going to make it easier for you if you do switch to another programming language later. So I would say, if you're going to have to do battle with one or the other, I would actually recommend dot format. And I'll do one last example in Visual Studio here. I want to do one with 2 arguments, just so you can sort of see how that works.
There's actually a couple of questions about that.
Yeah, there was good stuff.
Yeah, like I'm looking, how can I format multiple numbers?
Here are 3 numbers.
Yeah.
And so I'm going to say, here's 3 numbers, and 0. The first is open curly brace, 0, first argument, and this will be a nice decimal place. The second is open curly brace. So position 1 would be the second number in the list. Remember, we count from 0, so 0, 1. So the second argument is number 1. I know it's confusing. Welcome to coding. There are a few moments. Just remember, you start counting by 0.
Yep.
And
that is pretty consistent across most
programming languages. And let's just format this one differently, just to sort of prove that we can specify different syntax. And then the last number is going to be 2 colon, and it's also a decimal place. And then I just do my dot format, and I say my 3 values are 7, 8, 9. So I just use commas to separate the different values that I want to pass. So what's going to happen here is the number 7 is going to be used as the first argument, and we substituted here for this placeholder. The number 8 will be used to substitute this placeholder because it's in position 1, and the number 9 will substitute for this placeholder. So if we run that, you can see the first number is 7, the second is 8, and 9. And you can see how 8 is being displayed with that padded white space because I asked it to, just to show that you don't have to specify the same formatting for each of the arguments. You can play around with it, whatever looks good.
I like it.
Cool. All right. Here I'm just going to add a little comment. This is an example with multiple numbers. And that is easier to do with dot format than it is with that % syntax. So that's the other advantage to it as well. So said, all things being equal, if you have to learn one, I would recommend dot format, but I want to expose you to both of them. So if you encounter it somewhere, you don't go, what the heck is that? I've never seen that before. You go, oh, that was that other way of formatting it. And you may decide to write it the other way. Said, it's all about choices. One way versus the other isn't necessarily wrong or right. It's mostly programming personal preference.
Yeah.
Yeah, a lot of the time. Okay. So let's clean up. I've got rather a mess of stuff on that slide here, don't I? Let me clean up all that. Okay, so we just did a little demo showing how to format numeric values. Another thing that can come up, and actually it was starting to happen on that last command.
Yes.
Sometimes you start writing a command and it starts filling up that line, and you're starting to scroll over and scroll over and scroll over, and this starts to happen when you're doing math. And that is that the command's actually too long to fit on a line. One of the things you can do is you can use a, hang on, forward, is this forward slash, isn't it? Or is this backslash? I get my slashes mixed up.
That's a backslash.
Thank you.
You're welcome.
It's the one that goes this way. So you can use a backslash at the end of a line, which will basically tell Python, hey, this line continues on the next line. So for that really long command that I had in Visual Studio, which was getting really long here, you can't even fit it on the screen, what I can do is I can, now if I just put a slash here, what's going to happen, Christopher? If I put a backslash there?
It's going to think that it's a string literal?
Yeah, it's going to think that slash is actually part of the string.
Right.
So you can't, if you're just displaying a really long string and you want to do over 2 lines, that's actually not going to work particularly well for you because you have this little problem of it thinks the slash is part of your string.
Right.
It doesn't know if the slash is, no, I want to continue on the next line. But what we can do is we could go here and we could say, you know what? I actually have 2 strings.
Okay.
Here are 3 numbers. The first is 0:D, second is, and so that'll work, right? I mean, I'm just concatenating 2 strings together. Let's see if that works. Okay, so that works fine. And then what I can do is I can put the backslash here. And now it actually recognizes that, oh, wait, there's no little squigglies or anything strange happening here. So now it actually recognizes that that backslash is indicating this command is continued on the next line. So when I run, it executes as if it was 1 line of code. One very important thing I want to point out here in this code, though, and that is right here, is you have some space here. That is an indentation. That matters. If you get rid of that white space, then Python is going to get confused. That indentation of the second line is how Python points out that, oh, this is part of the previous line of code. So indenting is very significant in Python, and in this case, it's that indentation that's part of the syntax to show this is part of the previous command and not a command unto itself. So that's really important, and you need to watch out for that. Don't delete those spaces. If you do, well, then just for the sake of, hey, what if I accidentally did delete those spaces? What's going to happen? Well, hey, I take it back, and this one it worked.
It is going to work, but it really is. It's about that readability. You know, that one of the problems if we bring up the code again here, you know, that if you get rid of the tab.
Yeah. If you do that.
Yeah, I mean, if I go in and I look at that, there isn't anything that indicates to me that it's on the same line or that it's part of the previous line. But if you have that tab, that tab is sort of of an indication that it's
associated with the previous line.
with the prior line. Exactly. Yeah, it's about readability there.
Yeah, there are a lot of commands in Python where the indenting, if you take it out, will actually change the behavior of your code. In this case, it's being forgiving. It's saying, I'll forgive you if you get rid of it here.
Yeah.
But said there are other situations in Python where if you actually get rid of that indentation, it will actually execute a different way. Execute a different way. Awesome. So we have the ability to continue a line. We have the ability to display numbers and strings intermingled. So we're starting to get some fairly complex code here.
Yeah.
Yeah. Now, something else we sometimes want to do is maybe we want a user to enter some numbers.
Okay.
So I'm going to go, and this is getting to be a bit crowded on here, so I'm actually going to do something that may throw you off a bit. So what I'm going to do is I'm going to go to this window in Visual Studio called Solution Explorer, which you probably have open on the right-hand side of your screen. And I'm just going to go to my project, module 4, working with numbers, and I'm just going to go, I'm going to say add a new item, because I want to add a brand new file, because this one's just getting kind of cluttered with a lot of code in it. I want to start a fresh Python file, but I want to keep all my files together because they're all about this same chapter. So I'm going to go add new item, and I say add an empty Python file, thank you. This is going to be my ask user for input. Choose add. And now I actually have 2 files. inside my project. And I can go back and forth between them by selecting the one I want to work on inside the Solution Explorer, or once I've opened them, there'll be tabs open at the top of the screen I can use to move back and forth. So what I'd like to do is ask a user for a value. I'm going to ask, let's see, salary equals input. Please enter your salary, right? Because we learned how to use the input statement to accept values from a user. And then we're going to have a bonus that you're going to receive for the year for your amazing work this year, Christopher. You're getting a big bonus.
Woohoo!
Please enter your bonus. And this is an awesome company because you get to type in your own bonus.
Wow.
I want to work at companies like that.
I need that.
Yeah. And then I'm going to say, then I'm going to have paycheck equals, or paycheck amount equals salary plus bonus. Make sense? Right?
Huh?
Your salary plus your bonus would be your total paycheck amount. And then I'm going to say, I'm going to print your paycheck amount. Oh, and I just caught myself. I almost got myself in trouble. I just noticed I have a lowercase c here and an uppercase c there. I know that Python's case sensitive, so I'm just going to copy and paste that variable name to make sure I type it the same. All right, now I run and it runs the other program.
Oh, that's not what we wanted.
That's not what I wanted. I created another file. I want to run my new file. Well, that's because when you have more than one file inside a project, there's always one which will run by default.
Doesn't know which one to run.
Yeah, it doesn't know which one to run. So it's still running the old one because it's still there. Now I can go here and I can say, start it. So I can run it by right-clicking on it, saying start without or start with debugging, and it will run my code. The other option is if you're going to be running it frequently, you can also right-click on that file and you can say set as startup file. And that'll change which one runs by default when you just press the F5 key or press the play button. I like doing that because usually I'm working on one file at a time and I just want it to run that one all the time while I'm testing. So I prefer to change the startup file option. So if we go back to Visual Studio, I right-click, I have set this as a startup file, so I right-clicked and chose Set Up Startup File. And now when I run, and I just realized I should have a space there, it'll be nicely formatted, it says, please enter your salary. Okay. All right, so I'm sure your salary must be at least $500, Christopher.
I think so.
And your bonus this year is going to be a whopping $75.
All right.
All right.
That's not bad.
And then it comes back and says my total paycheck amount will be $50,075.
Not for nothing. I kind of like that. I like that. That's new math. I like that math. That math worked out really well for me.
Yeah. And this is one of those things where you go, whoa, wait a second. What just happened here? How can 500 plus 75? Shouldn't that be 575? You would think.
Yes.
Right. What I'm going to do here is I'm actually going to try and show you what's doing. I'm actually going to try debugging. We haven't seen the debugger yet, but this is there will be times when you're going to need to see what's going on inside the code where you're going, well, why? My code ran, it didn't give me an error message, but the result's totally off. Mm-hmm. So you might want to see what's happening. One of the neat things you can do in Visual Studio is you can actually execute your code step by step, and as you go through the code, all those great variables you've set up, you can see what's inside the variables. And that's really powerful when you're trying to figure out what went wrong. So let's go back to Visual Studio. And I'm going to click in the margin here. And see that little red dot that appears in the corner? When I do that, that little red dot makes a breakpoint. So I can put it on different lines of code. I can make multiple breakpoints, and I can get rid of them just by clicking on them again. And when you put a breakpoint in the code, then you're telling Python, hey, or you're telling Visual Studio, hey, when this code runs and you get here, stop. I want to look around and see what the heck is going on. So I've got a breakpoint on the very first line of code because I don't know where it's blowing up. And I say, run. And it flashes on the screen. You're like, hey, where's my screen? There's a hint over here in the corner. Let's go scroll over a little bit here. Try not to make you dizzy. See the little yellow arrow that we've got there? That yellow arrow on the red circle indicates you're about to execute this line of code. So what the debugger has done is said, you put a breakpoint here. You told me to stop when I got here. Well, I'm here. I've stopped. What do you want to do next? Oops, I did wrong control button. So when I have that breakpoint, whoops, wrong one. Apologies. I just hit the wrong function key there for a second.
Other file.
Oh, file's running too. Okay, let's try this again. Run. Okay, so now here I am again. I'm at that first line of code it's about to execute. Now the neat thing is, when you hover over different points inside the code, it actually sort of shows you some of what's going on. It gives you like hints as to what's happening. But it hasn't executed any code yet, so there's nothing really to look at. So what I'm going to do is I want to execute the next line of code. Over here in the top right corner, you're going to see 3 buttons. Step into is the one you want to play with. Step into means execute the next line of code.
Okay.
So let's just stick with that one button. Just execute one line and go back.
Sure.
So I'm going to hit that step button, and now it executes. Oh, and of course, it's asking me for a value because, of course, that command was ask the user for a salary.
I make $500.
$500. I hit enter, and I'm back in the code again.
Okay.
And the little yellow arrow here has moved to the next line because it's saying, I'm about to execute this line of code. Anything you want to look at? So what's neat is I can actually hover over salary.
I'm noticing something funny there.
Yeah.
I'm noticing the single quotes. Single quotes means string.
Bingo, yes. Remember we talked earlier when we first created our first numeric variable, we said when we said age equals 42, how does it know it's a number, not a string?
Yep.
No quotes.
Right. Okay. So it's seeing that as a string. Because that's right, because input returns a string. That's where things are going wrong.
That's right. The input function returns a string. So what it ends up with is it ends up with a string value for salary, a string value for bonus, and suddenly when you say salary plus bonus, it's seeing string plus string. That means concatenate them together and you get 50,075. Oops, not what we had in mind. So we can see, thanks to the debugger, we can actually see that, oh, we have a number that's being treated like a string.
And that's not what we want.
It's not what we want. So what we need to do now is we're quickly going to go here, and we got this weird result that happened because it was basically treating it as strings. It was as if we had typed in a salary of 500 with quotes around it and a bonus of 75 and got these strange concatenated strings. So what we have to do is we have to somehow convince it that when it gets that result from the input statement to treat it as a number.
Right.
And the way we do that is there are functions that will convert from one data type to another.
Okay. And just kind of looking at that, those functions seem to match the data types that we want. So if I want an integer, I would just use int. If I want a floating, I would use float. Somebody else actually had pointed this out earlier, the str for string.
Yes.
Okay.
Yeah. Exactly. So these are functions you can use to say, take this value, or the value in this variable, convert it into an integer, please.
Yep.
Take this value, convert it into a long, which is just a bigger integer value.
Right.
Any sort of whole number if it has no decimal places. Float converts it to a number with decimals, and string will take a number and switch it into a string.
Yeah. And actually, there's a couple of people that have pointed out that when it comes to doing something like this, this is something you run into constantly across all languages. Because anytime that I put together a text box, or we're doing a command line, that by default it's going to treat it as a string.
Yes.
So that's what you've got back. Now you're going to try and do math with it. Well, now you've got that problem. Now the way that you're going to do the conversions will vary, but the fact that you have to do them, the fact that it's coming in as a string, that's consistent across all languages.
And and you bring up the point of, like, if you decide to start building websites or forms where users enter data, you made an awesome point. That's right. Typically, when a user enters a value in a text box and you ask for the value of the user typed in, it's going to give you a string. So you're going to have to convert it to a number to do your math. So this is such a common scenario. It's annoying. And you know how we usually find out we have to do it? We run it, we get the error message and go, oh yeah, I got to convert that, don't I?
Yep.
So all I have to do in my code, in this case, is I need to say, take the value inside, let's do a float here. Let's take the salary, convert it to a float. Let's take the bonus, convert it to a float. And now it should be taking a numeric value. It takes a string, converts it to a number, takes the other string, converts it to a number. So now I'm adding 2 numbers instead of 2 strings. So fingers crossed. Oh, hang on, I was still in the middle. I just did the editing while the code was running. Let's get rid of that breakpoint. I don't want that anymore. I just want to run my code. Please enter my salary, 500. Bonus, 75. 575. Success. So.
But I liked the old math.
You liked the other math, did you?
The old math worked out better.
Christopher would prefer it if we left that bug in the system. But just imagine the disaster it would be at a company. And it's the kind of thing, you might have had it in your code. It was off printing paychecks, and everybody's going, wow, this is great. Everybody at the company is really, really happy. just because you forgot to convert a data type.
Yeah, you know?
So it's important to test your code is what I'm saying. You know, make sure the output is what you think it should be. Just because it runs doesn't necessarily mean it's doing what it's supposed to.
Yep.
Always take the time to say, well, if I type in this, does it give me what I think it should give me back?
Always test it.
Always test your code. It's not just knowing it runs doesn't mean it's doing what it's supposed to. It's really important to test.
Yep.
So in our case, to fix our code, we have used converted to a float instead of just adding salary and bonus, and now we're adding 2 numbers instead of 2 strings.
Perfect.
Now, I do want to bring up a little situation of, Christopher, what would you think would happen if somebody typed in a salary of Bob?
Well, it looked like you spelled Bob backwards, but anyway, so, you know, I'm guessing that what would happen is Python would look at it and sort of do what I would do, which is, what do you want me to do with this? Well, it's 3 letters.
Exactly. So if we go look at the slide here, you know, if somebody types in, I'm going to bring up the highlighter here quickly. So we've asked somebody to enter a value for salary. And then we take that salary value and we've typed in Bob. So salary storing the value Bob. When we get to this line of code and it tries to convert Bob to a float, Python's going to choke. It's just going to go, I don't know what to do with this. And you're going to get some weird, nasty error message spewing all over your screen. So this sort of thing will happen. We are going to look at error handling later in one of the later modules tomorrow. So we will show you how you could handle that gracefully, because I guarantee you someday a user is going to enter something like letters where you only want numbers, and you don't want the code going and spewing nasty error messages to the user just because they accidentally typed a letter. You want to come back and say, excuse me, if you don't mind, could you please enter numbers only?
Pardon me.
We want to be polite to a user. We don't want things crashing. So we will look at error handling tomorrow, and we'll show you some graceful ways to deal with those types of mistakes that users do things you don't expect, and we got to handle that. So the code would crash. So we've just done a demonstration of showing that data type. So now you have the information you need to complete this challenge.
Okay, so what's our challenge?
Your challenge
today, should we choose to accept it?
Should you choose to accept it? You are going to create a mortgage calculator. There's a lot of websites that do this online. And we have the formula. Your monthly payment is the loan amount times the interest of 1 plus I times number of payments minus 1. And it's this big, scary formula. But all you need to really know is that the user is going to enter a monthly payment. You're going to calculate a monthly payment. The user is going to enter a loan amount, an interest rate, and number of payments. And with that information, using the formula here, you're going to be able to return to them what their monthly payment would be. So that's your challenge, a very real-world problem. But hey, you may find yourself using this code to, calculate how much you can afford to buy that car or that house.
Absolutely, absolutely, fantastic.
So congratulations, you guys have now got the ability to solve mathematical problems using your code.
Start working with the numbers. Excellent. Well, I don't know about you, but I'm kind of hungry.
You guys have been doing well. You've held up so well being here this long. You rock. Now, the good news is we've gotten through the long part of the day. After lunch is the shorter part of the day. We got through 4 this morning. We're only doing 3 this afternoon.
So what do you say we take a break for a meal?
I like it.
And we'll be back in about an hour. So we'll see you guys back here in about 60 minutes. 60, about an hour.
See you soon.
We'll see you then. All right, welcome back. I don't know about you guys, but I'm kind of full.
Yeah, I'm feeling much stronger. Got my energy ready to finish off the day.
Absolutely, absolutely. 3 more modules coming down at you, and we're going to sort of again kind of continue where we left off. So we've dealt so far with strings, we've dealt with numbers. Now let's take a look at the last big data type, which is dates. And one little thing that's kind of worth highlighting real quick is, of course, there's a lot of other types of data and so forth that you could be playing around with and so forth. We're looking kind of for the big ones here. So that's why we went numbers. That's why, of course, we went strings. And that's now why we're going with dates. And so let's kick into it. That's sort of the best way, I think, to get in and do it. So, fact of the matter is that we spend an awful lot of time dealing with dates, dealing with deadlines, dealing with schedules. In fact, while we were, eating, I was having to deal with a little fire. I have to have something done by the end of today. So you've got all of those different things. So you're frequently trying to calculate the number of days before a particular event, or be able to maybe highlight something before or after it's completed. So based on a project being due, is it late or is it on track? If I'm looking to book an appointment 2 weeks from now, so maybe like my contacts,
a follow-up appointment with the doctor or something.
Exactly.
Sure.
My contacts are 30 days. So I have to remember to pull them out after 30 days. So how do I go in and do something like that? Well, the way that we deal with all of that is by working with dates and times. And one great thing about Python, which is true across almost every language, is that it has the ability to understand and give you the ability to manipulate then a date. So let's say, for example, that, and this is kind of a classic example, that I want to figure out the number of days until my birthday. Now, in order for me to do this, the first thing that I'm going to need to know is what is today's date. And you'll notice that we can go in and pull that in by utilizing the date time class. Okay. Well, there's a lot that's going on here. So one of the biggest questions that's come through the chat window is, can we create blank apps with Python? Can we create web apps? Can we create Windows apps? And the answer to all of those questions is 100% yes. You can create all of those. But typically, what all of those are going to require is some form of a library. So I'm going to need a library, so that way I can more easily make the web calls. I'm going to need a library so I can go off and communicate with a database. Well, we're going to need some component to be able to work with dates.
I'm just going to throw in one other library I just want to mention, because there was a couple of questions that actually came up on the chat window that were talking about things like dealing with other languages and currency symbols from other languages. You'll find a library out there, a module which contains functionality that help you deal with what we call localization, those different locales, called locale, L-O-C-A-L-E. So for those of you who are asking about how do I handle Danish characters, how do I show the euro symbol and things like that, there's a locale library for that.
Absolutely. Actually, you can just draw it on the screen.
Oh yeah, that doesn't work so well inside Visual Studio.
Oh, okay. All right. Well, I tried.
Even Visual Studio has its limitations. It doesn't have touch input for writing your code yet.
Shucks. That'll be the next version.
Yes.
Okay. In any event, so in order to incorporate that level of functionality, what we're going to need is an import statement. And import, in a nutshell, simply means take something and make it available. So whatever it is that it happens to be, we're going to take that, we're going to make that available. Now, once we make that available, what you're going to notice is that we immediately have access to then date time. So in fact, here, I think sort of the best thing to do is actually get in and do it. So
especially something like this. This is
exactly.
You want to see, and it is such a common situation that you just need today's date. So you can figure out how many days from now to another date, or it's just a display. How many times do you see a report or something, or you print someone an email that confirms, hey, you ordered the tickets and you ordered them on this date. We constantly need today's date. It comes up all the time.
Exactly, yeah. So let's take a look at my code here. I'm just going to say today, which is spelled like that.
You sure you had some caffeine? Maybe you should have had some caffeine at lunch.
No kidding. Today equals, I'm going to say date time, date, you're going to notice a little error message here. It tells me right there, no completions.
So it's basically saying something, I'm confused.
Exactly. It doesn't know what date time is.
The IntelliSense in this case is actually telling you I can't find it.
Exactly. Yep. And so this is kind of a very quick way to see, oh, wait a minute. And if you ever see something like that, where you type something out, you hit a dot, you're expecting IntelliSense, and you're getting like no completions, that's frequently an indication that you forgot an import. So now I'm just going to say import, and you'll notice that this will show me all of the classes that are available to me inside of Python. So I'm going to go ahead and say import, and I love anti-gravity. I know it's not really going to be, true anti-gravity, but wouldn't it be nice if we could start working with anti-gravity? Anyway, all right, I digress. So let's go ahead and say import date time, and now you're going to notice the moment I do that, a lot of different things light up. And one big thing to keep in mind as you're typing something out inside of Visual Studio, if you see the color change, there's a reason for that. What Visual Studio is trying to do is tell you that this is a keyword. So you're going to notice that today is, in that case, you know, the little bit of teal.
I guess it is sort of a tealish blue. Yeah, it would be reasonable, yeah.
Periwinkle?
Yeah.
Sure. But whatever that color is, what this is trying to indicate to me is this is, at this moment, a reserved word or a special word, or this word means something. And anytime that you have a word that means something else inside of Python, you're not going to be able to use that as a variable name.
That is true, yes.
Yep.
So that's we didn't mention that in the rules when we talked about variables, but no, you cannot use a reserved word as a variable. You can't use print as a variable name.
Exactly.
You can't use input as a variable name because those have other meanings to Python. So
Yep.
today, and it's funny because today is just such a good example because it's the kind of thing you logically go, hey, I need a place to store today's date. Why not call it today? Unfortunately, not an option. Just have to come up with something slightly different.
How about, let's go with...
Usually you lose current date.
Now, or current date.
I've seen now as a reserved word in some systems as well.
Yeah.
So I like current
Okay.
date. That's mine, but find your own. I think you're okay, you know? So.
Why are you still giving me that turquoise? It shouldn't be giving me that turquoise.
You know what? They recently posted an update. I actually had somebody pop up a question on the Q&A saying, hey, my colors aren't matching what you have on the slide.
Yeah, and that...
There was
okay.
literally a release 2 weeks ago to the Python tools for Visual Studio. And so we're running with that. So it's possible there may be a couple little small quirks in it.
Yeah.
So I wouldn't stress over it. I said it was literally an update like a week and a half ago. So we're still getting used to the update. We only saw it a week and a half ago.
Exactly. All right. So in any event, so we'll go with current date. And then I'm just going to say date, and then we'll say today. And that will give me today. So I'm going to go ahead and you know, one of the big questions that's come around is, you know, when do I need the parentheses? And there's a couple of different ways that you can tell. But one of the easiest is these icons right here. So that little blue box that you see right there, what that's trying to indicate to me is a method, function.
A function. We talked about functions like print and input, these things that go do something for you.
Exactly. So that's going to need parentheses. So when you see a box, method, function, parentheses, and then on the blue ones, that's going to be some form of a property.
So those don't require the parentheses.
Those won't need it. Exactly.
Oh, by the way, when you zoom out, the color fixed itself now, by the way. So it must have been just somehow a screen refresh with that update. So
Yeah, that's sort of weird. Okay.
I think we just say new version of the tool.
Yeah.
Obviously, the colors don't refresh as quickly as they should.
Exactly.
Yeah.
Okay, cool. So I'm not losing my mind
you're
there.
not losing your
All
mind.
right.
It's all good.
So yeah, so we'll go with current date today, and then we'll just go ahead and print that out. So I'm just going to say print current date, just like that. And now let's go ahead and hit start. And sure enough, it prints out today's date as 2014-9-23. Perfect. Okay. So now what you're seeing here is how we can go off and grab today's date and how we can start working with dates and times. All right, let me get back to my slides here. Give this a second. All right. Now, we've already got it, the ability to store that into a variable, and you can kind of see that right there. There we go. And again, we see the output. We can see when the slide was created. So that was created on July 20th.
Yeah, you can see when I was creating my deck, yeah.
Absolutely. And then we've got our little demo slide.
Right.
Now, one of the biggest things that we're going to be looking to do when we look for a display or when we look to do calculations is to go grab the different components, the different parts of the day. And so you're going to notice that there's a whole set of different properties that are available on a date. Now, I've thrown around this word properties a couple of times. Let me go ahead and define this real quick. A property is, in a nutshell, an adjective. So whenever we're talking about whenever we're talking about an object, the way that I always like to try and describe things is picture a real-world object. So here, let me hold up my little water bottle here. So you'll notice that I've got my little water bottle here, and my water bottle has a color, something that I could use to describe my water bottle. And so the color here happens to be blue. So property or adjective, color, the value would be blue. So in this particular case, coming back to the slide there, what you're going to notice is that I've got year, I've got month, and I've got day. Those are properties. Those are all different components or different adjectives, different ways that I could describe today's date. So I could give you the year, which is a part of that. I could give you the month, which is a part of that. I could give you the day, which is a part of that. And all of those are going to describe different pieces of information or different adjectives about that date object, in this case, the current date. Unlike
the functions. Functions are going off and doing something. These are just giving you information.
Exactly.
About that item or about that thing.
Yeah.
Okay.
Yep. That's exactly it. So, and really, if I was going to go one step further, and I'm not going to dig too deeply into this, but when it comes to methods, I always like to call them verbs because those are the actions. So adjectives, give me something. Verbs, do something.
I like it. So functions and methods are like verbs, whereas properties are the adjectives. I like that.
Yeah,
that's a nice way of thinking of it.
I think so. I think so. Okay, so let's go in then and take a look at how we can access all of this. So let me fire up Visual Studio. And I'm just going to kind of keep on keeping on here. And let's just say print, and we'll say current date. And you'll notice again,
every now and then,
it's not going to give me my completions. That's all right. I'm just going to say month, and I'm going to say print and current date. And I'm going to say year, like that. And if I run this, it's working. Yeah. So, so we've got that, even though it's just not giving me the
problem is Python doesn't know until you're executing the code that current date contains a date value. So we have that situation where Python has a variable, current date, which we know is going to contain a date, but there's no way when you're writing the code for Python to detect that's going to be a date value. It's only after you've executed the code it gets a date, and that's why you're not seeing the IntelliSense pop up for that.
Yeah.
So if you initialize it to a date value somehow, you could trick it into it, but that unfortunately is one of the things about dates.
And it's sort of true with Python in general. You see this actually in other languages. That Python, some people will refer to this as weakly typed. There's weakly typed and strongly typed. So when you declare a variable will always have a type, a string, a number, a date.
Yeah, it forces you. When you create a variable in some programming languages with strongly typed, it says when you make a variable, you tell me what data type is going to be in there and don't mess with it. It can only have that data type.
Exactly. But with a weakly typed, which is like JavaScript or Python, you can actually have a variable and you don't have to tell it up front, this is what it's going to be, which means that I could actually take a number, throw it into it, and it would go, oh, okay, cool, I'm a number, I'm a number, I'm a number. And then you could, 3 lines later, throw a string into it, and it would go, oh, okay, I'm a string, I'm a string, I'm a string. And
it's great, it's forgiving, it's flexible, but it gives side effects like, oh, the IntelliSense doesn't know what you're putting a date in there, so it can't give you the pop-up list of date functions, because for all it knows, you're going to want string functions.
Exactly.
So, like I said, pros and cons, it is what it is.
Yep.
We'll let you move on.
Okay.
So that just explains why you don't have the IntelliSense.
Exactly. Yep. Okay. So let's take a look at date formats here. And, I'm just pausing here for a second, so that way anybody in the chat window, because there's a little bit of a delay between us broadcasting and the chat window, but I just sort of want to put this out here to the chat window. So what date does 12/5/2014 represent? Or, I could have even done something even better. I could have done something like 12/6/9. Or maybe, put zeros in front of that. So 12/06/09. What date does that represent?
So we have a vote here for 5th of February 2014.
Okay, so we have 5th of February. What else do we have?
That's the only vote in so far. We'll see if we get another one coming in. I can tell you, this is one of those interesting ones, though, because, see, I went to a school that I was taught in French, and I was always taught it goes day, month, year. So 2 would be second.
Yep.
5 would be your month, January, February, March, April, May. So for me, that would be 2nd of May 2014. So, and now we've got some coming in now saying, that's funny, somebody else miscounted the months like I've done on occasion, but we have 2nd of May 2014 and 5th of February 2014. Yep. And therein lies the problem.
Exactly. Yeah, that depending on where you are, depending on the culture that you're working in, this could represent who knows what, and especially if we got rid of, and I'm really going to kind of circle that example right there, that I'm keeping every number 12 or under, and I'm using 2-digit. I could make the argument that that's going to be June 9th. I could make the argument that that's December 6th. I could make... I mean,
you know what? And nobody's wrong.
Exactly.
So it's important for us to be able to have a little more control over how we show dates to users.
Exactly. Yeah. And this is really the biggest issue when we're talking about dates is it's not just simply okay, now we've got something other than a string. It really is, how do we take the input and how do we display that back out? So what if we want to change the way in which way display everything?
Right. So what we could specify the actual name of the month rather than the number for the month. Because if I say 2nd Feb, then it makes it pretty clear that's the month of February.
Right. Yeah. And that's honestly, I mean, in my own personal life, that's why I always spell it out. That I will always go day, month, year, but I will always put the 3-letter abbreviation for the month.
Yeah.
Just make it nice and clear. Let's just eliminate ambiguity, you know?
Absolutely.
So, but in any event, so what happens if we want to change the way that we display everything out? Because again, different countries are going to be doing different formats. And a lot of times that default isn't what you need. And on top of that, even if I might be thinking, well, the culture is set for US English. I know that my user is expecting US English. So I might be thinking, well, I'm just going to rely on the default output from Visual Studio. Let's just fire this back up again. There we go. You're going to notice, you're going to notice that I opened the wrong window. You're going to notice right up there that it's giving me year, month, day, which not everybody is necessarily going to be expecting.
Yeah, and again, people can mix up, is it year, month, day, or year, day, month? So it's not clear.
Exactly. Okay, so let's kind of go back to the slide and talk about all that. Let me, where's my slide? There's my slide. Okay, so here's the thing. This is something we can handle. This is something that we can deal with, but it is just going to take a little bit of extra time and a little bit of extra code. And it's one of those where it's not difficult. It can sometimes be a little bit tedious.
I was going to say, it's a bit fiddly.
It can be, fiddly, funky, tricky, but it's not necessarily difficult.
Yeah.
All right. So then how can we start to break things down? Well, one way that we could break things down is to actually just use that day, month, year. But one of the problems with just using the day, month, year properties is that after a little while, that particular bit of code can just get longer and longer and longer. And then, of course, we also have the problem of trying to convert those number types into strings and so forth and so on. So fortunately, just like Susan demoed with our numbers where we have different formatting options, we've got the exact same thing for dates. Awesome. Till we look at the slide.
Yeah. Not exactly intuitive at first glance. You don't look at this and go, well, obviously that's taking a date and formatting it to show day, month, year.
Okay. So yeah, we've got current date.
That part's straightforward, right? Yep. That contains the current date. That's our date variable.
strf time, string from time.
Yes, make a string from a date time element is what that's actually short for, but they made it nice and cryptic.
Yep. And then you'll notice that we've got %d and %y. And so those two are pretty straightforward.
Those make sense.
Yeah, the %d is my day, the %y is my year, the %b is my month.
And the reason, just so you know, they aren't just making it %b to make your lives difficult. The reason they had to use %b is because they use m for minutes when you start getting into times. So they always have this problem, but there's minutes and there's months, and they can't use m for both of them.
Yep.
And uppercase, lowercase mean different things. We're actually going to see that. So that's why they had to go with something else. Why they picked B, I have no idea. But they're not doing it to confuse you. Programmers, people who make these languages are not out to get you. So yes, it's a little confusing to getting used to %b. When you forget it, look it up. Just search for help on string format time or how do I format a date output in Python. You will find on the first page of results in Bing something that's going to have a nice example. And actually in the reference document that is in the GitHub, we have a link to the documentation for string f time, which gives you a link to all the different options.
In fact, if we take a look at my slide here, you'll notice there's a little link. I'm just going to tap on that. Whoops, I'm on a highlighter. All right, give me 1 second here.
Got to convince it to let you out of highlighter mode.
Yeah, get me out of, there we go. There we go. Okay, so right here, there is all of the different options that are available. Again, don't memorize these.
No, we don't memorize it. Look them up when you need them.
There's an old story. Albert Einstein was being interviewed by the New York Times, and the interviewer asked him about some constant, whatever the constant value was, and Einstein said he didn't know what it was. And the reporter was, a little incredulous. How could you not know what this is? And Einstein said, why would I memorize something that I could look up in a book in under 2 minutes? Same concept here. Don't memorize these things. Somebody asked earlier how it is that, we know all of this. Well, the reason that Susan and I know this is because we've done it. Because after a while, you just keep doing it, you're just going to remember it. But sitting down and trying to memorize this, that's not going to be helpful. Because the other thing is, you don't necessarily know how much of this you're going to wind up using on a day-to-day basis. So you decide one day, well, I'm going to sit down and I'm going to start memorizing this because this is what's going to make me a real developer, which it's not.
Nope.
And then you're going to wind up memorizing a whole bunch of things that you're not going to actually wind up using.
At least not every single day.
Yeah, exactly.
You'll do it once, and then you'll figure it out, and then you probably won't have to write code like that again for anotother month.
Exactly. So, go look it up. Go look it up. But in the meantime, you are going to notice, coming back to my slide here, D for a day, B for a month, and then Y for that 4-digit year. And then again, if you want to break things down a bit further, you're going to notice the full, the abbreviation, the 2-digit, the 4-digit, and again, strftime.org to go get all of them. So that is what that breakdown is all about. Okay, so with that, let's take a look at that in action. All right, discard. Let's go back to Visual Studio. Woohoo! Okay, so now let's go in and let's say print, and what I'm going to do is say current date.strftime.
Yep.
There we go. And I'm going to go with %D. I'm going to go with %B, comma, and %Y, just like that.
Yep, that
Cool.
makes sense. Day, month, year.
Yep. And sure enough, if we do it,
Much
there
better.
it is.
All right, high five. I like that. Way better as an output.
And actually, if I was going to, do it my typical way of doing my formatting here, I'll just do it like that. There we go.
You like 2-digit years?
I like the 2-digit years.
That's a very popular format too.
Yep, exactly. And that's it. Is that and you'll notice that if you want a specific format, you can get it. Again, we're not launching rockets here. Whatever date output it is that you're trying to put together, unless you're forming your own nation, and maybe you are, but unless you're forming your own nation, somebody else has needed to output dates like that. I guarantee you that there's a code sample, snippet, or otherwise that you can go get, or just go in and kind of play with it, and you'll be able to figure out exactly what it is that that you're trying to do with your date formats and your date outputs. Okay. I want, where is the right slide?
You looking for the slide with a few more examples on it there?
Almost.
Okay.
Okay. So then, kind of taking this one step further, could you print out a sentence like, please attend our event on Sunday, July 20, in the year 1997.
Just to show you that you really can be very specific and in terms of how you display your date. So yes, you do have a lot of formatting options.
Exactly. Now, here's what I want you to notice. I want you to notice that I can't use a keyboard. I want you to notice that we're calling strftime again.
Yep, it's the same function.
Exactly. But you're going to notice, and you might have clued in on this, you might have sort of seen a hint at this earlier when we put in the comma, that we're not restricted to just using those special codes. So if you remember back to Susan's earlier demo where she was displaying out digits, well, the thing about displaying a digit is that a digit is still one component. So all that we need was a placeholder for that number to be dropped into. But when we talk about a date has multiple parts. It's got, the day, the month, the year, and everything else to go along with it, the day of the week. And so it's very common for us to need to break it down into individual components and to put string text around it. So if you want to go in and say something like, please attend our event, or put in commas, or whatever else it is that, that you might want to throw into there, you absolutely have that capability.
Nice.
Okay.
I could print, you said print out wedding invitations with Python. Things that business applications of Python. I can start up a business with that.
I love it. Okay.
Okay, I'm just going to touch on this one briefly because it said this did come up earlier in the Q&As, and people were asking about working with other languages. So,
Yep.
We've got, if I'm in Canada, we are French and English. So if I want to see février instead of February, those sorts of situations are going to come up. That's one of the nice things about the numeric display is you have the advantage that I don't have to worry about whether it's the month is December or Décembre. So yes, you do run into some fun when you start dealing with multiple languages. We are not going to try and cover how you localize that, but we do have a hint for you where to start your Bing searches for examples and so on. There are examples in things like Stack Overflow and blog posts that talk about how do I localize a date, and I think the slide may have a reference
Actually,
to it,
if you take a look at the slide, this summarizes basically everything that Susan just said there. But yeah, down there at the very bottom, you'll notice that there's a little project right there that you can go in and check out for going in and kind of dealing with localization.
Yeah, it deals with both currencies and date features, so it's a really useful library if you are dealing with different symbols in different languages.
Exactly, exactly. Oh, and by the way, let me just fire this back up again real quickly here, only because I want to just mention right up here in the top right, you'll notice Fork Me on GitHub. There's a reason that we chose GitHub to share out our code, and it wasn't just simply because, oh look, we've got someplace to drop our code.
Yeah, we can put it on OneDrive.
Exactly. The reason that we chose GitHub is because you're going to notice when you start getting in and start digging deeper into Python, you start using different libraries like this, or you start using different libraries like strftime, you're going to notice that quite frequently they're open source. Meaning that if you wanted to go in and see exactly how they work behind the scenes, if you decided that maybe you want to get in and contribute, you have that ability. And most open source projects these days are maintained on GitHub. Actually, I shouldn't necessarily say most because I don't actually have the numbers. I don't know if it's most or not. We'll say many, just to be technically accurate there. So many projects, open source projects, are hosted on GitHub, and there's many a Python project that's hosted there as well. So a big part of the reason that we did that was also just to kind of get you a little introduced to GitHub and get you kind of poking around in there. If I can again kind of throw in a real quick shameless plug, I know I did this earlier this morning, but it's worth mentioning one more time that we do have an MVA on Git and Visual Studio. So if you decide that you do want to get a bit more into Git, maybe use this for your own projects, even if you're not necessarily contributing to others, then you can go in and do that.
So we're just trying to do best practices ourselves by sharing code the way most people share code. So you start getting familiar with the ways people tend to share code. So when you want to look at someone else's examples, you'll know how to access it.
Exactly. Yep.
All right.
Yeah.
Okay. Back to the world of dates.
Back to the world of dates. So now, at the very beginning of all of this, we started out with a basic question. I've got my birthday, I've got today. How do I figure out the number of days until my birthday? Well, fortunately, you're going to notice that there's a lot of different ways that we can start doing calculations based around dates. Now, in order to do this, the first thing that we're going to need is we're going to need to know what your birthday is.
Yeah, we already know how to ask people for a value. We just use our input function.
Now, pop quiz, what's the problem with input when it comes to data types?
Input always returns a string. We ran into this when we were talking about number variables earlier.
Yes. So we need to convert that into a date.
Right, because we want to be able to use those cool date functions to do some logic and some calculations.
Exactly. And this is where strp time comes in to allow you to do that conversion.
Not to be mixed up with string f time for formatting dates for display.
Exactly. Now, what I want you to notice here, and let me fire up my highlighter, it's going to be the easiest way to show it, is you'll notice that it's off of date time, date time. Now, first of all, why is it twice? because that datetime class is inside of the datetime module that we're using. So it's a little clunky, but that's why that's there. We've got that strp time, so that's how we're going to pull in our time. And you're going to notice this takes two parameters, two values. Number one is the input from the user. Number two is the format that we are expecting. Now, let's do two demos here. Let's start here. So let me open up Visual Studio. Whoops. How about I open Visual Studio? There's Visual Studio. OK. So what I'm going to do is I'm going to say this. Oh, you know what I am going to do? What's this? I want to comment all of those out. A lot of people have been asking about multi-line comments, and you really can't do multi-line comments in Python. You can sort of do a very hacky solution, which I really don't like. On top of that, I personally don't like having a multi-line comment, because one of the challenges with a multi-line comment is you cannot nest one inside of another. Well, what happens if I've got a full block of code and I want to comment all of that out? Well, you're going to notice if I click on Advanced and Edit, that right here I've got comment selection. And you'll also notice, let me zoom in here, that there's a shortcut keystroke there. Control-K, Control-C. And you do need to hit Control for both of those.
Yeah, you actually hold the keyboard down and go Control-K-C.
Exactly.
Yeah.
Yep. And then if you want to uncomment, it's Control-K, Control-U. So Control-K, Control-C, comment. Control-K, Control-U, uncomment.
And that is a really handy little keyboard shortcut that will definitely help you a little faster when you've got a lot of code and you're trying out different things.
Exactly. Exactly. OK. So let's do this. I'm just going to kick back real quick here to the slide. You're going to notice month, day, year. So that's what we've decided. That's what we're going to go with, month, day, year. So let's go ahead and come back over here. And I'm going to say that I'm going to declare my input, user input equals input. Please enter your birthday. And let's go ahead and say birthday equals datetime, str p time.
Somebody suggested that you could remember it as F is like format and P is put.
OK,
P is
sure.
to put the time, the date time in here. I thought that was not a bad way of trying to remember it.
No, I don't want to go with that.
I don't know what it's supposed to stand for, but put works.
Yeah, put works just fine. All right, so we'll go month. We will go %d day. We will go %y for our year, and that should give us our birth date. And let's just go ahead and print that out. We'll just do a very simple print and birthday. Excellent.
That looks good.
OK, we'll hit start. Please enter my birthday, and I'm going to go with 5, 8, and we'll go with 2014. So we'll put in this year's birthday and hit enter, and sure enough, it works.
You have successfully taken a string and converted it into a date.
Awesome. All right. Well, let's say that I decide that I'm going to get a little bit funny here.
OK.
And I'm going to say 8 SCP.
All right. Because how do you know?
I don't know.
Enter. You just said enter my birthday, and if you're used to typing in the month spelt out, then that's the way you're going to enter it.
Exactly.
I got a bad feeling this is not going to end well.
This is not going to end well. You'll notice, sure enough, it did not end well, and it gave me a very, very, very long error message. But you're going to notice the key part to this right here, which is does not match the format month, day, year. So, you know, granted, yes, a lot of that is very ugly, but it still did a very good job of telling me, the developer, this is what went wrong, that they didn't give it to me in the correct format. Now, how could you solve that? Well, when you're dealing with a console app, there isn't necessarily a very simple way to solve that. That if I'm working on a Windows app, then what I could do is I could just go in and give them a control where all that they can type in is the specific values that I want, or they only have to choose it from the UI, and that's it.
I have a suggestion actually from somebody in the audience of how you solve the problem. Tell them.
Hey, that
Why
seems
not
simple enough.
Why not in that statement when you're asking them to a date? Tell them the format you expect. So
Yep,
absolutely, you guys have already figured this out.
And it's sort of stealing my thunder here.
I know. Well, it was actually our coders have already solved it.
I had a slide.
Yeah. Sorry, we got usurped. Somebody in the audience already beat us to it.
All right. Well, let's go back to my Visual Studio and take a look at it. And actually, all kidding aside, that one of the things that I always find is if somebody's jumping ahead and they've already figured something out,
that means you get it.
Yeah, exactly. That means that we're going along the right path. Or if somebody asks a question and we answer it, like 2 seconds later, that always means that we're down the right path. So I'm actually very happy.
That is actually, exactly. I'm seeing lots of great questions where it's like, we're about to cover that. So I can tell that some of this, you guys are immediately not only understanding, you're thinking, but then when I want to, and we're trying to address those, we're trying to get to them. So you're thinking the right way.
Yep, exactly. Now, I just updated the code here to kind of add that in. And the nice thing is that putting that month, day, year, that's sort of a convention that most people understand, that if you've gone to a lot of websites, for like credit card expirations and things like that. So you've seen all of that. So now I'm sort of prompting the user, hey, this is what we want. So, okay. Now, back to our slides. There we go. All right. Now, you could also add error handling.
Yeah, that's not going to, you still want to tell them to enter the right format, but in addition to that, you should probably include some error handling, which we'll cover tomorrow. Just because if they do enter something in the wrong format, maybe just because they hit / instead of /.
Yeah.
You don't want the code going and exploding everywhere and giving them all these ugly messages. Said tomorrow we'll look at how to handle that a little more gracefully.
Is there a module where you can add on that sound effect? Yeah, exactly.
I'll have to look up if I can find a Python module that allows sound effects. That would be awesome. All right.
All right. In any event, so the dates then, this seems like a bit of work. So why not just work with everything with strings? Well, the problem is, what about calculations? That about the only thing that I can do with a string is concatenation. Well, now you're going to notice that I've got things like the ability to do addition and subtraction because it knows what a day is.
And so can I point out how awesome this is? One of my first real-world programming assignments, I was my first programming job. Graduated school, got a job. I was a member of like 20 programmers on a team writing code. And one of the things we had to do, we had to determine things like the number of days between two dates. And we didn't have this function or this ability in our code. We had, I kid you not, it was a 700-line program. That had about 9 different functions in it to do things like, say, tell me the number of days between two dates, but would convert Gregorian dates to Julian dates and back to Gregorian dates. It was a beast of a program. So the fact that we can do things like say, well, just tell me the number of days between these two dates by subtracting date A from date B, still brings me back to the days when I had to write that code from scratch. And let me tell you, that took a little while. So it's fantastic, but all we have to do is say, subtract date A from date B and tell me how many days.
It always seems so simple, but yeah, it really, and it wasn't.
We take it for granted
long
now.
Ago. Yeah, it wasn't.
No, because I'm only 29.
Yeah, exactly. Yes, only 29. Right. So back over here to 29.
That's right.
29.
Continue.
Okay. All right. Okay, so coming back over to here, seems like a bit of a hassle, so why go in and do it? Well, you're going to notice here that we could go in and just do the subtraction. And you'll notice that we'll get a difference there, and then we can see the number of days. So let's actually just go in and do this real quickly here. Where's my Visual Studio? Beautiful. So I've got my my birthday, and let's go in and just simply say print, and I'm just going to kind of keep it real simple here. I'm just going to say days equals, and let's say birthday minus current date, and we'll just do a print and days.
Sure.
There we go. Just kind of keep it nice and easy. And I could have made it, a little bit fancier there. That I could have gone in and maybe
okay.
Oh, it's giving me a problem between date and date time.
You just doing some data type conversions there? Is this the part where I start juggling and doing data? Did we mention in one of the earlier modules that somewhere along the way we would have an error or a mistake in our code? I think so. Yeah, I don't.
Oh, that's why.
It happened, guaranteed. You think you got it there, Christopher?
Yeah, this is one of those, sometimes you just start moving too fast and you just forget a little bit of code. Here's what I want to highlight, because this is actually very important. And I always love when something goes sideways, because it does give us the opportunity to kind of use this as a teaching moment. I want you to notice something, and actually it's sort of funny because this will be our next slide. I want you to everybody read aloud the word that I have just highlighted there, the word that I'm circling. Date time. Date time, is that a single word or is that two words?
Date time appears to be showing up there as a single word.
Okay, but in English it's how many words?
Date and time could be treated as two words.
Two words, yes. Okay, so date
and time. Yes.
So this is a different object. This is both date and time. The only thing that I'm interested in is the date. So you know what I need to do? Is I need to just tell it I only want the date.
Oh yes.
That was where I went wrong. And this is something that comes up constantly. It comes up in programming. The biggest place where this comes up is in databases. When you're doing reports, ask somebody about the midnight problem, which is when you're trying to get today's all the orders from today. You can't just simply go in and say where date equals and then whatever today's date is, because in a lot of places it's going to be date time. So that would include midnight then as the time. Well, if the order was at 3 o'clock, that's not going to come out as equal. So there's a couple little tricks that you can use to get around it, but that was the trap that I fell into here. So I just needed to make sure that I use date. So now, let's just, let's go in and dot date.
There we go.
Now,
that should help.
Hit start, and then now let's go 9, 30, 20, 14, enter. And now you're going to notice 7 days.
Hey, 7 days. Sweet.
Hey.
Awesome. Very
All right. Cool. And then you'll also notice that I could have gone days off of that, which would just give me the days. So we'll just say 9, 30, 20, 14. And you'll notice just 7 days.
7 days. So you could just return just the number of days in between.
Exactly, yeah. I'm just going to put that off to the side, kind of let that sit there on the screen for a second.
Sure.
So that way anybody who's following along kind of has the ability to see, oh, okay, that's what we did. And again, just to kind of review, that was the part that I missed right there.
That was it. That was the mistake you had in your code. You'd forgotten to say, just give me the date.
Just give me the date. Exactly.
All right.
Yep. Okay. Cool. Let's go back to slides. So, now, here's the thing. You are going to be amazed at the amount of work that you have to do with days. Susan told the story from a while ago, again, only 29, where she had to go in and write 700 lines to go in and start tweaking and working with dates. Again, we're not launching rockets here. Whatever it is you're trying to do, somebody else has already done. Chances are they've already been kind enough to go in and create a little project. So if we take a look, you're going to notice date util. So let me just click on date util. And there is a whole set of different functions and otherwise that are available to you to go in and play with. So you could go in, download this little module, and then start playing around. Source code development, you're going to notice, interesting. See, not everything is inside of GitHub. This is actually using Launchpad. There you have it. So, but in any event, although all similar products there. But in any event, the big point that I want to make is if you are looking for some bit of functionality, I promise you it's out there. All that you have to do is just kind of go look, and you'll be able to find it. Promise. All right. Let's close all of this out, taking a look at the other part of date time, which is?
The time.
There you go. What about times? Well, you're going to notice date time, so yes, it can in fact store times. There we go. So if we go in, we say datetime.now, you're going to notice that I could go in, grab the hour, grab the minute, grab the second to go in and print all of that out. And you'll also notice that there's a whole bunch of different format strings that are available. Remember again, strftime.org will show you all of those that are available. I'm not going to sit here and just keep reading them all to you.
You wouldn't memorize them anyway.
Well, yeah.
There's no point. You look them up when you need them.
Exactly. And me reading them, I would just wind up putting people to sleep. Yeah.
And it's late in India right now.
Exactly,
so
yeah. It's late a lot of places right now, yeah. Okay, so let's just kind of go back to my little code. I'm just going to comment that bottom part out again. Control K, Control C, Control K, Control C.
Yep.
Comment. I'm just going to sneak back up here, and I'm just going to say print current date, and let's go in and say current date dot day or dot minutes.
Okay.
There we go. And hold on one second, because I think I'm going to be wrong up here. There we go. I want now, not just today.
Yeah,
I want now.
Okay.
So now, let me go back in.
Do you want to go just double check that syntax on the slide?
There we go.
Okay.
Nope,
I'm
good.
Just missing a close. We were talking earlier about closing
Have
double
some
brackets.
faith.
All right.
And now, have some faith, and I still blew it. But that's okay. So let me do this. I've got all sorts of funny things going on here.
I wasn't quite sure why you had that extra date in there.
There we go. And I'm still missing something. That's all right. You know what I'm going to do? You know why? Because I had started going one direction, and I just sort of went a different direction with all of that. But
that's fine.
Yeah, but in any event, and I'm just going to leave that there at the moment. But what you're going to notice there is that we could go in, use the date time like that. We could also go back in and go grab our hour, our minute.
We have properties. We have properties just like we did with dates. We could use string f time just like we did with dates. The only difference is we're dealing with the times.
Exactly. Yep. So there's our little minute, and then away we go from there. So you can go in and go grab all of that, and there it is. Okay. So dates, times. Again, here's the thing. You are going to find yourself working with date times on a regular basis. And yes, as we've seen, working with date times, again, not difficult.
It's fiddly.
It's fiddly. It's a little funky. It's a little bit of can be a little quirky at times. The biggest thing that I really want to have gotten across here is sort of three things. Number one is the fact that we do have date time.
Yes.
Number two, the basics of how to go in and play around with date times, how to accept user input, how to do a little bit of math, a little bit of display functionality. And then finally, last but not least, number three, and this is the biggest point, and it's a point that I know I've made over and over and over again today, but it really is that important. Whatever it is that you're going to be looking to do, somebody else has done it. There are utilities that are out there. Don't be afraid to go grab them. That we talked about the date util. We talked about localization utilities. We talked about the function strings. Go take a look at all of those. Go use those to help make your life easier. Okay, so with that, I have a challenge.
All right, and this one, be prepared. You've seen us struggling with the formats of this one, so this one's going to be a little more difficult for you because you're going to have to deal with some of the formatting issues. So what you want to do, ask your user, give you a deadline, figure out how many days it is that they're going to have, maybe also go ahead and give it to them in some combination of like weeks and days. So I would suggest, first of all, just try and solve it so it tells them how many days they have to complete the project.
Yep.
Once you get that working, then you say, all right, bring it on. Now I'm going to break it down and give it to them as days and hours or days and minutes and things like that. So break it down. But I would suggest get the first part working and then go to the next level. Yep. Cool. Well, with that, what do you say we take 10 minutes? Yep. And then we'll come on back, depending on something. I was trying to get a segue. I was trying to get a joke there, and it
failed. We're going to talk about if statements, which is all about we're going to do one thing if something is true. So depending on this, we're going to do. Anyway.
You were just trying to be clever. We'll be back in about 10 minutes.
There we go.
We'll
be back in about 10 minutes. All right, we'll see you then. So I says to the guy with the monk, oh, we're on.
Oh, we're live. Yeah, sorry.
Yeah, sorry.
Back.
All right. Hi. So, welcome back. Now, for those of you who may have missed it earlier, where have you been? No, for those of you who are just tuning in, that is Susan Ibach. I am Christopher Harrison. This is Introduction to Programming Using Python. And so far today, we've actually seen a lot of core components to programming in general, and then, of course, specifically in Python. We've played around with strings. We've played around with numbers. We've played around with date types. Now it's time to start adding a little bit of logic to our code, adding in a little bit of branching, and we start off that by utilizing if statements.
Absolutely. When we start doing problem solving with code, one of the things that we're going to have to end up doing is helping our code make decisions, figure out when to do what. Otherwise, we're going to be very limited in the types of problems that we can solve. You know, every day in our normal lives, we're faced with decisions. We have to decide in the morning whether we're going to school or going to work. Am I going to drive or am I going to take the bus? We have to decide tonight, you know, when this is all done, you know, am I going to cook at home or am I going out for dinner?
Going out for dinner.
You know, I need a new PC. What laptop should I buy? So we're always being faced with all these different decisions we have to make. Surface?
Surface.
Yeah, Surfaces are sweet little devices, I got to say.
Yep.
And the choice we make, though, does depend on different conditions. Whether we decide to drive or take the bus might depend on what time is it. I mean, if I'm running late, I might have to take the car, or am I going to miss the bus? Or what's the price of gas? If the price of gas has gone up a lot, I'm more likely to take the bus. If I'm trying to decide, do I cook at home or do I go out for dinner? The kind of things I think about is, well, is there any food in the refrigerator? You know, those are kind of factors that make a difference. Or am I broke? If I'm broke, I'm not going out for dinner. I better cook at home. What laptop should I buy? The kind of things I think about is, well, how much RAM do I need? How much power do I need? How much money do I want? And I know you do want touchscreen.
Yeah.
Once you go touchscreen, you're never going back. We actually had someone asking what are these monitors touchscreen, and you've even noticed this even here.
Oh yeah.
Leveraging touchscreen. It's funny how quickly you get used to it.
I never thought I would want it. Then, like within a day and a half, now I just go up to random monitors. Like, why isn't this touchscreen?
Yeah, you just end up leaving fingerprints all over your friends' monitors.
Exactly, yes. That's how you can tell I've been in your house. Yes. Fingerprints on your monitor.
So there are a lot of different conditions, though, that affect what decisions we're going to make. And if you want to be able to write code that's going to solve problems, your code is going to have to make decisions as well. So let's say you're working at a bank. One of the rules they have at a lot of banks in North America is they'll waive the transaction fees if you maintain a balance of over $1,000. So if you were writing a program that has to calculate what fees do I charge a user, you need to be able to say, well, if it's over $1,000, don't charge this fee. If it's under $1,000, charge the fee. Very simple, but very real world. If a user has canceled an appointment less than 24 hours before appointment time, a lot of times you still have to pay for the appointment. So again, if you were writing the program that was sending out bills, it would have to look at, well, what time did they cancel the appointment? If it was canceled a week ahead of time, don't charge them. If it was canceled within a day, charge them. And then I have to add a little Canadian reference here, right? My Twitter handle is Hockey Geek Girl. I am a Canadian, and I do love my hockey. So the other analogy I have is if a hockey player does get the puck in the net, then you add 1 to the score. If they miss the net, obviously you wouldn't do it. And you may be sitting there going, Susan, why would you ever write a program to do this? Well, hey, I could be creating a video game. There is Pygame, which helps you use Python for video game development. And you know what? If you've ever go to a hockey game, there is actually a sensor inside the net at the professional hockey games. And when the puck goes in there, the sensor detects it, and that triggers the little light to go flashing and the little whee, that lovely horn noise that always goes off when someone scores a goal.
We're not going to do sound effects on that.
Yeah, that's never good. But that's code. It's saying if the puck goes in the net, then play this sound, light this light. That's code behind the scenes what's happening. So there's tons of situations, real situations, where our code has to say, if this happens, do this. And that's what we want to get into here. So what we're going to do is we're going to use an if statement. So if we take a look at the code here, there's a few pieces of code here in terms of syntax. We start off, hopefully that first line of code looks familiar and isn't scary at all.
Yep.
All right, so I'm using an input statement to ask somebody to enter a value. I'm storing the value they give me into the variable answer. Now, so what do we do have as syntax, though, is we have an if statement. So we're saying if the answer they give us, I'll talk about this in a second, is yes, then print the following message. So without worrying too much about syntax just yet, basically we're saying if the answer is yes, print, that will be an extra $10. Because I'm saying, do you want express shipping? Yes, okay, then I'm going to charge you more.
It sounds actually relatively close to English, that essentially what you're saying is if this is what I want, then do this.
Yeah. It really is.
If this is the state, do this.
Exactly. So now we understand the logic of it. Let's go back to the slide and take a look at the syntax behind it. So you have the keyword if that indicates we're looking at a condition. You have a colon at the end of the line. That is very specific to Python syntax. If you forget that colon, you're going to get weird little error messages appearing in your screen, and eventually you'll go, oh, I forgot the colon. That's one of the ones I forget all the time. And then the other thing, and this is very significant, is the print statement is indented. That's how Python knows what's the command that I only execute if the answer is yes. If I say answer is no, and you have indented code, that code's not executed. So the indenting is crucial here because that's how Python knows what is the code you want me to run when the answer is yes. Now, if we go back again to the code, there's one last little piece I want to show you, and that is this double equal sign here. You'll see this in some other programming languages as well. In earlier code, we even have it on our previous line here, we use the equal sign to mean take this value, put it in here. So we say take the result of our input command, our input function, put it into the variable answer. So we're assigning answer the value returned by the input function. So the equal sign means take this value, put it here. So we can't use that in an if statement. It would be confusing.
Exactly, yeah. And that's really, it's sort of both for us, but it's also for the runtime as well to understand the difference between an assignment where you're taking a value, putting it into a variable, and when you are trying to do a comparison.
Right.
Yeah.
So as a result, we end up with a special syntax. When we want to say if something is equal to something else, the double equals is the syntax for saying is equal to.
Yep.
So now if you look at this slide, we're saying if answer is equal to the string yes, then we have our colon, that's just part of the syntax, then print on the screen, that's going to be an extra $50.
Perfect.
So that's the syntax. Let's just look at a few examples so you can get a handle on it. We'll do a demo as well so you can start to get comfortable with it.
It's sort of funny watching the Q&A right now because there's now a little bit of hockey banter going back and forth. You know, go Ducks. Somebody said, you know, we should make a dyno to set off the horn every time the Rangers score. Somebody else said that'd be a very quiet dyno.
Oh,
I mean,
man.
Yeah,
And I'm sorry, speaking as a hockey geek girl, it's go Sens go. So I am a diehard Ottawa Senators fan. So, but not that I have any great hopes of winning the cup this year, but I am, for the record, go Sens go. So I showed you the double equal sign for is equal to. It's probably a good idea to talk about some of the other symbols you might need to use.
Yep.
Because sometimes you might want to say, is it not equal to? And that's another one where you just have to, this is one of those ones you will actually end up eventually memorizing it because you'll use these fairly frequently. Not equal to, the symbol for that is a exclamation mark followed by an equal. The exclamation mark is frequently used in programming languages to mean not. And that's why exclamation mark equals means is not equal to. So it's a convention that's been used in other programming languages. So the nice thing is, yeah, once you learn that syntax, you'll be able to use it elsewhere. Then if you go back to the slide, we can see a less than symbol. That's nice. It's the same as when we learned it in school.
Yep.
Greater than. One we didn't see necessarily when we're doing math in school is that less than or equal to. Because there certainly are times like, hey, wait a second, I said you don't pay service charges if you maintain a balance over $1,000.
Right.
But what if it's exactly $1,000? Do I have to pay the fees?
It's a good question.
It is. And is that a question the programmer answers?
No.
Yeah, this is one of the things you will run into in some situations. If it's your bank, you're defining the rule, and you're saying, well, no, it has to be over $1,000. So you have to have $1,001 to not pay transaction fees.
Right.
So this is actually something you will frequently need to double check on. And if you're writing code for someone else, you'll probably need to go ask them. Because they'll often say, oh, if it's over $100, if they make a purchase over $50, shipping is free. What if it's exactly $50? How do you want to handle that? Because you may discover if it's greater than or equal to $50, the user should not be charged for shipping or doesn't pay transaction fees. And the syntax for that, as you can see here, is greater than equal to or less than equal to. And there's some examples on the right-hand side of sort of what the code might look like.
Yep.
But I will say, we talk about making mistakes as coders. One of the most common mistakes we make as coders in if statements is less than should have been less than equal to, or greater than should have been greater than equal to. That is one of those. And it's one of those ones that the code works, but it doesn't do what it's supposed to do.
Yeah. Yep.
Yeah. We getting more hockey comments in the background there?
No, well, we are, but yeah. I was actually laughing. I was paying attention. I was listening to it, and I was laughing at that, because that really is one of the hitches in my delivery, that I frequently inverse the Boolean statements.
Yeah.
So, yeah.
Easily done.
Yep.
So here's another example of an if statement. And this is an example on the slide here. And what's significant about this is I want to point out the indenting here. So Christopher, do you want to take a guess here at if I ask somebody, would you like express shipping? And if they answer yes, I charge them an extra $10. Now, if they answer yes, do you think they're going to see that message, have a nice day?
I'm going to say yes, based on what you told me about tabs. And because of the fact that print is back on that first line, I'm going to say that yes, have a nice day is going to print.
And what if the person says, no, I don't want express shipping?
I'm going to go with the same thing because of the tab.
So all in all, if somebody says, yes, I want express shipping, what do you think is going to appear on that screen?
Right. I think if somebody says yes, I think it's going to print out, that will be an extra $10. Have a nice day.
Right. And if they answer no?
Have a nice day.
Exactly. Because, and this is sort of where that indenting is so important to see, and I just wanted to illustrate that a little more clearly, that only if the answer is yes will the statement that's indented, or the statements, you could have multiple commands here, only then will those statements be executed. The code that you have that's not indented, doesn't matter if the if statement is true or not. Basically, it's going to ask the user for if they want express shipping. If they answer yes, it'll print the statement. But regardless of what they answer, it will continue executing the non-indented code, and everybody will see the message, have a nice day.
So if I wanted multiple lines to execute on that if, I would just need to keep tabbing them in to make sure that they're all there. Okay.
Exactly. Perfect. So you indent however many lines of code you need to execute. If answer is yes, you just make sure they're all indented. When you have a line of code that's not indented, it says, oh, that was all the code you wanted executed in that if statement. We're good. Now I just execute this code all the time.
I like it.
So the print statement being indented is essential. It's part of the Python syntax. Particularly important for if statements, and later on we'll see it with loops as well. All right, so let's take a look at that in terms of code, because you actually brought up an interesting scenario there, Christopher, of like, what if I do want things like multiple lines of code executed? So let's try that out. Whoops, cancel. Sorry, I didn't mean to do that. All right, so let's go write some code. And what I'm going to do is I am going to say, let's see, favorite team, based on the conversations earlier, input, what is your favorite? And you know what? I'm gonna stir it up a little by adding a U to the word favorite, just for the Americans out there. All us British, Canadian spelling folks, Canadians are famous for inserting extra U's and everything. We even pronounce the word about as if it has an extra U. So I'm gonna include that there. What is your favorite hockey team? And then I'm gonna say if favorite team equals Senators, then I put my colon. And now one of the nice things is Visual Studio is smart enough that when you hit the Enter key after the colon, it automatically indents the next line. Because it's guessing you just wrote an if statement, chances are you want to now write the code, but only executes if the if statement is true.
Yep.
And if favorite team equals Senators, oh, and I've already got a typo.
Yep.
Before everybody starts throwing it into the comment window going, Susan, you've got a mistake, that should be equal. So if favorite team is equal to Senators, and that requires the double equal.
Somebody else has already written one out for Blackhawks, by the way.
Awesome, very nice. Then I'm going to say, yeah, go Sens go. Go, And then I'm just going to say print. It's okay if you prefer football/soccer, because depending on the country, you may call it football, you may call it soccer or cricket or tennis or insert sport here.
Now, real quick, just to answer the question in the chat window, if we bring the code back up, right there, you've got if favorite team. By the way, you've got okay, you've got a small inconsistency. You said favorite on the display, but favorite on your variable name without the
name. Okay,
but in any event, just to answer the question, that double quotes, that's checking a quality there. So single equals.
You mean the double equals?
Sorry, double equals. Double equals. The double equals is a quality. The double equals is a quality. Single is assignment.
Yes. So single means take this value, put it here. Double equal means is this equal to this?
Exactly. Yep. That's it.
You've got it. And yes, just to be consistent, I'm going to add an extra U to my variable names too, since you pointed it out.
Yep.
So if I run this code, and let's just slide it over so you can kind of follow the logic, and I enter Senators as my hockey team.
Yep.
Then it says, yeah, go Sens go, and it's okay if you prefer football or soccer. Whereas if you run this and you say Leafs, my son is a diehard Toronto Maple Leafs fan. It's a very tough life. They're not known as the top team in the hockey league. And I just say, well, it's okay if you prefer football or soccer, but it doesn't display the go Sens go.
Okay. Perfect.
And just because we were talking about what if you have multiple commands you want to execute, if a condition is true, I'm just going to add a second line of code here. And I'm going to say, but I miss Alfredson. We had a tough time with my team. They traded away our captain last year. So we miss our old captain, Daniel Alfredson. So anyone who would say favorite team Senators would know about Daniel Alfredson. But if you don't know the Senators, well, that's not going to mean anything to you. So I'm only going to display that message if you say you like the Senators. So now, when I specify Senators as a team, it says, yeah, go Sens go, but I miss Alfie. And then again. So you can see all the lines of code that are indented are only executed when you specify Senators as a team.
Perfect. Okay.
Now, of course, there's one thing that eventually somebody's going to be going, but what if?
Yep.
What if I enter Senators in lowercase letters?
Only one way to find out.
Yeah. So, because you'll notice when I said if favorite team is equal to Senators, I put an uppercase S there. What happens if I type in lowercase? So is the string, and I'm going to ask you, the string Senators in lowercase letters, is that the same as a string Senators with an uppercase S?
Well, first thing this morning we learned was Python is case sensitive, so I'm going to say those are different strings.
Yeah, let's find out. And oh, look at that. It comes back right away. It does not think my favorite team is the Senators. It is case sensitive.
And there's actually one other big thing that's worth pointing out here, since now we've done it the other way, is that you'll notice on the display that it just simply says, it's okay if you prefer football, soccer. It does not say either of those two tabbed in lines. It doesn't say anything about go Sens go, or in particular the second line, it does not say I miss Alfie because of the fact that those were tabbed in. So you'll notice the tabs again make a big difference there.
Yeah, those tabs, and because they were tabbed in, those messages do not appear.
And a couple of people have mentioned, you know, the tabs there is subtle, and absolutely it is. But one big point that I would make here is this is actually a good habit to get into anyway, because there are a lot of other languages like VB where they're going to use an end if, or C#, which is going to use curly braces to denote the beginning and end, where technically that's what's going to figure out what's going to run if that happened to be true or not true. But you're still going to want to tab it in anyway just to make it more readable. So is it subtle? Absolutely. But it's still a very good habit to have gotten into anyway. So when you make the move to another programming language or to another programming language, you're going to have learned these good lessons.
Yeah.
So yeah, it is subtle, but yeah.
But at the same time, it's interesting. If you look at the code right now visually, what jumps out at you is, hey, there's some code here that's pushed over to the side.
Yep.
And it is very visual. A nice, simple way. The Python interpreter has to have a way of knowing what code do I execute only if statement is true. Yeah, you have to have brackets or something to tell it stop here. But the indenting, it's actually a habit most of us do in other programming languages anyway. So they just said, let's just adopt what they're doing anyway and not make you write anything extra.
Exactly.
That's what I like to think of. It's just less work.
Yeah, there you go.
I'm a lazy coder. I like it.
And again, just to highlight, those do need to be tabs. You need to tab in.
Which it will do by default when you hit the Enter key. But if you need to add extras, yes, that'll work. So that's your basic if statement. Now, I guess we should fix that, shouldn't we? Now, I'd left us sitting here with hanging with a problem. Which is somebody typed lowercase and, didn't find a match. So we should really fix that. Now, if only there was a way we could use something to manipulate a string, because the problem is I have a string, and the user didn't enter it the way I expected them to. If only.
I remember doing a module on this.
On strings,
I remember
variables.
I was typing something in, like IntelliSense came up. That was cool.
So, exactly. We saw a number of functions we could use to convert values. So I could take, for example, the value for favorite team, and what if I converted that to uppercase? Right? Okay, now this is a funny one, and I've done this before to myself by accident. This is one of those silly mistakes. I told you I'm good at finding coding mistakes because I've made a lot of them. And here is an exact example of a piece of code I have written and run and beat my head against a wall going, why isn't this working? So take a look at this code for a second. I'll give you a second to read it. And see if you can spot Susan's mistake. I'm going to run it now. I'll leave the code up on the side so you can still look at it and see if you can see what I did wrong. And I type in senators, and it's going to convert that for me to before it does the comparison. And then I enter senators, and it still says, hey, it's still not executing my if statement. Can you see what I did wrong? And I have done this.
Yep.
Go ahead, Christopher.
The problem is you've got senators with a capital S and lowercase after that.
Right. So I'm taking the value they type in for a hockey team, converting it to all uppercase letters, and saying, by the way, is senators all uppercase, is the value they typed in all uppercase equal to this value that contains lowercase letters? And that's where I sort of sit there and go, oh my God, did I really just do that?
Yeah, you've hard-coded in a bug.
Yeah, so what I should really do here is this should be senators would be helpful.
Yep.
And now it should match, no matter how I type it in. Yay, success. Where I usually actually get caught with this isn't necessarily that I had the string senators. What often happened is somewhere earlier in my code, earlier in the day, I had written some other code early. Exactly. I had written a best team equals senators. And what I had was maybe I had something like it was up here somewhere else, and over here I said, oh, if favorite team equals best team, then go ahead and continue. And maybe this was even a value I read from a file somewhere where I couldn't even control the case. So maybe when I read this from a database or read this from a file, I don't know if what I read from the file was uppercase or lowercase. So I'm saying compare what they typed in to a value I read out of a database or out of a file. So now I'm saying, well, I want to convert it to uppercase so it's case insensitive, but now what I need to do is go back to the code, and I may need to actually say convert both sides to uppercase before comparing.
And that generally is the best way to approach this, that if you're going to say, I'm going to convert one side to be it uppercase, lowercase, or otherwise, convert the other side as well, so that way you know that it's always going to be that consistent casing, so you won't get stuck there. I would also mention that a couple of people mentioned about, well, you could use capital, you could use lower, and all of that is 100% true.
They will all work.
Yeah, as long as you call the same function on both sides, make sure that they're both cased the same way, it'll work.
Yeah. For some reason, upper seems to be the more popular choice.
Yeah.
But there's absolutely, it would work with lower. It would work with the initial capitalization function as well. Yeah, just make sure they're both the same casing.
Yep.
It does happen. That is one of my Susan's pet mistakes that I just make all the time. So I just wanted to share that one with you.
Yep.
One of the other things that's interesting about writing if statements, we learned about how you can write code different ways. If statements can often be expressed in different ways. If you look at this slide, I could say, if the answer equals yes, do the following, or I could say, if the answer is not equal to no. So the syntax for saying if the answer is not equal to no, I could have used the exclamation mark equal symbol, or I could have said if not answer equals no. This is a way of saying if the condition I'm providing is not happening. If this is not true, do this.
Right, okay.
So saying if the answer is yes, do the following. If the answer is not no, do the following. It's kind of saying the same thing.
Yep.
I could say if the total is less than 100, or if not, total greater than or equal to 100. Because if a total is not greater than or equal to 100, then it must be less than 100.
Yep.
So which is the right way to do it? Well, I don't know. It really falls into a certain amount of what do you like. I find it easier to express it in a positive way. I find saying if not total, if not answer kind of confusing. My brain just, especially, hey, when I'm getting tired and it's late in the night, I start looking at that and my brain has to think about it 6 times.
Exactly. Yeah, and especially if you've got, the word not, and then you've got not equals there, and now you're dealing with, double negatives and double secret probation, and, I just don't want to have to sit down and try to figure all of that out. So really, when it comes to writing those things out, keep it as simple as possible.
Yeah. But
what's the easiest way you can state it, and just go with that.
Yeah, so generally I will try to put things in the positive perspective rather than the nots if I have a choice. But the other way I think of it is, think of it how you would say it out loud.
Right.
If a course is completed, then send a certificate to the student. So you'd say, well, an if course completed is yes, send the certificate. If the order is under $50, add a shipping charge. Okay, then if total is under 50, add shipping. If a cat has not been vaccinated, call the owner. Now this one, you go, oh, see, now this one, it's if they have not been vaccinated, call them over. So in that case, I might actually use if not vaccinated, because it's actually the way I think of it. I only do the action if the cat is not vaccinated. So,
You could also use the not equal, so you could say if vaccinated, bang equal, or bang, exclamation point, bang, it's a Unix thing. In any event, you could also say the exclamation equals. And again, it does come down to a matter of personal preference.
Absolutely.
Which do you think is going to be the easiest to read?
And by the way, that is a great way that's another great geek tip. You want to learn how to speak geek with your geek friends? They'll say bang for exclamation mark. Yeah. It's just one of those terms that's used. And yes, it's a hangover from...
Yep.
Hangover, that's a nice term. It's held over from the days of Unix. Maybe it is a hangover from Unix, let me tell you.
Completely
there was some stuff going, Unix was not a user-friendly place to be coding. Bring back the VI editor, no.
It makes sense.
And we did talk a little bit, this is just reinforcing that it is case sensitive when you do a comparison. So if you type uppercase and your if statement is looking for lowercase letters, then it's not going to be considered true. Uppercase YES is not equal to lowercase YES. So it becomes very important to use a function like lower or upper and do a conversion before you do the comparison. And you may want to actually convert both sides, especially if you've got a variable on the other side. You might want to do that convert to lowercase on both sides of your expression. Now, what if we want to do an if statement that uses numbers instead of strings? All the examples so far have been looking at strings, but absolutely there'll be times you want to do things like, hey, when you deposit money, if you deposit over $100, you get a free toaster. I remember these days.
Yeah, I was just going to say, yeah, you can't be 29 and remember the days of depositing something and getting a free toaster.
Hey, are you kidding? People still use toasters? What's wrong with that?
Well, yeah, but you don't go to a bank and get a free toaster anymore.
Where do I go get a free toaster?
We give them out here.
We give them out here.
All right. Okay.
Cool.
Free toasters.
Yeah, so we'll go collect a toaster. Excellent.
Awesome. So in this case, if you follow the sort of logic, if a user enters a deposit amount of 150, then that's more than 100. So you get a free toaster, and it'll say "Have a nice day." If they enter $50, well, $50 is not more than 100, so they will not see the message "You get a free toaster." They'll just see "Have a nice day." But here's the big one. What happens if they specify exactly $100? What do you think there?
So if they specify exactly 100, so it's got to be greater than, it wasn't greater than, so it's just going to be "Have a nice day." Yeah. You're not going to get a free toaster.
That's right.
There's no toaster love.
No toaster love. That's right. 100 is not greater than 100. It's equal to.
Right.
And this is one of those scenarios where it's really important when you're working with if statements and numeric values to test all those combinations. Test a greater value, a lesser value, and exactly equal to. And then if you're not sure, because you really have to ask, and sometimes you may have to go ask somebody, hey, if it's exactly $100, not $100.01, $100.01 is greater than 100. But if it's exactly 100, do they get the free toaster? Because those kind of mistakes can actually cause some pretty serious problems.
Yep.
Because you're actually changing their business rules if you don't do it correctly. So I think we can do a quick example of using some numeric values. So this is if statements with strings. And I'm going to use your wonderful trick you showed us earlier, Christopher. I'm going to use that Control-K-C command.
Control-K, Control-C.
Well, you just hold down the Control key. You go Control-K-C. I just hold Control, go and Control-K-C.
Yeah, I always just say it with the second control, because a lot of times people will let up off the control.
Yeah, you have to hold the Control key down the whole time.
Exactly.
Very true.
Yep. Yeah.
But I love that little keyboard shortcut. There's a way of adding that to your toolbar as well, but I can't remember how to do that.
Yep.
So let's add an if statement here, if with numbers, and we're just going to say if, let's see, let's do a deposit equals an input of how much do you want to deposit. There we go. I'm going to add a space there so it looks a little bit nicer on the screen. And then I'm going to say if deposit is greater than 100, then we are going to print enjoy your toaster. Woohoo! All right.
Toast.
Yes, exactly. And otherwise, we're always going to say print have a nice day, because regardless of how much money they deposit, we're going to always wish them to have a happy day. All right, now the first thing is when I run this code, I'm going to run into a little bit of a crash. I am expecting this one. Deposit, I want to deposit $150.
See, we'll always admit when we had something go sideways that we weren't expecting. Yeah. This one we were expecting.
This one we are expecting. And I love, I do love the fact it gives me even a line saying, this line here blew up on you, Susan. It says, okay, you have an error. What is that error? Well, that error is unorderable type string greater int. So we're back to the usual problem again, that we have a string value and it's trying to see if a string is greater than an integer value. So we can't compare a string and an integer. This is like when we're trying to add strings and integers or compare them one equal to another. So it's my data type problem coming back to haunt me again. Because if we go back and look at our code, you can see that we used the input function to ask somebody to enter a value, and input functions return a string. And then we're trying to compare a string to the value 100, so it's giving me an error.
So there we are back at data type conversions here.
Right, so we have to think back 2 modules now. And it's funny how we were like, man, 5 modules in, I gotta go back 2 modules. This is getting hard on the brain. But there was that float function, and I'm gonna get fancy here. I'm actually going to do it. This was actually suggested by somebody in the Q&A.
Yeah, a lot of people
saying, why don't you just convert it to a float right away when you get it back?
And the answer really is, it just depends on your level of comfort. That I know a lot of people that will look at that, especially people that are new to programming, and seeing the 2 things happen at the same time will kind of cause them to be thrown for a loop.
Yeah.
So they like that separate breakdown of just take the user input first, convert it second. Okay, now let's go ahead and use it. But can you go ahead, just like Susan had on her code here, and combine them both? Absolutely, 100%.
Yeah.
Yep.
So it's just said, you guys have some choices there in terms of how you write your code.
Yep.
Somebody had asked about in the Q&A, so I just wanted to show you, absolutely, if you want, you can take the value returned by the input and immediately convert it to an integer or a float before you put it in your variable. So right away, it's treated like a numeric variable. So if we go back to the code, you can see I have basically said take the results of the input statement and convert it to a float, which meant I did need to remember 2 closing brackets at the end. 1 to close the input command and 1 to close the float.
Paren, paren.
So now when I run, and this time when I type in $150, oh, now it's blown up for a different reason. Unorderable types. It's still giving me a string. Did I get something?
You want it to be an integer, I believe.
Integer?
Just 100.
Oh, yes. It's an int, not a float. Thank you.
Yep. Data types.
Yes, it's all getting the right data types. 150. There we go.
There we
Enjoy
go.
my toaster. Yay!
Yay,
I get to have a
yay
nice
toasters.
day. I get my toaster. This is all good. So again, now, but of course, remember, I just want to prove that if I type in exactly 100, I don't get a toaster.
Have a nice day.
100 is not greater than 100.
Yep.
Which hopefully is the way the bank wanted me to implement it. I'd better go double check if I'm not sure. That is so important. When in doubt, ask your users. Find out the real business rules. So, yeah.
I was just going to say, now we've actually got enough skills that we could, take the rounded pennies off and start funneling them off to a separate account somewhere.
So it seems to me somebody did that many years ago and made rather a scary amount of money and got in a lot of trouble later.
There should be a movie around that as well.
Yeah.
In any event, okay, carrying on.
Going back,
Yes.
so just always remember when you're testing, if we look at the slide, we always want to make sure when we're using greater than and less than in our if statements, when you're testing, always test a value greater than, a value less than, and what we call a boundary condition, the exact value you're comparing to. Always test all three situations. Now, one of the things we did just talk about was the issue of when we're asking people to enter a value, right? We use an input statement. You can run into data type conversion errors just like we did now. And so you may need to actually convert that to an integer, because you can see below that if I actually take a look here, you can see in the error message that the actual error message that's being returned is it's got an integer on one side, a string on the other. So we need to convert that integer, we need to convert the string into an integer so we have the same data type on both sides. So we fix that. And you know what? My apologies, there's a typo on this slide. That should be if int deposit, not if float deposit, because we just saw that in the demo, but when I convert it to a float, it doesn't work. Now here, you'll notice I actually converted the data type when I did the comparison. So it's funny, every time I write the code, I approach it a different way. I don't always think about it. So lots of different ways that you can, there's different times in your code when you can do the conversion. It's really up to you. Do you want to do it right away? Do you do it when you need it? The only thing I would say is if you're going to find yourself converting it 8 or 10 different times, do it once, put it in a different variable that'll store the float version of it, or do it right away. Yeah. Because I'm lazy. I don't want to have to convert more often than I have to.
I'm noticing that theme today.
Yeah, I'm lazy with my code. And here's the example actually where I've done the conversion when I actually use the input statement. So I do have that example in the slides as well. Though again, I'd like to make a point. I did make a typing mistake here. That should be int input, not float. So replace float with int, please. I will try and fix that in the slides up on the GitHub when we have a break. All right. So the other thing that you do run into is, what if they don't get a free toaster? You might say, well, you get a free coffee mug no matter what. But if you deposit over $100, you get a free toaster. So we run into these situations where you get one or the other. So if you get this, if you deposit over $100, you get a toaster. Otherwise, you get a coffee mug. And in coding terms, that's else. So there is a special syntax we use. You use the keyword else, and you have to remember that colon after it. And this code will only be executed if the condition is not true. So in this case situation, if they have over $100, it will execute and give them a free toaster. If it is not over $100, if that statement is not true, then it jumps down and runs the code in the else statement. And it's important that the code inside the else statement is also indented so it knows what is the code to execute when the condition is not true. So now I have a one or the other type situation. It will either give me a free toaster or give me a free mug, but I'm getting something either way, no matter what I deposit now. So the else statement is only executed if the condition is not true. If we enter $50 in this scenario, Christopher, what's going to appear on the screen if I put in a deposit of $50?
Enjoy your mug. Have a nice day.
All right. What if I enter $150?
You get a free toaster. Have a nice day.
And if I specify exactly $100?
Enjoy your mug. Have a nice day.
That's right, because $100 is not greater than. We always want to test that boundary condition. Another neat trick, and I'll do a demo of this one in a second, is the idea of Boolean variables. So there wasn't one variable type we didn't talk about earlier, and that is Booleans. So a Boolean variable allows you to actually remember the result of a condition. So in this case, I've got code that goes off and asks the person how much they want to deposit. And if they deposit more than $100, then I actually create, and we often call these variables flags. It's just a naming convention we often use for Boolean variables that store a true or false, because they're often flags to us. Has something happened or not happened? So we'll often use this term and call these Boolean variables flags. So I'm creating a flag here, but in the end, it's just a variable, and the variable stores a value of true or false. And I'm saying if they deposit over $100, free toaster is true, because yeah, they can get a free toaster. And then later in my code, maybe I have a whole bunch of other complicated logic that actually updates their balances and so on in the actual system. And then later I say, oh, by the way, I got to remember, by the way, if free toaster is true, but you don't have to say if free toaster equal true.
Right.
You can just say if free toaster, then do the following.
And then the advantage here is your code is more readable. So if you put in that $100 value or something like that, the problem is, number one, if you're using that in multiple locations, you have to go in and kind of keep stressing that. But also number two is that you've now given a little bit of meaning. So kind of going back to our comment, and that can oftentimes be used to try and disguise bad code. Now, if we go in and we say free toaster, well, when I go in and I look at this, I know exactly what we're testing. I'm testing, do they get a free toaster? Rather than having to interpret, okay, well, what was the amount supposed to be? You know, and that way I could put that somewhere else, put that, say, in a function. We'll talk about that tomorrow. Put that up earlier in the code. And then in the long run, my code can be more readable and also more maintainable, because that way, if I'm doing that test multiple times, the rules change. I only have to update one spot of code.
And that's it. Yep. All about being lazy. You know, it's funny, writing the code, when you start getting further into coding, one of the things you'll discover is one of the constants of life is change.
Yep.
And whatever the business rules are now will change.
Yep.
Right now, it's $100 gets you a free toaster. Oh, guess what? Inflation, you now have to deposit over $1,000 to get a free toaster. Mm-hmm. So if I had 3 or 4 different parts of my code, maybe there was a part of my code that says, if they deposit over $100, send an email to the person to order the free toaster. And if they later on you have, oh, by the way, if they deposit over $100, we need to prompt them for the shipping information so we can send them the free toaster. And we also have to make sure that somewhere in the code we have this logic that says, if they deposit over $1,000, then, you know, enough to get the free toaster, then we have to remember to send them an email saying, hey, congratulations, you're getting a free toaster.
Right.
So, like 3 different things we have to do, and maybe our code is kind of chunky, so it's all not nicely tidy and put together. And then, yeah, down the road, they change their mind about the amount. And what happens, and this has happened to so many coders, you remember it updated in 2 of the 3 places. And then suddenly somebody's going, how come we ordered this person a free toaster, but we never asked them for their shipping address? And you're like, but that was working before. And then you realize, oh, I set that rule and I was checking it and I forgot to update the threshold amount of what we get them a free toaster in this place, but I updated it the other 2 places.
Yep.
By using a flag, we check the condition once, set a flag, and then we just use that flag anywhere else we need to check. Did that happen? Do they get the free toaster? If so, ask them for the shipping information. Did they get the free toaster? Order of a toaster. Did they get the free toaster? Send them an email and say congratulations. So yeah, it reduces the chances of you making mistakes later.
Yep.
And those are nasty mistakes to catch, because your code works, and it might be a month before somebody clues in that one little, that you only fixed 2 of 3 places.
Yep.
So coding once is not only lazy coding, it can also be safer coding.
You know, I will always remember I was talking with somebody who had gone in, and this is a long time ago, but he had set up, I was at a training center, he'd set up all of our different routers for all of our different classrooms, so that it really was that you could just walk in, unplug one of these things, drop it into any other classroom, plug it back in, and make one change, just like go in and update the name of the computer, give it a reboot, and poof, it automatically started working. And I just looked at the amount of work that he had to do to make all of this happen, and I looked at him and said, why in the world did you go through all of this effort? And he said, because I was too lazy to not do it right the first time. So, you know, when we talk about lazy, we're not really just talking about...
We're not being disparaging.
Exactly. We're not being disparaging. We're not talking about just throwing slop together. That we are talking about, you know, if you make a good code up front, in the long run, that's going to make your life that much easier.
It's actually efficiency.
Exactly, yeah. Be lazy. Be lazy. Because when you're thinking about, well, if I have to go back and update this later on, which you will, the only constant in software development is change. If you only have to update one spot, that's going to make your life easier. And that's also going to, in turn, feed your laziness. So keep that in mind as you're going through and writing your code. What's going to be the easiest to maintain? That's the lazy code.
Yes, it's said. So we use the word lazy. We're kind of joking. What we really mean is it's efficiency. Efficiency in our effort, both in creating the code and in maintaining the code later. Because I don't know if you realize that probably when you get into coding jobs, probably 20% of the coding you do is creating new code, and maybe 80% of the code you do is maintaining and updating existing code. And
if
that's
not, maybe
the real
a
world.
90-10. Yeah, exactly. Somebody just mentioned right here, lazy perfectionism. That's a phrase that I really like. So yeah. Scott,
that.
I'm stealing that one. Thank you, Scott. Lazy perfectionism.
I love it.
I like it.
All right. So these things like a Boolean variable are really useful for that sort of situation.
Yep.
But of course, if you're using a Boolean variable, whenever you're testing if statements, make sure you test what happens if it's true, what happens if it's false. Always test both conditions, because you may find the code works once and not the other way. In fact, I'm actually going to do that exact example, where I'm going to say if a deposit's greater than 100, then I'm going to set a flag called free toaster equals to true. So I'm creating, that reference I got, but it was pretty obscure. So I don't know how many people know enough Eddie Izzard to get that reference. So if a deposit's over 100, I'm going to set free toaster as true. And then I'm going to imagine I have a whole bunch of complex code here. And then later in my code, oops, don't need a double, I say if free toaster, then print enjoy your toaster. All right, so if we take a look at our code now, so just scroll down a little bit. So we ask them to enter how much they want to deposit. If they deposit over 100, we set our flag free toaster to true. By the way, this is case sensitive. Lowercase t for true is not right. Uppercase is correct. The color coding can help. If you don't see the blue, that means it's not recognizing it as a keyword. And then we say if free toaster, and you can imply here is equal to true, but you don't have to say. You can put it there if it helps you. You can say equal true. If that helps you to remember. No, uppercase.
Oh, sorry. You're right. Sorry.
No problem.
My brain just immediately went to C# there.
No.
So,
I know. I always get that one in Python. So if you prefer, if it makes more sense to you to type if free toaster equal true, by all means do it. It's unnecessary though. Then enjoy your toaster. So now I've got this code. I execute. And I say, I want to deposit $500. I always test greater value. It says, enjoy your toaster, have a nice day. And then I'm going to be a good tester. I'm also going to test a smaller value, and then I'm going to test the boundary value, $50.
And while you're doing that, this is perfect, because somebody just asked in the window, would it not be a good idea to default free toaster to false above the if? It was like, we
like
knew
you knew.
Yeah.
Excellent question, because look what happens when I specify $50. Boom, it crashes. Because what happens here, if you take a look, it says free toaster is not defined. It can't find the variable free toaster.
Yep.
You go, wait a second, I declared it there, but then when you stop and think about it, you realize I only create the variable free toaster if they deposited over $100. So it doesn't have a value, it doesn't exist. So when you just say, hey, look at the value of free toaster, it goes, what value? What free toaster? I've never seen it. So this is where good habits, it's a good habit to declare your variables and give them an initial value at the top of your code.
Yep.
So I'm going to say, assume by default that free toaster is false. And then if they happen to deposit over $100, then change that to true.
Yep.
And that's going to get rid of that nasty error message.
Don't forget to hit stop.
Oh, yeah, thank you. My code is still running, so I need to stop
There we go.
and run again. And now if I specify $50, it says, oh, that's nice. Have a nice day. Just to be thorough, though, I'm going to be a good tester. I'm going to test my boundary condition. $100 should not give me a free toaster. Excellent. I've coded my lines correctly.
Well done.
So initializing variables, especially Boolean variables, very good habit, because otherwise, and that's why it's also very important to test true and false, greater than, less than, equal to. Test every possible path, because you might have gone and said, hey, it's working.
Yep.
And then one day somebody deposits less than $100 and the code crashes.
Yep.
Yeah, so we want to make sure we do lots of good testing. All right, we've just done that. And we just walked through this exact scenario of why did it crash? Because the variable was only declared if the values were greater than 100. So we had to initialize the variable. So this is just the same code. I'm going through it quickly because we just saw it in the demo.
Yep.
Are we just making the code more complicated by using the Boolean? Again, we just had that whole discussion. You know, there might be more than one place you have to check the conditions, so we're trying to be effective and efficient. If it's very complicated, it can make the code easier to follow if you just write the logic for checking it in one place, and then you just check the result later on when you need to. And we often call that a flag. So we had that whole discussion just a couple of minutes ago. But now we have more ways to make some typing mistakes. So Christopher, I'm going to challenge you. See if you can find 3 typing mistakes here.
Deposit equals if float deposit. It should be int, but
Yes, it should be int deposit. Yeah, okay, bonus. There might be 4 mistakes because we were just seeing that should
actually,
be int.
you know, one of the things, and somebody pointed this out in the chat window, for whatever it's worth, you actually didn't make a mistake. Float does work.
Okay.
The reason that it failed was because you still had the code running.
Oh.
See, so you didn't make a mistake after all.
There you go.
Yep, so you can take that off your quota for the day.
Well, that's good, because now I don't feel so bad, because I was thinking, did I make the mistake on all the slides?
Nope.
I was like, okay, I feel better now. So
exactly.
I had something else wrong with the code. Okay.
Yep. So anyway, so to bring the slide back up, so free toaster.
So I'm going to remove that because that's okay.
Yep.
Yep.
True should be uppercase T.
Correct. Excellent catch. That's a sneaky one. You know, that's a, oops. Oh, I cheated and gave you a hint. Hey, hang on, I got to take those away. I gave you a hint. All right, hang on. Yes, that should be uppercase T. Absolutely.
The second problem is you need a colon after 100.
I forgot my colon here. That is correct. After the if statement.
Third problem is free toaster needed to be tabbed in.
Yes, this needs to be indented. That is correct, and that's,
Yep.
You got it.
All right, go
So
me.
there we go. So those are the mistakes we had. We forgot the colon in the if statement. We forgot to indent the line about setting the free toaster flag to true, and we forgot true. We accidentally entered uppercase. So your challenge, now that you've seen all this, you're going to try and calculate the shipping charges for somebody making a purchase. You're going to ask the user to enter the amount for their total purchase. If it's under $50, add $10. Otherwise, shipping is free. Tell the user their final total, including shipping costs. And here's an extra little credit challenge because we haven't covered it. So this is going to require going off and doing a little Bing search to figure it out. Format the number so it looks like a monetary value. Add that dollar symbol to the output.
There you go.
I'm not going to challenge those of you working in other locales to start including euro symbols and so on. Just doing the dollar value will be a little challenge for you. Let's not get into localization just yet. And don't forget to test your solution when you're done with the value 50, less than 50, and exactly 50.
There it is.
So congratulations, you can now write code that reacts to different conditions and solve problems that require decision making.
Cool. Well, yeah, I think there's still one more module left to cover today that we want to go in and kind of take a look at a bit more complex if statement, things like ands and ors and all that good stuff. So what do you say we take 10 minutes? I could use a bit more water, and then we'll come on back and we'll close today off. Now remember, we still have tomorrow, so still an entire day tomorrow.
We're going to draw stuff tomorrow.
Yeah, we've got a lot of cool stuff tomorrow. But for right now, let's go ahead and take 10. We'll see you guys back here to finish off the last module of today. So 10 minutes, we'll be back here. All right, well, welcome back. We obviously had a good time over the break. For those of you that are just joining us, or maybe have forgotten, it's been a bit of a long day. This is Introduction to Programming Using Python. That is Susan Ibach. I am Christopher Harrison. That is Hockey Geek Girl. I am Geek Trainer, and we finished off our last module introducing if statements. And now what we want to do is take our if statements up to the next level, because you know, when you're creating your logic, it's not simply going to be, if this is true, do this, otherwise do something else. It's never just that simple, that there's always more things involved, that maybe two things need to be true, or maybe if this was false, then maybe we want to check something else, and if that was true, then we're going to do something different.
Yeah,
and
basically, life's just more complicated than that. So we're going to need a little more capacity to handle a little more complex situations.
Yeah, it's more than just black and white. You know, there's a lot of gray here, you know? And that's what we want to take a look at. So, you know, there's a lot of different conditions that that can affect the outcome. So, if you're in England and you say hello, you say hello. If you're in Germany, you say Guten Tag. If you're in France, you say Bonjour. To everybody who's a native speaker of that language, I apologize for my complete lack of an accent. I just say everything in an American accent. So, for that, I do apologize. If you win the lottery and the prize is over $1 million, then you can retire to a life of luxury. It'd be kind of nice to retire to a life of luxury.
I'm all for that, yeah.
Yep, absolutely. And then finally, last but not least, if it's Monday, check to see if there's fresh coffee. Actually, if it's a day ending in Y, for me, go check to see if there's fresh coffee. I always need coffee. But in any event, go in, check to see if there's coffee. If not, then we'll go to the nearest cafe. So there's a lot of different things that are going to drive that decision-making process, that we're going to have, an if, then, otherwise, otherwise, otherwise. That is what we're going to try and build in. So to kind of keep going with this little example, if you're in Canada, say hello, or England. If you're in Germany, say guten Tag. If you're in France, say bonjour. It's sort of an interesting situation because of the fact that you've got these multiple possible outcomes. That it's not simply going to be, if one value is this way, do this, otherwise we're just going to move on to something else. So it's one value that we're checking, but it could have different entries inside of it. Now, we've already seen this syntax here, that we've already seen the, where are you from, and then country equals. We could also have a to upper,
Yeah, but that basic logic of,
Exactly.
somebody enters a value, if we check if their values equal something specific, react accordingly.
Exactly. Yeah, I was just being pedantic up there. But yeah, so what we're going to do is we're going to do that very basic if, and away we go. We've seen that. We've already seen that. But now what we want to do is we want to check to see, well, are you in Germany? Or are you in France?
Yep.
And so this is where the elif, or else if, comes into play. Now, here's the most important point to keep in mind about a compound if statement like this. The way that if statements work is that they will execute the code associated with the first thing that tests as true. So if we bring it back to the slide here, if it turned out that you had entered in Canada, so I said Canada, C-A-N-A-D-A, and I had typed that in, now what's going to happen is that it's going to run this first check. That's, of course, going to test as true. It's going to run that bit of code, and then it's going to skip to the end of the if block. If it turned out that it was Germany, then that would test as false. It would go here, and then again, skip to the end. So it's always going to be whatever the first one is that matches. So it's not going to be like a game of Plinko or anything like that, where it's going to bounce and check and check and check and check and check. It's not. The first one that tests as positive, it's going to run the associated code and then exit out of the if statement.
And that can be really important. In this case, I mean, you're never going to have somebody enter a value that's equal to Canada and Germany at the same time.
Right.
But where that can become really significant is, let's take our example of, hey, you get a free toaster if you deposit more than $100. I'm bringing back my free toaster.
Yay, toasters!
But what if you donate over $1,000, you get a free TV. If you put it as a deposit. So imagine the situation if I was using elif statements there, and I said, if deposit is over $100, you get a free toaster. And then I say, elif, you deposit over $1,000, you get a free TV. Guess what? They deposit $5,000, and it's going to say, oh, they put in over $100. That was the first condition. It's going to say, oh, you get a free toaster. It's going to exit. And they'll be mad because they want their free TV.
Exactly. So, and I'm kind of sketching this out real quick. Free toaster, elif, deposit greater than 1,000, and then, and I know I'm spacing over. That's a Zoom It thing. Zoom It won't let me do tabs, but in any event, and then free TV. So, of course, here's the catch: is that, just like Susan said, if I deposit, let's say, $4,500, last I checked, in my math anyway, $4,500 is greater than 1,000. So the bit of code that I want to run is going to be that bit right there. Well, which code is going to run? Well, the code that is going to run is going to be that part right there. Why? Well, because 4,500 is greater than 100. So that little bit of code is going to execute, it's going to go down here, and you're going to be stuck with a crummy toaster rather than a brand new TV. So ordering does matter. And Susan talked an awful lot in the prior module about
free toasters.
About free toasters. about going in and testing your code. And this is extremely important, especially in situations like this, because it's so subtle that if you go in and you read it, and you're reading it as a human,
you wouldn't catch it.
It sort of makes sense, exactly, because we're going to really kind of be a bit more flexible. The problem is that the computer is not. It's doing exactly what you told it to do. And that's always the worst kind of bug. The worst kind of bug is when it did exactly what you told it to do. You hate that. And that's exactly what happened here, is that it did exactly what you told it to do. And it said, well, 4,500 greater than 100. We're going to execute that. We're going to go down here. And again, you're stuck with the crummy toaster.
And this is just another one of those reminders of the importance of doing your testing.
Yeah.
Test those conditions. Test less than 100. Test exactly 100. Test greater than 100. If you've got that elif of 1,000, you also need to test under 1,000, equal 1,000, over 1,000. That's why the testing is absolutely crucial when you start adding these branching conditions into your code, because otherwise you're going to miss it when you do make those mistakes.
Exactly.
It'll happen. You're going to do this. One day you're going to do this. And when you finally figure out, you're going to go, they told me I was even going to do this mistake, and I can't believe it took me 4 hours to figure it out. And you will. One of you out there is going to literally do that. Go, I watched that video and they told me I was going to make this mistake.
And sure enough, you did.
But that's why the testing is so essential.
Yep. Now, one last little thing here. Let's go back to the right slide. Highlighter, there we go. The elif statement, you're going to notice, is not indented. And the reason for that is it's just like the else block, is that this is what's going to run if it's Canada, this is what's going to run if it's Guten Tag, this is what's going to run if it happens to be Bonjour. And so that's why the elif is right there.
Oh, by the way, we have a comment somebody in the comment said, oh, already made that mistake.
Oh,
so there we go. So we weren't lying.
I love your predictive capabilities. Somebody already had, and Susan called it.
Would you like me to suggest some lottery numbers later?
All right. Now, the last little thing is, what happened if somebody entered in something that's outside of the bound? So what would happen if we used Canada, Germany, France, and you entered in Japan, you entered in Italy, you entered in South Africa, you entered in, some other country here? Well, let's sort of kind of talk this thing through. Is it's going to check the first one. So let's say we entered in Japan. So we'll just say Japan. So you entered in Japan, country equals Canada. Well, nope, that's not it. Let's go down. If country is Germany, nope, that's not it. Let's go down. If country is France, nope, that's not it. So it's just simply, in this particular case, going to exit out of that if block, because we didn't tell it what to do in the case of Japan.
Right.
Now, of course,
we saw last module, we saw you could use an else, which meant if this condition isn't true, you can also say that for if none of these conditions are true.
That's it. Yeah, you could just add in that else statement to catch everything, well, else. And adding in an else statement, just as a real quick best practice thing, adding in an else statement can be extremely helpful, especially when you are dealing with input from something external, and this could be a file, this could be user input, because it gives you the ability to do two things. That number one, it gives you the ability to display out an error message, hey, this was outside of the range of values, ask the user to try again, but also B, it can be a little bit of a security thing as well, because in this particular case, country, it's not in a range of values that we were expecting, and so that could wind up causing potential issues otherwise. So it's not a bad idea at all when you're dealing with something like that and you've got multiple to add in an if statement, so that way you can display the error message or handle that otherwise, or maybe even set it to whatever you want your default value to be.
Sure.
And then you'll notice down here at the very bottom, you're going to notice I did, let me just erase all my ink. There we go. You'll notice down at the very bottom I've got my else and then print and then aloha, ciao, g'day, ciao. And we'll go from there. I'm having a good time.
Awesome. Go for it.
All right. So let's go in and take a look at a little demo here on our else if. And what I'm going to do is open up Visual Studio. There we go. And let me file new project and Python. And let's go in and complex if statements. And you know what? Let's go ahead and kind of keep having fun with the hockey.
Okay.
From
Awesome.
from before. All right.
Go Sens.
So let's go ahead and say team equals, and then we'll say input, enter your favorite without the U.
Okay. I'll forgive you for that since you're talking hockey.
Hockey team?
I was in. I got to visit Russia last year, and I went to the store for Team Ska, which was kind of cool.
Oh, nice.
Yeah, I mean, man, I had a great time talking hockey with the Russians.
I believe it.
Yeah.
Okay. I'm also going to do a real quick two-upper as well, just to go ahead and have that. So I'm going to go ahead and say if team equals, and yes, I'm doing this on purpose, let's go in and say Flyers.
Mm-hmm. Oh, yes, that's your favorite team.
That's my favorite team.
That's right.
Now, I've purposefully done this. I've entered in my two little mistakes, kind of as a review, that number one, we need double equals.
That means
that's equality.
Is equal to.
Yep.
Right.
So again, just to differentiate up here, that single, that's the assignment. That doubles, that's checking the equality between the two.
Right.
Okay. And then the second thing is I need my colon.
And that's just syntax. You just have to remember it. And when you forget it, well, you'll go back and go, oh, yeah, I forgot the colon. Don't worry about it. You're going to forget it. When you see the little squiggles and things, you'll go back and you'll fix it.
Exactly. So we'll say if team equals Flyers, we'll go ahead and say print and best team ever. I'm not feeling very creative, so I'm just going to go with that. And then elif team equals Senators. We'll go ahead and say print and then go Sens go, and then elif team equals Rangers, and we'll just simply say go Rangers.
That works. That's fine. You keep it simple for now.
Yeah, exactly. So we'll just kind of keep going with that. And then down here at the very bottom, we'll say else, and we'll just simply say print. I don't have...
Oh, you're bringing us back to module 1 there.
I am.
You have the challenge of I have a single quote inside my string, so you've chosen to solve that by using the escape character in front of it. You're bringing us back to like the second module. That's mean when we're this late in the day.
I'm just trying to keep everybody on their
All right.
And I'm really just trying to keep building on what we've already done. Okay. In any event, so there is our basic little statement. I'm going to go ahead and tap on play here, use the touchscreen. We'll go ahead and say Flyers, hit enter. Sure enough, it says best team ever. Hit enter. Let's go ahead and run this again, and let's say Senators, and hit enter, and you'll notice that it'll say
Go Sens, go.
And one real quick thing, I'm going to throw in a breakpoint right here.
Oh,
just
yes.
going to walk through this, something I always really like to do, and hit start, and then we'll go ahead and say Blackhawks, which I don't have, and I did this one on purpose.
Okay.
So we'll just say Blackhawks and hit enter, and then we'll just come back down to Visual Studio, and we'll just keep hitting that step into. And what you're going to notice is if you keep an eye on the arrow on the right side of my on the right side of the screen, what you're going to notice is that the arrow, I hit it once already, is now on Senators. I'm going to hit it again. It's now on Rangers.
Because it's checking. It's going, it's here. No, it's not here. Go check the next condition.
Yep.
Yep.
Yeah, so it's looking for a match, and of course it's going to leave disappointed because there is no match, because it's Blackhawks, so you're going to notice that we're now down at
And it's now it's actually going to go execute the command in the else statement.
Exactly. Yep. There we go. And so now, there we go. I don't have anything clever to say here, which I don't. Okay, perfect. So there is our else-if statements. And again, just to hit the point one more time, keep in mind that the order in which you do your logic, especially when you're dealing with numbers, is extremely important. So make sure that you are going in and doing that testing so that way everything is coming out the way that you expect it. One very simple strategy, one very simple technique is if you're using greater than signs, then when you list them, start with the biggest number. And if you're using less than signs, start with the smallest number. Kind of the simplest way, I think, to go in and approach all of that. Awesome. All right. Now, I will always remember I was in 7th grade here in the U.S., so 13 years old, so whatever the math works out to, wherever it is that you happen to be. And we were going to learn logic in our math class, and our teacher got up in front of the room, and he told a room full of 13-year-olds, I'm going to teach you how to win every argument with your parents.
Oh, that would go over well.
That's a smart teacher. That's knowing your audience. That's what that is, ladies and gentlemen. That is knowing your audience. Of course, immediately we all perked up like, oh yeah, we're ready to go. And so he then started going into the concepts of ands and ors, which is exactly what I'm going to drill into here. And what he said was very simply this, and I'm going to hit this right now, and then we'll dig in and we'll kind of come back and start reviewing this, is you always want to use or. Because if you say, I'm going to go to Steve's house, and I'm going to go to the game, in order for that sentence to be true, in order for what you just said to be truthful, logically speaking, you must have done both of those. So you have to have gone to Steve's, you have to have gone to the game. On the flip side, however, if you say or, I'm going to go to Steve's house or I'm going to go to the game, you could do one or the other and be perfectly truthful, at least as far as logic goes. My parents didn't go for it, by the way.
Didn't work?
No.
Worth a try.
Yeah, absolutely.
I like the logic, yeah.
Yep, you know. But that's honestly the way that I always remember this. So, and both sides had to be true, or one side or the other. Keep that right there. I'm going to pull that back out in a couple of minutes, but before we get there, let's go ahead and start talking about a little scenario. So, congratulations, you just won the lottery.
Sweet.
But here's the thing. If you win the lottery, there's obviously a lot of different denominations. I mean, I could go out, I could get a little scratcher, I could, go ahead and scratch it off.
I usually win enough money to pay for a ticket if I win anything. I buy a $4 ticket, and my big win is I win $4.
That's about it.
That's what I usually win, yeah.
That's about it. So did you win the lottery? Technically, yes. Did you win a significant amount of money?
Do I get to retire?
Yeah, do you get to
a life
retire?
of luxury on my $4 win?
Yeah,
probably not.
Yeah, you're going to need to use some creative spending in order to be able to retire on $4. I mean, if you can do it, go for it. But yeah, so we really need to test two things there. So, for example, kind of going back to, maybe you're writing a banking app. And so what we need to do is maybe test for two things. That maybe we need to test for the type of account, and we need to test for the deposit amount to determine whether or not we're going to give you that little free prize. So that if you're going with maybe a basic checking account, then we're not going to give you a TV. But if you open up a checking account or a checking and savings, and you deposited $5,000, now we're going to give you that toaster, then both of those have to be true. That's going to require a little bit more complex logic. So, a lot of different scenarios.
Sure.
So I require $5,000 rather than $100.
That's what you need to retire in a life of luxury?
Well, no, for the toaster.
Okay. I thought you were going to retire to a life of luxury if you won $5,000.
$5,000, yeah.
I don't know what currency. I know that U.S. dollars are worth more than Canadian dollars, but I didn't think the exchange rate was that good.
Not these days.
Okay.
All right. So what we need to do is we need to go in and check for a couple of different things. So again, if you win the lottery, only $5. Can't retire on that. If you win $1 million, but if the lottery gives out $1 million but you didn't win it, well, you can't retire.
Yep.
So what we need is we need both of those to be true. We need an and statement here. So we need to have won, and the prize needs to be over $1 million. So. Exactly.
I'll do the movie reference.
Yeah.
$1 million.
$1 million. Thank you. Thank you.
Sorry, bad movie references. My apologies.
I set you up for that. You can blame
you did.
me.
Yeah.
Yep. Now, here's the thing. You have to use and here. Because what you're doing is you're saying both sides must be true. So you have to have won the lottery, and it has to have been greater than $1 million. So that is where and comes into play. So both won lottery and big win has to have been true.
Yep.
Otherwise, it's not going to execute that. So both of those sides have to be true. Now, one of the things is that this can be a little bit complex trying to figure out, okay, well, you know, when is it actually going to run this? When is it not going to run this? And I love this table that you have here because it breaks it down very simply. That if the first condition is and the second condition is, that is what the result is going to wind up being. And what I want to highlight here, let me highlight this on the screen, is you're going to notice false, false, and false. Put simply, to summarize all of this in one sentence.
Yep.
If there's a false anywhere, the answer is false.
Yep. When you're using an and statement, everything has to be true for it to be true and to execute the code.
Exactly. Yep. So let's go in, take a look at our real quick and here, and I'm going to open back up Visual Studio, and you know what I'm going to do is I'm going to go ahead and do a real quick Control-K, Control-C.
Right.
Yep.
Comment out that code.
Exactly.
Yep.
And I'm going to say sport equals, and we'll say input, and we'll say enter your favorite sport.
That's right.
Yep.
There we go, for all of those who prefer cricket or tennis.
Exactly. Yep, that's it. And so we'll go in and do that. And what I'm going to do is I'm going to keep it relatively straightforward. I'm just going to go with an if statement. Now, here's what I'm looking for. I'm only interested in the hockey team, the Rangers. There's also an MLB team as well, the Rangers. So we have an NHL team Rangers. We have an MLB team Rangers. So I'm only interested if it turns out that we're talking about the Rangers hockey team.
Right.
That's what I'm looking for. So what I'm going to do is I'm going to say if, and we'll say sport equals hockey and.
Because you know what? Because I know in Ottawa we have a Rangers football team.
Oh, well, there you go.
So it happens.
Yep, it absolutely does. And team equals, and make sure you have your double equals, Christopher. There we go.
Yep, is equal to.
Yep,
right?
Is equal to. And let's go ahead and say Rangers. And then we'll go ahead and say.
Don't you miss Messier? He was an awesome Ranger. He was my favorite. He does these commercials now. He's this great hockey player, and now he does these commercials for things like potato chips. He's got this awesome sense of humor. My favorite commercial was, you know, bet you can't eat just one potato chip. He goes, if I lose, you have to play hockey with us. And it's this guy on the street, and then he has one potato chip, and then they show him, you know, playing shinny hockey with a bunch of guys, and it's just an awesome, you know, he's got a sense of humor. It's awesome.
Well, you gotta love it.
Yeah, I like my professional athletes to, you know, have a good sense of humor. We gotta like those.
Absolutely. Okay, so what I've done here is I've put together a very basic little statement where I said if the sport is hockey and the team is the Rangers, then we're going to go ahead and print out I miss Messier. Otherwise, for right now, I'm just going to say I don't know that team. And so let's go in, hit start, favorite team, and let's go in and say Rangers, and then favorite sport, and let's say baseball. And hit enter, you're going to notice that it says I don't know that team. Now, if I go in and I run this again and I say, come here, I say Rangers and I say hockey and hit enter, now you're going to notice that it prints out I miss Messier because they're both true. That we typed in Rangers and we typed in hockey. Cool. All right, so let's go back to our slides here, kind of keep on keeping on.
Yep.
One of the other things that we might want to check is an or. So I only need one side or the other to be true. So if it's Saturday or if it's Sunday, I can sleep in, assuming that it's not a long run day. So if it's Saturday or if it's Sunday, I can sleep in. If it's raining or snowing, can't bike to work. This is our or statements. And what we're looking to do is looking to test whether or not one side or the other is true. Now, before we get in and take a look at our sample, I want to do a little bit of an English versus logic lesson. Let's imagine that I was building something up that was going to do some form of reporting. Well, it would be very common for a sales manager to come up to me and say, hey, Christopher, I need something that's going to display to me the sales from the Northeast and southeast regions. That's the way that he would say it in English. That's not logic, though.
Ah, that's an excellent point. And yes, this is the kind of thing that gets you when you're writing your code.
Exactly.
Yeah.
Because let's think about this again with logic. When we're talking in logic, remember, and I'll go back to the slide here, this perfect slide that Susan put together. You're going to notice with an and statement, they both have to be true. They both must be true, otherwise it's not going to work. So if we're talking about if region equals northeast and region equals southeast, you know how many times that's going to test as true?
Never.
Never.
How can a region be equal to two different values at the same time?
Exactly.
Can't happen.
Exactly. So one big thing to keep in mind when you're sitting down to write your code, and again, this is universal, this is not specific to Python. So if you're doing this in SQL, if you're doing this in C#, keep in mind what you're actually looking for. So if you're looking for one side or the other to be true, so northeast or southeast, you want an or statement. So even though in English, frequently people will say and, listen to what they're saying, listen to what they're trying to communicate, because quite frequently you're going to need an or statement. You're going to need an or. So one side or the other.
Yep.
Okay. So with that, let's go back into, oh, by the way, one last thing. You'll notice again, table. And the big thing that I want to highlight, there we go. You'll notice anywhere where we have a true, 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 true.
Yeah, so if any of the conditions is true, we're going ahead and executing the code if any of those conditions is true.
Exactly. Yep. All right. So now let's go in, do a demo, give me my or statement. Back to Visual Studio. Okay. So now let's go in and tweak things around just a little bit. And now what I'm going to do is I'm going to say,
how about if you're a fan of the Leafs or the Senators, good luck getting the Stanley Cup. I mean, I do love my Sens. I can say that to my Sens because I am a Sens fan, but if we win a Stanley Cup this year, it's going to be a miracle. That's our big trophy, and we've lost a lot of good players. I'm going to be cheering my Sens all season, but I'm not holding my breath for a Stanley Cup this year. I can say it, you can't.
nobody can beat up my brother except for me.
That's right.
Yep.
Yeah, you can only make fun of yourself.
Okay. So what you're going to notice here, so if the team is the Leafs or the team is the Senators, then we're going to say, good luck getting the cup this year. And so I'm going to leave this the right way first. And let's go in and hit start. Hockey team, Senators, hit enter, sport, hockey, and hit enter. And what you're going to notice here is it's going to say, good luck on getting the cup this year. Now, if I do this, let's go back in. Do a line break here, and let's kind of walk through this logically. We'll say Senators and hockey. Let's kind of talk about what's happening behind the scenes. What you're going to notice, there we go. What you're going to notice is that we're first going to check to see whether or not the sport was hockey and the team was the Rangers. Well, we did type in hockey, but we didn't type in the Rangers. So this is going to test as false. So if I escape out of that and I hit F11, which will actually move us down to the next line, you're going to notice that test is false, so it didn't run it. We're now on the elif statement. So now let's go back in, and now let's do the next check. So the next check is simply looking for the team to be the Leafs or Senators. And if we remember, we typed in Senators, so this part here is going to be true. We've got an or statement, which means that now the entire part is going to be true, which means we're going to run that line. Sure enough, I hit F11, and you'll notice the little arrow, that's the line of code that's now going to get executed. And if I just escape out of that, there we go, I can see the display right there.
Perfect.
Cool. All right. Now, I did want to go in and introduce the error here. I am going to say and. This happens constantly, and again.
Because you'll do it because your brain just thinks of it that way. Yeah.
Exactly. Because that's the way that somebody came up to you and asked it. So I'm going to say Senators, and I'm going to say hockey, and I'm going to hit enter. Oh, and I still have the line breaks. That's okay. I'm just going to F5 through that. There we go. And sure enough, it's just going to say, I don't know that team. Because again, the team can't be two separate values. So be very careful about your ands and about your ors. Awesome. All right, back to slides.
Perfect. So we've got ands, we've got ors.
Yep. Now, how about combining them into a single statement? So, for example, maybe I'm looking to say something about the Rangers, but only if they're hockey, but maybe a team named the Maple Leafs, regardless of the sport that we happen to be talking about. So there could be a cricket team somewhere called the Maple Leafs.
All right, sure.
We'll go with it.
Yep.
So maybe I want to say something about all Universal teams being the Maple Leafs, or something about the Rangers and them only being hockey. Well, you can go in and combine multiple statements together. So you could string across multiple or statements. You could string across multiple if statements. And I love the breakdown here. Make things a lot easier.
You mean the breaking it over multiple lines?
Yeah.
Yeah, and of course, remembering if you do that, you have to put that backslash to say I'm continuing this if statement on the next line. Mm-hmm. Yes, I did that there, so it's a little easier to read.
Exactly. Now,
this is the one, I have done this one on production. This is I'll be honest, there is a mistake here, and I have made this mistake on production code, and it's gone live. Not with the beaver and the moose, but the idea of I had a combination of and or statements, and the end results weren't quite what I expected, and I have seen this happen in code that was live, and it took us a couple of months to figure out what we'd done wrong. So I'll let you walk through this little, or I can walk through it if you like, but go for it.
Okay, so here's what we got. So you're going to notice we've got an and, we've got an or. Now, just like we saw previously, we can have them both.
Absolutely, you can have ands and ors mixed together. It's perfectly legit.
Now, I want to kind of go back and point out earlier on that I was telling the story in my math class, logic, and talked about, and or, both sides have to be true or otherwise. Here's the other thing that I want to point out. This was in math class. Now, the reason that I'm pointing out math class here is because, just like in math, there is a set of precedents here that ands and ors do have precedents.
Just like math.
Yes.
Multiplication and division are done first in math, then addition, subtraction.
Yep.
Well, guess what? Ands and ors, it does the and statements, it'll do all the and statements, and after doing all the and statements, then it'll go and do all the or statements.
Exactly, and in fact, here, you're going to notice that one doesn't work the way that you might expect it. Because what you're going to notice is that it's going to say, well, we put in beaver, and we put in Vietnam as the country, so you might be expecting that because of the fact that that's what we typed in, what you might be expecting is, well, or pet equals beaver. So that part right there is true. We have a true. That must mean the entire thing is true, right?
Yep.
Not quite. Not quite. Because what's happening is that the and there is overriding everything. That it's that and first and then the or. And I'm actually going to skip right over here, again, that order of precedence, because I really want that little slide, because you kind of broke it down perfectly here, that you're going to notice up at the very top, that first part is what's going to run first, and then the second part. So if I'm looking to see if you live in Canada, or if you like a moose or a beaver, then what I'm going to do is then go in and do my check from there. And I think I said that wrong, so I'm going to try that.
Yeah, I was going to give that another try. It didn't come out quite right. And this is hard to follow. It actually may make more sense to read than to try and say out loud. And I'll tell you the actual situation where I had this happen. It was a case where I had to say if it was a super youth, let's say it was a gold card member from the US or Canada, give them their free benefits. Mm-hmm. And the way what happened to me was if somebody wasn't a gold member, so they were only silver, and they were from USA, they were still getting the benefits. I'm like, whoa, wait a second. I said if they're a gold member and they're from the US or Canada, they get the benefits. That was the way I wrote my code. But for some reason, my silver member, who happened to be from the USA, was getting benefits. Because the and statement returned a false, but then I compared that false and said, or from USA, and they were from USA, so boom, they got the benefits.
So to bring that back to here, let's kind of break this down. So I'm going to actually go all the way back here to our initial spot, because you'll notice the line break here, and this is really what we're looking for here. So I'm just going to say erase all link, and let's kind of start this whole thing over. So here's what we're looking to do. I'm looking for two things. I want to make sure that you're in Canada. And if you're in Canada, I want to check to see if you like moose or beavers.
Yes.
If you like moose or if you like beaver, cool. We're going to go ahead and say, hey, do you play hockey as well? Because we're kind of assuming that, there's some level of stereotype.
We want to know. If you're a Canadian and you have a pet moose or beaver, man, you're a stereotypical Canadian. You must love your hockey team.
Absolutely.
So you're a Canadian and you either have a pet moose or beaver.
So what we're really looking for is this particular breakdown that we're looking, and I'm just going to fire back up my ink, we're really looking to test, first, are you in Canada? And only if you're in Canada do we care about your pet. If you're from some other country, such as Vietnam, we don't care.
Because we're not gonna assume the stereotype that you play hockey if you're not from Canada.
Exactly.
That's a Canadian stereotype.
Exactly. So what's happening is this. Order of precedence is that it's running that and statement first. And if I kick back to this slide right here, because this breaks it down perfectly, it's running that part there first. And then it's running that part second. So in order for this to work, it's only going to test the way that we want it to work if you live in Canada, if you live in Canada, and if you have a moose.
Right.
But if you're the other combination, and this is the other one that we're looking for, that you live in Canada and you have a pet beaver,
then you're still good.
That's what we're looking for. That's the desired result.
That's what I'm looking for. Canadians who have a moose or Canadians who have a beaver.
Exactly.
Right?
Yes. So that one's still good. So that one's good. That one's good. But if we go in and we say, for example, US, and then our, US and our moose, there we go. Now I've got my logic. Let's talk about this. What's going to happen is it's going to be US here. It's going to be moose here. What we're looking for, I only care if you're Canadian. If you're not Canadian, we don't want to ask you about hockey. What's going to happen is it's going to test that part right there. And that's going to test as false. And then, of course, it's going to come down to the pet and test as false as well, but that's sort of irrelevant. But it's going to test as false, false.
It's going to say country. It's going to give you a false for the country is not Canada with pet moose, but the pet is a beaver. So therefore, because the part of your or statement is a true, if any part of an or statement is true, it evaluates as true.
Right.
Yeah. And actually, you know what? We have somebody has guessed the answer on how to solve this.
Cool. Can I just close
carry
this
it
off?
through. Carry
Okay.
it through.
All right. I just want to close this off,
Please do.
just because I'm trying to make sure there's no confusion here.
It's tough. It's a weird scenario, but yeah, go on.
Okay. So trying to make sure there's no confusion. So here's what we've got going on. So we want only if you're Canada, and then again, moose, beaver. So if we put together a scenario where you are in Canada and you had a pet beaver, here's what's going to happen. Is this part right here, you're in Canada, that's going to test as true. Mm-hmm. The second part here where it's going to test the moose, that is now going to test as false. And then our or right here is going to test as false. So that result, false.
Right?
Not going to come out the way that we want it to come out. If I go in and I say Canada and I say moose, that's going to test as true. That is going to test as true. This sort of becomes irrelevant. It's going to test as false, but we've got a true. So that is going to come out as
true
over here.
Okay.
So what we want to make sure of is that if it turned out that you were in the US,
okay,
but you had a beaver. So let's clear out my screen here. Let's go back in. US, beaver. We don't want this to test as true.
That is correct.
So we're going to go US here. This part up here is going to test as false because that's not right.
Yep.
Then we're going to compare our beaver. That's going to test as true. Let's remember the OR statement is executing second. So what's going to happen? This is going to return as
true.
True. What did we want it to return as?
We wanted it to return false.
There we go.
Yeah.
There's the whole kind of come together of all of
Yeah, I said, and it's tricky because we've got 4 different scenarios, and 3 of the 4 scenarios are working, and the 4th scenario is not working. So yes, it's confusing to follow. Our apologies. Now the good news is, fixing it. Wait till you see how easy it is.
Exactly. So this sort of goes back to when we were talking about math a while ago, that when in doubt, put parentheses around it. So what I'm going to do is I'm just going to clean up the prior code that I had here. And I'm going to put in one statement. And I'm going to say this in English. If the sport is hockey, and the team is the Senators or Leafs, display the cup message. So we're looking for 2 parts. Again, that first part is, want the sport to be hockey. The second part is, we want it to be the Senators or the Leafs. That's what we're looking for. So what I'm going to do is I'm going to say if. And then I'm going to say, if our sport is hockey and the team is the Rangers, oops, not the Rangers, the Senators, or the team equals the Leafs, and I'm doing this wrong the first time and I'm doing this on purpose, then print there we go. Good luck getting to the cup this year.
Okay.
All right.
That sounds good.
So again, what we're looking for is we want to make sure it's both hockey and it's the Leafs. So if I fire this back up, and I go in, and I'm going to go straight to the wrong case. So I'm going to say Leafs, and I'm going to say cricket. And I'm going to hit enter. You're going to notice it displayed the message. And that's not what we want. And the reason for that is that this and statement right here is overriding everything. That's our problem. So what we want to do is we want to surround it in parentheses. So now what we're doing is we're breaking this down into 2 separate statements. And now that part is going to be evaluated as 1. That part is going to be evaluated as a second. And then our and is what's going to do the final test there. So now let me go in, hit start, enter my favorite hockey team. We'll go Leafs. I'm going to enter my favorite sport. I'm going to say cricket.
Yep.
Hit enter. Doesn't display anything. That's what we were looking for.
Woohoo! High five. Yes.
It doesn't display anything. Yes.
That's actually the output we wanted.
And then we'll go ahead and we'll do it again. And we'll go ahead and say hockey team is the Leafs. Our sport is hockey. We'll hit enter. And now it displays what we want. So the real takeaway that I want you to get from all of this, a couple of things. Number 1, when in doubt, surround things with parentheses.
Yep.
Number 2, when it comes to complex statements, break them down into smaller, bite-sized chunks to make your life that much easier. Because otherwise, this can get away from you very quickly, and dealing with logic errors can cause you to really develop a fair amount of gray hair. So be very careful about going through and doing all of this. Test everything, and again, make your code as simple as possible. You know, one of the things Susan was talking about earlier was the concept of just putting in flags. One great thing about flags, especially in a situation like this, is it can allow you to better break things down. So what I could do is maybe something like this, kind of just go in and rewrite it, and maybe something like this, is I say, if the sport is hockey, and I'm going to say, sport is hockey equals false, So if it turns out that it's hockey, then we'll go ahead and say sport is hockey equals true. And then we'll go in and say team is correct equals false. And then we'll say if team equals the Senators or the team equals the Leafs, then we'll go ahead and say team is correct equals true. And then now what I can do in my final if statement is now I can say if sport is hockey and team is correct, then we'll go ahead and display out our little error message.
Yeah, so those are some good tricks to try and avoid hitting these scenarios. But again, it comes down to test for different scenarios. Try every single possible combination. You've got to make sure that it operates as expected.
Absolutely.
So we've got parentheses we can use to solve the problem. We've got Boolean variables we can use to reduce the chance of hitting those situations.
Exactly.
So two great tools at our disposal.
Yep. So you'll notice that both of these blocks are the same. One of them is much longer than the other.
Yep.
The top one is 1, 2, 3, 4, 5, 6, 7, 8 lines of code as opposed to 2. Just because you have less lines of code doesn't necessarily mean that it's better code. Go with the one that's going to be the most readable. Don't be afraid to go in and break things down like that.
Yep.
Okay. Cool. And by the way, just to sort of prove the point, favorite team, Rangers, sport, let's use the right team, Christopher. Senators.
Getting end of the day, typing skills diminishing.
Exactly.
We'll have to wrap up soon.
Hockey, enter. And so you'll notice that it's displaying out, good luck getting a cup this year, twice.
Because you have both your if statements are in there.
Exactly, both the if statements, and that proves that they are both doing the exact same thing. Let me go back in, hit start again, and let's go in and say Senators and cricket, and now we should notice it doesn't do anything.
Perfect.
So there's our little fringe case. So yeah, so again, whatever's going to make the most sense to you, and to go back to this one more time, Do
we have to? No, I don't mean it that way, because I'm sorry whatsoever. It's a tough one. It's a long day. No, you've got two fantastic options for solutions there of solving the problem, and now you've proven you've got it working.
Yep.
When you enter the correct data, it's giving the right output. When you enter a scenario that was failing earlier, it's giving you the correct output.
Right.
And the last point you wanted to make?
Was just simply that, again, there's multiple ways to do the exact same thing.
Yeah.
Go with whatever's going to be the easiest
Absolutely.
for you. That's really it.
And
Okay.
It's nice that you have both those solutions up there, because it's interesting. We're actually seeing some comments in the screen that they love your solution with the Boolean flags, and that suddenly people are like, oh, the light bulb's clicking, and I like that solution. So I can see that solution's really resonating with a lot of the people on there.
Excellent, excellent. I like that. All right, so last little thing then is nesting our if statements together. So again, things can get much more complex. So what you're going to notice here is that we can go ahead and break things down. So you'll notice if Monday, and then you'll also notice down below if not fresh coffee. So, kind of keeping in mind what would happen is it's first going to check to see if it's Monday, and if it is, then it would run this block of code and then do a secondary check. Now, one thing that you might be wondering is, well, wait a minute, couldn't you have just done an and statement here? Because in order for that little line of code right there to run, both Monday needs to be true and this needs to be false. So couldn't we have gone in and maybe just left that at fresh coffee and written that with an and statement and put it together? You probably could have done it that way, but the biggest thing is that we also want to print that out as well, that there's something else that we want to do if it turns out that it's Monday. So if it turns out that it's Monday, we want to print out I hate Mondays. If it turns out that it's Monday and we don't have fresh coffee, then that's when we want to do that. So you're going to notice that we need to do multiple things on that top if statement.
Yep.
So you can go in and tab in and nest your if statements. Now, we've already seen this. If statements can get away from you in a hurry.
Yep.
So be very careful how things are indented. be very careful about how you document things. So that way you can better determine and better explain what it is that's going to happen. And in particular, to go with the tabbing part of things, if I had taken that little print and I tabbed that in, that would then only work if we didn't have fresh coffee and if it was Monday.
Yep.
Okay. So let's close all of this out with a demo here, and let me go in and do this. And I'm
you
going
can
to
see why practicing becomes
that.
so important. We talked about that in a couple of the modules, but it's essential to practice, and we've talked about how essential it is to test. And all of these, different scenarios and combinations, it starts to get a bit confusing after a while, but it just reinforces that basic principle. You've got to try things, you've got to test things. So practice, practice, practice. Write different if statements, different combinations. So get used to, whoops, I forgot to indent, and finding that mistake when you forget to do the indenting. Those sorts of things are going to happen. So the more you practice, you will make mistakes, but the more you practice, the faster you're going to get at finding those mistakes.
Exactly. Yep,
Yeah.
That's exactly it. So what I'm doing here is I'm just kind of going back and creating one last little scenario here where, and let's just go in and do one last print statement. There we go. So what you're going to notice is if it's hockey, then we're going to print out go hockey. If it's Senators, good luck getting the cup. And then down at the very end, I'm going to say we do love hockey. So I'm going to go in and I'm going to play this, and I'm going to type in Senators, and I'm going to type in hockey, and I'm going to hit enter. And you'll notice that it gives us all three because it's hockey and it's the Senators.
Right.
Okay. Now, the next little part there is I want to tab this in real quick just so we can see what happens with that tab in. And let's go in and let's say Rangers for our favorite team.
Yep.
Hockey for our favorite sport. And you'll notice it only says go hockey.
Yes.
Let's do this one more time. Let's go back here and let's just get rid of a tab. Mm-hmm. Let's go ahead and run this again. Let's go in and say Rangers again.
What a difference a tab makes.
Hockey again. Exactly. And you'll notice that this time it actually printed out both go hockey and we do love hockey. It was all about that tab. So if I tab that in, now I hit start again, Rangers, I say hockey, and you'll notice that it's only displaying out go hockey. So you're going to notice there that that tab makes all the difference. And, a couple people mentioned earlier when we were talking about if statements that those tabs are very subtle, and I'm with you, but trust me, while yes, it doesn't necessarily impact the syntax in other languages, it impacts the readability. And that's almost just as important, if not more so in a lot of cases, because if I can't look at code and figure out what it's doing, that's going to lead to even more problems. Awesome. All right, so.
Fantastic, Christopher. Holy smokes, man. You've had a tough module for the end of a day. I had to give you you had to have the most complex logic situation to deal with at the end of a long day. Well done.
Thank you. I'm glad we finally got to break that down there. Took a little work, but we got there. The challenge then. And I'm going to kind of let you guys read through this on your own. But the big thing that I want to point out, and this is very much a real world thing, is you're going to notice that what we're trying to do is give you a scenario that's real world. And if you're dealing with a lot of countries, and Canada is a great example, where you've got different general taxes for the country, you've got different provincial taxes, the way that they combine them together can be different, and so forth. Here's your different scenarios. So if you're from one province, apply this tax. If you're from a different province, apply this. And all of that can be done with if statements. And again, up on the GitHub, we do have solutions for all of that.
And breathe. Ladies and gentlemen, you have learned so much today.
We've covered a decent amount of
how much
ground.
everybody's had a chance to learn.
Yeah.
And the cool thing is we do have some more fun stuff for you tomorrow. We're going to get into reading and writing to files. We're also going to get into loops and have a little fun doing that with a program that actually allows you to start drawing funky shapes on the screen. So we'll have some fun with that. So it'll give us a chance to do some fun new things tomorrow. Anything we need to do tonight before we wrap up?
Yeah, absolutely. There was one last poll question down there at at the very bottom of the screen. If you want to go ahead and hit a choice on there. Do want to thank everybody for sticking with us. It's been a lot of fun. We've been loving seeing all the
awesome.
different comments. Absolutely. And hopefully you guys have had a fair amount of fun. I know I had a blast. I'm going to assume that you had a blast.
It's been an absolute blast. Having a lot of fun.
Excellent, excellent. So with that, we've got a lot more to cover come tomorrow. So 9 a.m. Pacific Daylight Time. Daylight Time for still about another hour, or about another month. So come on back tomorrow morning. We'll pick it up. Day 2, learning to program with Python. Again, Susan Ibach. I'm Christopher Harrison. We will see you tomorrow morning. Thanks again for
Can I just briefly ask you, do you remember off the top of your head the aka.ms URL for the GitHub for those people who wanted to go look at it? I know this is tough at the end of the day. And
Intro Python Code?
So
I'll look it up. I tell you what, I'll look it up. I'll put it into the chat window.
There we go. So because I had a couple people asking, hey, I remember you mentioned it was GitHub What's List. We'll put that in the chat window before we leave.
Actually, wait a minute. Tell you what, I can do that. Yeah, it just dawned on me. I had it in a notepad. If Danny, you want to just take my screen?
Awesome. I knew you'd be organized.
Yep.
There we go.
There we go. Intro. Hey, if we rewind the tape, I said that correctly.
Well done. There we go. Awesome. Excellent.
All right. So there's the shortcut to all the GitHub code. We'll kind of push out all of our last changes here momentarily, so you'll have access to everything that we've done.
All the demos, solutions to the challenges, a reminder of what the challenges were, the PowerPoint decks, all that stuff, so you can review. And of course, later these will all be online recorded as well, so you can watch them, review them, watch them at your own pace, and so on.
Exactly.
Looking forward to seeing you tomorrow.
We'll see you guys tomorrow morning, 9 a.m. Pacific time. Can't wait. All right. Well, good morning, good afternoon, good night. Welcome back to those of you who were here yesterday. For those of you who missed us yesterday, we missed
Thank you. Yes, thanks for joining us.
Yeah, thanks for joining us this morning. This is day 2 of Introduction to Programming with Python. That is Susan Ibach. I am Christopher Harrison. And what we want to do is sort of reset the level, as it were. That we want to go back, introduce ourselves, because we know we've got a fair number of people that are kind of just joining us, kind of brand new, don't know our quirky sense of humor. Our little quirky brand of delivery here. So we want to make sure that we introduce ourselves. We want to talk about what it is that we're going to talk about, and then kind of launch on into it, because we certainly have a fair amount of content to try and
great content to get through today.
Yeah, absolutely.
Absolutely.
Yeah. So Susan, right along those lines, why don't you go ahead and introduce yourself?
So my name is Susan Ibach, and I'm a technical evangelist based out of Microsoft Canada. My Twitter handle is HockeyGeekGirl, and I've been programming for a number of years. I'm not going to admit to exactly how many years of coding experience, but as I was making the joke yesterday, it's remarkable how many years experience I have, given that I'm only 29.
Only 29?
Yeah, I'm celebrating my several anniversaries of that 29th birthday now.
We won't ask how many.
And so I spent a lot of time coding. I love exploring the world of code and having fun with it, and looking forward to sharing it with you guys today, and hoping that you guys will have some fun with it too.
Yeah, excellent. And I'm, of course, Christopher Harrison. My Twitter handle is Geek Trainer, which really kind of tells you everything about my professional career that you might ever need to know on a personal basis. I started off with the Commodore 64, picked up my copy of Byte magazine, punched in the programs from there.
I remember getting those books and typing in the programs in the books. Yes, that's how we started. Yeah,
exactly. Yeah, and it is those little things, just getting in there, kind of breaking things. That really is the way that you want to learn to do code. On a personal basis, I have a 4-legged child and a periodic marathoner when I'm not, battling yet another injury. I would also like to point out, since this is day 2, Susan and I both decided to get a little bit more casual this morning.
We're more coder garb today. This is more what you wear when you're coding. Get comfortable, settle in, and start coding. So that's just it. Now we're really ready to settle in and do some coding. Exactly. Now, real quick, if you take a look at the slide, you're going to notice this was
everything from day 1.
Which it was all recorded, and it will all be posted and available in a couple of weeks.
And
you'll get an
2
email
weeks.
and notification when the recording's available. So if you missed any of the content yesterday, yes, you'll have a chance to go back, look at that. And we have this awesome, on GitHub, we also have available the slide decks, the demos we've done in terms of the code. We have challenges for you at the end of each module. The challenges are on that GitHub location, and even the solutions to the challenges, which you can use if you need a little help.
Exactly. Yep. Yeah, that bottom code right there, that's going to get you to everything that Susan was just talking about, all those little sample files. And one of the things that you're going to notice is we'll do our demos live, which of course means things will break.
Yep.
That's what happened. But we will be putting everything up onto that GitHub location, and you can access that with the bottom URL. This top URL, the reason that I threw that back up there is that's the shortcut URL that you can use to get to the presentation today. But what's cool about that shortcut is that once all of this becomes available on demand, which will be in about 2 weeks, that URL will be updated. So you will get the email, and that's really the best way to know that now all of this is live. So you'll get that email, but if you maybe lost your email, or if maybe the email that the site has for you is different than the one that you usually use, you can go ahead and use that URL. And that's always the one that I point people out.
So that works for the live event, and it will also get you access to the recordings once those are available.
Exactly.
So one URL for live, or just to watch us over and over again.
That's exactly it. Yeah, you know.
All joking aside, actually, when you're trying to learn how to code, there'll be times when you're watching us do a demo, and there's times when you'll be coding along, and times when you're going, oh no, I just have to pay attention now, and you'll be going, oh, I wish I could just rewind and watch that over, or pause it here while I try something. So I do recommend, in a couple of weeks when you've been playing for a bit, go back to some of the chapters that maybe you were struggling with, and review them, and stop and pause and try things out, because you'll find that really useful as you're trying to master coding.
How do you get to Carnegie Hall?
Practice, practice, practice.
There you go. All right. Now, as far as our day 2 topics today, day 2 topics today, this is what we're going to be talking about, which is starting off with 2 modules on loops.
Yep.
So we'll start off with 4 loops, and Susan will draw cool little things on her screen. We'll then go into while loops, and I probably won't draw a whole lot of cool things on my screen, but that's okay. We'll then get into lists, multiple items of information. We'll take a look at both writing, reading files. We'll take a look at functions, which is going to help simplify your code, make your code more reusable, and finish it all out with error handling, which one big thing that we want to kind of highlight here is our target audience and who you are. That one of the things that you're going to notice about yesterday, one of the things that you're going to notice about today, is we make no assumptions as to programming level.
Yep. So
that we spent a fair amount of time yesterday, for example, talking about the basics of what a variable is, not just simply how to declare it. So if you're relatively new to development and just trying to check this Python thing out, or really just trying to check programming out in general, you're in the right spot. Now, we are going to build on the concepts from yesterday, so I would definitely count yesterday as sort of a prerequisite to today, or the knowledge anyway from there. But even if you didn't watch yesterday and you're still brand new to programming, you're probably still going to pick up a few little things.
I think you'll be able to follow what we're doing today, even
Yeah.
if you missed yesterday. There might be a couple of things that you want to go back and check up on later, or read up on later, or check out in the recordings afterwards. But I think you'll still be able to get a lot of value out of the content today, even if you weren't able to attend yesterday. And that's it. We're not expecting you to come with coding experience. If you have never written a line of code in your life, this is still the right place for you to be to learn how to code, and the language we'll be using as we teach you to code is Python.
Yep. Absolutely, that's it. And that really is the key. We're teaching you to code. We happen to be using Python.
Yeah.
Yep, that's really it. Last but not least, the MVA community. 2 million people in the MVA community. You can earn points for attending this little MVA, 50 MVA points. You'll notice the shortcut URL. You'll notice the code down at the very bottom. There is not a new code for today, so there's not a bonus 50 for attending the second day.
Bonus if you get to hear more of Christopher's jokes.
And more hockey references.
Yes. More free toasters.
Yes.
If you were here yesterday, you'll get the free toasters.
Exactly, yeah. And anyway, no spaghetti. That's a different reference.
Yes, I know that reference.
You do know that reference.
Move on.
But anyway, yes, moving on. So what you're going to notice is the fact that you can go get the 50 points if today's your first day. There's the URL, and then away you go from there, which actually is away you go.
So now we're done with our introduction and ready to start digging into some new code.
Exactly.
For today.
Let's do some code.
So let's jump into and talk a bit about repeating events. You know, there are times, yesterday we talked about how the reason we get into coding is because we want to solve problems. And what we do when we're coding a program is really we're solving a problem by writing code. We're getting the computer to solve a problem for us. That's why we write code.
We actually had this conversation last night about kind of math and programming, and that was the biggest point that Susan made last night. So it's awesome to hear you making that again this morning, that's what you're doing with code. You're problem solving.
Yeah.
That's it.
Yeah. Programs are there to solve problems for us.
Yes.
So as we learn more commands, we can solve bigger problems, more complex problems with our code. And some of the problems that we have to solve involve repetitive actions, things you have to do over and over again. A simple example, you are having a party and you have people coming over, you want to pour a cup of coffee for each guest, right? It's not just pour yourself a cup of coffee. It's like, oh, wait, I've got people at the table. I'm going to pour everyone a cup of coffee.
Exactly.
Wash the dishes until they're all clean. You don't just wash one dish and say, I'm done the dishes. No, you've got to keep washing the dishes until there's no more dirty dishes. Making a name card for each guest that you've got attending a party. You know, when you're having a wedding, you thank you card for each of the people who attended the wedding. There's all these patterns where we're repeating a similar action over and over and over again. And when we're writing code and we have something we need to do over and over, we use loops. And that's our way of repeating a task. So we're going to have a little fun. I'm going to use a well-known, actually, tool. It's called Turtle, which is something we can use inside Python to actually show you how we can use loops to make our code a little easier and to repeat events. So we're going to use loops, in this case, to do some drawing. So I'm going to actually start off by doing a little demo and introducing you to Turtle. So I'm going to go into Visual Studio. If you weren't here yesterday, we're using Visual Studio and Python tools with Visual Studio to do our demonstrations. You can find the installation instructions in that GitHub location. We also have that link up inside the Q&A window if you haven't got it. So
I'll throw it back up there right now. Just
good idea. That'd be great. Now, so if I want to use Turtle, Turtle is in a library, so I have to start off by importing the Turtle module. And by doing that, what I'm doing is I'm simply telling Visual Studio that, hey, there's some logic inside that Turtle module that I want to be able to use. And Turtle is, said it's used in other programming languages as well. Turtle is a little turtle who moves around the screen and draws lines.
And for those of you who may remember back to many years ago, this was actually a very common way, and it still is, a common way to teach kids programming. Because what's nice about it is you get all those core concepts about doing things like loops, issuing commands, and it's just kind of fun watching. Oh yeah, cool! I saw a little drawing on my screen, so I still get a charge out of it. I'm 29.
Yeah, exactly.
Yeah.
Yes, you're 29.
That's 29.
Right. So once we've imported Turtle, then we can call some of the methods inside Turtle to do different actions. Now, so we call the Turtle object, and we tell it we want it to move forward. Now, there is something quirky. I'm not sure what it is. I think my IntelliSense library is out of date. So you'll notice when I hit the period after typing Turtle, there's a list of methods that pop up. And unfortunately, with Turtle, it doesn't list the methods I actually want to be calling. I'm not sure what's going on with that. So you'll see me just typing in the methods I want to call, and every now and then it goes and selects one that isn't what I wanted. So I'm just going to say, let's tell Turtle to move forward 100. Now, when I execute this code, you'll see basically a line that gets drawn that's 100 pixels long. So it draws a 100 length line. And I can go, and then I can tell Turtle to move to the right.
To the right.
And I can tell it to turn 90 degrees. And then maybe I tell Turtle to move forward 100 again. And again, my apologies. I'm not sure. I think my IntelliSense database is a little out of date. So it keeps thinking I want to select a different method every time I type forward. So now you'll see it draws a line.
I like watching it actually draw.
I actually like watching the motion, and then it goes down and draws another line. So with Turtle, we can go ahead and draw different things on the screen. So if you ever there was a toy I used to have as a kid, it was called an Etch-a-Sketch, and it was this little red thing with a little dial, and you would turn it and draw little lines on the screen. I think of Turtle as like Python's Etch-a-Sketch. That's actually how I think of it.
Okay, I like it.
So we have these awesome little tools that allow us to draw things on the screen. So we're going to be using Turtle in this module to have a little fun and also to introduce the concept of loops. So what I've done is I've drawn a line using Turtle. And if you take a look, there's other things you can do. You can change the color of the pen if you like as well. If you call the color function, you can actually set the pen color to green or blue or red and all kinds of different colors. So if I go here and maybe after I turn the corner, I say turtle.color is red. And once again, the IntelliSense in this case is actually messing me up and trying to change the method on me. Change the color to red. And now you can actually see that the second line that was drawn was actually drawn as a red line. So I can change the colors of the pen, I can move the pen in different directions and draw my object. So that just sort of shows you what Turtle itself can do. Now, I just did some drawing with Turtle, so let me get into a few other commands you might want to play with. If you want to explore Turtle, have a little fun with it. You can rotate to the right, rotate to the left. That's how you make it turn corners to make things like squares, triangles, and so on. You can change the pen color by calling the color function. You can tell it to move forward, you can tell it to move backward. There are more methods than that. If you want, go do a Bing search on Python, Turtle, functions, and you can get a list of all the different functions. You can do things like lift the pen up and put the pen down so you can't actually get gaps between the lines. You can do a stamp to make a little, like sort of capture of a little turtle shape at different points on your object. So there's some other functions as well, but this just gives us enough to play with. So if we wanted Turtle to draw a square, you think about what we'd have to do. So we'd have to tell Turtle to draw a line, turn the pen 90 degrees, draw another line, turn the pen 90 degrees, draw another line, turn 90 degrees, and draw another line up to a start. So we'd basically draw a line, turn, draw a line, turn, draw a line, turn, draw a line, turn. And that should give us a square.
Yep.
Ineffectively, if you actually look at the code we'd get for that on the slide here, what you end up with is you actually get the same 2 lines of code over and over again. Move forward 100, turn right. Move forward 100, turn 90 degrees. So that'll draw a square beautifully, but what we really end up with is just 2 lines of code repeating over and over and over again. This is a perfect situation for using a loop. Because a loop allows us to say, execute these lines of code however many times we want. And that's going to be much easier to work with than having to write the same code over and over. And we talked a bit about this yesterday in terms of good programming practice. It's not a lot of work to copy and paste those 2 lines of code and move them down the screen and just go copy, paste, 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 paste. But somewhere down the road, I guarantee you, someone's going to say, could you make a triangle instead of a square? Could you make an octagon instead of a square? So suddenly you now need to loop to run 8 times instead of 4 times, and now the angle's got to be different because your angles aren't going to be the same for a triangle as they would be for a square. And if you don't remember to make the change in every line of everywhere where you specify the angle, then the code's not going to work properly. So one of the reasons we don't want to just copy and paste the same code and execute the same 2 lines of code 4 times the way I have it on the slide here is because if we had to make a change later, that's more places we have to go make the change. We might forget to make it in one place, and now we've just screwed up our code.
Exactly. So, I mean, we keep talking about being lazy developers, but just doing that copy and paste isn't being a good lazy developer, because in the long run, you're just making more work for yourself when you have to go back and change something, because now you have to go back and change it in a lot of places.
That's right. All right, so what we're going to do then is we're going to use a for loop to do the same thing. So if we take a look at the slide, I want to take you through the syntax of the for loop. It's fairly intuitive when you look at it. You've still imported the Turtle library. I'm still using Turtle and telling Turtle to move forward 100. So this line of code hasn't changed. This line of code hasn't changed. And this line of code hasn't changed. So we're still importing the Turtle module, telling the Turtle to move forward 100, and telling the Turtle to turn right 90 degrees.
So we basically have the exact same code that we saw already.
Yes.
But now what we're going to do is we're just going to tell it, hey, I want you to do this
4 times. Exactly. So the code we haven't looked at yet is the code that's telling it execute these 2 lines here 4 times. So the way we do that is we use the for loop. The for loop is specifically a loop which allows you to specify a fixed number of times. If you know how many times you want that loop to execute, a for loop works perfectly. So if you take a look at the code, you'll notice I say 4 steps in range 4. So that number 4 is telling my loop how many times I want it to execute. The rest is really just syntax. You have to say for something in and then specify number. So those are, the only thing you're going to change is the number here. You get to choose that number. The word range, that's a keyword. You're not going to change that.
Okay.
You always have a semicolon. Yesterday we saw after if statements you need a semicolon. After
Colon.
for loops, colon, thank you. After for loops you need a colon. Just like yesterday we saw after if statements you need a colon.
Yep.
You have to indent the code that is going to be repeated. We saw that in if statements yesterday, that it was a way, indenting is a way for us to tell Python, these commands are part of that if statement, or these commands are part of that for loop. So this is the code that will be repeated.
Right. And so again, very subtle, and a lot of people pointed that out when we talked about the if statements. But again, it is something that you want to get yourself into a habit of. Absolutely. Yeah. So, and if we go back to Susan's slide, if I can point out one other very big thing, Susan did something really, really, really good here. And I want to commend Susan for this. So you get the gold star today, Susan. Congratulations.
Are you talking about this word here?
I'm talking about that word.
Because I haven't explained it yet. Let me explain it, and then I'll let you comment right after I explain it.
I want to give you a gold star.
Okay, I appreciate that. so far, really, the syntax, there's nothing you need to think about. It's just syntax. You say for something in range, you specify the number, which is how many times you want to execute, and you have to specify this value here. Basically, this is a variable name that's going to keep track of how many times you've gone through the loop. You can call it anything you want. I just chose to call it steps. Cue Christopher.
Cue Christopher. So one of the big things about steps is that steps there is a variable. So if Susan wanted, she could have called that Wibble. She could have called that
X.
X.
Or I.
It's so painful.
Yeah.
The thing about single letter variables is that they don't mean anything. That if I look at a block of code and I see the letter I, what does that mean? I have no idea. But if we take a look at a block of code and I see the word steps, I know what we're talking about. We're talking about steps. So even if you're not using the variable, still give it a good name. If you ever have the opportunity to name something, give it a good name. That if you have kids or if you have pets, you don't name them A, B, C, D. You give them meaningful names. It's the exact same concept here. Give it a meaningful name. Okay, rant over.
Okay.
You get your gold star.
We get to go back to the slides now?
Yes.
All
yeah,
right.
now I can breathe.
Back to slides. Awesome. That's great. So that's that variable steps. If you look at the slide here, he's talking about that variable steps right here. You can call that X. You can call that, as you said, Wibble. You can call it Bob. But yeah, having a meaningful variable name. You'll see I typically use the word steps because I sort of use that as I think of myself as stepping through the loop. And every time I step through the loop, I'm keeping track of how many times I have stepped through the loop. So that variable steps, the first time I go through the loop, it'll be equal to 0. 0. The second time through the loop, it'll be 1. The next time through the loop, it'll be 2. Because programming in Python, we always start counting from 0. So first time is 0, second time is 1, and so on.
Yep.
All right, so let's go back to the slide. Now we've taken a look at the syntax. And so you can see we specify the number of times to execute the code in the loop. You have to indent the code you want repeated. And if you change the range value here, so here I've changed it to 3. So that means my loop is only going to execute 3 times. So if I was to execute this code, I end up with an incomplete square because it only drew 3 lines on the screen. So you can see how changing the range changes the number of times the code is repeated. And it's also important to recognize that only the indented code is repeated, right? So these 2 commands are repeated. So I've got a loop. It's executing 4 times. That's a significant number there I have to really worry about when I'm writing for loops. The rest is just syntax. You'll look it up when you need to. I specify to execute 4 times. So 4 times, it's going to move 100, turn 90 degrees. So it's going to draw a square. And then afterwards, I tell it to change the pen color to red and go forward 200. So what this is going to do, though, this isn't indented code. So it's going to draw a square. And then when the pen gets back to start, it's going to go off and draw a red line. So if I execute this code, what you end up with is a square and then this red line going across the top. So you can see that the red line did not execute 4 times. It didn't draw a square, a red square that was bigger.
And it's all about that tabbing. So if you would tab that in, that also would have executed 4 times.
Exactly.
Yep.
It's not indented, so it's not part of the loop. It's not repeated.
Perfect.
So I'm just going to take the code I had here, and I'm going to just demonstrate that actual for loop here, and I'm just going to say for steps, and just to prove it, for weird name in range, just to prove you really can use any name you want here, in range 4, because I want to execute this 4 times. And now I'm going to have to indent my code.
With tabs.
With tabs, yep, using the tab key there. And now, when I execute my code, I can see it draw my little square.
I just love watching that on the screen.
Yep. And then if I specify that after I'm done, I want Turtle to move forward. It's so annoying the way it does
You
it.
can hit escape.
Escape will work for that?
Yeah.
Ah, there we go. Thank you.
You're welcome.
Forward, let's say 200. And again, I'm going to change that pen color as well. I should do that before I move forward. There's no point in changing the pen color afterwards. Turtle.color. To be red or green or whatever color I like. And you will see, just like I showed on the slide, that at the end of my loop, it then goes off and draws that longer line that's colored in red. If I just indented that code, then suddenly these commands will be executed 4 times as well because they're indented. They're now part of that loop. So now, oh, look at that. Woo-wee. Oh, you know what I did? Of course.
Yeah.
Within
you
the
left
loop.
it as part of it.
That's
Yeah,
really funny. I hadn't even thought about it. Because what I did is I said, move forward, then turn right, then change the color to red, and move forward again. And do that 4 times. So it caused a little unexpected result there in terms of how it draw it. But you can see, actually the end result in terms of it, it does actually just draw a really big
it did
square
exactly
for
what
me.
you told it to do. Don't you hate it when that happens? Does exactly what you tell it to do.
Computers only do what we tell them to do.
Yes.
It is frustrating sometimes because sometimes we want them to do what we want them to do, not what we told them to do.
Yep. By the way, can we switch back to Susan's code here real quick? Just because I want to highlight one little thing that came up in the chat. And this is one of those things where and this is true universally, so I guess it's kind of good that we all learn it now, which is sometimes the methods, the properties don't always behave the way that you would expect, that somebody was expecting that color would be a property rather than a method, which I could certainly understand. But yeah, you'll notice that color is a method there, meaning that you're going to say color, and then in parentheses, you've got red there.
Yeah, you're actually calling Turtle, you're calling a function called color, which changes the pen color to red. But absolutely, the person who designed Turtle could have designed that as a property instead of a function if they had chose to. It's just a choice the person who wrote the code for Turtle made.
Yep, exactly. Yeah. And by the way, method and function, those 2 terms are essentially synonymous. So,
they're generally interchangeable.
Yeah, yep, exactly. Cool.
All right, let's go back to our slides. Okay, so now Christopher, one of the things we've talked about is that as we write code, we are going to make mistakes. So I have a slide here, and there's 3 mistakes in this code. I'm going to check.
You're doing this to me again.
I'm going to play spot, because one of the things you have to learn how to do is find the mistakes in your code. So can you see 3 mistakes?
Well, I see improt.
Improt, yes, you're right. I have made a type mistake. It's import Turtle, not improt Turtle. I'm putting Christopher on the spot. He hasn't had a chance to look at this before.
You are, and well, I'm seeing the second, but I want to talk about that one at the end.
Sure.
Because that one's a little bit different. 4 steps in range 4. Oh, you need a colon. Thank you.
Yes, that's correct. Good guess, Christopher. Yes, we're missing a colon after the range 4.
Now, the reason that I was kind of holding off on that last one, so you've got, improt Turtle, so obviously that's a typo.
That should be import.
And that's going to give you a syntax error. So that's going to, Visual Studio will typically tell you right away, hey, you've got a problem here. Or when you run the code, it will bomb out on you. With steps, Visual Studio will give you, and this is the technical term, red squigglies to tell you, hey, you've got that wrong. The last mistake that you've got is Turtle 90, right 90.
I probably meant to have that indented, didn't I? Because I'm trying to draw my square again.
And that's one of those, should be indented. A lot of people caught that, which is perfect.
Yep, good catch.
The thing is that's what developers call logic error, meaning that your code is going to execute correctly. It's not going to give you an error message, but it's not going to do what you want it to do, which makes it one of the hardest bugs to try to debug.
Why don't actually we execute that exact
let's do it.
mistake,
Yeah, we can see it.
And you can see what would happen if I ran the code. So yeah, absolutely. If I left off that colon, then I get the little red squiggly, as you said, and yes, that is what we call it, the red squiggly. Or a syntax error or a compilation error. We'll use those terms. But if I forget to indent the turning right, Visual Studio goes, this is valid code. You can do this if you want. But then when I run it, I end up with a really big long line. And I'm like, that's not what I was trying to draw.
And if we actually did, go, 8 billion steps off the page, or I guess 400.
If I made
steps
this
off
only
the page.
10 wide, you could
exactly.
see it.
Yeah, what you could see at the very end there is you'll notice at the very end that the cursor did in fact turn that 90 degrees to the right.
Yes.
So it did. Run
worked.
the code, it did exactly what you told it to do.
But not what I wanted it to do.
Exactly.
Yes. So that is the challenge, is you have to find both the
Yeah.
mistakes. Some of the mistakes Visual Studio will help you find. Some of the mistakes Visual Studio can't help you, because what you wrote is syntactically valid. It just doesn't do what you want the code to do.
Yeah, exactly. Yep.
All right. So yes, you have successfully found all the mistakes. Well done to those of you in the audience as well who
A lot of people
pointed
got
them out
that.
in the Q&A.
Yeah.
That's awesome.
Yep, and there's still actually a lot of conversation around that tab, and that is something that's relatively unique. I'm sure there are other places where you will see that. But again, yes, it's subtle. I'm with you on that, but it's a good practice. It's something you would do anyway, even if you did have curly braces or end statements or the like.
Yeah, because some other programming languages, instead of using that indenting, there has to be a way. If you think about it, if you were designing a programming language, you need a way to say which commands should be repeated. You have to have a way of doing that.
Yep.
Some programming languages will require to use certain braces, and you do an opening and close brace around the commands that are going to be repeated. Some programming languages have effectively an end loop command that indicates the loop starts here, loop ends here.
Yeah.
But the interesting thing is, in all those programming languages, as a convention, most of us always indent the code that's inside the loop anyway, whether we have brackets showing beginning and end or an end loop word indicating the end of a loop in the beginning.
It just makes it more readable.
It does. We tend to indent the code anyway because it's more readable. So in a way, Python's letting us be lazy by not having to type a word like end loop or having to add curly braces. We were indenting it anyway, so it was easier to see. When I look at it, I instantly go, oh, that's the code in the loop.
Exactly.
Yeah.
And here we go back to being lazy developers again. You'll notice a theme.
Yes. I encourage being a lazy coder in the sense of it's being an efficient coder. That's what I like to think.
Lazy perfectionism, to bring out the little phrase that we learned yesterday from one of our attendees.
That's
right.
right.
I don't know if he's on board yet this morning, but yeah. So.
All right. So now let's take a look at nested loops, because it is also possible to put one loop inside another. So you can actually have a lot of fun, especially in this drawing tool with Turtle. When you start nesting loops, you can have a lot of fun. So if you think about it, so what I've got is I've got my for loop, which is repeating 4 times. And then inside the for loop, this is all nicely indented, but look what else I have indented in the for loop. I have another for loop, and this for loop has to execute 4 times because it's indented. So this is going to be so this will all be done 4 times.
Yep.
And then 4 times, I have a loop that will execute 4 times that draws a slightly smaller line and turns.
What's going to happen is you have 2 loops, so you've got that outer loop, so that's going to execute 4 times, and then each time that it does that, it's going to execute that inner loop 4 times.
Exactly.
Okay.
So if you look at that inside loop, all right, challenge, think about it, those in the QA, how many times is this code going to execute?
There's math again this morning.
Yes, it's math this morning. Is it going to execute 4 times? 8 times, 12 times, 44 times. You got any guesses in the QA window yet, Chris?
Not yet.
Might be a little lag. Sometimes there's a little lag
there's a little bit of a
between
lag
when we're
there.
talking and when you get a chance to see what we're saying.
But
so the answer is
I'm seeing a couple people saying 4. The answer's actually going to wind up being
16
There we go. Yeah, we got and actually, somebody called it out specifically. It'll run 4 times 4. A couple people actually called it out.
4
and
times 4.
That's really the best way to think about it.
That is a good way.
4 times 4, because you've got the outer loop. Inside of that is that inner loop. So the outer loop is going to run 4. The inner loop contains another loop. So it's going to be, while we're doing this, 1, 2, 3, 4. While we're doing this, 1, 2, 3, 4. So 4 times 4 is 16.
Yeah, well done.
Again, there's math this morning.
Yeah. What's really fun, though, is I love the output you end up with. If you draw it, you end up with little squares inside a big square.
It's really kind of funny watching the lag now kick in because, it was a little bit of time and no answers.
And now everybody's got it.
See the Q&A.
Everybody's got it.
16.
You guys rocked it. You knew the answer. I knew you had the answer. It's awesome.
16 will be the number of the day.
Now, I had a little fun. When I was playing around and I started doing nesting loops inside Turtle, I started going, well, what if I do a different shape instead of nested loops? And I had fun. So then now I've got a loop. And the outside loop executes 5 times. And inside, again, I've got a nested loop, and the inside loop executes 5 times.
So 5 times 5, so 25.
Right, so this code is going to execute 5 times.
So that's going to give me a pentagon.
A pentagon, correct. And then this code is going to execute 5 times 5, which is going, so yeah, 5 times 5 times.
Yep.
Because you guys figured that out, and so it's going to execute 25 times.
Right.
Now, what's interesting, of course, it's doing this along the way. And now you'll notice I'm still moving forward 100, but I'm turning right. My angle that I'm changing is 360 divided by 5. If you want to draw an equilateral shape, is that what you call it when everything's the same size of every side?
Oh, now we're going with geometry.
I know, geometry is
Geometry
tough.
is actually one of my worst subjects.
Okay, yeah.
Yeah.
So, but if you want to draw a triangle, the angle of a triangle that's going to have 3 sides that are equal size is 360 degrees divided by 3. Do you want to draw a perfect square? Then the angle of each corner is 360 divided by 4 because it's got 4 sides. If you want to draw a pentagon and have exactly the right angle and everything the same side, the angle is 360 divided by 5. So if you have a 6-sided object, it would be, and you needed the angle would be 360 divided by, Christopher, fill in the blank.
I wanted 6?
Yes, 6 is correct.
6.
6 is correct. Now, the fun thing is when
I was answering Q&A questions.
I know you were.
By the way, I do want to mention, because, again, we actually now have 3 people that are helping with the Q&A. It's Susan, myself, and
Sonal. Thank you, Sonal.
Yes.
Appreciated.
So we're doing our absolute best to try and respond to as many questions as we can. But if somebody winds up kind of falling through, there's only 2 of us. We're doing our best.
Yes, exactly.
Yeah.
So do be patient if we take a little while to answer a question.
Exactly.
So, but anyway, if you actually go back to the slide here and you look at the shape that's been drawn, it's neat because when the pentagons overlap, you get this funky star shape that ends up appearing on the screen. So you can have a lot of fun when you start playing with the drawing and the nested loops.
Exactly. Yep.
So if we just demonstrate that,
Right on
I'm going to go ahead and add another nested loop here for steps in range 4. So let's do that nested square. And we ask Turtle to move forward 100. Let's make it smaller. So we're going to make little squares inside the big square. And we're just going to take that command, paste it there, indent it nicely. And now I have one loop nested inside the other. And if I execute, you can actually see it. Whoa, that's not quite what I meant to do. Oh, actually it is, right? That's kind of neat.
Yeah, that is.
So you can see the kind of fun little patterns and things you can end up drawing. Just depends on the length of the square you end up drawing inside, how it looks.
Exactly.
So I had some fun with that. Because I forgot I'd drawn a little square. Originally it was a 100-size square.
Yeah.
So you can have some fun playing around with this. Now I am going to take 1 minute just to sort of illustrate. I'm going to put a breakpoint here. And I'm going to execute my code. And the reason I'm going to do this is because I want you to sort of see, here I am going in. Oh, frame not, that's getting, oh, it doesn't, it's a little messed up here. Stack frame was not found loading. That's a neat message. Execute, please. Okay, it's...
Maybe stop.
Yeah, I think it's, I don't think it likes me debugging when I'm in the middle of drawing things. I think that's throwing it off. But it will literally, it'll execute this code once, enter this loop, execute this loop 1, 2, 3, 4 times. Then go back here, execute this a second time, enter this loop, execute 1, 2, 3, 4 times. Go back up to the top, execute this a third time, execute the inside loop 1, 2, 3, 4 times. Go back up here, it'll be the 4th time, execute it, then execute this loop 1, 2, 3, 4 times. So that's actually the way the code flows when it's actually executing. All right, now, one of the things we did look at yesterday was the power of using variables inside your code. And one of the great things about using a variable, instead of repeating the same value over and over in your code, is it means if you need to change a value later, it'll be faster. So what I've done here is, in my code, I've created a variable called number of sides to my object. Because I was telling you, you can calculate the angle to draw a perfect shape by just saying the angle you need is 360 degrees divided by number of sides you want the shape to have.
Yep.
So by doing this, I can just say, hey, you know what? If I want a 6-sided object, execute the loop 6 times. But instead of putting the number 6, I'm saying just read the number of sides on the object from my variable. And then when I tell it how many degrees I want it to turn, I say it's 360 degrees divided by number of sides.
Yep.
Now what's neat about this is if I go and do this in my code, number sides equals, and I'll start off with 4. So initially it's going to be exactly the same square that I was drawing before, number sides. And I'm changing the angle is going to be 360 divided by number of sides. And if you do the math, 360 divided by 4 is 90. So it should still be a 90-degree turn.
Carry the 1. Yes.
Got the math? My math's good?
Yep.
You've had your coffee this morning. Well done, Christopher. And now when I run, we get exactly the same drawing we did before. So, initially you look at it and go, this is just a little more code. Why would you bother doing it this way? And I'm actually going to make this a little bigger because I think the other objects will look nicer. So I'm just going to redraw it with a bigger outside square. So it looks a little more like this. So you can see the little square is being drawn inside the big square. But now, if I want to make it a pentagon, I just change that to a 5. One change, and suddenly I have a whole new object. Oh, did I forget to change something
you
somewhere?
forgot one little update.
Oh.
Yeah, you'll notice you've got
there
the
we
second
go.
one. Yeah, that also needs
I
to
told
be
it the inside loop needs to execute.
Although, having the string of pentagons was actually kind of cool.
Kind of fun. Yeah, it's fun. This is what I was after. There we go. So you can really have a lot of fun playing around with this, and you can see how now this sort of becomes a, what if I make this 20? Who knows, right? What do I end up with then?
And, a lot of people are asking about circles, and so kind of there you go, and loops would be a great way to do that. And, one of the things that a couple of people pointed out is, hey, you know what? My kids are going to love this.
Oh, yeah.
And there is a reason why logo is, and turtle, well,
This is turtle.
This is turtle. Oh, logo, turtle.
Yeah.
Anyway, but there's a big reason why this is used with kids and also with adults is because of the fact that it's fun, it's cute, it's something to play with. And when you're learning, if you're having fun, you're going to learn it that much better.
And you'll practice.
Exactly.
Because you're going to want to play with it. You're going to want to experiment. I love this. It's like spirograph playing with this thing.
Ooh, good reference.
Yeah. So anyway, you can see the objects drawing there. So it really is quite fun to play around with it. So that's why I love playing with the nested loops.
Yeah.
But notice how it said by using a variable, I can now change one line of code and completely change the output. And that's the power of using variables in your code. So we just talked about that.
Yep.
All right. So we've also demonstrated that as well. Now, one of the things I haven't done yet in my code is I've never actually looked at that variable steps. I never actually used it anywhere in my code. I had to declare it it's part of a syntax. I have to have these variable steps in my code, but I was never using it. The fact is, that is a variable, and it will actually have a value every time the code executes. The first time you go through the loop, it will have a value of 0. The second time you go through the loop, it will have a value of 1. The third time you go through the loop, it'll have a value of 2. The last time you go through the loop, it'll have a value of 3. The way this works is when steps reaches the value here, it exits the loop. So you can actually reference that variable inside your loop. And there will be times when you want to count. And using a for loop is a great way to count to a particular number. And you can use that to do math and all kinds of neat little things in terms of problem solving. So just remember, in programming, we always count starting from 0. That's really important to remember. It takes a little getting used to. You'll forget it occasionally. Your code won't do what you want. And then you do something. I've actually done this to debug code before when I couldn't figure out what was going on. Sometimes I'd actually print the value of step on the screen, even though I didn't need it. I just printed it on the screen so I could see what was happening. That's an old coder's trick, to just print a value on the screen while your code is executing so you can see what's going on.
Yep.
We do have a debugger, but sometimes I still fall back on that. All right, so if we go back to the slides, what if you want to count from 1? I mean, there are business situations where sometimes you need to count from 1, not from 0.
Yep.
In that case, you are actually allowed in syntax of Python, instead of just specifying a range of 4, you can specify a start and end. So you can say start counting from 1. So the first time it executes the loop, the value will be 1. The second time, it'll be a value of 2. The third time, it's going to be a value of 3. And now it's done.
So it's up to.
Right, because when the value equals the range, it stops executing. So the thing to remember is if I write a loop that says run from 1 to 4, it only executes 3 times. So that's the thing you got to remember about that, is when it never reaches the higher number. It usually counts from 0. So a range of 4 would execute 4 times. But when you say, start from 1, then it only executes 3 times. As soon as it reaches a value of 4, it says, I've reached 4. That's the maximum. Time to get out.
And I'm done.
And I'm done, exactly. So that's important to be aware of. Now, there's another neat thing you can do in terms of syntax on for loops, and that is specifying a step or a skip, amount to skip by. What this is going to do is the first time it executes the loop, it's going to be a value of 1, because that's our start value we specified here.
Yep.
The second time, it's actually going to have a value of 3, because we specified this skip step of 2. So basically it said, jump by 2. The third time it executes, it'll have a value of 5 because we told it to jump by 2. The next time, value of 7 because, again, we told it to jump by 2. The next time, it'll have a value of 9 because it jumps by 2. When it reaches a value of 11, it's going to say, oh, wait a second, 11, that's up around, that's higher than 10. If it reaches 10 or 11, it would never execute with a value of 10 or 11 because we've said get out when you reach to 10. And so this one actually only ends up executing 5 times. But it's interesting when you start playing with steps, and if you specify minimums and maximums, you have to be very careful. You might accidentally write a loop that executes 1 too few times or 1 too many times.
Yep.
I'm drawing it out on the screen. I'm literally writing out the numbers. I do that on paper when I'm trying to figure out my loops. I have sat there with a piece of paper beside me going, okay, wait a second. The first time it does a loop, it's going to be a 1, and the second time it's going to be a 3, and I literally write it out on paper so that I can count, and then I go back and count and go, wait, oh, I needed it to execute 6 times. I need to change the value.
Yep.
So that is a perfectly valid practice. Write it out on paper, and then you can see what your code's going to do. If you're lucky, you'll get it right the first time, but quite often it's a common coding mistake to just get it off by 1.
Yep.
Test, test, test. So you think it's running 4 times, run it, make sure it's running 4 times.
Exactly, exactly.
So if we go back to the slides, and now this is a really cool, I love this trick in Python. This is really interesting. Now, however, I want to point out is a little different syntax here. There's a word missing in this command. The word range is missing. I've written a for loop, but I didn't say the word range.
Okay.
And the other thing is, my brackets changed. I was using the rounded parentheses before. Now I have square braces or square brackets. So 2 big changes in syntax here to be aware of. And I'm specifying a series of values. What I'm doing now is I'm actually telling my for loop exactly what values to use when it runs through the loop. So I can actually tell the for loop, the first time you go through the loop, use this value. Second time you go through the loop, use this value. Third time you go through the loop, use this value.
So it's sort of like what other languages might call a for each loop.
Yes.
So if you were in C# or VB, like a for each, because what you're saying is the first time through it's going to be 1, the second time through it's going to be 2, or you could of course have changed the numbers.
Those numbers could be 72, 15, 7, and 8.
16. Don't forget 16, the number of the day.
Sure. So if we go back to the slide, the first time it goes for the loop, it takes the first value in the list, and the value of steps is going to be 1. Second time through the loop, it takes the second value in the list. That's going to return it, so steps will be 2.
Yep.
Third time through the list takes the third value. That would return a 3.
Yep.
Now, and instead, this number here could be 44. That's fine. And if it was 44, it would then, steps would be 44. I happen to enter 4. And the last time through the loop, it is 5. Now, in this case, yes, it will execute for that last value because you're telling execute once for each value I'm providing. But just, I guarantee you, the first time you do this, you're going to accidentally type the word range, or you're going to use the wrong brackets, and you're going to get syntax errors. So just look it up when you need to, but it's a really cool feature and very useful.
Yep.
So that's the output we get. Now, what I really like about this is the way you can play with things like, I said, so there's that reminder. You don't have to use numbers.
No.
No, you can say any value at all. You want the loop to execute, and here's the value to put into that variable steps. So we go back to the slide again. This time, I said my loop is going to have a value of red. So the first time the code executes, the value will be red. The second time the code executes, the value of steps will be blue. The third time the loop executes, it will have a value of green. And the fourth time it executes, the value of the variable steps will be black. So what I'm doing is I'm drawing an object, I'm changing the pen color each time through, so I end up with a multicolor square.
Awesome. So a couple of things that I'd love to mention here. Real quick, number 1 on your slide, and I love the fact that you've been consistent with steps, but it's definitely worth calling out here that you could have used whatever name it is that you wanted.
Sure.
So you could have maybe used color instead.
Oh, I like that.
Yeah.
Okay, hang on. Maybe we can do the little eraser thing here. I don't want to let me think.
Yeah, it won't let you erase the
hang on. We'll have to.
Yeah, you'd have to bail out of the slide there.
Okay, hang on. No, we'll get a pen here, and we're just going to scribble that out.
There you go. I love it.
We're going to write color. But I'm a Canadian, so I'm spelling it with a U.
And then put that
scribble
down
that
there as well.
And this is now going to be C-O. That's a really good point. That's a much better name for the variable in this scenario, because in this time when I'm going through the loop, the variable I'm setting is really holding a color.
Exactly.
That's a much better name.
Yeah. Now, the other thing that I'd like to point out real quickly, because there's been a few questions about this in the chat window, about putting together that list of numbers that you had. And if you were using 1 through 5, could you have done like 1.5, or could you have done 1-5?
No, unfortunately, Python doesn't support that syntax. You do have to, if you want to count from 1 to 5, use the syntax we had earlier. If we go back to my slide, if you want to go from 1 to 5, use the in-range syntax.
Exactly. Yep. Yeah, the only catch would be with range, of course, is if you wanted to display the number 5, you'd have to say 1, 6.
That's right.
Exactly, because always remember that it's going to be up to, but not including that number. So you would have to use 1, 6 if you wanted that 1 to 5 range.
Yeah. Awesome. Awesome. Great. Some great questions coming up there. So just to sort of show that sort of neat little example, if I'm just going to comment out this code using the great Control-K, Control-C command to turn that into comments, and I'm just going to write a little for color in red, green, blue, and black. And in that loop, oops, I forgot my colon. And then I'm simply going to tell Turtle to change the color to the color value that I read from the loop. And then I'm going to tell Turtle to draw a line, move forward 100. And then I'm going to ask Turtle to turn, oh, what the heck, let's go left, just because we can. Because I can turn left. No Zoolander references? I was waiting for that.
Oh, no, I was going to say jump to the left.
Okay, yeah, that would work too. All right, so I execute my code, and the first time through, the color should be red, so we should see a red line, then a green line, then a blue line, then a black line, if I did this correctly. Fingers crossed. There we go.
There it is, just like that.
So really said you can have a lot of fun with this. Okay. You can actually mix up different data types when you are specifying explicit values. So in this case, I'm saying, you know, red, blue, green, black, and 8. But there is a little problem with this. If I execute this code, the problem I'm going to have is when I say change the color of the pen to 8, Turtle's going to be really confused and go, what color is 8? So 8 is not a valid color, and so this would actually crash my code. So you do need to be very careful if you're trying to mix data types. It's not generally recommended. It's valid code, but it might crash your code because maybe when you use the variable later, it doesn't work. If you actually go back to the code, let me look at the slide here. You can see it is possible. I was doing a print statement, it would work, but not when I'm trying to change a color. So your challenge, now that you've had a chance to play around with this.
Should you choose to accept it?
I want you to have Turtle draw an octagon. Right? So there's just a reminder here of how to calculate the angle for an octagon. As an extra bonus or extra credit, try to rewrite it so the user can type in how many sides they want the object to have and draw whatever they ask.
And one little thing that's worth highlighting there, especially for people who weren't around yesterday, that they could use input to obviously collect that piece of information, but the catch is that input's only going to send in a string, so you need to convert that. So
you're going to need to convert that string into a number before you try to count how many sides the object has. So you're going to have to, if you get to the extra credit, you're going to have to deal with data type conversions as well.
Yep, exactly.
All right.
Yeah.
And there's even double extra credit, which is add a nested loop inside to make the little one inside the big one.
Exactly. Yep.
So have some fun with that. And we'll be back in 10 minutes.
Yeah, that's basically it. Yeah, we'll be back in 10 minutes, and the next module will be looping when we don't know the number of times that we're going to loop.
Yeah, so we're going to look at some different types of loops for different scenarios.
Yeah.
See you shortly.
We'll see you in 10. All right, well, welcome back. This is still Introduction to Programming using Python. That's still Susan Iback. I'm still Christopher Harrison. And in the prior module, we took a look at how to do for loops.
That's right, yeah. So we were starting to look at how you can write code that will repeat.
exactly.
efficiently.
Yeah, exactly. Now, the for loop is fantastic, and I have to admit, and we talked a lot about this yesterday, that there's oftentimes multiple ways to solve the exact same problem, and when it comes to having to do something X number of times, I trend towards, and this is true across all programming languages, some form of a for or a for each, depending on the language, some form of a for or a for each. But the catch with using for or for each, depending on your language of choice, is that you have to have a pretty set number of items right from the get-go. And a lot of times, you don't actually know that. So you might be looking to go through a loop of records where something could change while you're looping through it, or maybe while your code is executing, maybe you're going through a queue. And something might happen where I go, all right, well, I know this item is going to take me a little bit longer to process, so I'm just going to throw that back down to the bottom, or something like that. So it could be that I don't know right up front the number of times that I need to do something, or the number of times that I'm about to do something could change while my code executes.
Yeah,
so,
or just from one execution to the next.
Exactly, exactly. Yeah, so, we still need to have kind of those same actions, the kind of real world or analogy of, pour a cup of coffee for each guest. By the way, pour my cup of coffee first, please.
Okay.
Yes.
Sure.
Yes. Thank you. Washing all of the dishes, putting together each name card. You have to handle all of those different things, kind of those analogies. But when we get into programming, I might be looping through a file. I might be looping through a number of entries in memory.
I'd say a lot of times in coding, we'll have things like somebody gives us a file and we want to read all the values in a file, or we do have a database table and we want to read all the people from a particular country from a database, but we don't know how many records we're going to be getting back from a database before we start.
Exactly.
So, yeah, there's a lot of situations where we know we're going to have to do something over and over, but we just don't know how many times.
Exactly. And sometimes, we can calculate it, but again, not always, So if it's a scenario like this, where, we know that we've got 20 guests, then we could just go in and explicitly state, okay, fine, it's 20 guests. Or it could be a scenario where maybe we've got this in a list, and a couple of people asked about that earlier. We'll be talking about lists.
We will
in the
get
next
into lists.
module.
Yeah.
But I could go in and I could ask the list, well, how many items are inside of you? And I could throw that into there. Or we could actually just simply say for in list, but now I'm sort of stealing your thunder.
Yeah. Come on, I'm going to get to that. Don't steal my next slide.
Right, you're right. Okay, I'm sorry. But in any event, I can calculate that number of times, but that's not always going to be the case. And this is where while loops come into play. That the concept of a while loop is we're going to do something, perform an operation, while something is true. So what I'm going to do here is sort of just jump straight to the syntax. And this is a perfect example of where a while loop is going to shine. So let's start with, of course, keyword while.
Yep.
And just as a real quick refresher, I'm just going to do this right away. You'll notice my colon, and then you'll also notice the tab in right there. So kind of, again, that same thing with an if statement or a for loop or everything. We've got the colon, we've got the tab. This is what's going to be executing, and that's just simply what says, hey, go there. All right, cool. So again, we've seen all of that. Now let's explain the concept of a while loop, and I think the easiest way to explain it is to do it in English. A while loop means do something while a condition is true, while something is true. So if we go back to our code here, what we're going to be saying is while answer, whatever answer is, we'll talk about what answer is here in just a moment, while it's not for. So this could be something like while file is not empty, while all candidates are not processed, or again, some conditions. So as long as something is true, we're going to stay inside of that loop and we're going to kind of keep doing what we're doing. Now, the next part that I want you to notice here is that unlike that range, where again we had that set of defined numbers, what you're going to notice with this example is we're asking the user for input. And we're asking the user to input the answer to a question. So what is 2 plus 2? I have no idea how many times it's going to take somebody to enter in the correct value. It could be that they do it the first time. It could be that they do it the 51st time. And again, the next time that the program runs, I still don't know. And the next time, I still don't know.
Right.
So there's no way that I could say, well, we're just going to loop 5 times, or we're going to loop 20 times. I don't know how long it's going to take them to get it right. So this is where a while loop shines, because now I can say, well, look, as long as they keep getting this answer wrong, we're going to stay here until they get it right.
Yes.
That's what my while loop is all about. All right.
I'm going to keep going as long as I have to.
Exactly.
While loops are great that way.
Yeah, and that's really it. So give me 1 second here. I'm going to do 2 things behind the scenes. One is going to be to get out of my slide, and the other one is to launch Zoom It, which, by the way, if you haven't already seen or heard, what we're using to draw on our screens and zoom in is a great little tool called Zoom It. I know that we've got a lot of students. What was the percentage? Did you see the poll?
30% of the people here are students.
Yeah.
Yep.
So one of the things that I remember in college and in university was having to do different presentations to kind of show off, hey, this is what I learned. This is a great little tool to play with to do presentations. And again, it's a free tool. It's a great way to draw attention to the spots on the screen that you want. Okay. In any event, let's start doing this here. And I'm just going to go in and say answer equals 0. Now, a couple of things that are worth highlighting. Number one is you're going to notice that I'm going to initialize that variable right away. And the reason for that is because I'm going to use this on my while loop. So if I'm going to use this somewhere, it needs to be initialized in advance. So I'm initializing that up at the top. The second thing that I want you to notice here is that I've initialized it to a string, and I'm going to be using strings. Now, you might be looking at that and you might be thinking, well, gosh, Christopher, that seems a little bit odd because you're asking somebody a math question. That you're asking them, answer equals input, and what is 2 plus 2? And you are right that I am asking them a math question. But if you remember back to yesterday, input gives me back a string. So the fact that I'm asking them a math question is sort of irrelevant. It's sort of secondary here. That the fact that it's a math question is not what's key. What's key here is the fact that we're doing an input, which again is going to give us back a string. And that's what we want to do here.
Okay.
Okay. So now,
rather than converting everything to numbers and comparing, I mean, you could have converted the answer into a number and said if the answer is not equal to a number 4, but in this case, it's a bit of overkill.
Exactly. So here, you know what we could also do? We could just do this real quick. What is the answer to the ultimate question of life, the universe, and everything? Boy, how about that? I barely had enough space to fit that onto the screen.
Yeah, well done.
Thank you. All right, so now let's go in and run this. It will then ask me what's the answer to the ultimate question of life, the universe, and everything. And as we all know, that's, of course, 42. Yep. And I'll hit enter, and it says, congratulations, you are right. Let me kind of run that on the bad side. So we'll say 16, which is the number of the day. Hit enter, nope. 54, nope. 67, nope. 42. And now it says, congratulations,
there you go.
You're right.
And so now we exit this loop.
Exactly. Yeah, so it was waiting for the answer to be 42. So as long as it wasn't, it was just going to stay inside of that loop. And that's a perfect example of where to use that type of a loop, because I had no idea up front how many times it was going to take for whoever it was to get that answer correct. Okay. Let's see. I want that. That's sort of weird.
Going back to your slides?
I am, but PowerPoint is beating me up here. There we go. Okay.
All right, you're good.
I'm having PowerPoint issues. All right. So let's talk this through. What will this code do. And I'm talking a bit slowly here to kind of wait for the bit of a lag that we've got here for our fine viewers to go in and kind of contribute inside the chat window.
Right. So I can see you're using turtle again.
Yeah. Okay. So we're using turtle again.
You've got a counter, a variable called counter.
A variable called counter.
And you're setting that to start off at 0. So I know counter is 0 when the program starts.
Yep. Okay.
Then you have a while loop. That says while counter is less than 4. And I know right now when I'm starting the program, counter is only equal to 0. So 0 is definitely less than 4, so I'm going to enter the loop.
Okay, that's good math. Yep.
Okay. And then, so I'm going to enter the loop, and it's going to move my little line forward 100 and turn right. So this is me trying to like draw lines on the screen again. So I move forward 100 and I turn a corner.
Yep.
And then I'm saying counter equals counter plus 1. Now that's my way of saying add 1 to the counter.
Yep.
So now counter is equal to 1. So now, I guess when I get to the end of the loop, it's going to go back to that while statement again. And 1 is still less than 4.
Yep.
So I'll go through, draw another line, add another counter, it'll be 2. I'll go up, 2 is still less than 4. I'll draw another line, I'll turn right, I'll add a number to, it'll be, counter will now be 3. I'll go back up, 3 is less than 4, it'll draw a last line. And then the next time I go through, counter will be equal to 4. And when 4 is not less than 4, and then it should exit the loop. So 4 times?
Okay, so it's going to do the loop 4 times. What's it going to wind up drawing out?
Square.
It's going to wind up drawing out a square. So it's going to go forward 100. It's going to turn right 90, forward 100, right 90, forward 100, right 90, forward 100. That was actually a little off of a square on my drawing. Not bad by hand, though. But in any event, it's going to draw out that square. So we've actually already seen this. We just saw this with a for loop rather than with a while loop. Now, I do want to just pivot off of this real quickly here, just to highlight that little counter equals counter plus 1. That there was a couple of people in the chat window that had mentioned the concept of variables in Python and kind of mentioned, oh, you don't have to declare them. And the answer to that is no, you could just start using them. So I also want to highlight the fact that what we've done is a counter, again, is a bucket. So what you can do is dump that bucket out and put in a new value, but you could use that variable for that update. And I gave the analogy yesterday that, again, if it's a box, if I had 2 slices of bread, that I could take out those 2 slices of bread, put in a couple of slices of ham, some nice good spicy mustard, and then put that back into the box. And what I've now done is I've used what was in there, but I've now updated it. So we've gone from 2 slices of bread to a sandwich. So sort of that same concept here, that our counter, kind of coming back over to the slide, is our 2 slices of bread. Our number 1 is our ham and good spicy mustard. So I've combined those together to now update the value that's inside of there. Okay, so that's going to draw us out a square exactly as we would expect it. So to spin this back to what we did before, these 2 blocks of code are really the same. So let's answer the question. Which should you use? Well, the answer is, it really just depends on a matter of personal preference.
Yeah, in this case, I like the for loop easier because it's easier for me to keep track of how many times loop is executing.
Exactly.
When I just say for range is 4. But I just, for me, when I'm running a for loop, if I know I want to execute 4 times, I like just saying the range is 4. I know it executes 4 times. I don't have to think about it. With a while loop, I have to sit there going, counter was 0 the first time, then 1, then 2, so it's less than 3. So that, I got it right, it's 4 times. So in this situation, I prefer the for loop, but it is a personal preference.
It is a personal preference, and I'm with you. And the reason that I'm with you, and I'm going to steal a little bit of my thunder here, there's a slide coming up. I'm allowed to steal my own thunder. But coming up, we do have a slide on this, but I'm going to highlight it for right now. The most important line here is this right here. I have to make sure that I update the counter. So this is on me. So if you're not sure of, which should I use, for loops or while loops, again, it does come down to a matter of personal preference. For me, the dividing line is, can I have something else automatically handle the condition for me? So in the case of our for loop, The condition is, as long as we haven't reached 4 times yet, keep doing this.
Okay.
That's the condition. And this little in range will automatically do that for us. But over here, it's my responsibility to go in and update the counter. Again, kind of that lazy developer. If I can let something else do it, I'm going to let something else do it. So this is really nice in scenarios where that condition there will automatically update. So if I can say, as long as we haven't reached the end of the file, keep doing this.
Yep,
you know, those types of things are perfect for our while loops. Okay, so they both have the same end result, but again, it's going to do kind of whatever it is that, that you might want. Now, I hinted at this, so now we're going to get in and talk a bit about it. That when it comes to a while loop, remember that you're responsible for handling the condition. Susan actually called that out perfectly. Your responsibility, because now you have to stop and think, okay, well, how many times am I going to loop? So you might do something like this. That you might think, okay, well, counting starts with 0 in most languages. And somebody mentioned this, and it's worth mentioning now. That's not true across all languages. There are certain languages, like VBA, that, you know, doesn't always start with 0. But most languages start counting with 0. Python does, so to avoid any confusion, from here on forward, counting starts with 0. So you might be thinking, oh, okay, right. So counting starts with 0. I'm going to be consistent. So I'm going to declare a counter, and I'm going to set that equal to 0. Cool. Well, I know that I want to draw 4 times, so I'm going to go in and set a while loop, and I'm going to say something like this. I'm going to say counter less than equal 4. So if we talk this through, and it's basically the same code that we saw a second ago, if we talk this through, what's going to wind up happening is it's going to run our conditions, and it's going to go 1. Or I'm sorry, 0 rather. That's going to be the first one. So 0, and then it's going to go 1, it's going to go 2, it's going to go 3. Now 3 is less than equal to 4. It's going to go 4, and then it's going to execute that 4th time because 4 is equal to 4.
Okay, yep.
Generally speaking, 4 is equal to 4, you know? So it's going to execute a collective 5 times.
Right, just because I said less than or equal to instead of less than, I end up, you know, somebody might look at that and think, oh, it'll execute 4 times, and oh, surprise!
Exactly.
5 times.
All because of that little sideways
And that's why I like for loops, when I know exactly how many times I want to execute. Because that's the kind of stuff I do by accident, and then I'm executing going, huh, what'd I do wrong?
Yep. Yeah, and this is, you know, one of the things that we talked about yesterday, and both of us have this little hitch in our deliveries, is we both have a propensity to invert our Boolean logic, or make a small little mistake on Boolean logic, like throwing in a less than equals when we just simply meant less than. So, I also have a propensity to say the word propensity, but that's sort of a different conversation. All right, let's kind of bring it back and take another look at another possible scenario that maybe you've decided, you know what, I don't want to count with 0. Or maybe you coded that last one and you said, well, starting with 0 just gave me a mistake, so I'm gonna start with the number 1. So you write code that looks like this, that you say, all right, well, counter equals 1. And you say, well, counter less than equal to 4. Well, again, let's talk this through. 1, 2, 3. 3 is less than 4.
Yep.
So when this is incremented up to 4, what's going to wind up happening is that that's now going to test as false, meaning that 4 is now going to not be run, so it's only going to run a collective 3 times.
So now it's actually running 1 less than I expected instead of 1 more than I expected, because this time, just because I initialized to 1 instead of initializing to 0 with my variable. Again, these subtle things, right?
Yep,
a less than an equal instead of a less than, initializing your counter to 0 instead of 1, and suddenly you're not executing. These are such common mistakes with while loops. They happen all the time.
They really do. They really do. And if you are going to use this with numbers, the best bit of advice that I could give to you is be consistent. Organization and consistency will set you free. And nowhere is that truer than in code. That if you've going back to that whole lazy developer thing, when it comes to things like formatting my code, I don't think about it. I just do it naturally. The reason that I do it naturally is because I've already made the decisions ahead of time. So I sat down and I said, okay, this is where I'm going to put my tabs. This is where I'm going to, in the case of curly brace languages, put my curly braces. This is how I'm going to format my variables. I've made all of those decisions in advance. So when I sit down, I don't have to think about those things. I think about my code, and that's it. As a real quick side note, for anybody who's listening who's just getting into developing, I would say that the one book, if I could take any new developer and say, if there's one book that you need to read when you decide you're going to take the next step into development, is a little book called Code Complete, and it's written by Steve McConnell. It's a Microsoft Press book, and it's a fantastic book. It does focus a bit more on languages like C++ and C#, but it does a fantastic job of going over things like, choosing good variable names, dealing with casing, where to put your tabs, and it's all of those little things that, when you're taking a programming course, even like this, we're trying to highlight those things, but we only have so much time. That's all that this book is about. So it spends a lot of time talking about those things that really do have a big impact on the readability of your code. It's a fantastic book. In any event, so I've made all of these decisions in advance. So if I'm going to do a loop like this, I'm always going with 0, and I'm always going with less than. That way, I don't have to think about it. I made this decision already. That's what I'm always going with. So rather than kind of approaching this and going, well, I need to loop 5 number of times. Well, should I go 1 and less than 6, 1 and less than equal to 5? Just stick with what you've always done. And in my case, what I would do is I would set it to 0, and I would go less than, and then the number of times that I would want to increment. So if it's going to be 5, I would say set it to 0, and then go less than 5. And that way it's done. Now, all of these are different looping issues. And we've talked about a couple of different ones here, but
before you do that, can I just ask you quickly the name of that book again? It was called Code Complete, and the author was Steve
McConnell.
McConnell.
I think I have that name right on his name. Code Complete is the name of the book.
All right, I'm putting that down because there was a couple of comments in the chat window just sort of saying, can you just put that name in there? So it's in the chat window there. So if anybody's interested, we put that in there. So the name of the book is in the chat window.
Yeah, absolutely. You know what I'm going to do? I'm going to do this. I'm going to actually put the slides to the side here. And I'm going to comment out my my code. And let's do this. I'm going to say import turtle. There we go. And let's say counter equals 0. I'm going to say 4. Whoops, not 4.
You're doing well.
See, my brain just wants to go to for loops.
You knew. It was a fixed number of times. You wanted to use a for loop.
Okay, so in any event, you'll notice that I've got my while counter less than 4. And again, you'll notice I'm sticking with that. That I said 0 less than, that's what I always do. That's exactly what I've done here. So I'm going to say turtle dot forward, and we'll say 100. And I'm going to say turtle dot right, and I'm going to say 90, and I'm going to say counter equals counter.
Can I get you to make a little change instead of counter equals counter plus 1? We had a lot of questions in the Q&A about different ways of adding 1 to a variable. Somebody was asking if you can use the plus plus that we sometimes use in some languages, and about the plus equal. So would you do me a favor? No, plus plus won't work, but the plus equal syntax does work. So I just want to show that as an alternative way of adding 1 to a variable or adding a value to a variable, because that came up a few times in the chat window. So we just want to show you that's another way of adding 1 to a variable. That plus equal means take this value and add this to it.
Exactly. Yep. So, and one of the things that I would mention, in particular for my for the junior developers that are watching here, people that are new to development, that a lot of times what I'll find is kind of a little bit of pushback on that bit of syntax, because it's certainly not as clear as doing that. And you know what? I'm sort of with you, but I always kind of look at it like a contraction.
Yeah.
That it doesn't necessarily, especially when you're first getting into it, look as clear. But once you start using it, it just becomes second nature. So you might decide, you know what, that doesn't make a whole lot of sense to me, so I'm not going to use it for right now. That's totally cool. Again, that's just a matter of personal preference, but you are going to see this quite frequently. And honestly, after a little while, you're just going to, oh, I know what that means. And
yeah, so it's just nice to see both options.
Absolutely.
It was coming up in the chat window, so I wanted when you got to the demo to show that is an option. You can either say counter equals counter plus 1 or counter plus equals 1.
Yep.
Your choice.
And in fact, here, let's go ahead and just prove it. So I'm just going to hit start. And then, sure enough,
Yep, it works.
It works.
There you go.
Okay. Now, let me, I'm going to close this out for right now. There we go. And I'm going to go back to my slide. And let's talk about this. How many lines is this loop going to draw?
Okay, how many lines? Oh, I got to go think again. All right, let's see. We've got counter starts off as 0. So I go into the loop, counter is 0. I've got my, keep track of my fingers here. Well, counter is less than 3, so we draw it. And, okay.
So talk it through.
Okay, so I see what you're doing here. Okay, so counter is 0. I enter the loop. I draw a line.
Yep.
I turn right.
Yep.
I go back to the top of the loop, and my counter is still equal to 0,
Okay.
which is still less than 3.
Okay, so keep talking me
I
through
draw
it.
another line, and I turn right.
Yep.
And then I go to the top of the loop, and counter is still 0. So
Okay.
once again, I enter the loop. This loop is going to go on
Hey, Susan, I'm going to cut you off because it sounds like you're going to go on and on and on forever. Here.
forever and ever and ever and ever and ever and ever.
Okay, Susan.
Am I done?
Yeah, now you're done. We need a control C.
break.
But yeah, exactly that. And Susan did a perfect job of explaining that with a bit of humor as well. That's exactly what's about to happen. Is my condition here is never going to change because I never updated, I never incremented my counter. And this is one of the biggest pitfalls of using a while loop. Is you have to make sure that that condition is going to change. So let's actually kind of go in and do that. You'll notice it is, in fact, a trick question.
And well done to the Q&A group. We got a lot of people who caught that one. So
awesome.
You got it. Well
Love
done.
It. And you know what I'm going to do? I'm going to introduce this bug a little more subtly.
Aha! Sneaky. What you've got is because you didn't actually indent the adding 1 to the counter. So
Yep.
just because you forgot to indent it, that code isn't going to execute inside the loop. It'll only execute when you exit the loop. But that means when the loop is executing over and over and over and over again, it never gets out. So it never gets to the line of code that says add 1 to counter.
Exactly. So when I go in and I hit start.
Whee! Round and round she goes. When she stops, nobody knows.
We could be here for a little while.
Maybe now would be a good time to show someone what do you do if you're in Visual Studio. Can we go to Visual Studio and show how you get out of this if you code this by accident, because you will.
You absolutely will. Again, if I had a nickel, I'd be able to take my wife out for a very nice dinner. You'll notice right up there in the upper right-hand corner, there's the Stop Debugging button.
Yep.
Just click that.
And you're back to your
and
code.
You're back to normal. Absolutely.
That's your break
Yep.
command.
Yeah. So we'll go back in. We'll hit start again and rerun it. And now you'll notice that it's just doing it the 4 times. So close. There we go. Okay.
Yep.
So yeah, and that is going to happen. So if you're going to pick up anything about while loops, the biggest thing that I would say is to make sure that your condition changes. So either you do it manually, or it is easier if whatever it is that you're doing, the scenario is going to update automatically. So I remove an item from a list, or as part of my code, just naturally I'm moving to the next line of the file, or whatever it is that you happen to be doing. So kind of to wrap all that up with our best practices here, use for loops whenever possible. That if you can figure out the number of times that you're going to do it, use that. But again, don't fear the while loop. That there are going to be scenarios where the while loop is the only way, and sometimes, it could actually be a little bit easier to remember. Plus, on top of that, the while loop gives you a little bit more flexibility because there's nothing that says that every single time that you go through the loop that you have to increment the counter. When you're doing a for loop, basically once you start that for loop, the die is cast, so to speak. That's your counter, and away you go. But here, I can go in and get a little bit more manipulation as needed. So, don't fear it. Sometimes it can be a little bit easier. It's certainly going to be easier when you're looping through kind of an unknown number of times. Don't be afraid of the while loop.
Yeah, there is a time and place to use a while loop. So
Exactly.
yes, you can accidentally end up with an endless loop or execute one too many times, one too few. That's why we test.
Yep.
That's why we have the stop debugging button or Shift F5 if you're a keyboard person.
That's it.
So, I mean, you can get out of it. We'll all make mistakes in our code, but there is a time and a place to use a while loop. And in the end, when it comes to picking loops, a lot of times you can use one or the other.
Yep.
One of these you looked at and said, I get that one. Well, use that one whenever you can. It's simple.
That really is it. I'm sorry, I'm off screen drinking coffee. All right, so your challenge, should you choose to accept it, is create some form of an Etch-a-Sketch program.
I think this one should be fun.
Yeah, absolutely. Ask the user for a pen color, ask the user for a line length, ask them for an angle, and then away you go from there. So use that turtle to go ahead and draw the line based on those specifications. Now, a couple of things that are worth highlighting is the fact that, remember, when you're doing the input, it's going to be coming as a string. Also remember that you may need to go in and do the math on that, so that 360 divided by whatever number it is.
Yeah, well, in this case, we're actually letting the user specify the angle.
You're doing it line by line.
This is they get the user picks the angle when they're doing it.
Yeah. Sorry about that. But again, you still have to make sure that you convert that to a number. Congratulations.
Yeah.
How to manage loops. And that is a big thing. That's going to be one of the more common things that you're going to be doing inside of your applications, because you're going to have a set of items that, a lot of people have asked kind of what can you do with Python? And the answer is whatever it is that you want. So if you want to create web apps, if you want to create things for automation, etc., you can do that with Python. So, one of the target audiences is IT pros. Well, if I'm trying to update X number of servers,
or all the users in a particular group and things like that.
Exactly. Yeah, that's exactly where something like this is going to come into play, and it's exactly where you're going to have a while loop. So I have my list of servers, and I kind of run through and say, update or reboot or whatever it is that you're going to be doing. Awesome.
I'm just going to mention one little thing because it came up in the chat window. There was a question, are we going to cover for else loops and while else loops? We're not going to bother doing demos of syntax. That's a more unusual situation, but just to state fairly simply that it is possible, just like when we saw there was an if statement, you could say if this condition is true, do the following, else do something else. You can do that with loops as well. You can say while this is true, else go do this. So it would basically be on exiting the loop, or when the condition for the loop doesn't occur, it would go to the else statement.
Yeah.
That's a fairly unusual syntax. It's something fairly unique to Python, actually. I haven't seen that in a lot of other programming languages. If you are interested, go hit bang, type in for else Python, while else Python, you'll find lots of great example stuff out there. One of the things about coding, we can't show you every single variation of every single command. We want to show you enough that you understand the concepts and you can start solving problems through the code. But you're going to end up discovering little extra options you can do here and there, different features that we haven't shown you just because we can't show it all.
Exactly.
So just to answer that question, we're not going to cover it explicitly. Go explore. So we'll add that to the challenge.
Yeah, exactly. All right, well, with that, what do you say we take a little bit of a break?
Sure.
And we'll come back and we'll answer a big question that a couple of people had earlier, is what about looping through a collection of items? What about a list?
Yes, lists are very powerful. So yes, we're going to get into lists, and we're going to actually start storing values in lists and then mixing that up with our loop capabilities, and then we can make some real magic.
Oh yeah, then we can have some fun.
Yeah,
so we'll
just gets more fun the further we get into it.
See? Yeah, this is the fun stuff. All right, we'll see you guys back here in 10. All right, well, welcome back. This is still Introduction to Programming Using Python. Susan Ibach, Christopher Harrison, and we left off doing loops. And when we were doing our loops, based on numbers, which is a great way to learn loops. And you will certainly be doing it based on X numbers. You will absolutely be dealing with numbers. But I would argue more commonly, you're going to have a collection of items that you need to do something to each item. So wouldn't it be nice if maybe I could, create some form of a container that would allow me to have multiple items and say, a list?
don't stop still. You keep trying to jump ahead on my slides here. Let me go.
All right.
All right.
Susan, go.
Awesome. Yeah, so yeah, we have been talking about loops, and loops are great for going through doing things multiple times, but they also could be great for looking at multiple values. And so we want to talk a little bit about the idea of lists, because there are times when we talk about our problem solving again, where one of the problems we have to solve is to remember a list of values. And this happens in the real world, day to day. You want to maybe remember the names of everybody who's coming to a party. Because you have to print out their name cards later, or you have to make sure you remember if anybody's a vegetarian or needs kosher food. You need to make sure you have enough glasses and plates for everyone. So a lot of times you need that sort of remember everybody who's coming. You might need to remember all the scores you got in the different courses that you're taking, because you need to calculate your GPA. Maybe you need to remember the directions to get somewhere. You want to, so many of these tools now, there's all these map applications that'll tell you turn-by-turn directions, but I need to remember, go down this street, turn right, then turn left, or go north on this street for 1 kilometer. I am a Canadian, I did go with kilometers. Then turn right, and so on. So there's a lot of situations where we're given what effectively works out to be a list of different values. So it's important when we start problem solving with code that we have an ability to work with those lists and to remember those different lists. So a list is the object in programming that allows you to store multiple values. The directions, the names of your guests, what you need to buy at the grocery store, whatever it is. So to declare a list, the syntax is fairly straightforward.
I love the sample names.
Yeah, you like the names? I'm planning for, this is my guest list for the party.
No.
So Christopher, good news, you're invited.
Thank you.
Yeah, you're invited to the party, and I'm hopefully invited to my own party. And I've decided that Bill and Satya can join us as well.
Okay, well,
I thought
that's awful nice of you.
I thought that would round out the group of 4. Maybe this is our little golfing foursome.
There we go.
It'll be you, me, Bill, and Satya going out for a little round of golf. And by the way, I'm a terrible golfer, so my sympathy.
That's okay. My handicap is my swing.
Okay. So I can create a list, and this is literally going to store all those different names inside the variable guess. So the syntax is a little bit different when we declare a list. If you take a look at the code, you can see we have square brackets indicating the start and end of a list, and we have commas separating the different list values. So that's just the syntax you have to use, and you're welcome to store different data types in a list. You can store numbers, or you can store strings, or you can store dates. It's really up to you. Python will allow you to put different data types in a single list, so you could store a name, a number, and a data type, and a date all in one list, but I don't recommend that because it's very hard later when you're trying to go through the values in the list to go, wait, is the first value a date and the next one's a string and the next one's a number? If you're storing, for example, the names of all your guests and the ages of all your guests, right, I would actually recommend you have 2 lists, one with the names, one with the ages. That's going to be a lot easier for you to work with than having a list of name, age, name, age, name, age, name, age.
Yeah, you don't want to have to remember where you are in each one of those.
And even if it's, so anything where you want to store different values, you're probably better off having lists for each value than mixing it. Even if it's name and the city where they live. They're all strings. I could theoretically store that all in one big long list. You know, Susan, Ottawa, Christopher, Seattle, Bill, Seattle, Satya, Seattle. Apparently everybody's in Seattle.
Move to Seattle.
Yeah. No, thank you. But it would be better to have a name of guests list and a home of guest list. And I know that the first value in the names goes with the first value in the list of cities. And the second value in names goes with the second value in cities. And I know the third value in names goes with the third value in cities. So that's just, in generally speaking, when we're working with lists and code, we generally store one piece of information.
Yeah.
Yeah. We store all names in one list, all cities in one list, all favorite sports in another list.
Sure. And again, you know, there's always multiple ways to solve that. So you can, you know, kind of get a bit more complex and maybe creating more complex data types and things like that. So there's a lot of ways that you can handle that. But keeping things simple, especially for where we are, you know, try to keep one data type inside of a list.
And just said, not even one data type, one piece of information.
Yeah.
You have multiple names, but they're all names of the people coming.
Yeah.
Said, if you're storing storing their cities, you're going to make a separate list for that. So that's just a tip that'll make your life easier when you start working more with lists. So if we go back to the slides for a second here. In terms of syntax, sometimes we were talking last chapter about one of the things we often do with loops is things like reading from files or reading from databases. So what we might do is initially we create an empty list, and then we end up with a loop that goes and reads values from a file, which, hey, guess what modules we're doing this afternoon? We're going to be reading from a file. So you're actually going to start putting everything together here, and you'll be able to write loops that read from files, put the values in a list. We're going to get to that by the end of the day. So to create an empty list, the syntax is simply give your list a name, and then you just specify the square brackets with nothing in them, and that literally is an empty list. Once you have created a list and you've given it values, it's important to know how do I ask for a specific value, because having a list of values is great, but if my program is going to print out a guest list for me, then I'm probably going to need a loop that says go get the first value, print it, go get the second value, print it, or take the first value, write it to a file, take the second value, write it to a file so I can send it to someone else. So the way we do that is we have to specify where in the list of values located. And remember, how do we count in programming?
Counting starts with 0.
Counting starts with 0. That's right. So, Christopher, you're guest 0.
I'm 0.
You are 0.
Okay, wow.
Hey, guess what? I'm number 1.
Okay.
Bill's number 2, and Satcha's number 3. So
this doesn't resemble the org chart in any way, shape, or form, by the way.
Not at all. Absolutely not. But in terms of their positions, if you look at the slide, you can see it said the reference, if I reference the value in index position 0 or in position 0, that's going to be Christopher. If I specified guest 1, that would be Susan. Guest 2 would be Bill. Guest 3 would be Satcha. So you can, at any time you need to, it's possible to say, give me that specific value. In this case, if I say, give me score 3, that's going to return what value, Christopher?
0, 1, 2.
Yeah, 0, 1, 2.
62.
3. So therefore.
49.
Yes.
Okay.
It will return
Sorry.
49.
Yep,
Yeah.
you're right.
I was waiting for you to catch up there.
0.
Okay. We'll practice counting later.
I need to take off my shoes.
We didn't get past 5, but. So anyway, so because it's score number 3, because we start counting from 0, 0, 1, 2, 3, the value in the list that's in position 3 is in fact the number 49, even though that's the 4th value in the list. Remember, counting from 0. One of those little things we have to keep remembering. So sure enough, yes, this would print out Christopher and 49 on the screen. We call the position in terms of, in geek speak, when we talk about a position of an item in a list, we refer to that as the index. So you'll hear us say, what's the index of that item? What's the position index? So that's just a term we use when we're referring to a location of an item inside a list, or sometimes called an array. One of the neat things I like about Python is it actually allows you to count backwards. This is kind of neat. So if you want the last value in the list, that's position -1. The second to last value in the list is -2. Third to last is -3. And in this case, because there's 4 entries, Christopher would be -4.
I just seem to be the smallest number.
Don't take it personally. So you can literally say, print the value in the list that's in position -1. And that is actually something where there are times where you might want the last value.
Yep.
So it's nice to just be able to say, hey, get me the value in position -1. Rather than, there are other ways to do this. You can ask for what's the size of the array and then say, get me the one that's at the highest row. But it's just really nice not to have to do that. Just say, just give me the last value.
Yep.
The one in position -1.
Yeah.
I can't honestly think of a scenario, a business situation, where I would find myself asking for the third from the last. It's a little weird.
No, but it is quite frequent. You know, I just need that last item. Sometimes the second to last, but the biggest one is that last item. So having that kind of neat little shortcut of just -1 works really well. And actually, a couple of people asked that in the chat window. So that was like perfect timing. Like, just saw the question, and then sure enough, Susan's doing her demos.
There we go. Awesome. You know you've put the right information on the slides when someone asks the question. And it also tells me that you guys are already getting it and already thinking about, wait, I want to do this. How do I do that? So that also tells me you're already thinking about real world problems you want to solve.
Yep.
So yeah, it's really nice to have that ability to count backwards.
Yeah, and somebody actually asked, so counting backwards, there's no 0. No,
Yes.
0 is the starting point for going forwards. -1 is the starting point for going backwards.
Yeah. So a little inconsistent maybe, but the thing is, if you specified
-0.
how do you say -0 exactly? If you specified -0, well, that would still be 0, and then that would be the first value, not the last value.
Yeah.
So it kind of makes sense if you think about it.
Square root of -1.
Yeah. So let's go into some code and let's actually create a little list. So I'm going to go here and I'm going to create my guest list. And just to make you feel better, Christopher, look, I'll list myself first. I can be in position 1 or 0, and you can be number 1.
I liked, however, though, that you still said, I like 2 things that you did there. I like the fact that you still said 1 for yourself, and I also like the RE on Christopher, very Canadian again.
Yeah. Isn't that how you spell your name? Or you would think it was Christophe. Would you like me to turn you to Christophe?
Yes, there we go.
That's changes your name completely.
Yes.
No, your name is Christopher. I will enter it as Christopher.
Thank you.
And now I have that list. Obviously, I can print a value. Now, when you're specifying a position, one of the things you want to do is you will specify, you use the square brackets. So if I say guess 0, that will be the first value in the list.
Yep.
And if I want the second value in the list,
don't forget your parentheses on print.
1. Yes. Oh, yes, I do need, that's right. I need by parentheses around the print statement as well. Hey, as I promised, we would make a few mistakes in our code along the way.
And then go ahead and maximize your Visual Studio there. Make it
yes, absolutely. Dun, dun, dun. Thank you.
You're welcome.
All right. And now when I run, you can see that we get back Susan and Christopher back from the list because position 0 was Susan, position 1 was Christopher, so they both come back.
Perfect.
So fairly straightforward, nice and easy to create it and go through and create that list.
I like it.
All right, now once you have a list, one of the other things you're going to do is maybe you're getting a list of values from a file or a database, and then you have to update that list and send it back. Maybe that's what your program is there to do. Maybe you're getting a list of guests, and then your program is going to vet them and decide, do I really want this person at my party?
I'm hosed, aren't I?
So, but in all seriousness, there are definitely situations where you'll get a list of values, and the purpose of your program is to work through that list of values. I'll give you an example. I used to do a lot of programs which worked with addresses. So I might get a list, and I don't know if you know this, but the big companies get a discount on mailing things out if they specify the address in a very specific format. And so maybe my program is one that's written for a big bank or something that's mails out bank statements to everybody, all of their customers, and they want to make sure they get the discounted rate from the post office because that's going to save them a lot of money. But to do that, they have to always display the addresses in a very precise format. So maybe your program is taking the address the way the user entered it and standardizing it. So it's making sure that the state or the province name is using the appropriate abbreviation. It's saying, if you enter WA dot, we're going to remove the period off the end. We don't put that in a standardized address. So maybe that's what your program does.
And there's also going to be a lot of times when maybe you're actually starting with nothing, and that what you're going to be doing again is kind of reading in from a file, reading in from a database, reading user input. So I have nothing to start. I need to go read the data in, and again, I don't know what's going to be, how many items are going to be there, what's going to be there, but I just know I need to go collect my data, and then let's go back and start processing it. So that ability to manipulate and manage that list is going to be imperative. I've got to have it.
I have to be able to add new values when I need to. I need to be able to update the values that are already in there, and there's other business situations where I do want to actually remove people from the list. It said, I'm sorry, Christopher.
I know.
I'm not sure you're getting to come to the party.
I'm hosed.
So to update a value in a list, it's actually pretty straightforward. How do you update a variable? Well, you would just say variable name equals a new value. Well, if you take a look at the code here on the slide, if I want to change the value of inside a list, you specify the list name, but you have to specify the index position. Which value in the list do you want to change? So I'm changing, and I'm sorry, Christopher, I apologize. What I'm doing now is I'm saying Steve is invited, and so basically what's going to happen is the value in position 0 is now going to be, and I'm just going to chase slightly better pen here. There we go. I'm sorry, it's now apparently Steve who's coming to the party instead of Christopher.
I'm just going to sit over here and cry.
I promise you'll be invited to the next one.
All right.
So this basically updates that first value from Christopher to Steve. And you can see the way the output, when I print out the value of row 0 or position 0 in the list, it now shows Steve instead of Christopher. You can add values to a list as well, also very useful, using the append function. So if I use the append function, I'm going to go back to my highlighter. I do an append to so I specify my list name. I call the append function, and then I specify the value I want to add. New values will always be added to the end of the list. So if I have 4 values, this is going to become the 5th value. If I have 10 values, it'll become the 11th value. So you don't have to say, add if I have 10 rows in my array, put this in position 11. The nice thing is you just say, here's another value, put it on my list, and add it to the end. So if you look at the code, if I want to confirm that the value was added correctly, I can just use that little last value trick. Use that little -1 to say, hey, after I append it, let's look at the last value that I just appended. And sure enough, that's going to return Steve because that is now the last value in my list.
So it's dynamic. It automatically stays up to date.
Yes.
Okay.
Absolutely. I don't have to
I
worry
like that
about
you're
it.
just explicitly removing me.
Yes, in this next example, I'm sorry, it's just plain.
Wow.
So in this case, you can also remove a value
Not
from a
even
list.
being subtle about it. Just boom, you're gone.
So I can remove a value from a list as well. There's actually 2 different ways to remove a value from a list. If we take a look at the code on the slide, one option is to use the remove function. With the remove function, you specify the value contained in the list that you want to remove. So I'm not specifying the index position this time. This time I'm actually saying, I'm explicit, as you said, my apologies, Christopher, this time. I know you were double booked this evening and you won't be able to make it, so I'm removing Christopher from the guest list. So now if we do this, if we then say, well, what's the first value in the list now? What value is going to be in position 0? It's going to be Susan because Christopher is removed. It doesn't leave an empty list item. It actually removes that entry from the list. So now the first item in the list will be Susan. So it's not leaving a blank behind. It's actually removing that value from the list completely.
Okay.
The other way of doing it is the delete command, because sometimes you're going to want to say, I want to remove Christopher, I want to remove Bill, I want to remove Susan. Other times you're going to want to say remove row or value, the first value, remove the 8th value, remove the first value. So the delete command, now it's a little weird because this one is, the syntax is different. It's not guest.delete. It's actually a delete command, so a little confusing. You know what, you'll probably forget which it is and have to go look it up because you won't remember. But the nice thing about the delete command is it allows you to specify the index position of the value you want to remove from the list.
Okay.
So you can do it either way. If you know the list position, specify that. If you know the name or the value you want to remove, you can specify that with the .remove. So your choice. But both of them do the same thing. They both remove a value completely from the list. They don't leave a blank or a placeholder in there. So if you had 4 values in the list, after you remove a value, you only have 3 values left in that list. So let's actually play around with that. Let's go over to Visual Studio, and we've got our list here. So let's go ahead and let's add, who should we invite to our party? Christopher, got any suggestions?
Colin.
Let's invite Colin. All right, we're going to invite Colin to our...
Parentheses.
Oh, oh, yes. Add, yes.
Yeah.
Let's add. I'm going to add the value Colin.
That is one of the things that's probably the
drive you nuts.
trickiest to get used to is when to use parentheses, square brackets, and so forth. And one thing that I always recommend to people that are getting into development is, be particular about your vocabulary, about how you call things. That you'll notice that I never interchange things like parentheses, so that's your parentheses, your square brackets, so square brackets, and then your curly braces. I always call them those exact same things because regardless of the language that you're talking about, they always mean very different things. And so if you're using the same terms over and over and over again, so if I'm just calling everything parentheses, all that you're going to wind up doing is confusing other people and probably also confusing yourself as well. So kind of keep an eye on that as you're getting into development.
Yes, yeah, because there are some situations where you use curly braces, some situations where you use square brackets, like in lists. When I specify an index position or the values for a list, I use square brackets. When I'm calling functions and methods, I put the parameters I'm passing to those functions and methods inside parentheses.
Yep.
Or braces, some people just call them. Or, there's so many different names for it all.
Yep, absolutely.
All right, so if we go back to Visual Studio, you can see what I've done. I've invited Sonal to the party as well because he's helping us out with the Q&A today.
Hey, Sonal.
And he actually created a couple of the slide decks for this course, so definitely deserves to get invited. This will be our post-MVA celebration. And now when I go off and I run this code, you can see I've used the add method to add the values. And if I ask for the last value, oh, was it not add? It was append. Oh. See, I already messed up.
And actually, while you're fixing that, I would mention real quick, because I'm looking at it, I didn't catch it either. That's in .NET, when you're working with a list, it's add.
I know, yeah. It's just, one language. The more coding you do, the more confused you get between languages. Okay, so let's go back to the code and see if it works now. I've changed the .add to a .append. And now we go off, and sure enough, we can see that the last value in the list is now Sonal. So it must have successfully added our values to the list. Now, what would be really nice would be to have maybe a loop that showed everyone in the list. We'll get there.
Yep.
We will get there.
By the way, a couple of people have, actually several people have asked, do this real quick for me.
Sure.
And because the best way to do it is, you know what, let's do it this way.
What's the question, Christopher?
The question is, if I say remove and there was multiple items in there with the same name,
oh, sure.
What would it do?
Well, then I'm at append. The next one I do is an update. Then we'll do remove, and we'll get right into that.
Okay, perfect.
So let's try, let's do a guest dot, let's change a value. If we want to change a value, and we decide that that Bill isn't going to be invited anymore. We're going to now change that. Actually, what I've decided is Sonal is now going to be our third guest. And so we're adding Colin to our guest list.
Okay.
And we've decided that, I'm sorry, Bill, Sonal's coming instead of you.
Wow, that's...
Yeah. He's a busy guy. It's hard to get him. And he's often not available. So this is a way of updating. So this is update a value. And this append method is used to add a value. So we'll try that out. And sure enough, obviously the last guest is now Colin because he was added to the end of a list. Let me just print out the value of guest number 3 to prove that that is now, in fact, Sonal.
And while you're doing that, it's also worth highlighting real quickly that while you were doing this, you could have just as easily have used input rather than just hard coding it in.
Sure.
It's one of those things when you're doing a simple demo like this, that if you throw in that input, that's now just another step to go in and do the demos,
Yeah.
and that's why we're just hard coding it in. But could you use input or anywhere else that you could be reading a string from? Absolutely 100%. Yeah, so it doesn't have to be hard coded. It's just easier to demo.
Absolutely.
Yeah.
No, we're just trying to keep the code as easy to read as possible.
Yep.
So if we look at the code now, you can see we've appended the value, and then I'm just printing the new value, and then updating a value and printing it. So you can see that the updates happen in the code. So you can see the new values that have been updated in the list. And that takes us to delete, or the remove. So if I was to remove someone, so let's have, we're going to invite Bill twice. So we actually have the same value in there twice. And actually, I don't know what's going to happen. I'm curious. Let's find out. Was it .remove? Yes. Oh, thank you, IntelliSense.
Yeah.
There we go, helping me remember that it is remove. And let's going to remove Bill from the list. And then I'm just going to comment out these 2 lines, because then I'm going to ask for the last value.
Okay.
Because if I ask for the last value, if it removed both the Bills, then the last value should be Christopher.
Yep.
If, however, it removed only one Bill, then the last value will still be Bill. So that's going to be my little, I'm just going to comment out this code, and then we'll see what is the last value in the list. Keep forgetting no dope. Yes, I know. I keep forgetting that. Last value.
And again, while you're typing this out, if you're ever curious about, what's going to happen, the easiest way to figure it out is just write a little bit of code and just test it real quick.
Try it.
Yeah,
Yeah.
absolutely. So I mean, I remember, and I know you've done this as well. When you're in the classroom, somebody asks something that you don't know, because we don't know everything. We'll openly admit that. Somebody asks a question. Hey, let's go in and try it. Give it a shot. So go ahead.
In fact, there's been a couple of questions in the Q&A where I said, I don't know what would happen. Try it. I've actually answered that in the Q&A.
Yep.
So let's find out if we specify a value that exists multiple times. It only removes the first one it finds. So if you search for a value, if there's multiple occurrences of that value in the list, it will only remove the first one.
Correct.
So now we know what happens. Of course, if you specify a name that only appears once, then, I can't really prove that by printing the last value. It will only remove that specific value. And we can also use delete to remove a specific one. And we can say delete a particular entry from the list. So I could remove my name from the list. And then if I print the first value in the list, it should now be, don't
forget your parentheses.
Yeah, I'll get there. And that would be, let's say, print who is guest 0. So let's try, this was one option. Actually, let's not remove that. Let's remove.
Yeah, leave me.
I'm going to take off Satya off the end there. Satya. All right, so we remove Satcha and we delete the first row. So now the first row should be Susan and the last row should be Bill.
Close paren.
Okay, close parentheses. Thank you. All right, so I'm just going to move this code up a bit so it's a little easier. By the way, this is one of my favorite little keyboard shortcuts. If you highlight some code inside Visual Studio and you hold down the Alt key and the up-down arrow, it just moves the code up and down. So instead of always going copy, paste, copy, paste, copy, paste, sometimes if you're just moving code, it's a handy little trick. Alt up arrow, Alt down arrow. So now I run, and because I removed Satcha from the end of a list, that means the last value in the list is now Bill. And because I said delete the guest in position 0, that's Susan, the first guest in the list is now Christopher.
There you have it.
Okay, so I can now update a value in a list. I can now remove a value from the list, and I can now add a value from the list. The next thing really is the ability to start moving around through the list. It'd be nice to see how do I go through all those values? How do we combine what we learned about loops with these lists? So I can say, well, just show me everyone in the list, because that comes up quite frequently. Oh, and actually, I forgot one last thing I want to show you, which is also how to search a list, which can be useful as well. So if you take a look at the slide here, there is also an index function you can use. And if you call the index function, what it will do is it is actually a function of your list. You pass it the value you want to search for, and it will return you the first one it locates. So if you had 2 Bills in this case, it would tell you the location of the first one it locates. And it'll return the index. So in this case, if I ran this code, Christopher's in position 0, Susan's in position 1, Bill in position 2, Satcha in position 3. So when I say go find Bill, it's going to come back and it's going to return a 2.
Yep.
Because that's the index position of Bill's entry in the list.
So a couple of real quick things that I want to highlight just from the chat window that's been coming up. People are really into the remove. And so one of the questions was which item is removed if there's multiple. So if there's 2 Bills in there and I say
the first one
Bill,
would be removed.
Exactly, yeah. It's going to be the first one. Yep. And then the second thing that a lot of people have been asking is, how about a wildcard remove? So could I just simply say Bill or B asterisk and have it remove everybody? And the short answer to that question is no, that there's no like wildcard or anything like that. However, one of the things that you could do is kind of combine different things that we've already done.
You can get creative.
You could have done that with a loop. So you could just simply say, go in, find all the Bills or find all the Susans. See, I'm going to remove you from the party this time. Go in and find all the ones that you want and remove them one at a time. So you could loop through it if you wanted to get rid of everybody, but at least out of the box there isn't anything. But that's one of those that you can easily do. It's not that challenging.
You know what? There's a problem for you.
There you go.
So now you get to ask yourself, okay, if that function won't do it, how could you, once we've learned how to do loops, ask yourself, how could I write a loop that remove everybody that had that name from a list? So there's an extra challenge for you to try at the end of the module, because I'm sure by the time we're in this chapter, you guys are capable of solving that by writing a loop that goes through everything and says, everybody named Bill, remove them. You could do it. And for the wildcard, you could use some of those string functions we learned. Their string functions allow you to say, take only the first character. So you could use a string function that says, take only the first character of a name. And if the first character of a name starts with a B, remove them from the list. So you could use string functions in a for loop to get your wildcard functionality. Does this feature do it? No. .index doesn't do it. .remove doesn't do it. But you could write your own logic to solve those types of problems.
Exactly. Yep.
Awesome. So we can also search a list. I'll do that in a second when we're playing around. I do want to point out, though, if you do a search for a value that doesn't exist in the list, you will, in fact, it can't really return, a lot of programs would return a 0 or a -1 if it didn't find a value in the list. That's sort of a convention used in a lot of other programming languages. But we have a little problem here. Because if I tell you that I couldn't find it and I say it's in position 0, well, hang on. Position 0 is Christopher. And if I returned a -1 as a way of trying to say, oh, it's not in the list, so I'll return -1. Well, if I say, get me the value in position -1, well, that's the last value of the list. That's Satcha. So in Python, unlike a lot of other programming languages, which would return a 0 or a -1 or something if it couldn't find a value in a list, you actually get an error. And your code's going to go spewing and spitting nasty messages all over the screen if you search for a value that it can't find on the list, which is why the error handling chapter we're going to cover later today is really important. Okay, back to the slides. The last thing I want to do is I want to talk about how we go through that loop. How do we use a loop to process all the values in the list? So now we're taking what we learned before and applying it to our lists. The easiest way, let's start with a for loop, because we're comfortable with the basic for loop. You know how to declare a for loop. You say for, we create a variable. I'm calling it steps. You know that's my favorite name for that variable. And this loop is going to execute 4 times, because I happen to know, right now, I know there's exactly 4 values in the list. So then, as I go through the loop, I can say print out from the guest list the one in index position of steps, because the first time through the loop, that's going to be 0. So it'll print out Christopher. Second time through the loop, it'll be 1. That'll print out Susan. Third time through the loop, it'll be 2. It'll print Bill. Third time through the loop, it'll be value 3. That'll print out Satcha. And remember, in for loops, it never actually reaches that higher number. It executes 4 times, but it counts 0, 1, 2, 3.
Right.
So that will print out each of the values. So let's just go see that in action. And I'm just going to do a little Control-KC, comment that out. Remove a value from the list, just so I can remember what all that code was when later on, if you're looking at it, you'll remember what it all was. So what I'm going to do is I'm going to write a loop that says for steps in a range of 4. So go through 4 values, and each time you go through the loop, I would like to print out from my list of guests the value in index position steps. Now, I'm going to try and put a breakpoint on here so we can sort of step through it. You can see how it works. So when I execute, the first time I run in, I'm right here, and it's executing my code. So it's just entered my for loop. You can tell by the little yellow arrow there. You can tell, oh, I haven't run Zoom it yet. My apologies. Let's do this then. So by the yellow arrow is indicating the next line of code is going to execute. So right now, if I hover over the variable steps, really neat feature in Visual Studio when you're running the debugger, because I put a breakpoint here, it stopped when it got to this line of code. And if I hover over the variable steps, it tells me the current value of steps is 0. And if you want to get really fancy, I can actually pin that so that little window stays over there so I can see the value of steps as we're chugging along. And
Visual Studio is so cool.
If I hover over the variable guests, I can see that the current value of the list guests is Susan, Christopher, Bill, and Satcha. Let me pin that over there as well, so we can kind of keep track of that as we're chugging along.
Nice.
Now I'm going to step through my code. There's a little step into F11 or the step into button in the toolbar. And now it prints the first value and says, okay, let's go to the next value. So now you can see it sets steps to 1. And then prints that value and then steps to 2. And then you can see the value of steps going through and the output appearing on the screen. But you can actually see it as it's going inside the debugger and the output appearing.
I like it. Okay.
All right. So we've got the ability to loop through all the values in our list. If I take out the breakpoint just to have you see it running more quickly, no, take off the breakpoints, thank you. And I just run that, you'll just see, boom, there's my 4 values printed from the list.
Yep. Awesome.
But I don't know about you, Christopher, but I do see one little problem in that code. I'm saying execute the loop 4 times.
And actually, somebody called that out in the chat window, like, wouldn't it be better to? And they threw out one possible. And
what did they? I want to know. What did they suggest?
They called out pulling up the length of the array.
I love it, and that is exactly what I would like to do. Is I don't know how many values are typically going to be in an array, or in a list. So one of the things I can do is there's a function that allows me to find out how many values are in the list, and then I can say execute the loop as many times as there are values in the list, and that's done using the length function. So fantastic job by someone in the chat window there, because guess what? If you don't know how many values are in the list, if you take a look at the screen here, there is a function we can use called len, which is short for length. And when you pass it a list name, it tells you how many rows are in that list. So let's make our code a little more robust.
Yes.
So it can handle lists of any size.
Yep.
And it'll still work. So I'm going to go back to Visual Studio now, and I'm going to say number of values in my list equals whatever values returned by length guests. Because the length function will tell me how many values are in that list. And then in my for loop, instead of saying execute it 4 times, I say execute it however many values in list. And watch my casing there, make sure I got my uppercase all matching. And now, if I have 4 values, we're good. But if I go in and I add Sonal to the list, my code will still work. And that's making my code more robust so it can handle more situations, different sizes of lists. And really, it's also allowing me to be a lazy coder because I don't have to change it if somebody gives me a different list value back.
Yay, being a lazy coder.
Yes. All right, so we have now that ability to loop through all the values in a list. Now, if we go back to the slides, though, don't tell anyone, but there's actually a really, really easy way to go through all the items in a list. It's such a common thing we have to do in code. I mean, really, if you're working with lists, I can almost guarantee in your code, you're going to end up having code that says, now, for every value in the list, do this. It happens all the time. So they have a special loop, which is for every value in the list, do this. It's a for loop. Do you remember when in the for loops chapter, we're going to give you a flashback, we actually said for color in red, blue, black, green, and it was a special syntax where we could specify the exact values to use when we entered the list? And when we specified red, blue, black, green, we put them in square brackets with commas separating the values, which is exactly the same syntax we use to declare a list. That's not a coincidence. That is actually quite deliberate. So if we take a look at the slide, you can see when we declare a list of values, you can just say for, and guessed you can call, this is just like steps, color, or whatever you want to call it, right? Some variable name in this list. You could actually put for guest in open square bracket Christopher, Susan, Bill, Satya. Or if you've got that set of values stored in a list, you can just say for guest in guests.
And what's actually been kind of cool is, again, watching the Q&A window, a lot of people were calling exactly that out. And one thing I would like to answer while we're here is that if you do this, so for guest, if we throw the code back up, if you say for guest in guests, and let's say as part of that loop, we added a brand new guest, and back to the end, it will actually pick that up as well. So if somewhere in there I said guest.add Sonal, and we're kind of doing that loop, Sonal would be picked up by that for loop, which is really neat. So if it is dynamic, if it is something where you're going to append on to the end, that for loop will pick that up.
So if you have logic where as you're going through the guest list, you're saying, oh, if this person, look them up here and see if they said they're bringing a friend. And if they said they're bringing a friend, add the friend to the guest list. And then, so within your loop, you're actually adding new guests, which are the friends of your original invitees. Then it'll actually look for friends of the friends.
Exactly.
Which is kind of freaky when you think about it. So let's look at that in the code and sort of see how that would work. So option 1 for looping through a list, that's what we were just looking at. So now I'm going to show you a second option for looping through a list using my Control-KC to comment out my code again. Option 2 for looping through a list. And in this case, all I have to say is I like to sometimes do it this way. I sometimes call it current guest.
I do quite frequently because, again, it's one of those little things that just makes the code more readable. It's the current guest.
And then I just say print current guest. And that in my brain helps me remember, so as it's going through the loop, the current guest is the one that's being looked at by the loop right now. So I just like that word current guest when I'm going through loops as a way of going through lists, So when I'm going through a list in a loop, I like using the phrase current guest or current color because mentally when I'm reading my code, I say, well, print the current guest as I'm working my way through my list. All right, so we've got the code here. So let's try executing that and see what happens. Sure enough, still gives me back every single person in the list, no matter how many different values. But it's a very clean, very easy syntax. Like I said, you could specify the actual list value here. That's actually what we did a couple of chapters back. But you could just specify a list that contains the values as well. All right.
And again, it's worth sort of mentioning here that you could absolutely have pulled that in dynamically. So again, if you had read that in from a file, from a database, from input, that how the list is generated is sort of irrelevant. The fact that you have the list is the important part. So you could do the for on that.
That's right. And when we get into files and we start reading from files, we're going to read values from files. We might just end up putting them in a list and doing something just like that. So you can see again how it all starts to fit together.
like we planned it that way.
Yeah. Another thing that's very useful, you know, it's funny, when I first took my first programming courses, one of the #1 assignments they gave you on programming courses was, here's a list, sort the values alphabetically. And then there were like 6 different ways to sort it. You could use a bubble sort, or you could use a something sort, and all of these different things. And
if you had 11:28 Pacific time for the first reference to bubble sort,
yes,
please come forward and collect your prize.
Standard programming assignments, exactly. You were always told to sort a list. Well, guess what? If you're a professor, you're ever taking a course, and they give you a list in Python, and they ask you to sort the list, 1 line. Thank you. All you do is call the sort method.
Woohoo!
And it will sort the names in alphabetical order.
And actually,
sort the values in alphabetical order.
There again in the Q&A. Can you sort?
Yes, there you go. So yes, you guys are thinking of exactly the right kind of problems. There is a sort method you can call. So you do not have to learn how to write bubble sorts. You can just call the sort method, and it will sort your records. Mm-hmm. So I'm not going to bother demoing that just because we're running a little bit long. But your challenge, should you choose to accept it, would be to try this out yourself, because you're going to get to try doing the sort in the challenge. Mm-hmm. You're going to ask a user to enter the names of everyone attending a party. So I'm going to have to use the input function.
Yep.
Then I have to return a list of the party guests in alphabetical order.
Yep.
This is actually going to require pulling together a little bit of everything we've seen. So if we take a look at the slides, when you get more complex problems, what I recommend is break it into steps. Mm-hmm. So what do we actually have to do? 1, we're going to have to ask the users to enter the names. 2,
Yep.
we're going to have to put those values in a list. 3, we're going to have to sort the list. And then 4, we're going to have to print out the list after it's sorted. And then you can think, well, I know you guys out there already know how to ask a user to enter values. That's going to be the input function. And what type of variable we need to store the variable? Because we have multiple names to store, we're going to need to create a list to hold the values.
Yep.
How do you ask a user for more than one name? Because I'm going to keep asking them for one name, after another name, after another name. Mm-hmm. So I'm going to need a loop. Should it be a for loop or a while loop? Well, do you know how many names are going to be entered? Mm-hmm. I don't know. So therefore, I can't go with a for loop. Yep. So I'm going to have to go with a while loop. How will the loop know when to stop executing? You're going to have to figure that out. Maybe the user enter a special keyword when they're done or something like that. But if the user has to enter a special keyword, you better tell them. That would be a good idea. Then the second thing you'll have to do in terms of steps is you'll have to take the values that are entered by the user, and you're going to have to store them in a list. So every time someone enters a new name, add it to your list. Then sort your list. We already saw we have a sort method to do that. And finally, you're going to need a loop that goes through the values in the list and prints out the values. So this one's going to be a little more complex. We're starting to pull together a lot of different things we've seen.
Yep.
We're also solving more complex problems. So it's going to be something along these lines. I am going to throw out a little problem for you that you're going to run into. If you write code like this, and I say, hey, guest, when you enter a name word done, I'll assume you've entered all your names. And in my code, they enter a value, and then I add it to the list. But I want to point out a little problem. When I print out the list of names invited to the party, I end up inviting Dunn.
And Dunn, you know, just whenever he shows up, he just makes a mess of the place. You know, we never want Dunn at the party.
Yeah.
You know?
So this is the kind of little things you run into when you start solving problems. So if we go back to the slide, I'll give you a little hint. You might want an if statement as well. So wow, if statements, loops, inputs, prints, lists, we're putting everything together. So you're going to have some fun with this challenge, but I also know you can do it. And I think that takes us to the end of another module.
Yeah, that actually does it. So, you know, lists are cool, but of course the problem with lists is that it's just in memory for right then. What happens if we close the program?
Yes. If I want to remember that list for later, I might just need to save that information in a file.
Ooh.
Coming soon.
We should talk about that. We'll see you in 10. We'll talk about that.
Bye.
All right. Well, welcome back. That was a fantastic little overview on lists that we saw. Just in case you're just joining us, this is Introduction to Programming using Python. That is Susan Ibach, DP out of Ottawa, Canada. I am Christopher Harrison, content developer, now out of Seattle, Washington.
That's right.
Which seems a little odd to say, but
and
in any event.
I was just looking at the Q&A, some of the questions we had coming out of that last module, and we were talking about how we can process and work with lists.
Yep.
And one of the questions that actually came out was, you know, gee, I literally had the question, how could I save that list to a file?
That's a great question, but you know what? Not going to answer it.
Okay.
Well, at least not yet.
Not until you get a couple more slides into the module. All right.
Well, the other thing I want to do before we get into that, because we will do it, is I do want to highlight GitHub real quick.
Oh, yeah. We've been getting a lot of questions
yeah.
about where do I go to we've got all the demos we're doing. We're saving them so you can access them. All the challenges we're giving you. The solutions to the challenges are all available for you to access at any time. Even just a quick list of all the challenges. If you want to go back to it later and you don't have to open every single slide deck, we have those in a nice little document for you.
Yep.
So, Christopher, yeah, if you could show everybody, again, where you access that and how you access those files, that'd be awesome.
Absolutely. So what you're going to notice here is I've got up here on Notepad, and Susan will put this into the Q&A
right now.
as well, is there's the link to our GitHub to download all the sample files that we've been playing around with and all of the different slides and so forth and so on, just as Susan mentioned. Now, one real quick thing that I do want to highlight is the reason that we chose GitHub to share all of this out is because Python has a fantastic open source community around it. And I would say, you know, the vast majority of the time, or at least quite often, vast majority might not be right, people use GitHub to take whatever it is they're building and share that out with people. So if you haven't already played around with GitHub, it's probably not something you're going to start doing today or tomorrow if you're brand new to coding, but it is certainly something that you're going to be coming across in the not too distant future. So we decided, well, let's kind of go with everybody else and let's go ahead and put this out onto GitHub. Now, there's a lot of tools that you can use with GitHub. Visual Studio will actually work with GitHub. I'd be remiss if I didn't mention the fact that we have an MVA on using Git with Visual Studio. The reason that I highlight using Git with Visual Studio is because that's actually the name. So
GitHub is the site, the hub for working with Git.
Exactly. There you have it. So there's a lot of tools you can use Visual Studio. The big thing that I want to highlight is if you don't want to monkey around with any of those different tools or anything like that, what you can do instead is down here at the very bottom, you're going to notice there's a link that says download zip, and if you just click on that, it will zip everything up, download it, and you can have it all in one shot. So easiest way to go in and do that is just to simply click on download zip file, and away you go from there.
Christopher just getting in trouble because you're not supposed to be in the studio with your phone turned on. So Christopher quietly going, I'm sorry, that was me. All right, moving on.
Christopher is now turning all sorts of shades of red. That's a pretty good shade of red there.
That is a pretty good shade of red. Why don't we go back to the slides, Christopher?
Yeah, let's do that. Subject change. Yeah, so slides. Okay, but in any event, yeah, you can go to GitHub and access everything that we've been working on. All right. So keeping with our real world analogy there, have you ever needed to jot something down and remember it later on? So, you know, things like list of ingredients to buy for a recipe, that guest list, although Susan's going to throw me right off of it, a phone number. You need to be able to jot things down. And just like you do in real life, that holds true in digital form as well, that we do need to be able to store files. So, you know, for example, if you were putting together an ebook reader, where's the user along that? If you are doing a game, you know, figuring out where you are inside of a game.
I hate games that don't remember my level, so I have to redo everything all over again after I get somewhere. It drives me nuts.
Exactly. The one in particular that I remember when I upgraded to the Lumion 920 at the time was I had gotten into a particular game that involves birds and things blowing up. What drove me crazy was that I had gotten pretty far into it, and then I upgraded to a brand new phone, and I had to start all over again. You know? So write those things out, and better yet, write it out to the cloud, but write those things out so that way when somebody opens up the application again, they can pick up where they left off, and they're going to be much happier with their experience. So let's then talk about how to work with and write files. Now, question is, how do we then go in and make some note and write that out to the file? I love that little picture you've got
well,
there.
that's what it is. It's, you know, that's how I think of files. It's writing it down so I can find it later.
Exactly. Exactly. So How do we write out to a file with code? Well, it's relatively straightforward, of course, once you know the syntax. That you'll notice that if I want to write out to a file, the first thing that I need to do is open that up. And in fact, let me kind of kick back to the slide, and I'm going to beat this analogy into the ground, is that look at this like a notebook. So the thing about a notebook is typically it's going to have some form of a cover on it. So if I want to write onto it, the first thing that I need to do is flip that cover back. That way now I've actually got paper that I can write onto.
Open the notebook.
Exactly.
I like it.
I need to open it. And by golly, wouldn't you know, there's an open function.
I do, you know, this is much better than yesterday when we were learning how to handle dates and the function names were things like strp time and strf time. The good news is when you're working files, guess what? They're called things like open, read, and I'll take a wild guess at what the one we use for writing is called. You'll be shocked, I'm sure. But anyway, go on, Christopher.
Yeah, we'll have to.
But first we have to open the file.
Yeah, let's open it. So what you're going to notice right here is, sure enough, it's simply open, specify the name of the file, specify the access mode. We'll get to that.
Yeah, we'll have to explain what access mode is.
Yep, exactly. So you have to give us a file name, you have to specify an access mode, and away you go from there. Now, one of the things that I always like to kind of mention here is a lot of times, and things like access mode is sort of a perfect example of this, a lot of times parameters might have default values. So kind of going back to something we talked about in the last module, sort. One of the things that Susan mentioned was that you just simply call sort, paren, and away you go from there. And what it will do is it will sort alphabetically or from, A to Z or A to Z. There you go. I gave you an A to Z.
Yeah, thank you.
Yep,
nice
you're
nod
welcome.
to us Canadians.
But you would also notice that there is a parameter that you could pass in called reverse that would allow you to go ahead and reverse the sort order, so that way you can go Z to A or Z to A, I suppose, depending on where you're from. Now, if you leave it off, it's going to go with the default. And sometimes the defaults are going to be obvious. So in the case of sort, the most obvious is going to be A to Z. Fantastic. Well, there are also going to be times when the default isn't necessarily obvious. And if the default isn't necessarily obvious, my general rule of thumb is don't depend on it if I care about it at all. So if I truly don't care, and there are times when I truly don't care, then I'm not going to worry about specifying that default value. But if I do care, and quite frequently I will, then I will always specify a value. So when it comes to things like access mode, I want to be careful about how I open up that file. So if I know that I'm only going to read from it, I don't want to open it up and allow for writing, because that could allow for some form of a security issue going on or going forward. So you should always specify that access mode. Just get into that habit right away.
Yep.
Now let's start off with that file name. What is the file name? This is, of course, wherever it is that you're going to be outputting it to, including the extension. So if you want it to be CSV, specify CSV. If you want it to be a text file, specify .txt. Now, if you just specify the name of the file and you don't specify the full path, then by default, the file is going to be created in the same folder as your program. And generally speaking, that's perfect, because what's nice about creating it inside of the same folder, especially if that's like, settings, something where the user wouldn't necessarily open that up, or the only way to open it up is if they use your program. The nice part about putting it in that exact same folder is if they drag and drop it somewhere else, they'll have everything that they need right there. So that is kind of nice. The one little tricky part, however, is what happens if we're testing this inside of Visual Studio? Where's that default folder? Well, as it turns out, there is the default with Visual Studio. But what gets a little bit tricky here is that that's only the default if you haven't gone in and modified anything, if you're maybe not using source control.
Okay.
And so, like in our case, we're using GitHub for all of our files. And as a result, Visual Studio is actually putting this in a different location. It's putting it into C:\, users, whack our username, whack source, whack repos, whack, and then the name of the project.
Yep.
So where it is can be a little bit tricky. Fortunately, Visual Studio makes it relatively easy for you to figure out exactly where to go find it. So you'll notice that you can right-click on any file that you might want, and then just simply choose Open Containing Folder, and that will take you exactly to that folder. So a very easy way that you could go in and do that. All right. So the first part is the file name, and the file name is probably the most obvious, because if I'm going to open up a file, I need to know what the name is. Everybody's going to go along with that one. Not a whole lot of explanation that's required. Well, what about the access mode? Well, the access mode is going to indicate how it is that you want to open up that file. Do you only want to be able to read? Do you only want to be able to write? Or as it puts it right here, what are you going to do with this thing after you open it? That's what the access mode is all about. And what you're going to notice is that there's 4 basic access modes that are available. You've got read from the file, so that will of course be read. You've got write to the file, which is going to put it into the file from the very top, so overwrite that file.
Yep.
And you also have append. And the main difference between these two, between write and append, is write is going to overwrite that file.
Yep.
So if this is, I'm just going to write out all the information all over again, I'm going to use write. Append will put it at the end. And append is perfect for things like log files. You know, that one of the things, you know, people are frequently asked, well, what can we use Python for? You can really use it for anything that you might want. And if you're using it for, say, an automation script, or if you're using it for a website, or, you know, maybe when we get into error handling later today, one of the things that you might want to do is just create a log file that says, well, every time that an error occurs, we'll just write it out to the end of this, and then later on I could open that back up and see what went wrong with it. Append is absolutely perfect for that. As a best practice, only open to the level that you need. So if you don't need to write to the file, just use read. And that's going to avoid any potential security issues or otherwise. So, you know, only open to the mode that you need. So in our case, since we're going to be looking to write, it's going to be W. And how does it all look when we put it together? It looks a little bit like this. So Susan kind of put all of this together, put the slides together. You'll notice file name equals and guest mode or access mode equals.
Yep.
And then you'll notice that we've got open. Let's open up Visual Studio and actually see it. Yeah.
More interesting.
Okay, exactly. Where is my Visual Studio? Okay, so file, new project. I knew I could do it.
You got it. You got it. I know it's getting close to meal break, and you're getting, you know, a little bit low on sugar.
Hungry, yeah.
Yeah.
Okay, so this is module 11, and this is going to be writing files. Beautiful. Okay. Now, what I'm going to do here is I'm going to just simply say file name equals, and I'm very creative with my names.
What are you going to call your file? Oh, demo.txt. I like it. Okay.
Very creative. And then I'm going to say access mode equals, and we'll go with W for write.
Okay, now there's a couple of questions coming up in the window which you're going to answer through this demo, but I just want to sort of highlight it so people who ask the questions can watch what's happening. One of the questions was, hey, if you say write and the file doesn't exist, does it create the file or what happens? So we're actually going to check that out right now.
Yeah, we're going to do that here momentarily.
And then I'll give you the other scenarios. Maybe you could sort of try those out for everybody.
And I'm going to drink some water.
All right.
Okay. Now, in fact, here, let me kind of do this real quick. I'm going to right-click and do that open containing folder, that little trick. And what you're going to notice here is that it doesn't exist.
Yeah,
so demo.txt is not...
Yeah, so it's funny. You're not actually saying, you might expect that it would ask you to create the file if it doesn't exist. In this case, we're just saying, no, open it to write to. And if the file doesn't exist, we're going to see what happens.
Exactly. Yep. So now what I'm going to do is I'm going to simply say file equals, and we'll say open. And then you're going to notice, first of all, that we get a nice bit of IntelliSense here. And so it's going to ask me right up front, okay, file. And all of these from here are positional. And, you know, a lot of these really don't matter on a day-to-day basis. You're not really going to care about those. And that's why I say, you know, if you don't care, don't specify it. If you do care, specify it. And so a lot of those I don't care, you'll notice that the default default mode is going to be R, again, meaning read.
Yep.
So if I just simply said open and then the file, I now know by looking that up that it's going to be read-only. I still like to specify.
Yeah, because it's one of those ones where if I'm looking at a file, when someone's working with a file, I always wonder, are they reading from the file or writing to the file? Because that's very different problem solving and very different things I'm doing.
Exactly. Now, while we're talking about, different things that we're doing, I'm going to show you about like 12 ways that we could write this because it really is up to you how you want to put all of this together. So you'll notice, for example, that I could go just like that. So file name, access mode. But I could actually, one very cool thing that Python does is it supports named parameters. So I could actually say mode equals, and then maybe W like that. So rather than declaring a variable, I could do like that.
Yep.
I could also have said mode equals access mode, which is probably a bit heavy-handed. It's probably a little bit
given that we've
redundant.
got it in a variable at this point,
Exactly.
It's fairly easy to read already. But it's nice to know you have that ability to be specific.
And one last thing that you can do, and this is something I love doing, is you could set a flag. Where, do you have a flag? You could set a flag. And so what I could actually do is I could just simply say write equals. And typically if it's a constant, you'll put it into all uppercase letters. So I could say write equals W, and then I could say mode equals write. So now my code winds up being a little bit more readable. So when I look at this line of code, I know exactly what we're doing. We're opening up the specified file, mode equals write.
Yeah, I like that. That's a nice, when I look at that code, even if I don't look at your variables up top, if I just see that one line, file equals open, right away I see what's going on. That's pretty cool.
Yeah, so there's a lot of different ways that you could do that. So you could go in and set another flag, read equals R, and then that way I could go in and update this. And, we could keep going down this this rabbit hole all day long.
We need to find out, is it going to, I want to see it run now. I want to, we still have that poor person out there going, but what happens when we say write mode and the file doesn't exist? They're waiting on bated breath.
Let's go ahead and hit start. It tells me to press the NE key. I'm going to press the NE key. I'm then going to, there we go, right click and open containing folder. And sure enough, it did in fact create that file.
Okay.
Yep.
So now, if you do it and the file already exists, well, actually, let's say you write something, because the next question was, if the file already exists and you write to it, will it overwrite what's already in the file or add to what's already in the file? So if you could, when you get to writing, if you could try that, that would rock.
Actually, well, let's start here.
Okay.
Take a look.
There's some text.
That's that's some text. Again, I'm creative.
Yes.
So let's go in. Let's just go ahead and save that. So just to kind of prove the point, it is in fact there. Now let's come back over to Visual Studio. Let's again hit start. Tells me to press the NE key. And let me go back to my little folder. And you'll notice that when I open it back up, it's empty. So write is going to overwrite that file. If you wanted to write to the end of it, you could do append. And in fact, here, let's do that. So we'll go in. Once again, this is some text. And again, just proving the point, it is there.
Okay.
Let's come back over here and let's say append equals A.
Right.
And then let's go in and update that, say append. Let's again hit start. Tells me to press the NE key. And if I open up my folder again, open the file back up, this is some text, and it will allow me to write to the end of it.
So that's where that access mode is so important.
Exactly.
You control if you're going to overwrite the file or whether you want to add to the existing file. So that all depends on the access mode that you choose when you open the file.
That's exactly it. Yep. Cool. All right. I think we answered all the questions.
I think so, yes. I think we're good. No, I'll let you go ahead.
Perfect. All right. I love that interaction.
It's good.
Yeah. Okay. So, see, we are doing this live. Let's talk now about actually writing something out, because just simply opening up a file isn't going to get us very far. We need to actually put something out to it. So let's talk about how to write out. So once again, you'll notice there's our little code. We go in, we do our open. Now, how do we write? And the answer is we simply use the write function. Not the RIGH. Well, I guess that would be the right function.
Yeah, okay.
I'm done. All right. In any event, so we use the write function. So all you have to do is just simply say write and write. Now, there's a very big question that I'm sure is on everybody's mind, and if I pause long enough, somebody would ask it inside the Q&A, and that is this. You said write, you said write. Are those going to be on the same line, or are those going to be
on different lines? Because that's really important. When you're writing information to a file, you look at certain files. Sometimes you want everything to stay on the same line. Sometimes you want to create a new line. Yeah, how do I control? So Christopher, tell me, how do I control, or is it going to write to one line or multiple lines? How do I control that?
That's a great question. And the answer is that write does not put in a brand new line by itself. You have to tell it to put in a brand new line. And if you remember back to yesterday morning, or I guess earlier in the recording if you're watching this on demand, one of the keystrokes that we talked about, one of the shortcuts that we talked about was \n for a new line. And that's exactly what you're going to need in order to get this onto the next line. So we've got kind of a little screenshot here. You'll notice, hi there, how are you? All on the same line. You'll notice that if we want a brand new line, think back to that print statement. What we're going to need is that \n. And so now if I do a \n there and I bring this back up, now you're going to notice that it's on a brand new line. Cool. Now, the last little thing is this. One of the things that you're going to be talking about later on is error handling. So what happens if something goes wrong? Well, as we all know, things can wind up going wrong. And if a program crashes, what can wind up happening is it could wind up locking up the file and maybe not releasing that handle.
You know when you're working in Word?
Yeah.
And you're working in a Word document, and then you sort of forgot you've got it open, and then you're like trying to email it to somebody or something, and sometimes you get that weird error message. Or actually, my favorite is when I'm like using a USB stick or something, and it says, "Oh, I can't eject the USB stick because this file there's still in use."
Yep.
So
That's exactly what that is.
So Windows and operating systems do generally sort of go, someone's in the middle of using that file, so you can't mess with it.
Yep.
That you can do that with your code. You can, when you do an open file and you start writing to things with your code. Just like when you open up a document inside Word, the operating system is going to go, you're using that file. I'm not letting anyone else in there right now.
Yep.
And yeah, you're right. When your code crashes, sometimes you get in a situation where the operating system says, you were using that file. You never told me you were done because the code went kaplooey. And so you're stuck with this code in this file. You try to reopen it, and it's going, no, the file's in use by someone else.
Or even, kind of go one step further with this. I remember when I was in college, which is sort of dating myself a little bit, one of the popular posters was everything I needed to know about life I learned in kindergarten. And one of them was...
I actually read that book. It was awesome.
See? And one of the ones that was on there was something towards the effect of basically naps are awesome. And naps are awesome. But one of the other very basic things that you learned in kindergarten, which applies to both real life and to your code, is clean up after yourself.
I like
so
that.
if you open something, close it. And what you're going to notice if we come down here is there is a close method. Get yourself into that habit. And in fact, I know people who will frequently, when they're writing their code, that they'll actually just simply say open and then immediately write the close and then put the cursor back up between them and start writing out the rest of their code. And you know what? If that's what's going to help you remember to always call close, do it. Because it's one of those things, if you're anything like me, and I know I am, I tend to get very focused on solving the particular problem that's in front of me. And so that's where all of my attention is going. And so I then frequently forget to do the one last little thing down at the very bottom. So I'm so focused on what it is that I'm trying to write out to the file that when I finish it, I'm like, okay, cool, I'm done. And then I forget to close the file, So it's not a bad habit to get yourself into. All right, let's go in and take a look at how we could do this. So let me go into Visual Studio here, and there's the code. In fact, let's just go right in and let's say File and just say Close, just like that. And now what we're going to do is we'll say File.write. And unfortunately, my IntelliSense isn't be quite the way that I want it, but that's okay. This is the first line. And I'm just going to sort of skip to the end. Let's just do the \n there. And then file.write. And this is the second line. And we won't do that. OK, perfect. And let's just make sure that all of my code looks good. It does. I'm going to hit Start. Tells me again to press the any key. one other good habit to get yourself into is if you're writing something that's going to be automating and it's not naturally going to display anything on the screen, it's a good habit to print something out, just to simply say something like, file written successfully. Because otherwise people are just going to look at that and just kind of get that awkward feeling of, well, did it actually work? Or they might rerun it. That I hate doing something and not getting a confirmation back that it worked.
It's true. You're always sort of paranoid. It didn't run properly.
Feeling uncomfortable. Yeah. So let's just go in and do that one more time. Now it tells me file written successfully. Cool. And then let's go ahead and open up our file again. And sure enough, we've got those 2 little lines.
Awesome. I just want to bring up a question that came up in the chat window.
Absolutely.
The question was, can you open a file for read and write at the same time? And the answer to the question, in fact, somebody actually already answered the question in the chat window, which is fabulous, but I wanted to highlight it here. Because not everybody's always going to see what's in the chat window. But yes, if you specify access mode of R+ for read plus or W+ for write plus, that either of those modes will actually allow you to open a file for reading and writing. So you can do it in a single command if you want to.
And, kind of going back to what we were talking about a couple of minutes ago about, putting that in there to make it a little bit clear, W+ or R+. When I look at it, that wouldn't necessarily mean a whole lot to me.
You'd expect it to be like RW or something.
Yeah, exactly. So you could, again, go in and declare some form of a constant for that to help make your code more self-documenting. That one of the things that we talked about, again, all the way back at the beginning of the course was the concept of putting in comments. And comments are wonderful. And I don't in any way, shape, or form want to discourage you from writing comments. But one of the problems with comments is you're sometimes just describing the code when you could just modify your code a little bit and let the code describe itself. So in my case here, my code is describing itself. So rather than me having to say something like, mode equals W+, and then just going in and saying W+ means read, write, instead what I could do is I could just simply leave it as read, write. I could leave it as read, write, and now my code is telling you what it's doing. So much cleaner than just putting in the comment. Okay, and I'm just going to go in and kind of clean things up a little bit. Perfect. All right. Now let's go back to slides here, and one of the biggest things that you'll frequently need to write out for a text file is CSV.
Oh, comma-separated variable files. We see those a lot. In fact, we literally just had a question in the Q&A, one of those nice lead-up moments where somebody said, what if I wanted to create a comma-separated variable file?
Yep.
Because you see that a lot in it's a very common file format.
Absolutely. Well, the answer is just kind of do it on your own.
Write a comma.
Exactly. Write in the comma. So you know what? Let's do this because we've got a couple of minutes here, and so you'll notice that just go in and put in the commas, and you'll notice that that is your challenge. Well, tell you what, I'm going to help you out a little bit here. That if you want to write out a CSV file, all that you need to do is just write it out. So let's just go in and say, for example, file write Susan, and we'll say 29.
Yeah.
And then right, 29.
That's right, 29.
Okay, and then we'll say Christopher, and then we'll go in and say, I'm going to, say 31.
Okay.
Yeah, we'll go with 31. In any event, so I've just simply put in both of those, and then if I go in and hit start, it tells me again that it was written successfully out to the file, and if I go back to File Explorer, open this up, you're going to notice I forgot my...
you missed a comment.
I did.
Yeah.
\n. There we go. So you were really cooking here. Now let's go back and open up my file again. There we go. And now there is everything.
Nice.
Now what I want to do is I'm going to...
Would you want the spaces?
Spaces, not spaces, that's sort of up to you. I put them in just for a little bit more readability.
Typically when I'm creating comma-separated var files, but I'm going to be using props, I don't usually have the spaces because then, I don't know, if I'm converting it to, when I read it back, sometimes I end up with a string that contains a space and I'm converting it to a number. Sometimes that causes weird wonky things. So
yeah.
I tend not to put spaces in, maybe a bit of personal preference, but I especially something like a number, I might not necessarily want spaces after the commas. Nice for readability here in the demo.
Yeah.
But I'm just thinking afterwards.
Yeah. You know, one of those little things. Okay, so what I'm doing here, kind of in the background, is let's do all files. Oh, that's why. Is it as demo.txt? You know what I'm going to do?
Do you want to open it in a different file extension?
Actually,
or
no. You know what I'm going to do is I'm going to do this. I'm going to update this to be CSV.
Sure.
That's really what it should be.
Usually, when you're creating comma-separated var files, CSV, they have an extension of CSV.
Let's go ahead and rerun it. And then now let's come back over here to Excel. There's my demo CSV. Let's open that up. And you'll notice that sure enough, and I'll kind of zoom in and make it a little easier for everybody to see here, you're going to notice that sure enough, Excel uses that as a CSV because at the end of it all, it's just a CSV.
Yep.
Now, to close all of this, I'm going to go one last step further. And that is, I'm going to go with a little bit of user input. So maybe, and I'll kind of keep it relatively simple here. I'm not going to worry too much about, you know what I'm going to do? I'm going to just sort of comment that. There we go. Okay. So let's go in and say data equals input. Please enter file info, and then let's go in and say file equals open, and then file name.
So now the user decides the file is going to be created.
Exactly. Mode equals write, and then let's go in and say file.write, and then, I thought I hit escape. I guess not. Write the data, and then file.close. OK, so what you're going to notice is that I'm grabbing the data from the user, and then I'm going to write that out to the file. So let's go in and do that real quick. So we'll just go in, hit start. Please enter. I should have put a space, but that's OK. This is going to be in the file. Hit enter. Written successfully. And now let's go back to our text file, and that's going to be in the file.
Nice.
I know I kind of moved a little bit quickly through that, but I sort of did that on purpose because these are concepts that we've actually all already covered. And if we go back and take a look here, what you're going to notice, I didn't do anything fancy. I just simply used an input to get input in from the user. And then I just simply put that into a variable, and I wrote out a variable. So a lot of people were asking, especially like when you were doing your demo with list, could you have input in from the user? Could you have read that from a file, which I know you're going to be doing later? Could you have...
Could you take the values from a list and write them to a file?
Exactly, yeah. Could you do all of that? Could I sit down and put together a for loop and do it that way? The answer to all of those questions is 100% yes. That if you've got a value, and it can be represented in some way, shape, or form as a string, you can write it out. And can you loop through things and write all of those out? Absolutely. So bringing that back, actually, then to our challenge is to create that CSV file below. You can do this in numerous ways. That
you could have the user, if you want to practice user input, entering things, have them enter it. If you want to make it a list and then write the values from the list to there, absolutely, lots of options.
Yeah, whatever it is that you want to do, and that's really the key that we want to highlight, is that, as we've been going through this, we've been focused on what we've been teaching. So when Susan was doing lists, she was doing lists. When I was originally doing files, I was doing files. Does that mean that I can't combine that with skills that I've already learned? Absolutely not. That you can do loops and lists and inputs and files and all of those together.
Can I get you, before you sneak off on the lunch break, there was one question that came in the Q&A window that was a really good question. If you could go back to your code for just a second. Somebody noticed the fact that for your variables write and append, you put them in all uppercase.
Yes.
Do you want to explain that?
Sure. The reason that I put them into all uppercase is 100% convention. Convention is when you have a constant to put it into all uppercase letters. And really the whole concept of a constant is sort of like it means in English, constant never changes. And that's what we're looking for. So some people would call that a flag. I'm going to call it a constant. But typically, those are going to be in all uppercase letters, just to sort of differentiate them from a typical variable, where the word variable meaning that I'm going to expect it to change. So that's why I put it in all uppercase letters. But that's a great question.
Yep.
And again, that kind of goes back to that whole formatting thing.
And it's not a rule. It's not something you have to do. It's, again, falling back to good programming practices.
Yep.
It's one of those conventions that a lot of programmers will use as a way of distinguishing between, so at a quick glance, I instantly know, oh, don't change the value of that. That's a constant.
Exactly. That's it. That's it. Cool. Well, now that we've seen how to write from files, let's eat.
Yes, let's take a break for a meal, and then you guys can work on the challenge if you want.
Exactly.
And see if you can create your first file using code.
Yep.
And then we'll come back and we'll learn how to read from files.
Exactly. Yeah. So we are going to show you the other side. So we will show you how to read. We're going to be back in about an hour. So we will see you guys then.
See you later.
All right. Well, welcome back. I'm full. I don't know if you're full.
I am re-energized and ready to go.
And I don't know if you're full, but in any event, welcome back. This is still Introduction to Programming using Python. Susan and I are back, of course, over there. I'm merely Christopher Harrison. And, we left off taking a look at how to write files. What do you think we might talk about next, Susan?
Seems to me there is a rather logical segue from that, which might be to talk about once you've written to a file, at some point you might want to be able to read it back again.
Well,
so shall we jump in?
Let's do it.
Let's start talking about how to read from files. One of the things about working with files, or, again, coming back to our issue of problem solving, writing things down is all well and good, but it doesn't help you if you can't read it again later. It's as simple as that.
Sometimes with my handwriting, I can't read it later.
Well, that's also important.
Yeah.
Actually, and strangely enough, it actually has its own parallels to programming. It's nothing like you write it in XML and somebody's expecting it as a CSV.
Yeah, exactly. Or, UTF-8 encoding. Or,
right. Yeah. So there are equivalents to I can't read your handwriting in the programming world as well. So absolutely, it's essential that we have not only that we can write to a file, but we can read it back again when we need it. If you think about it, right, when you create a shopping list, you need to be able to read that shopping list later so you know what to buy. It's as simple as that. Making the shopping list doesn't help if you don't have it with you at the grocery store and you can't read it when you get there. Checking the number of guests you have on the guest list so you can see if you've got enough food. Looking up a phone number so you can call somebody. I mean, really, what is... Okay, there was this device we used to use years ago. It was this thing, it was a big book full of names and numbers. It was called a phone book.
I'm sorry, you totally lost me there. A what?
Phone book, yeah. Not so common anymore. But, so what is a phone book really? It's just a list of names and phone numbers. So, but it's one thing if they write it down, but if you don't have it to look up again, how do all those websites look up phone numbers for you work? Guess what? They're probably reading that information from a database or from a file. The same one that was used to print the phone book beforehand. So in programs, we're often writing code that will read information that's saved inside a file. If you think about an e-reader, if you like to read books on your tablet, you can nice little apps you can install on your Surface and so on. When you start up an ebook, you don't have to start over from the beginning of the book every time you go back to read your book. It'll remember what chapter you were on, what page you were on. So that when you go back to start your book again, it just picks up where you left off. How do you think your program remembers that? What it does is it's probably creating a little file on your tablet that says, hey, by the way, in this book, they were on this page. So when they start up again, the program will actually say, quick, go check the file that says what book they were reading and what page they were on. And that way, we'll know where to bring them back to in the code.
Yep.
When you play a video game, I really find it very annoying when video games don't remember where I finished. It's really annoying when you play a video game and you have to keep restarting from level 1 every single time, especially these video games that are more story mode and things like that. You're playing Halo or something like that. It's really nice when it remembers, oh, I had passed this level and I'd achieved the following and I'd earned these weapons and so on. So that way, when I start at the game again, there's probably a little file that was created. So my program has to be able to read that file and remember what level was I on, what weapons did I collected, you know, how many hit points do I have, and all that kind of good stuff. Yes, I am.
What your charisma roll was.
Oh, wow. All right, there we go. Yep. And that's gotten way more complicated now. There's all these new modifiers.
Yeah, no kidding.
It's changed. My kids got into that, and everything's changed. I can't even figure it out
when I was
anymore.
your age.
Yeah, but I'm only 29. But
you're only 29.
Yeah.
I think I said I was 32.
Version 1.0, I think I was playing.
Yeah.
Luckily, the dice are still the same.
Red book.
So my kids can at least use the same dice I used when I was
There you go. Yeah, family heirlooms. You pass your dice down from one generation to the next. All right.
Absolutely. Anyway, but back to the code. The other thing that's really cool, even if you're not creating a file, the other thing that's really interesting and has become a very popular trend in the last about 5 to 6 years has been the concept of open data. And open data is really quite cool because with open data, basically what's happened is with the advent of smartphones and tablets and so on, a lot of people have started creating their own apps. And
Right.
you see this happening more and more these days. And you may have noticed apps that you get that tell you when the bus is coming, or that tell you where all the road closures are, or maybe it's just, I said, it's amazing the number of apps. Or you can get apps that'll tell you what happened on the last health inspection at the restaurant you just went to. I know New York City, there you can actually get a data file that will tell you the results of all the health inspections. It's a matter of public record. So what a lot of governments will do is they will make the files where they stored the results available to the public. And for programmers, this is gold. You can do such cool stuff with open data because basically what they're saying is, here's a file, thunk, read it, do stuff with it.
Yep.
So you could get the file from New York City that says, here's the health inspections of all the restaurants. And then you, once you're done this module, would be able to read that file. And you know how to search values in a list. So you could take those values, put them in a list, and do a search for somebody. Go and say, oh, wait, you wanted this restaurant? Let me look for that restaurant name, and come back and tell the person what was the results of their health inspection. You could actually do that with Python, based on what you've learned in these 2 days, which is pretty cool. So I'm just going to pop over to Internet Explorer here, and I want to show you, when I find the right one, here we go, get out of a chat window, and I want to show you how we can actually go search for open data. So if you're looking for interesting data you could potentially use in your code, if you actually just type open data, you will find all kinds of different websites from all over the world. I live in Ottawa, so if I search for Open Data Ottawa, and I search, I'll actually see that the city of Ottawa, where I live, has a special open data website. And if I click on that, it says, oh, well, here's our open data portal, which is all kinds of data that you're welcome to access. And I go, well, that's interesting. What happens if I say, let's get some data? And it says, well, here's all types of different data that I can collect. And they're in different file formats. You can see some of these are XLSX, so this one's an Excel spreadsheet. You may look at this one is CSV. We looked at CSV files yesterday, or not even yesterday, just before the meal, so just a little while ago. So you can get a CSV file that contains all the vehicular access ways, apparently. But water
access ways.
Absolutely, never know when I need those. But planning information, water information, federal governments, provincial governments, it's amazing how much information is out there for open data. One of my personal favorites that I came across recently, Australia has a remarkable collection of open data. And one I found in particular, you can see right here, this tells you about all the animals they have in the Tasmanian Museum and Art Gallery.
Well,
just in case you needed to know more about the Tasmanian tiger and Tasmanian emu, all the information you need to know about the exhibits at the Tasmanian Museum is right there in open data.
And yeah, I got to tell you, I was up late last night.
Worrying about Tasmanian emus.
Yes. Yeah.
I'm sure you were.
Yep.
But it's really, just to show you the incredible breadth of information that's out there in open data. And this is information that is free to use. You just go, you can download that file, read that file into your program, and do what you will with it. And this is often used in apps on tablets or even on websites. Python can be used to build back-end code for websites. So you could build a web page, and your web page could say, take the animal name they typed in, go call a program written in Python that will search the list of fauna at the Tasmanian Museum and come back and tell me, yes, we do have that at the Tasmanian Museum. So you'd write a little web page, somebody would type in the animal name, and then you would call a Python program behind the scenes that reads this information from the open data and gives back a result. I'm using Tasmanian Museum, but insert whatever data you found from open data here for your city, your state, your country, your province. And I said it's a real wonderful trend, and this is a powerful, powerful thing.
Yep.
They will be in different file formats. Some of them have CSVs, some of them will be Excel files, so that can cause some fun along the way because you try and just open up an Excel file and read it. In Python, it's going to have a lot of weird extra characters, so you might want to open it in Excel, save it as a CSV file, and then read it into Python. So we'll talk a little bit about file formatting, but you can do it.
Yep.
It's really quite cool. All right, so on that note, let's take a look at how we can actually read a text file. So let's keep it simple to start. Well, the good news is you already know the function you need to use to open a file. It hopefully should look familiar if you were with us when Christopher was helping us in that last module. We use the open function to open up a file, and we specify the name of the file we want to open, and we specify the access mode.
So it's the exact same as we did with write, because we're just opening the file back up, but something tells me you're going to use a different access mode.
Exactly, right, because it's the access mode that determines what the program expects us to do once we have opened the file. So if we specify an access mode of read, then it expects us to be reading the files write.
Yep.
If we are writing to the files. And then there is, it came up in the chat window earlier, there's an R+, which means read and write, or you can also say W+ to say read and write as well. So how does my program know if I'm reading or writing to a file? The access mode. So R for reading a file, W to write to a file, A if I want to append to the existing file content, and B is for binary files. There was a question in the chat window about binary files. Binary data is things like images, audio files, video files, those are stored as binary. It's unusual in Python, the level we're working with here, that you would be reading and writing for binary files, but I just wanted to mention it because if you ever do need to read the contents of an image file, you'd have to use the binary file access mode because they're read quite differently than they are from text files. And as I mentioned, our plus sign or W+ sign will open up as a read or write, so you can do both.
Yep.
All right, so once I've opened the file, how do I actually read the contents? Kind of important.
You know?
Now, here we go.
Details.
Here's one of those wonderful ones. Okay, anybody out in the Q&A, any of our audience want to guess the name of the method we use to read read the file contents?
I think you're trying to give people a hint. By the way, I just want to say that a couple of people love the Tasmanian emus, and somebody from Vancouver says hello.
Oh, hi, Vancouver.
And nobody in the chat window yet.
Yeah, we're just going to wait a little bit.
Yeah.
Going to wait
there
for
we
a second.
go. Okay, so I see
what
an R. That's the access
for
mode.
A read?
Yep. So the method would be, there we go. Yeah, now we're getting all sorts of reads coming
Guessing,
through.
yes. Why? What a shocker.
Yep.
Yes, and I do, I joke about this, but I really do appreciate it when the people who are developing a programming language make the function names really intuitive.
Yeah.
So you think, well, maybe there's a method called read. Well, guess what? There's a method called read.
Yep.
So you specify your file and you do a read. What this will actually do is this is actually going to return the entire file contents into one great big string.
Yep.
So when I call the read method, it returns the entire content of the file, every single line you've got in there,
everything inside
and puts
that file.
everything, dumps it all into one big string.
Okay.
So file content is going to contain all of the file.
Somebody said read toasters.
Read toasters. Nice. Somebody was with us yesterday, I can tell. All right, so it returns the entire content of the file. Now, of course, there are definitely times when that's a bit clunky.
Yep.
We were looking at CSV files in the last module, and in that one, you probably want to read it row by row. Give me the first row, give me the second row, and so on. So you can also, if you prefer, use readline. So that's sometimes useful. In particular, where I really love using readline is situations where maybe I have a CSV file and the first row is titles.
Yes.
You'll see that, in Excel spreadsheets, the first row of the spreadsheet is telling you what's in each of the columns. We do the same thing sometimes in CSV files, so when someone opens up our comma-separated variable file, the first row is actually the column headers. and then we have the data. So by doing a read line, I can distinguish between, okay, my first row here is the column headers, and the following rows as I go through them, I will know are the actual data. So I can distinguish between the two a little more cleanly. So read line, as you might guess, since it's read line, returns one line. So let's do it, because really, you've got to start playing. That's the only way to do this. Practice, practice, practice. And this time I'll remember to maximize my window right away. All right. Okay, so I'm going to just create a file, because I need a file to read. So I'm going to do the open containing folder there, and I'm just going to go here and create a new file. Let's just create a new text document. That'll work fine. Called Tasmania.txt, perhaps. Yes, I'm going to learn all about my Tasmanian emu now.
Come to Tasmania.
All right. And then I'm just going to open that file up in Notepad. And in Notepad, I'm going to list that there is the Tasmanian devil, endangered, which is an endangered species. And then we have the Tasmanian emu, which is in fact extinct. And we have the Tasmanian tiger, which sadly is also extinct. And then you have the possum, which I promise you, certainly true in Australia, I'm guessing true in Tasmania as well, is common. That's kind of like squirrels, raccoons, there's possums everywhere off that way. And I'm assuming it's true in Tasmania. Might not be, it's an island, but it gives me something to start with.
We'll go with it.
All right, so I have some data in a file, and now I want to write a program that's going to read that content.
Okay.
All right, so I'll leave that file over here so we can kind of remember what it was doing. So what I need to do first is I'm going to basically open the file first. So file, I'm just trying to think of a good name for my variable. I'm just going to call it my file. I'm sorry, I'm not feeling particularly original. That's terrible, isn't it? All right, it's bugging you.
Just
all right.
call it file.
Animal file. All right, animal file equals.
Lowercase a.
Thank you. Doesn't have to be. It won't give you an error.
Yeah, but you know,
we were trying to be consistent in the way we're doing our casing, camel casing versus Pascal casing. We talked about that yesterday when we did variables. And that is equal to open, and we have to specify the file name. And I'm just going to be different from what we did last module, I'm going to hard code the file name this time.
Sure. Yep.
And I called it, what did I call it? Tasmania.txt. Tasmania.txt. And then I have to specify my access mode, and I am going to be reading this file. So I'm going to specify the R. So first of all, I'm going to open my file. And then I'm going, let's try first of all just say all file contents equals animal file dot read.
Okay.
And then if I simply print all file content, and I've done it again, I've gone and made that uppercase, try to be consistent. And if I print all file contents to the screen, we should see the list of all the different animals that were in that file displayed up on the screen.
Let's see it.
So we run, and oh, it can't find my file tasmania.txt. I wonder if
might have saved it to the right spot.
Or it might be .txt.txt. You know how it does that on you once in a blue moon? Let me go to my open containing folder here, double check the file name. Open the containing folder. It is there.
Yeah, no, it is. It's got exactly.
Exactly.
That,
I'm going to say what I want to show you what happened to me here is view the file name extensions, and because of the way I created it, and when Notepad automatically puts on a .txt extension, so when I typed in a file name of tasmania.txt, it made it .txt.txt. Luckily, I've hit that error before, as you can tell. I told you, the more mistakes you make, the better you get at finding them. So that's probably why it failed.
Yep.
All right, so the file name was off.
Take two.
Take two. And there we go. Perfect. There is my output window displaying all the contents of the file. So boom, already I have the ability to just get all the contents of my file read in.
Yep.
Boom. Now let's try reading a single line at a time. So we're just going to modify this. So this is going to be read all file contents. So that would be one option. And I'm going to comment that code out using my Control-K, Control-C. And this time I'm going to do a first animal equals animal file dot read line. So this time I'm just reading the first line. And then I'm just going to print that value, first animal, on the screen. And then what I'm going to do is I'm just going to read the first 2 rows. I think some of you can guess on if I wanted to read all the rows, I might need a loop. So we will get to that, but just to start, keep it simple to start. All right, so now I read the first line, put that into a variable called first animal, and the second line, put that into a variable called second animal. I run, and sure enough, I see the first 2 rows from the file printed out on the screen. Success, already making some good progress.
All right, I like it.
Okay, let's go back and learn something else. Let's play some more. One of the most common file formats you do end up reading are CSV files.
Absolutely.
So one of the things we have
Like
actually—
the file you just created.
Yeah, the file I created was actually a CSV file. I wasn't even thinking about it. It's just so intuitive and so common. A lot of the open data files you find, you will often find CSV files or Excel files, which you could save as CSV files. One of the great things is you aren't going to be the first person to try and read a CSV file, and so many other people have to read CSV files as well. So one of the great things is there's a library to help you read CSV files specifically.
We're not launching rockets here. Whatever it is you're trying to do, somebody else has already done it. Quite frequently, they've already created a library for you to use it. Remember, got a couple of lazy programmers here. You know, be lazy. Take advantage of what's already there. Best code in the world is the code that's already written.
Absolutely, because I could write code that would take that read line output and go through, find the comma, and say get the string starting from the beginning to the first comma, and that's the animal name. And I could do all that. It's quite possible. It's called parsing.
Yeah.
And it's been done by many a programmer. But you know what? There's a module that will help you read CS files.
Yep.
Let's use it.
Exactly, and I'd even go one step further, that one of the most common mistakes that I see developers make is they look at something and they go, well, I could create code to solve that problem. You know what? You're absolutely right, you could. And you might even be thinking, and I might be able to do it a little bit better than they could. And again, maybe you could, maybe you couldn't, maybe you could. But in the long run, you've got a solution. It's ready, it's all set, ready to go, you could use it. Just go ahead and use it. It's there, and that allows you to then focus on what the real task or the real problem is at hand, rather than having to worry about the nitty-gritty of going in and doing all of this.
Yeah,
like,
so
you know,
because you're not writing this program, you probably, even though your program has to read a file, the problem you're probably trying to solve just happens to require that data.
Yep.
So let's not spend more time than we have to just getting the data. Then we can focus more on looking at the data that we've got.
Could we go back in and write a bubble sort? Sure. I've got better things to do with my time. I'm just going to use sort and move on.
Exactly. So yeah, absolutely.
Yeah.
So there is a library. If you import CSV, you will have a library you can use in your code to help you read CSV files. And I want to show you a couple of the functions you might want to use when reading CS files from this module. So if we go to the slide, you can see you do have to import the module because this functionality is not included in your Python by default. You have to say, I want to use the functions inside this module. And once you've done that, there is a reader function. And what the reader function will do is it'll actually return all the rows that were inside the file, but it will return them, instead of one just big giant string, it actually returns them as a list. And we just learned a little earlier how we can process and work through lists. So once you've got the values in a list, and it does assume by default that you're using a comma to separate the different values in your file. But it is possible, sometimes the data in our file might contain something like an address. And the address has a comma inside it. So sometimes a comma is not the best separator to use in a CSV file because there might be commas within the data. So sometimes people might use a slash, or they might use a semicolon, fairly common. But the idea is you can't be sure that every single CSV file actually uses a comma to separate between different values.
Yep.
So if you look at the syntax on the slide, you'll see that the reader function, you can call it a couple of ways. You can either call it by passing in the name, just the name of the file. That will assume you're using a comma to distinguish between the different values in a row. Or you can specify, by the way, the delimiter I'm using in this file is, and in this case, I'm specifying a comma, but it could be a semicolon, a colon, a slash.
The number of times that I open up a file and it's got a CSV extension and it's using semicolons.
Yes, and you read the data and you're going, why is it all messed up?
Yeah.
Yeah, so it's not that unusual. A lot of times it's because of address information. A lot of times addresses contain commas.
Yep.
Yeah, so it comes up fairly often. So now what we can do is, so we specify our file name, we specify our access mode, we open the file name with the access mode. That's nothing new there, right? I could talk about the new code in a second. But so we specify our file name, our access mode, we say open our file with the access mode read, and then we're using the CSV function, reader, to read that file and take the contents, and that's going to return a list, which is going to end up in a list variable called data from file. Now, I have kind of cheated a little bit here and snuck in some new syntax that you guys haven't seen before. And that is right here, this word with, and the with as my CSV file. We haven't seen this syntax before. Suddenly this is like, I'm not actually executing a loop here, but
no.
it looks a little bit like a loop.
It does, and again, I noticed the colon in the tab.
Yeah, and it's indented here as well.
Yep.
What this is doing is, last module, Christopher, you were talking about how sometimes you can get an error when you try to open a file and it's already in use.
Yep.
So we were talking about sometimes it was important to close your file, because otherwise, much like, if you open up a Word file and someone else tries to open the same Word file at the same time, it'll go, oh, you can't open it, it's already in use. And sometimes when we're writing code, we write code that opens a file and then an error occurs so it doesn't get closed. So then the next time you try and run the program, it gets confused. When it tries to open the file, you get an error message because it's saying, no, it's still open from last time. I can't open it again. And as a programmer, you get really frustrated trying to figure out, like, how do I release that lock and get it to work again?
Right.
When you use this method, when you use this syntax, I should say, to open a file, what this does is it's basically designed to help protect you. When you say with open file as and give your file a name this way, instead of saying my CSV file instead of saying my CSV file equals open file name access mode, instead I'm saying with open file as, so this is the file name here, my CSV file, you can call it anything you like. When you do it this way, this syntax ensures if there is an error during the processing, the file will always be closed. So if an error happens during the open or somewhere in your processing, if an error happens anywhere in the indented code as you're processing through the data, the file will always be closed.
And even if there wasn't an error, it would still close it for you.
Yes, it does the close for you. So this way, I don't have to remember to close the file. I don't have to add the error handling, say, if there's an error on open, please make sure the file still got closed. Comes back to, I get to be a lazy programmer by adding the words with and as. I save myself having to worry about file close. It's efficient. It's also protecting yourself.
Absolutely. And actually, I would even go just kind of one slight step sideways. But just to mention, because I know we have a lot of developers who do other languages, that for those of you who've done .NET, this is analogous to that using statement where it will automatically clean up whatever the variable was, so like files and database connections. So that's exactly what with as is doing for us.
Yeah, exactly. So that's a useful syntax. It's one I would recommend. It's a little more confusing. That's why we didn't want to introduce in the very first module on files. But I would actually recommend you get used to using the with open as file name instead of file name equals open, because you're less likely to have problems executing your code. So that's just the syntax there.
So I'm just laughing because again we've got that little bit of a delay. So I just said about the with and
just like using,
and sure enough, there in the QA is whether or not the with is just like using.
Bingo. All right. So well spotted by someone out there in the audience.
Exactly.
Good job. All right, so we were just talking about the with and the and. Okay, now once we have all the rows from the CSV file return, remember I said when we use the reader function inside the CSV method, so we're calling reader, we give it the name of the file, and it returns a list that contains all the rows. So it'll be a list of all the rows into this variable data from file. So that's going to be a list.
And what's nice about that is anybody who's tried to parse through a file line by line by line manually,
it's nasty.
It knows how much of a problem that can wind up being. Now, granted, yes, loading everything up into a list isn't necessarily the best use of memory. So be careful about doing something like that. I'm not going to try to grab a 30 meg file and just load that into memory. But if I know that the file is maybe only about 20 lines, 30 lines long,
even 100 lines. Or 1,000 lines.
Yeah,
you can handle 1,000 lines.
Throw it into a list, be done with it, because it will make your life that much easier when you're trying to program it. So, unless you're working with megs and megs and megs of data, don't worry about loading up some data into a list and reading that all from a file. Don't worry about it at all.
Because we saw an entire module of all the cool features and functions we can do when we work with a list.
You could do a for, you can,
We had that cool for loop for looping through a list. We had that index function, but would allow us to search a list. So effectively, that suddenly means I can search a file, load the file into a list, search for list. Boom, you just search the file to see if a value's in there. We had the ability to update the list, add to the list, delete from the list. So suddenly you're getting all of these capabilities and all this functionality really easily to do all of that information or all those functions on the data from a file. So
exactly.
at least they're so nice to work with. That's a great way to go. Now, if you do have all the values into a list and you want to see all the values, well, what did we see as a way of looking at all the values in a list? We saw you can use a for loop. And we do that. Remember, each row is, or each value in the list is going to be one row.
Okay.
I do want to be specific about that. So if we actually take a look at the file we had here, the list will actually have a value of Tasmanian devil, comma, endangered. The second value in the list will be Tasmanian emu extinct. The third value in the list will be Tasmanian tiger extinct.
Okay.
The fourth value in the list will be possum common. It is not going to be the individual values. So each row will be one list item. So I'll print that out so you can kind of see how that works. All right, so let's do that as an example because I think we need to see that in action. And this was read file line by line. I'll just take that code and we'll comment that out with my control Casey. And then this time, instead of doing, I'm going to change my to a with open Tasmanian text as animal file, colon. So now I'm using my with as syntax to open the file, just a slight change there in syntax. And then I specify that and let me remind myself of the syntax because every now and then I draw a blank on these things. That's right, csv.reader, thank you. Then I need let's call it all rows. I'm going to call it all rows. I'm trying to think meaningful names. All rows list. So a list that contains all the rows from the file, and that is going to be equal to csv dot. Oh, no IntelliSense. I forgot to import the CSV module, so that I have access to those awesome functions. Now, when I do csv dot, I can actually see the reader function in my IntelliSense, and I specify that I want to read the animal file that I just opened into that list.
Perfect.
Okay. Now, what I want to do is now I want to say for current row in all rows list, print current row. So let's print each of the rows right up on the screen. If we run, hopefully we should see a nice printout. Oh, I was going to say something's going to be wrong. Current row is not defined. That's because I have 3 R's in current row instead of current. Talk row. Like a Pirate Day was on the 17th. It's not. So let's try that again. And boom, there's all my rows printed on the screen. I'm just going to run through this quickly with the debugger because sometimes just seeing it all spewed out doesn't make it clear that it really is one row is one value. And that's so essential to understand because that's going to really affect how you process the data. So if I put a breakpoint here on the for loop, actually, let's even do it right here when we populate the list. So now when I run, I can hold my cursor over the all rows list. And right now that doesn't have a value because the yellow arrow means that's the next line of code that will be executed. So when I hit the step into button or hit F11, it executes and that row is ready to start entering the for loop. So any variable I hover over, I can see its value. And if I expand this one, I'm going to pin this up. Pin this so you can see it. And if I expand it, oh, this is a little hard to see here. Let me expand that. No, that's not what I meant to do. Yeah, come on. Okay, you know what? It's not showing up nicely there. Let me do it this way. It was showing up better here when I had it. Not line number. I have to expand it here. I had it showing a second ago. That's really weird.
It was there.
I know. Something strange going on with the debugger here. So all rows list. If I go here. So it contains literally one row for each. So let me just go to the next line of code. We can see it by current row. So you can see the current value of current row. What is going on with my debugger? It's acting a little odd at the moment. Let me just try, I'm going to try something else here. Let me go down to the autos window, and no variables are showing up my autos. My locals maybe? Locals, by the way, is this window here called locals. This is a window you can use when you're in the debugger. It shows you the contents of all the variables that are currently available to be viewed.
Right.
So if I go here, I can see, that animal file is currently, it says closed, which is strange. The name of the file is tasmania.txt. It's opened with read mode. If I open CSV, I can actually see the values of the CSV, but I'm just trying to, what's odd is my variables all rows list. Here it is. There's the variable all those rows list. But for some reason, I'm having trouble seeing the actual values.
Yeah, it's showing you that you have 4, but that's okay.
Yeah, so that's true. I can see it's got 4 lines.
Yeah.
And then current row, see, I'm confused because current row is not listed. It's throwing me off a little.
Yeah.
Let me try executing one more line of code and seeing if that pops up. Something odd just happened there. So let's just restart that. Try that one more time. All right, so we go through, we're here, we're about to execute this line of code. I'm just going to dock this back to the bottom again. So it's kind of out of the way. Not that much, thank you. It's a little generous in terms of space. Want to be able to see the code, I'm a little more concerned with you guys seeing the code. You guys just go away. Get away, go away. I'll bring up what I need. Okay, shrink this down so you can see the window. I want you to look at the code, that's what I care about. And the line is about to execute, about to read the contents into my variable. And then it goes into my loop, prints the current row on the screen, prints on the current screen. Now this time I think it's actually working. Now you can see the value of current row is Tasmanian emu extinct. And the next time I execute, the value of current row is Tasmanian tiger extinct. And this time, let's see if it actually is. There we go. Now I can actually see that, the different values, possum, common, and so on.
Yeah, it was really kind of funny that it didn't seem to read the file. That was sort of weird.
Yeah, I'm not sure. I said something wonky happened, and wonky things do happen.
Yes, absolutely.
It's life. So now I have all the different values displayed on the screen, but I still have them at the row level. There are definitely times when you're going to want to be able to access an individual value from the CSV file. You don't necessarily want the entire row. You want to know the name of the animal that's in that file, because the CSV file you receive might contain 10 columns of data, and maybe you only care about the name of the animal. You don't care if it's endangered, what region it lived in, if it's a herbivore and a carnivore and all of that. So then we get an interesting challenge if you think about it, because right now, I have a list, all rows list, and that is a list, and each value is the entire row. When I process through current row, then current row is a list that contains all the entries for that row. So this starts to get really confusing, because now if I want an individual value, I have to say for current word in current row, print current word. So I basically got a list of lists that's been returned. So I have to loop through each list in the list.
Okay.
And then, as I loop through each list in the list, I can get the individual words
So what it's
from that
looking
list.
like to me is that it's basically giving you back, if you will, sort of of an object, and it's giving you the ability to go into each one. So in your particular case, and if you ran this, we would see it.
I'm going to do this as well so we can see that. That will make it a little clearer.
Yep. Yeah, so if you go ahead and run this, and so we can see the output. So it's looking to me like it's just simply grabbing each individual item. There's your trailing space after the comma.
Oh yeah.
So, yeah, that's sort of a throwback to what we had earlier. And so it makes it very easy to take each row and then break down into it. So if there was a calculation that you needed to do, if there was a display that you wanted to put together, you could go ahead and do that. Now, of course, the main catch whenever you're working with CSV files is that I'm not able to access the individual items by name.
No, you can't say.
It's just by location.
You can't go in. Unfortunately, there's no ability to say, would you please give me third row, second column? We can't do that.
Right. Exactly.
Yeah. So you end up having to go through the whole thing and then extracting. Well, you could say, if I'm on the third time through the loop, and it's the second column, then take it out.
Exactly. But that being said, It's still a million times easier than having to parse through the CSV file itself. Ask any developer one of the things they hate doing the most,
Parsing.
and that's going to be parsing strings. That trying to figure out where the commas are, the +1, -1.
Where's the first letter of the next word? Where's the last letter of the first word?
Yeah, you know, got better things to do with my time, you know, so much easier just to go ahead and use the utility and let it do the work for you.
Yeah.
Yep.
So if you look at it, wherever I said print current row, that was the output that's appearing inside the square brackets. And wherever I'm printing current word, then those are just, so you can see here, this is the list value that was contained inside current row. And then what I did is I then had a loop that said loop through this list, which contains Tasmanian Deviled, and retrieve each of the words from within that list.
Yep, exactly.
So it's a little confusing. The more you do it, practice, practice, practice. That's how you get the hang of it. The more you do it, the more comfortable you'll get with these nested loops. But this is one of the most common nested loop scenarios is when we need to access the individual values inside a CSV file. So I'm just going to go back to the PowerPoint for a second. And so there's my how do I retrieve the individual rows. And then and there's just an example on the slide. I did want to put a more complete example in there. And then we just did the demo. And if you want the individual values, that shows you how you can make the nested loop to show the individual values in each individual row from your CSV file using nested loops. Now, one of the things, though, that I know somebody out there, I'm surprised, I don't know if it's come up in the comment windows yet, but I wouldn't be surprised if somebody looked at this output and said, I don't like those square brackets.
Not yet.
Oh, see, if I take this part of this out, if I comment out this code, and I just said, sure, I'll print you the contents of that file, that's ugly.
It is, and the reason that it's printing that way is because it's just showing you what's going on behind the scenes.
Because it's a list.
It's showing you the list.
Yeah.
And if you just simply want the text, that's not really what you're looking for.
As a programmer, I love the fact it returns it this way because that's why I can treat it as a list. Each row is returned as a list item. But to a user, they're like, what's with these square brackets? If you tried to give that to your manager as running a report, your manager would be like, oh, that's hideous. You got to fix the way that looks.
Right.
So there is a way to change the formatting. The way it works is you use a join function. And when you call the join function, you specify what character would you like to use to separate the different values. So you could show the different words or different phrases separated by commas or separated by semicolons. And then you call the join function to say, join all these different parts of a list together and use a comma to separate them or use a period to separate them. The syntax is a little funky, I will say. This is one of those ones when I first saw the syntax, I was like, what is this code doing? So the way it works is you specify the separator that you want to display, a comma, a semicolon, a colon, a slash. Then you say .join, so the word .join, this is a keyword, you can't change that. And then you specify the variable name that holds your list. And this doesn't have to be a list from a CSV file. This works on any list, by the way. So the way that's going to look is if I have a row, which I read from my data, then I can say print, comma, because that's a separator I want to use, and I'm including a space.
Yeah, because you have the space from comma to the next word, so yep.
I don't have to, though. And then I say .join, and then I specify the row that I want printed that way.
Yeah.
So the way that looks is, if I see if I can get this syntax right on the first time. This is always fun. If I do that, if I say print, let's say use a comma, .join current row. And that should print it out. Oops, would help if I wasn't still running the code. And now you can see that I don't get those square brackets appearing around it, and it's just a nicer, more user-friendly format.
Yep.
And just to be clear, this is not specifying how the fields are separated. This is how I want them displayed. If I change that to a semicolon, it now displays it using semicolon to display it when it's displayed back to me.
Yep.
So a little weird in terms of syntax. Again, we don't all memorize these things. You look it up when you need it.
Yep.
Don't stress over it. All right. So, given all that, I think it's time for a new challenge.
Okay, let's see what we got.
All right, so the challenge is to write a program that will print the names and ages of all the guests in the guest list file you have created in the last module if you completed the last challenge. If you did not get a chance to complete the last challenge and you want to jump straight to this one, what you can always do is just do what I did. Go into Notepad, create a file, kind of like the one I have below. that contains names and ages separated by commas, one row per line, or one name and age per line, and then try reading that. But just make sure you don't end up with a .txt file like I did. Make sure you can see the file extensions.
Can we bring that slide back up again? If that's names and ages,
yeah?
Why do you have me listed as 80? You know what? If I gotta say, if I'm 80, I look pretty darn good for 80. I mean, yeah.
Well, that's an octal.
An octal. Ah, I see what you did there.
Or
well done.
Or hexadecimal.
Yeah.
All right. Okay, so that takes us to the end of another module. Congratulations. You guys now have the ability. You think about how far you've come. You can now write code that can create files, read from files, process that information. We're really moving along.
Absolutely. Now, the next thing that we need to focus our attention on is this, is that we've seen a lot of the raw pieces on how to put together a program, on how to put together an application. But one of the problems that we're going to wind up running into with all those individual raw pieces is that if we're trying to keep doing something similar over and over and over again, we're going to wind up with 8 lines of code, 8 lines of code, 8 lines of code, 8 lines of code that are always the exact same thing. It'd be nice if we could just ball that up, put a name on it, and then just call it. Wouldn't that be nice?
It would make it a much tidier way to write our code.
Yeah.
And I'm lazy. I don't want to rewrite the code several times.
Yeah, exactly.
Yeah.
So what do you say we take 10 minutes, we'll come on back, and then we'll take a look at how to do exactly that. So we'll see you guys in 10.
See you soon. All right, wave.
Hi.
All right, hi everybody.
Hi.
Yay. Awesome.
Oh, hey.
So we're on. Okay, sorry. I was having too much fun. I wanted to zoom here. So I'll just tweet that. You talk. I'll
okay.
tweet.
All right. Yeah. I just say, you talk. All right. Well, over there, tweeting away our little picture, and you can check it out there momentarily at
Hockey Geek Girl.
Hockey Geek Girl.
And Geek Trainer.
And Geek Trainer here is Susan Aback. I am Christopher Harrison, and this is Introduction to Programming using Python. And I guess I'll just take it from here.
Sorry, are you talking?
No.
Go. Okay, go.
Up until now, what we've been doing has been focusing in on the little components that you're going to use to make your program. And in fact, we actually saw in the little chat window, somebody mentioned that they felt a lot more confident about going in and solving simple problems, which is awesome. That not only does that make our day, but that really was the whole goal here. Now what we want to do is kind of take what we've done and take it to that next level to kind of show one more component that you're going to need to start to write more complex code. And what we're going to need in order to start writing more complex code is simplify the basics. So rather than always having to say open every single time that I want to open up a file, let's go ahead and just create a function that will automatically take the name and give me back all the text inside of it. And so I've sort of given everything away by introducing the name function here, but let's start talking about what a function is going to do for you. Repetition. One of the problems that you're going to notice with code is that you're having to do the same thing over and over and over again. The same few lines of code, the same operations, again and again and again. One of the problems with code that you're going to notice is that you're frequently doing the exact same thing over and over and over again.
I'm not sure I got that, Christopher.
The same few lines of code, the same tasks, the same operations. Let's go to the next slide. So one of the problems that you're going to notice, in case you haven't picked up on it, what we're looking to do is avoid that repetition. Just like, nobody likes listening to somebody who's being repetition, nobody likes to see code that looks like that. That code with repetition is just fraught with problems. That not only is it now that I have to keep going back in and copy, paste, but one of the points that Susan made earlier very well is if you have to change a value somewhere, you you then have to run around to all of those different spots and keep changing it over and over and over again. And while certainly, yes, variables can help you out there, it's nice to have a black box. It's nice to have some balled up block of code that I can just toss in a couple of parameters and then just poof, it gives me something back. You know, basically think of it as a bread machine, if you will. That I've got my bread machine, what's it going to do? Well, it's going to bake bread. Well, what I can do is I can throw in rye and all of that, and now I get rye bread, or I could throw in cinnamon and raisins and all the ingredients, and now I get back cinnamon raisin. But all I'm doing is I'm just simply tossing a few ingredients into a machine, I wait for a few hours, and then voila, I have bread. That's what a function is all about. It's your bread machine. That what I'm going to have is some little box that I can toss a few items into, and it will automatically do work for me, so that way I'm not having to do the nitty-gritty. I'm not having to knead dough. I'm not having to punch it down, although that can be a great stress reliever. But you know, I'm not having to do that. I'm just letting the machine do it for me. That's exactly what a function is. So what if we could just create a button that does the work, and then just press that button?
And it's nice and sort of self-contained, right?
That's it.
I like it.
Yep, that's exactly it. That's exactly it. So let's talk about functions. Now, what is a function? I think the simplest way to put together a function is sort of define it in English. It's a noun. It's a reusable section of code that has a name that does something. And the big point that I want to make here is that what it does is sort of irrelevant. That what it does can be all the different things that we've already learned to do. So Susan did an example earlier about reading a file, and she automatically read the entire file into contents. And we saw that that took a couple, 3 lines of code to do. So what I could do is I could just create a function and say, read file text. Give it the name of the file that I want, and it will just simply give me everything back. Or maybe I say print file text and give it the name of the file, and it will automatically print it. Whatever it is that you want it to do, you're going to notice that the content of that function is going to be code that we've already learned. Now, the most important point to me, or I should say the point that's often overlooked when it comes to functions, is this part right here. The ability to give it a name. So if I created a function and I called this function print file, like that, and then inside of here I had code, 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 and that's all of the code to go in and print that file, I don't need to know necessarily what's going on inside of all of this, because if I look at this, that says print file. What do you think that's going to do, Susan?
I think maybe that will print a file.
Absolutely. And so kind of going back to that whole comment conversation, you know, comments can oftentimes be a smell that, yes, do comment, but every now and then, all that you're doing is explaining something that maybe could be simplified. So rather than putting in a comment, this is the code that will print a file, create a function, give it the name, print file, and then now you don't necessarily need that comment.
And you know
On
what?
top of that,
if you look at all the things we've been calling, all
Yeah.
the functions we've been calling, somebody wrote the function read that we were using to read files earlier. Somebody wrote the function print that prints things out for us. Those are all functions someone else wrote for us.
absolutely.
And we don't know how they work. We just call print when we want to print something on the screen. We call read when we want to read the contents of the file. And because they've got good names,
Yep.
the code is hidden from us. For us, it makes life easier.
Exactly, and actually, this is sort of funny that I keep stealing your thunder
I
and
just stole yours?
digging
Oh,
into
sorry
your
about
slide.
that.
Yeah, turnabout is fair play. And actually, again, this is sort of perfect because it's a great validation that we're moving in the right direction. If we take a look here, the next part of the slide, you've already used functions. You know, you've already used print and open and write and close. And here's the thing, I've been developing for years.
Yep.
That might have gotten garbled.
Yeah, it's an audio issue.
Yeah, exactly. Must have been an audio issue.
Yep.
But I've been programming for many, many years. I'll be honest, I have no idea how to make a call into the Windows APIs and open a file. I've got no clue. Why? Because every single programming language, every single environment that I've ever used has provided a wrapper for all of that. So all I had to do is just simply say, open, or open file or something like that, and it automatically made the calls behind the scenes for me. It automatically read the ones and zeros off the disk. I didn't have to do any of that. And I didn't need to know how to do all of that. How that happens behind the scenes, I've got no clue. But can I do my job? If the task is read data from this file, can I perform that successfully? Absolutely. And I don't need to know how things work underneath. And that's the whole goal of a function, is it can help simplify things. I'm taking away the stuff that I really don't care about. I'm putting it over here. I'm just giving it a bigger name, and then just calling it. And again, kind of going back to the bread machine, I have no idea how a bread machine works. I don't need to know. I just put in my ingredients, I hit start, and in 3 hours, I've got bread.
Yep.
So, yep. You love your bread machine, don't you?
I do. I use our bread machine all the time. And I love several comments of when you slice the bread and put it in your free toaster.
Yes.
It's been coming up in the comments. And I also want to specific call out to the person who suggested with Marmite, because Marmite, some of you may have heard of Vegemite. There was a song, you know, she just smiled and passed me a Vegemite sandwich, which made Vegemite famous.
Yeah.
The British equivalent is Marmite. I actually like Marmite. If you've never had it, most people think it tastes absolutely disgusting. So I'm happy shout out to that one lone person out there as well who also likes Marmite. Moving on.
You found the one person that likes
I found the other person who likes Marmite.
Well done. All right. So then why create functions is exactly what we've just said here. So code reuse, you are going to be doing the exact same thing over and over again. Simplify your code. So rather than having, you know, a big comment or a big block of code that requires some level of interpretation, you can just create a function. And it can also help break down your code that, you know, a lot of times you're going to be dealing with multiple things that maybe what I need to do is I need to collect some user input. So, you know, maybe that's going to be a bunch of input statements, but instead I create a function. So I'll say collect data from user. And then I create that as a function somewhere else. And then now I need to write that out to file. So I say write data to file. And again, that's created somewhere else. And so now when I go in and I look at this, that's pretty simple. That I know exactly what that's going to do in English. And if I need to go in and take a look, then I could go do that. But a lot of times, just that high level, that's all that I'm going to need. And then finally, last but not least, is it is going to make it easier to make changes. That let's say later on that instead of writing out to a file, I've decided that we are going to write out to a database. Or maybe what I want to do is write it out to a file and write it out to the screen at the same time.
Sure.
I only need to update that in one place rather than going around to the 8 places where we've got that same bit of code. So why create functions? Because in the long run, this is going to make your life easier. This is going to make it easier to do the most important thing. If you've learned nothing else this week, the most important thing about being a developer is to be a lazy developer. Lazy coders. For good functions will help make you a lazy coder. All right. Well then, how do we create a function? So, first little part that we're going to need is we're going to need keyword def, which is short for define.
Makes sense.
Okay. Next part right here is going to be the name of the function. Now, the name of a function is extremely important because this is now what you're going to keep using over and over and over again. So we were talking about variable names earlier, and when you're choosing good variable names, you want to make sure that it's nice and clear, that I can look at that and go, okay, I know exactly what's going on there. Cool. Well, I want the exact same thing when it comes to functions, that if I can look at a variable and figure out, oh, okay, well, that's the piece of data that it's calling, I need to make sure that when I look at a function, I know exactly what it's going to do. Because if I look at a function and I go, well, I don't know exactly what that's going to do, and I then have to go look at the code, I've sort of failed a little bit there. Yeah, that now I've defeated a bit of the purpose, because a bit of the purpose is to not have to go look at that code unless I explicitly need to know that maybe I need to do a little bit of debugging, or maybe I'm just curious, hey, you know, exactly what is it that it's doing. But if I have to look at it to figure out what it's doing because the name isn't clear, that's a problem.
Yeah, we should be able to do better.
Exactly.
Yeah, we want to make this, one of those things so that we don't need 22 lines of comments to explain something whenever we call it.
Exactly. Yep. That's exactly it.
So now, can we talk to the guys who built STRP time?
I'll work on that. Now, the next thing to note here, and I'm putting this on the slide just for kind of full disclosure, you'll notice that you can also set up parameters. We're going to talk about that later. So I promise you, we're going to have that. And then finally, last but not least, is you put the body of whatever it is that you want it to do tabbed in, and then finally, you're going to notice a return statement right there. Now, what return for right now is going to mean is it's just simply going to mean exit. It's going to denote the end of the function. Return can mean something else, which we'll talk about in a little while, but for right now, kind of keeping things simple, it's just going to be exit. Awesome. So now, the question becomes, well, how do we call it? Well, the way that we call it is really the exact same way that we've called other functions. That if you remember calling open, if you remember calling print, all that we did was name, parentheses. Name, parentheses. That's it. So if we take a look here, you're going to notice define print message. Print message. Done and done. That's it. Let's do it.
Yeah, I want to see it live. Because one thing on a slide, I sort of get it, but it makes more sense when you actually see it running in the code. Somehow that makes more sense.
100%. Okay. Let's see. This is module 13 functions. There we go. Okay. So, little coding thing.
Okay.
If you're putting a whole bunch of things into one file, and you're putting your functions into that same file, one of the things that you'll want to decide is kind of where you want to put everything. And typically, I like having my functions down towards the bottom. And the main reason for that is just so that way I can kind of more easily focus in on what's important and worry about the other functions later. So I can go in and say, for example, like define, and we'll just say print message. And there we go. Whoops, don't forget your colon, Christopher. And let's just go ahead and say print and hello world. Got to start out with hello world. We'll say return, which is spelled with an N today.
I feel like it's nice. It's sort of almost feel like we're coming around to beginning again. Hello world comes back.
Exactly. Hello world comes back. And then you'll notice right up there at the very top that I've got my print message. Now, this is, and I swear to you this is true, this is an on-purpose error.
Yep. I had a suspicion you were going to do this one.
I did this one on purpose. One of the things that we've been highlighting an awful lot is differences between code. And depending on the language that you're in, sometimes you need to define things earlier, sometimes you can define it later on. Here, what you're going to notice, if we kick back to my code here, is it's going to tell me print messages is not defined. Control-P print, can't find printer. It's right here. I'm just going to keep quoting a comedian.
Go ahead.
But in any event, what you're going to notice is we've got print message. It's right here. But the problem is that we put the calling up top.
Yep.
And we defined it down below.
So it's a little bit like when you try to reference a variable, in the wrong order.
Exactly.
You can't reference a variable and then create it later. It just doesn't really make sense.
Exactly. And that's a perfect way to put it. That's a perfect analogy, is that you can't define a variable later on and then use it earlier. Same thing here. And so now, if I reorganize my code, which I just did real quickly behind the scenes, you're going to notice that now this prints out hello world. So again, I'm going to stick with it. Kind of keep all your code block together. And like I said, typically I would like it down at the bottom. Not able to do that here. Not a problem. Just put it all up at the top and then go ahead and define everything down below. Now, another little trick that you could use to get around this, and you see this an awful lot, is to maybe go something like define and then main. And main in a lot of languages is a keyword.
Okay.
That main is how you start a program. And so what you're going to notice is I've reworked things. And this is actually going to work out really well. So I'm doing two things at the same time. The first thing that I want to highlight is you're going to notice that I created this brand new function up here, and I called it main.
Okay.
Now, main, again, this is in a lot of other environments, is the standard entry point. So Java uses it, .NET uses it, I'm pretty sure C++ uses it. I don't want to admit how long it's been since I've done C++. So, but you know, I'm pretty sure if I remember right, C++ does it, and so forth. So all that we're doing is kind of sticking with that convention. So you'll notice that I created a brand new function here that I've called main, and then you're going to notice that I called one function from another.
Yep.
Now, I'm highlighting this, but if you stop and think about it, this shouldn't necessarily come as a huge surprise because, Susan, what's print?
Print's a function.
It's a function. So when we did our print message, I already called a function from a function.
Yep.
So it would stand to reason that I could call another function from a function. Now again, you're going to notice that if I go in and I hit start, that now it behaves a little bit differently. You'll notice that now this is working.
Yeah.
And you might be thinking, well, time out, Christopher, hold on. Hold on.
It looks like you still are calling it before it's declared.
Exactly. It looks that way, but I'm not. And this is a very big point. When you define a function, what you're doing is you're saying when somebody calls this function, this is what I am going to do. And notice my conjugation there. Notice the tensing. This is what I'm going to do. Not what I did, but what I'm going to do. So and if we come back to the code here, when I called main, what I'm doing right now is I'm saying execute the main function. I don't need to shout. Execute the main function. That's what I'm doing. I'm explicitly stating I want to call that main function right now. And in order for me to do that, the function must be created.
Aha, and it was. It was created before you actually called main, that you could see the function defined before you actually called it.
Exactly. Now, when I define a function, what I'm doing here is I'm saying define this function. When someone calls this function, execute this code. So again, you're going to notice my tensing here that when I define the function, I'm going to wait until somebody calls the function to execute that code. So future tense.
Yes.
So what's going to happen is the Python parser is going to read through all those definitions, kind of put them into memory, as it were, and wait for somebody to call them. So nothing inside of here is actually being checked until we go in and call it. So that's why I could get away with print message.
Yep.
And so now I've gotten to the scenario that I kind of like, which is this is the body of my program, of my script, of whatever it is that I'm doing, and then down below are all of my method functions, and then down here at the very end is what's kicking it off. So, if I added another comment,
you're not actually executing any code until you reach that line that says main.
Exactly.
All by itself.
That's exactly it. That's exactly it. Okay, I'm going to take a drink.
Okay. Well done.
Thank you. I kept waiting for a good point when you were going. But
you were hoping me to go a little longer.
Yeah, exactly.
No,
yeah,
my
keep
apologies,
talking.
Kristen.
Keep talking.
You've had your drink now. Now I'll let you go back.
Okay, perfect. All right. So there is the basics of how we're going to go in and define that function. Now, in my case, I've kept it relatively straightforward, at least as far as the bodies go, that you're going to notice that all I did was just simply print and then hello world. And I drank too fast, so I need to. There we go. Sorry about that. Okay, so you'll notice that I kept it very simple, that I just went with print and hello world. But could I have also done, maybe something like this is, let me call this print names, and maybe call this print names, and then we'll go ahead and say names equals, and then we'll say Christopher, and we'll say Susan, and we'll say Danny, because I'm going to get his name right, which will make him very happy. There we go. And then I could go, I get to say for name in names, and don't forget your colon, Christopher.
Don't forget your colon.
And then I could go ahead and say print name. So could I go in and do something like that? And the answer is 100% yes. And of course, if I hit start here, you're going to notice Christopher, Susan, Danny.
Yep.
Cool. So it's doing exactly what we think that it would do, that really this block of code right here, there is nothing that we haven't already learned there. So can I open a file? Could I, parse CSV? Could I, write to a database? Whatever it is that you want to be doing, the answer is 100% yes. That if you can write it in code, you can put it inside of a function. Awesome. All right. Now again, just to kind of highlight this, the one nice part about all of this is that all I have to do is I just have to say print names. I don't need to know what's going on inside of print names. I now know it's going to print the names.
Though I will point out one thing.
Yeah.
Since you created this function, obviously at some point you knew exactly what was going on inside that function.
That
right?
is true.
So
Yeah.
I don't need to know
because
but the nice thing is once you have created that function, you can almost forget about it.
Yeah, exactly.
But when you create it, you have to know what's going on.
Exactly, yeah. And when you start to get a bit more advanced, you're going to start to create your own little helper libraries and maybe share those out with other developers, so they might not know what it is that you've done.
Yes.
So yeah, absolutely, absolutely. Yeah, I don't have that short term of a memory. My memory is really short, however. Okay, cool. So anyway, so there is our little functions there, and kind of how we can break all of that down. Awesome. Now,
you know what? Actually, can I suggest one of my favorite functions that I always like to write for myself?
Please.
I like writing a function that will format dates the way I want them. Because we talked about that syntax for that string f time and the %b's and all that is so confusing.
Absolutely, yeah.
It's something I hate looking up. And I find that when I'm working with dates, 99% of the time I want it displayed the same time because it's for the same group of users and they want it the same way. So one of the functions I often create for myself, one of the first ones I end up creating, is a function that will display a date the way I want to.
Yep. Exactly.
And that way, once I've done that once, I kind of forget about writing out how you do the str f time thing all the time. I just call my function when I need it.
Exactly. And a lot of people were asking earlier about looping through an array and maybe finding every particular item and if it getting rid of duplicates and things like that. Well, this is exactly where functions come into play, because could you do that? Absolutely. You would just take a loop and you go through and eliminate your duplicate. The problem is that it's going to be a few handful of lines of code. That's perfect for a function, because then I could just create a function, call it remove duplicates, pass in my list, and then let it do its thing. Ooh. Pass in its list.
Oh, and I need that for my date functionality too, because I'd have to let you pass in the date.
Absolutely.
And it would have to give me back. So you'd have to pass in the date you want formatted, and the function would have to give you back the nicely formatted string. So you're right. I need, and it actually already came up in the Q&A. As you can imagine, someone's going, hey, how do I pass a value to that function? So I'm glad we're there.
Yeah, exactly. Because if you look at the bit of code that I've got here, the only 3 names that this is ever going to print is going to be Christopher, Susan, and Danny. Period. End of sentence. That's it. So what happens if we want to be able to maybe allow somebody to pass in the group of names that we're now going to display out? Well, that's exactly what we're going to get into. So I'm going to go back to my slides here. There we go. Okay. So we want the functions to be more dynamic. Now, the functions that we created were good because they did one thing, and sometimes that's all that you need. But sometimes we need a bit more flexibility. So maybe we need to pass in a parameter about whether or not we want to set up custom messages, or maybe 2 numbers to perform a calculation, or maybe we want to write it out to the screen, but optionally write that out to a file as well. Wouldn't that be nice?
I like it.
And that's exactly where parameters come into play. Now, here's the thing. Parameters, fantastic Scrabble word, if you can, fit that on there, is a very fancy word for a concept that we've already played with. A parameter is going to store a value. Hey, Susan.
Yeah.
What have we already used for something that would store a value?
A variable?
A variable, exactly.
All right.
So what's a parameter?
Do I get a point?
You get a point. You got a gold star today, and you get a point.
I'm having a good day.
Well done. We'll have to figure out how you can catch those later. In any event, so a parameter is really nothing but a specialized variable. It's a variable for a function, And what's going to happen is rather than saying like we did in the past, variable equals whatever we want the value to be, we're going to wait for somebody else to give us what that value is. So it's just like a variable. And in fact, we've already used parameters. That remember when we said print hello world?
Yep.
Parameter.
Yes, true. I was passing a value to the print function.
Exactly. That's it. So we could actually update our little methods to accept parameters. So I give you an example here. Print message, give me the message. And then all we're going to do is just display it out with print message. Now, while we're here, you might be looking at this and you might be thinking, you know, Christopher, you're keeping things relatively simple. And you know what?
Those
You're
are very
100%
simplistic
right.
examples.
Yeah, you're 100% right because I'm focused in on creating functions. But I got to tell you, so many of my functions are really actually 2-3 lines long. And that's it. Because sometimes even just that little bit of cleanup can make a big difference, especially if I'm doing the same thing over and over and over again, or if, you know, we've kind of poked fun at strf time. You know, if it's not overly clear, creating your own function, like Susan mentioned earlier, can make life that much easier. So don't be afraid to create a function that's only 1 or 2 lines long. If it's going to simplify your code, do it. Don't be, there is no minimum number of lines for a function. I would say, however, there is a maximum in that if you have to scroll up and down, your function is probably too long, that it's probably going to be trying to do too much, or really, more practically, it's hard to read. That if you're having to scroll to read through a function, especially when you're trying to debug it, that just winds up making it that much harder to try and debug. So really limit yourself to one screen per function.
A function does one thing.
Exactly.
Don't write a function that does 20 different things. Write a function that will open the file you're planning to use. Write a function that will take the contents of the file and return you all the animal names from the file.
Exactly.
You know, but don't try to write one that will open the file, get all the animal names, do all the error handling for that, and close the file and take the results and print them on the screen. That point, that's your program.
Yeah, exactly.
Yeah.
So what you would do is you take each individual component of that, break that down into different functions, give those all good names, and then go ahead and call them, and that way you could stack them from there, and it makes it that much easier. You know, don't create a function that's going to take in a parameter and figure out, okay, well, we're going to write to a file, or we're going to write to a database, or we're going to write it up to Azure, or then you're just making your life difficult. Okay, so with that, let's go in and kind of keep going with our parameters here. What about multiples? Well, you could absolutely add in multiple parameters by just simply separating them out with commas. That's it. So just simply define display message, greeting and name, and then just simply concatenate that together, and then you'll notice that we can just print that out like that. Cool. Let's go in and take a look at a demo here. So let me open back up Visual Studio. So here's what I'm going to do is I'm going to, right up here, I'm going to, give me your names. There we go. Let's put our names right up here. And I'm going to say new name equals input, and let's say enter last guest, like that. We'll say names, append, and then that new name. And now here's what I want to do, is I want to print out those names, but you're going to notice that I, in my case here, have put together my names up here.
Uh-huh.
That's what I've done.
Yep.
So what I want to be able to do is I want to be able to take those names and send those down there.
I like it.
This is where a parameter comes into play. So what I'm going to do is I'm going to create a parameter that I'm going to call names. And then up here, I'm going to say print names and then pass in my names. Now, a couple of things that I want to point out. Number one is what's going to happen behind the scenes. Actually, before I get there, I'm going to call it list for right now.
Okay.
Okay. Just because I'm going to try and avoid confusion, then I'll step back.
Sure.
So here's what's going to happen. Names is automatically going to be passed into there. So it really is almost as if behind the scenes I said list equals names.
Okay.
It's almost identical
Sure.
to me doing that. So just like a variable, but I just don't have to say name equals and then whatever the value was. That happens automatically behind the scenes.
So the value that I specify when I'm calling it gets put into the variable name that's used in the function.
Exactly.
Okay.
That's it. That's it. And so now, let me go in and start this. And you'll notice that it will ask me for my last guest. Let's invite Satya.
Oh, yes.
Hit enter, and sure enough, it displays Christopher, Susan, Danny, and Satya. Cool. Now, I want to go back to what I did a second ago, where I had this as names. And you might be looking at that, and you might be thinking, well, wait a minute. You already used names.
Christopher?
Yes.
I'm confused. I've got the variable name names inside main, and then I have another variable name names inside print names. I'm confused.
Good. Well, not necessarily good, but let me help. One of the interesting things about functions, and I do have a slide on this, is functions also serve as a container. By the way, the big fancy technical term for this is scope.
And we actually had somebody say, maybe you guys should discuss scope, actually popped up in the Q&A. I said, we're not going to get too deep into it.
No.
Because we don't want to get too far, but
Exactly.
we just touch on it here.
Exactly, yeah. Because scope can become very complex really quickly. So what I'm going to do for right now is just kind of define it as this. Our functions create containers. Our containers define what's known as a scope, or more simply, a variable's lifetime. So if I declare a variable as a parameter or inside of a function, once we get to the end of that function, all of those variables go away. So after this, names is now no longer available. Or after this, names is now no longer available. So you'll notice that I can reuse the same, forgive me, name.
You know,
Now,
it's a silly analogy, and it's not entirely accurate,
Yeah.
but sometimes the way I think of it is I think of when you're inside Windows Explorer and File Explorer, you can have the same file name in two different folders.
Yeah, exactly.
And, you know, when you're in this folder, that
perfect
file
analogy.
name
Yeah.
contains the contents that it has in that directory. And if you
Yep.
have the same file name in a different directory, you can have completely different contents.
Exactly.
So it's kind of like that. One function is one folder, it can have the name, and another one can have the same name.
Exactly. And you might be looking at all of this and you might be thinking, well, you know, Christopher, for me, using the same names is a little bit confusing. And I could certainly see how that would be.
Sure.
But the couple of things that I want to mention is, number one, I mean, if it's a group of names, you may as well call it names. But not only that, if you're trying to make all of your variables uniquely named across your entire application, after a while, you're going to run out of names. You're going to run out of creative, A names, B names, C names, you know.
I have seen
Yeah.
people, one thing I have seen that isn't too bad if it does bother you, is I have seen people who will do P_name or P name when it's a parameter.
Yeah.
So they'll do that as the parameter, so they remember that anything which is P names is the parameter that they define for their function. So that's the only, if you really feel you have to do it, that might be a compromise.
Yeah, exactly.
Yeah.
Exactly. Yep. So you'll notice that sure enough, this is now going to keep on running for me. Excellent. So now let's kind of keep on keeping on here. I'm going to go back to my slides, and let's break things down into returning data. So up until right now, what I've done is I've created functions that went off and did something for me. They wrote something out to the screen, which can certainly be, again, exactly what I'm looking for. But again, it's relatively limited because the only thing that it's going to be able to do is print out. What happens if I want, again, a little bit more flexibility? That maybe I would like to create a little function that can start prompting the user for the collection of names. And then once they're finished with entering in all of the different names, it will just give me that collection of names back, and then I can decide what I want to do next. So maybe I want to print it out. Maybe I want to write it out to a file. So I would have that option there because it will give me the value back.
And I would need this, I keep coming back to my date formatting challenge, right? I said one of my favorite functions to write is I will write a function that accepts a date value as a parameter, and it returns a nicely formatted string with the date formatted the way I like it. And that way my little function has all that strp time, percent, whatever in it, but I just call my function that says format date. I pass it a date, and it gives me back a string formatted the way I like. And if my users ever change their mind about the way the date formatted, I just go change one line in my function, and I'm done.
And you know what's kind of funny here is I'm now regretting the challenge that I put together, that I really wish I would have put a challenge together of create a function to better format dates. I should have done that.
Let's make that the extra credit.
There we go.
There's
your
extra credit challenge. I like it.
All right. In any event, let's go in and kind of take a look at how this is going to look. And what you're going to notice, take a look at how it's going to look. What you're going to notice here is we've had our return before, and what return meant until now was exit. Well, now what we're going to do is we're going to use return and give it something. And what that will do is that will then send that back out to whoever it is that called it. So if we kind of break things down, you'll notice that down here I've got my little get message. So I'm going to pass in Christopher. It's going to do its work. And then message, sound effects and all, is going to go right down to there.
Nice.
So that is what's going to happen with our return value. Now, before I go back and do my demo, you'll notice there's my slide on scope. It came up earlier than here. But again, after a while, you just can't always use different names. And again, it's...
You can use the same file name in two different folders.
And sometimes that's what you need.
Yeah.
Keep using the same name when appropriate. Okay. Let's go ahead and take a look at how we can return back values here. So I want Visual Studio, and let's say I'm going to do this. I'm going to, let's just say def, and get names.
Okay.
There we go. And don't forget your colon, Christopher. Let's just paste that into there. Okay. Now, for right now, I'm going to keep it a little bit simpler on myself. That you're going to notice that I'm just going to keep the exact same code that we had before. And then right here, I'm going to say return names. Now, you're going to notice I can return whatever I want. So I could actually return, Christopher, I could just return a string. If we had a date time, I could return back a date time. We could return 42. So the fact that we're returning a list, sometimes people look at that and go, well, wait a minute, that seems, a little more advanced, because a list object is inherently more advanced. A list is more advanced than a number.
We saw that in the last module when we were looking at reading files.
Exactly. But you know what it is at the end of the day? It's still just a variable. So it's still just an item that I can pass around, so I can still return it just like I normally would. And then you'll notice that what I could do is I could say names equals get names. And now we're going to get the exact same behavior that we saw before. So now let me go ahead and hit start. Enter last guest. Again, let's go with Satya. We'll hit enter. And sure enough, there's Christopher, Susan, Danny, and Satya.
Cool. Do you know what? Can I make would you like to just take a second and maybe step through that code with the debugger so they can sort of see how it's hopping into the functions in the order of execution? Sometimes that's sort of interesting when you've got functions.
Okay. So what you're going to notice, I threw in the breakpoint here, is right now we're stopped on names equals get names. And so what I'm going to do is I'm just going to hit my little step into here, and you'll notice where that little yellow arrow is. You'll notice that the little yellow arrow is now inside of get names. Why? Because that's what I called. So I called get names, and so it automatically threw me into get names. So now what I'm going to do is I'm going to step down one more, and now we've got our new name. Now we're going to go ahead and get the last guest. Let's go in and again add Satya. He doesn't return any of my emails.
The thing is, he probably would return our emails if we asked.
Might, exactly.
So we shouldn't say that. For all we know.
You're right. Yeah, I shouldn't say that.
I've never tried.
Never emailed them. It was really an attempt at humor there. Most of these jokes are just for my own entertainment. In any event, let's go back to Visual Studio here. And so now we've got our little append and then return names. Now watch this. When we return names, I want you to watch where the arrow goes. The arrow now goes back up to here. So now we're back inside of main. Let's go down one more step. Now we're at print names, and then now you'll notice when I go into print names that it's down there on print names, and now we've got our for loop and away it would go from there. And so I'm just going to kind of skip to the end, and you'll notice that it's printed out all the names.
Cool.
Perfect. Okay. Now, the last little thing that I just want to mention here, because I'm willing to bet this has come into the chat window, and if it hasn't, then I'm going to do it anyway. Let's. One of the things that Zoom It can do is put up a break timer, as we've seen. One of the other things that you could do here, get names, is just like before, you can call one function and add in another function. You know, a lot of people were asking things like, well, could you do meaning of life equals int input, what is the answer, boom, 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 like that. So a lot of people were asking, could you go in and do that? And the answer, of course, was 100% yes. So could you do this? And the answer is 100% yes. That what you'll notice right here is paren and paren, that the parentheses are going to identify, kind of do this first. So the outer all the way to the inner. So it's going to, or other way around there, but it's going to call that get names first, and then it's going to call print names second. So you could absolutely do that. And whether or not you decide to do that is really up to you, that you really can start to get kind of fancy here. That if I maybe wrote a method that looked a little bit like this, maybe something like def get message name, could I go in and say return colon
Yep.
topic, if I go in and say return hello and name, is that going to work? Absolutely. That you could go in and define that in line. And whether or not you decide to break things down into different variables, into different steps, is 100% based on your own comfort level. That I know a lot of advanced developers who will never do something like that, who will never do a calculation on the return line, that they will always create a variable and return the variable. Hey, you know what? If that's what makes sense to you, if that's how it's going to fit, go for it. 100%. Yep. Cool. Huh. Awesome.
You're rocking.
So, I want to close all this off, and here's my challenge, which the date one would have been a little bit better.
It's okay. That's going to be the extra. So the extra. So the extra credit challenge is going to be write a function that accepts a date and returns a nicely formatted string, but shows a date the way you like to see dates displayed. So that's your extra credit challenge.
Here's your extra credit challenge.
Now,
Here's
Christopher has your regularly scheduled programming challenge.
Exactly. So the regularly scheduled one is, and what the whole thought process behind this was really kind of the point that I kept trying to make over and over and over again as we went through all of this, which was, the whole goal of functions is to try and simplify things, is to try and make reusable blocks of code that you can just kind of keep going back to help simplify things. So imagine a scenario where all you want to do is write some data out to a file. So what are you going to need? You're going to need two things. You're going to need the data, and you're going to need the file name. And could I sit down and write that in a bit of code? Sure. But you know what? If I put that inside of a function, then all I have to do is call that function. And that's exactly the challenge here, is create a function to simplify writing to files. Set it up to accept parameters, one for the text to write, one for the name of the file, and then of course add the code that's going to write the text out to the file that was specified. And you know, if you wanted to, now you could start to get all crazy with the cheese product that comes out of a can, and maybe start adding in input statements where you could then prompt the user, give me the text, give me the name of the file. So you could really take this and kind of keep building upon this. But again, the main takeaway that I want you to get, the whole goal, is that it's there to help make your life easier. So what we've seen, the congratulations slide here, is you now have the ability to save yourself some time by putting those statements into functions. It's going to simplify your code, it's going to simplify debugging, it's going to simplify your updates.
Absolutely. And in the end, it's going to allow you to be a better lazy programmer.
Absolutely.
Awesome.
I don't know about you, Susan, but at least periodically when I write code, something goes wrong.
I would say never, but I think I'd be struck down by lightning.
Yeah, and in fact, both of us have had things go wrong.
You've seen us have things go wrong right here
There's video
in our demos.
evidence of us.
So I think what better way to wrap up our day
Yep.
than by talking about what can we do when we're coding to deal with things that go wrong in our code, so we don't just get nasty error messages spewing all over the screen, and how do we deal with those? And I think when we're done that as well, I think we need a little more homework.
Okay. Yeah, more homework. All right. With that, let's go ahead and take 10, and we'll come on back with the last module of the day. Stick with us.
See you soon. And we're back.
And we are back. Yeah, last one. For those of you just joining us, you've missed a fantastic day here, a couple of days on Introduction to Programming with Python. It is worth noting that this will be available in 2 weeks, but we'll talk more about that at the end of this module.
Yep.
The last little introduction that I'm going to do one last time. Susan Ibach is over there, ladies and gentlemen. I am merely Christopher Harrison, and Susan, I'm just going to let you take it from here. No segue.
Right,
just
let's jump into this.
Go.
Yeah, we've been looking at all sorts of different coding situations and all kinds of different problems we could solve with code. We've been learning different syntax so we could solve more and more complex problems. But one of the things we haven't done yet, and we've even actually encountered some situations where we were writing code and there were errors occurring, but we really haven't talked about what do you do to handle errors that occur in your code. So in order to write an elegant solution to a problem, it is nice to be able to do error handling. Can you write code and solve problems without error handling? Yes, but it's really much more elegant and nicer experience for a user if you have good error handling. So we just want to talk a bit about how do you do that with your code. So if we hop to the slides here, even the best laid plans can go wrong. You go off, you create the shopping list, and then you get to the grocery store and realize you left your shopping list at home. Oh, I've never done that one. Sometimes I'm like, I know I'll be smart. I'll put the list on my phone. And I leave my phone at home. You go out and you go out to buy a pair of shoes. You spend all that time trying on different running shoes, and then they discover they don't have it in your size. Just after you find the perfect pair.
My habit is, because I'll often run here before work, so I'll bring my work clothes as well, and I frequently forget my work shoes.
So you end up spending the day in the runners.
In my running shoes, yeah, exactly.
Related story, just a brief side, I'll get right back to the code. But I did one time, I used to travel a lot for work. I used to teach a lot of programming courses, and I would travel and I would pack the dress shoes for the work. And I had a really grungy pair of running shoes, and this is when I wore a full suit.
Okay.
With the skirt and the blazer, and I got to the training center and realized I had no dress shoes. So actually, no, I had packed dress shoes, but I packed one black and one blue, and they were both for the left foot. So I ended up teaching the entire course wearing a nice, beautiful business suit and a really grungy pair of running shoes.
I love every bit of that. That's
funny. The best laid plans do go wrong. I was trying not to wake up my husband when I was packing, so I grabbed two shoes and apparently both left foot.
Yep.
You decide you need to call somebody and you discover your cell phone battery is dead. No matter what we plan for, things will go wrong. And that's going to be true when we're writing code as well. So things that go wrong when we're writing programs as well. So some of the scenarios you might have, you're writing code that's going to read a file. The file's not there. I have run into that one so many times. I used to write programs that would move file from one location to another.
Exactly.
And it would read a file from one location, move it over, and load it into a database. A very common sort of scenario.
Yep.
Somebody sends me a file, I take it and I put it in my database.
Exactly. And those are the types of things that you don't have control over.
Yeah.
That, when I'm writing the program, if I have a mistake in my code, that's me. But if I'm trying to read from a file, there's no guarantee that file is going to be there tomorrow.
Yeah.
I have no idea. Yeah, exactly.
So we often run into that scenario. So we need to be able to sort of handle that sort of error. You might have a situation where you ask a user to enter a date, and you tell them, hey, enter it as day, month, year, but they enter it as year, month, day. Or they specify a date like the 30th of February. You go, wait a second, that's not going to work. So you have to be able to handle those situations in code. Or you are doing math in your program and you hit the common programming error, the divide by 0. That one comes up quite common.
Absolutely.
So there's different types of errors you can actually run into when you're writing your code. First of all, there are syntax errors. And I think I'm going to go out on a limb and guess that everybody out there who's been practicing has had a syntax error. I know we've had several in doing our examples. Christopher's like, oh, I forgot the colon. Susan, you've got the parentheses around the print statement. These are great examples of syntax errors. Now, the wonderful thing about working inside a tool like Visual Studio is Visual Studio will highlight your syntax errors with that little red squiggly line. And you know what I love about that? It's the same thing you see with spell check in Word. We're actually used to the red squiggly meaning, go look here, you have a mistake here.
You have a problem here.
It's too bad they don't give you the autocorrect like they do for spell check.
Yeah,
That'd be nice. Maybe that's coming later. From IntelliSense, we could have a spell check autocorrect for our code. But no, when you see a red squiggly in your code, that's a hint that you have a typo somewhere. So if you actually look at this example here on the screen, you can actually see hello world, and what I've done is I've forgotten one of my quotes. So I forgot to put my opening quote, if I show here, I forgot to put an opening quote right here, so I get this squiggly line. I'll give you a little tip too, and I don't know if you've noticed this, Christopher, but sometimes where the squiggly line appears isn't exactly where the error is.
Exactly. But the way that I use it is basically the end point. So I'll start there and work my way backwards.
That's right. So if you see a squiggly line, that means on that line or somewhere before that line, you have a typing mistake. It could be 2 lines before that you forgot to close a quote or close a parentheses.
Exactly.
So where you see the squiggly means somewhere there or somewhere before that, you've got a syntax.
Yeah, that's basically, because Visual Studio and Python in turn are relatively forgiving. They're going to try and work with you. It's just finally reached a point where it finally just threw up its hand and said, I have no idea what you're trying to do here.
Yeah, when I got to here, I got confused. So somewhere back there, somewhere before this, there was a mistake. Sometimes the squiggle's right where the mistake is, but it does at least it's before that line.
Yep.
Yeah, which is helpful.
Getting a lot of Q&A of people saying, yeah, I've been doing this for 30 years and, still got lots of errors.
You know what? I said, you are not I don't think you're really a coder until you've made lots of errors. And the more mistakes you make, the better you're going to get at finding mistakes.
Yep.
And that's why I'm really good at finding mistakes in my code. Now, sometimes there'll be typing mistakes you make that aren't actually detected. You don't see a red squiggly. If you type in print hello world, which is incorrect because I would have to the IN there. So if that IN, I accidentally mistyped. But there's no red squiggly that appears if you type that into Visual Studio.
Exactly.
Instead, what happens is when you run the program, Visual Studio goes off and tries to execute this Python code. And the interpreter goes and says, I can't find a function called print.
Yep.
And at that point, it then throws an error and says, excuse me, there is no function with the name print that I have in this code. We
actually saw this in the last module, that when I had defined the function down below and then put the code up top, that when I went ahead to try and run it, Visual Studio didn't give me any red squigglies. In fact, Visual Studio was even nice enough to give me a bit of IntelliSense. And then when I ran it, that's when it said, oh, wait a minute, you've got a problem here.
That's right. So these types of errors, you'll get error messages at runtime. Again, this doesn't mean you're a bad coder. It just means welcome to programming.
Exactly.
Look at the error message. It does often give you a really good hint. And actually, one of the cool things about Visual Studio and Python is it actually gives you an arrow showing you the line of code which actually generated the error message to try and give you a hint. And again, that means the error message is there or before.
Yep.
Not necessarily exactly where it's pointing, but there before is where the error occurred.
Exactly.
As I said, but do check the error message. Sometimes there are options to literally links right there to search for help on that error message. If you're really stuck, go to Bing, type in the exact error message, name print is not defined, copy that into Bing, and type in the word Python so it knows it's a Python error message that you got.
Yep.
And you may well find somebody who's post Stack Overflow, I'm getting this error message. Why am I getting this error message? And some awesome developer out there has come and said, well, you're getting that because, and boom, you've just solved your problem.
That's it.
Yeah. So the other thing you'll run into is logic errors. These are the nasty ones, I will be honest, because the problem is the code runs just fine. You don't get any error messages, but for some reason, you're not actually getting the output you expected.
My forehead is a little flatter because of those. Just thud, thud,
These
thud.
are the toughest ones to find because sometimes you don't even know they're there. We looked at a couple of examples of these yesterday. We talked about the if you have a salary of 5,000 and a bonus of 500, and we calculate your paycheck, and we get back a result of 5,500,000. Because
I like that paycheck. I'm just saying.
And the problem was because we put quotes around our numbers, they were treated as strings. So the plus symbol, when you use a plus symbol to take this string plus this string, it concatenates the two strings together. If you take a number plus a number, it adds the numbers together. So we end up with a total of 5,500,000.
Again, if somebody who's writing the HR app for whatever company it is that I'm working for at any given time wants to make a mistake like that and give me $5 million all of a sudden,
You're in?
I am all for it. Sold.
We also talked another example yesterday. We were seeing the challenges of an if statement.
Yeah.
I want to write code that says if somebody is a gold card member and they're from the US or Canada, I want to give them free benefits. And then you write the code and you say, if status equals gold card and country equals US or country equals Canada, give free benefits. And then you suddenly go, wait a second, I've got somebody here from Canada. Why is everybody from Canada getting free benefits? That shouldn't be happening. And then you realize it's because the and was executed before the or. So everybody who was from the US that has a gold card gets the benefits. The US people who don't have a gold card didn't get the benefits because they weren't US and gold card. But then it said, or from Canada. So everybody from Canada got the free benefits. You're like, no, 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 no. I want only the people who are gold card and are from US or Canada. So just because I missed a set of parentheses in my combine and or statement, again, runtime error. Suddenly I accidentally gave free benefits to every single Canadian. Oh, I like that mistake.
Yeah, there you go.
If you don't mind making that mistake for any hotel chain or airline I fly with,
should we just start requesting
that would be
mistakes
great.
we'd like people to make?
Yes, I think this is a good plan. Yes, I like that. So it's important that we have a way of handling errors. So the logic errors, they're going to happen. How are you going to find those? Testing.
Yes.
You have to go through, test your code. The fact that it runs without an error doesn't mean it's working. So you have to test your code. You have to try different inputs. Make sure what comes out is what you expect based on what you enter. With ands and ors, try different combinations. Greater than, less than. Try smaller values, larger values, equal to. Try to break it, hack it. It's really important to test.
Yes.
Now, the other thing that happens is you may have written your code absolutely correctly. And yet, and it's run and you've tested it a half dozen times and everything works. You've got this wonderful code that opens a file, reads all the contents of the file, displays it correctly, and then one day it crashes. Your user goes, the code doesn't work. And that's the day you go, oh wait, someone deleted the file. That's a different type of situation. Now you've got a runtime error that is only occurring occasionally when there's a specific situation. You've written your code correctly. You write a calculator program and a user tries to do division and enters 0. So your code is now trying to divide by 0. Well, you know what? Calculators generally don't like dividing by 0. Your program tries to read a file, and the file's not there one day. Your program's trying to perform a date calculation, and a user enters the wrong format or says 30th of February, or asks for the 15th month because they weren't paying attention to the date format. So when you have the code just crash and spew error messages all over the screen, that's a very poor experience for the person using it. And even if you're writing functions that you're going to use, it's really nice if a function handles errors in a graceful way as well. So what we're going to look at in this module is how can we add code to trap errors gracefully so they don't just crash, but we can control what happens if something predictable as an error occurs. Because there are some scenarios where we just know they're going to be trouble. Things like reading from a file. That's the kind of thing where I can almost predict one day the file won't be there.
Yeah, absolutely. Yeah. Or you don't have permissions, or it's corrupt, or
Opening a file, that's one of those ones, you know what, always add error handling.
Yeah, exactly.
Standard.
Yeah, and really actually to take that one step further, basically the moment that you leave your application and try to contact something else, always add error handling. So, to get a little bit more advanced, if you were going to try to call a web service, if you were going to try and connect to a database, anytime that you're leaving...
Anytime you're talking to the outside world.
Exactly, yeah. If you're going to open up the front door and go outside, make sure that you've got error handling.
Yeah, because you're depending on someone else now.
Yeah, exactly.
And I'd love to say we can trust others, but you can't always rely on everybody else. So anytime you're calling someone else's code or someone else's database or someone else's file, you want error handling because one day they may not be there for you. So what I've got here on the screen, this is a very simple program. I wanted to have a nice, easy example we could all follow to start with. I've written a calculator program, and a user enters 2 numbers. This is a very rudimentary calculator. It can only divide. So, so maybe it's a divider program.
It's a divider calculator.
Yeah. So the users enter 2 numbers. So we have just our basic, they input the first number, they input the second number. I convert those to numeric values because input returns what data type, Christopher?
Wait, I know this. String.
String, correct. So I have to convert them to numeric data types so that I can do math with them. Then I calculate a result, which is the first number divided by the second number. If I execute this code, it's going to work. Unless, right? I test it, it works. 6 divided by 2, 3.0, everything's looking great. Until, you know, we start messing with it. So let's get this up and running because then we can actually mess around with it and see what it does. I'm going to need a new project. All right, let's create module 14. We are on 14, error handling. Trying to use good names so that if those of you who are looking for the examples later. So we're going to have first number equals input, enter a number. And I'm just going to be trying a little lazy here. Control-C, Control-V. And that's going to be second number. Input, enter another number. And then I am going to, I'm actually going to change my code a little bit. Again, I'm trying to be super efficient here. I'm being lazy. I'm going to convert them to float when I get them back right away. So I am taking the number that is returned as a string and immediately converting it into a number.
Okay.
So then I can take a result equals first number divided by the second number. Just because I want to get to the error handling. You guys have seen this stuff before. Hopefully this all looks familiar now. And then I'm just going to print the result on the screen. Really simple.
Okay.
Okay, I run my code. Phew, I got it right. Okay, no typos. Phew. I type in 5. I divide by 2, and it comes back with 2.5. So I go, yay, I've done my code. I hand it into my boss, and I walk away. And I tell them to go give it to the users, and one day a user comes along and types in a value of 10 and tries to divide by 0 and crash.
Sound effects and all.
Yes, the user won't have Visual Studio. They're not going to see a little box pop up with code saying 0 division error occurred or anything like this. They're probably just going to see error messages all over the screen.
Yep.
But now the nice thing about us as coders is we do have Visual Studio. And what I love is, again, if we zoom in a little bit here, you can actually see the line of code. There's a line showing me which line of code caused the error. And I can see the exact error message that occurred, 0 division error. That's really useful. We're going to take a little note of that. That's useful information. And there's a description of the error. There was a float division by 0, which is actually a really good description because I had a floating number and I tried to divide it by 0, and that's causing the error. So do take a look at that information because that is really useful when you're trying to write your error handling. You're going to want to know that information. Okay, so I have a calculator program. I now have an error that's running.
Yep.
So there's our scenario. We have our division by 0.
Yep.
So which line of code generated the error message? Christopher?
1, 2, 3, 4, 5. Well, in this screen, error 5, line 5.
That's right. And in this case here, it's the line where I'm actually doing the division that's caused the actual error. It's important to know which line of code generated the error because that's going to determine where you're adding the error handling code. You could just put error handling code and say, if an error occurs anywhere in the program, do the following. But in this case, you might get different errors at different places. So it's actually better to say, hey, if this line of code gets an error, it might be divide by 0. If I have a line of code that opens a file, well, I'm expecting errors because it tried to open the file. So I might want to handle different types of errors differently, depending where they occur and what types of errors they are. So it's generally better to try and put the error handling around the chunk of code you think could cause a problem.
Yep.
So what we're going to do is we're going to add something called a try except.
Actually, you know, it was funny. I was hoping to time it perfectly, and I missed by that much. Somebody had actually posted it into the chat window maybe about a minute and a half ago, saying, "Hey, is there a try catch like C#?" So there you have it.
For those of you who have used C# and used try catch, we have try except in Python. The only thing is, if you use C#, you're going to keep typing catch instead of except by accident.
Exactly.
The syntax is you use the word try, and your colon, and you hopefully by now you're starting to get used to the indenting. So the code that might cause the error, you put inside the try. So here's the code, which I think may generate the error. And what I do is I write an except. So I say, try running this code. And the reason it's called except is because we often call errors exceptions.
Yep.
So if an exception occurs, then I want to go do this instead.
The way that I always like to analogize this is it would be like if I turned to Susan and I said, "Hey Susan, can you do me a favor? Can you run down to the store and get me a
coffee?
bag of chips? Yeah, get me a coffee. Yeah, go down and get me a coffee." And so I want to make sure that she also understands what to do if something goes wrong. But what I don't want to do is I don't want to say, "Okay, Susan, go get into your car." And then if something goes wrong with getting into the car, I want you to do this. All right, now I want you to start the car and I want you to drive down. And if while driving something, because just like it would be annoying for somebody to explain all of that to you, it's annoying trying to program. So what I really just want to do is I just want to say, "Hey Susan, go down to Starbucks, get me a coffee, hopefully a dark raw roast."
Yep.
Then, if something goes wrong, get me an iced tea instead. So you'll notice that what I did is I just gave her everything of, hey, this is what I want you to do, assuming success. And then if something goes wrong, do something else. Basically let me know. And so if we take another look at the code, that's exactly the way the code is written. Is you'll notice
try to do this.
Yeah, try to do this. No error handling inside the try block. We're just assuming success. And if something goes wrong,
then we're going to say, so we're saying if an error occurs anywhere in this code, it will jump to the except and execute the whole code here. So the only time you're going to see that message, print, I am sorry, something went wrong, is if an error occurs in the code you have in your try. So let me go add that to my code. So let's try that here and see it in action. And I'll actually, so we're going to say try to calculate a result. And assuming everything goes well, after we get a result, I want to print it. So I'm going to leave that print in there as well, in this case. And then I'm going to say, now, in the event there is an exception, I'm just going to print, I am sorry, something went.
And then as Susan is typing all this out, I just want to mention real quick, somebody asked in the chat window about the possibility of throwing your own exception.
You can absolutely do that.
Yeah, and you can do that. Yeah, there's a raise function that you can go ahead and call to raise a brand new exception. And that's something you might decide to throw into your functions and so forth. For right now, we're just kind of focused in on error handling. But just to answer the question, quite simply, yes, you can. It's the raise function.
Yeah, and you would use a raise function. For those of you who are sort of going, why would I want to make my own errors?
Yeah.
It would be when you have business rules.
Yeah.
So if you have certain business rules that if somebody's trying to deposit money to a bank account and they try to deposit minus $1,000.
Yep, that's a problem.
Then you say, wait a second, if I'm depositing minus $1,000, is that or even better, I'm withdrawing minus $1,000, but I'm giving myself $1,000?
Hey, I like that.
Neat trick. Again, errors I'd like to write into your code. So that's something where you might have a business rule that says when somebody tries to deposit money, it must be the value must be greater than 0. And if a value is greater than 0 or not greater than 0, you might actually want to throw your own error to say, yo, hey, somebody's trying to deposit a negative amount. This doesn't make sense.
Yep.
So you use the raise command to raise your own errors.
Yep. And somebody else asked, is there a methodology on what to do with an exception? And a lot of times when somebody says exception handling, they make it sound very grandiose, that you could detect what the problem is and magically fix it. And yeah,
if the file's not there, the file's not there.
Exactly. And sometimes maybe you could execute some code and pull from a database and recreate it or something like that. But those times are so extremely rare that really all that you're typically doing is you're just simply going to write out to a file maybe, print a friendly message to the user, and that's really it. Now, exactly when to catch errors and so forth, that's a much bigger conversation. But to kind of simplify it, go with the core part of it. Typically, when you catch an exception, what you're going to be doing is just exiting gracefully and maybe logging it out to a file.
Yeah, giving a nice error message so people have an idea that it's not them.
Exactly.
If you can tell someone,
it's not you, it's me.
It's not you, it's me. Yeah. The one situation where sometimes you can fix it is if a user entered something in the wrong format.
Right. Yeah.
Sometimes you have the ability to say, hey, you need to give me the date as day, month, year.
Yep.
Please enter that again, and then you go back to the code. You might have a loop or something or a function that you call to say, prompt them again for that date value. So that's the one scenario that's the most correctable in your code. So if your problem is a user entered something wrong, you could write code that says, go let them try again, to try and enter it again. That's probably the one most correctable error handling scenario. But most of the time, you're just going to exit and say, sorry, I can't do this because this happened.
Yep, exactly.
Yep. All right, so what I have in this code, what we have, just zoom in a little bit there, is so we've accepted two numbers. We try and do our division. So we're trying to do our division. We assume everything goes well. If something does go wrong, if there's an exception, another word for error, then I'm going to print a message saying, sorry, something went wrong. And if I run the code and I enter 10 divided by 2, well, everything goes great.
Yay!
Yahoo! And if, on the other hand, I try 10 divided by 0, I hit the any key a little too quick there. Sorry about that. 0. And you can see the error message comes back and says, hey, I'm sorry, something went wrong. So it's actually kind of neat. If we put a debugger on here, and I run this again, so we ask somebody to enter the first number, right? And then the second, so I enter the number 10. And then it says, then I'm about to execute the line and get the second number. So I execute that line of code, and I'm prompted to enter the second number. I enter 0. And now you can see it's ready to go into the try statement. So it tries to calculate the result. And when I hit the step into, it's not going to go to the print statement.
No, and this is very important.
Yeah, it's not going to the print statement because there's an error. It immediately jumps to the accept and prints out the error message. So when an error occurs inside your try, whatever line generates the error, it will immediately jump to the accept statement. It will not continue executing the code inside the try. All right. Now, the other thing is also important to recognize is the code inside the accept will only execute if there's an error. If there's no error, the code that you put in the accept never runs.
Yeah, that if you remember back to when Susan ran that a couple seconds ago when she did 10 and I think 2, it just simply printed out 5.0, exactly what we were expecting. And it didn't print out, sorry, something went wrong because, well...
Nothing went wrong.
Exactly.
Exactly. So
simple logic.
Now, one of the things, though, is sometimes you might know something could go wrong, but you're not exactly sure what the error message is that's going wrong. So you might just want to say, tell the user something went wrong, but something a little more useful than, hey, something went wrong. And then the user's calling up support and going, what's the problem? I was running the code, and I got a message saying, I'm sorry, something went wrong. You do that, and your support team is going to laugh hysterically. Because the fact is, if you are the coder, the support team is usually people who fix code. And if you go to me and say, hey, Susan, I got a message that says something went wrong, how do I know what went wrong? Which program was running? What type of error message was it? Give me a hint as to what went wrong so I can try and fix it. So one of the neat things you can do is there is a variable, actually it's part of a module called sys, and it has a function called exc_info. Not very intuitive, but really useful. And if you ask for, this will contain the complete error message. And the complete error message is actually a massive list with all kinds of details about where the error occurred, all kinds of stuff. That you might actually take that information in a big program and write it to a file. So the support team could look at it later to get the full information. But you wouldn't want to show all of that to a user if they would just sort of be overwhelmed by it. So usually we just take the first part of that list, the first value in that list is the message, which is divide by 0 error or could not locate file. Something that a user might actually understand or might have meaning if they call support and say, hey, I got a message saying divide by 0 error or could not locate file. That's something the support team may actually be able to act on and be able to fix. Or the coder can actually do something with that and hopefully try and fix it or find out, oh, wait, we forgot to copy the file over. So what I'm going to do now is I'm just going to go back to my code, and instead of displaying a really generic message, which isn't that helpful, I'm sorry, something went wrong, I'm going to actually declare a variable called error, which returns system.out. And I just realized I'm going to need to import the sys module before I can do this, because I am accessing functionality of the sys module.
And while you're doing that real quick, somebody had asked, could you simply test to see if it was 0, and if it was, then prompt the user for a different number?
And that would be even better.
Yeah, and you absolutely could, and that would be, a concept called validation. But divide by 0 is just such a great little example to do with the demo. So that's kind of why we're going that direction.
But you know what? So. But you make a really good point. If you can stop the error from happening in the first place, that's even better.
Yep, absolutely.
Sometimes we'll write code that will look for a file before we try and read it. So we can actually say, I just looked for the file, it's not there. And we come back and say that file could not be located.
Yep. And then one other question that was in there, which is worth highlighting, is somebody asked about finally.
Oh, yep.
And there is a finally as well. And finally, just kind of real quickly, this is a block of code that will always run. So if maybe you needed to close off the connection to the database, you need to do that if everything went correctly or if things failed. So you could do that inside of a finally as well.
Yeah. Yep. Maybe I'll try adding it in a finally a little later, just so you can sort of see how that works. And I'll run the code and you can see how it executes. So hopefully I got the syntax right. I'm just going to double check the syntax of exc_info bracket. Yes, I think I got it right. And then I'm going to say, then I can just print the error message to the screen itself. So what I'm doing now is I'm just asking if an error does occur, then I'm just asking the system to tell me what the error message was. And now I can tell the user that message. So now when I enter 10 and I enter 0, I can actually see there's a class 0 division error. Except the user, this isn't going to be that meaningful for them, but if they're calling support and saying, hey, I had this problem, that's going to help the support team figure out why they're getting this error message in the code and hopefully fix the problem so the user can get their job done.
Yep.
And that's actually really important. And yeah, just to talk about the finally, because somebody was asking about it, because in C# we have this concept as well. Finally, print, I always like to do this, I will always run. So you can actually have a line of code that always executes, or multiple lines of code that always execute. So I'm going to go back to putting in I'm going to put the debugger in again.
Okay.
And when I specify a value of 10 and a value of 2, you can see I'm in the try statement. I go to calculate the result. You can see by the yellow arrow the next line is going to execute. Then I go print the result because everything's going fine. And then watch how the yellow arrow is going to jump down to the finally. So over here, hang on, what's the shortcut key for that? That is F11. All right, so I can zoom in a little over here. All right, so I'm going to zoom in a little. And when I hit the F11 key, it jumps right away to the finally.
Yep.
So so if everything goes well and there's no error messages, then we go and we do the code in the try, then we execute the code in the finally.
Yep.
And the message is displayed on the screen. I get my result. I get the 5.0 and the message I will always run.
Exactly.
And if I have an error, so let's try exactly the same thing, but this time I'm going to enter 10 and 0, so I get a mistake.
Yep.
And once again, I am going to go to my code here. I'm going to zoom in a little. So I'm at the line with the yellow arrow is the next line that's going to be executed. It tries to calculate a result. Because it's an error, it's going to jump right away to the accept.
Yep.
It executes the logic in the accept, and then it goes to the finally.
Yep, so the finally always runs, which is a big difference between doing that and just simply putting the call at the end of the try block. Because remember that the moment that the exception is thrown, it stops going down in the try block. That one of my early C# trainers taught me this, is that you're basically going this way in code rather than this way. That you're now going up in code, that it's just bombing out of that try block, and then it's just going to go straight for the accept block here.
Yes, so that's particularly important. As you pointed out, Christopher, the things like if you connect to a database, you need to close your database connection, or if you're opening a file and you need to close the file, regardless of you have an error processing the data in the file, you always want to close the file. So something like a closed file might go in a finally, or a closed database connection.
Exactly.
Those are most common scenarios you would encounter.
Exactly.
Yeah. Other than that, for divide by 0, I probably wouldn't bother.
Exactly.
Bothering with finalies anyway. So sys.exe info, useful way of accessing error messages, and we just saw the finally clause.
Exactly.
Now, if you know exactly which error is going to occur, it is possible to say, if that error happens, here's what I want to do. And that can be useful. So you can say, if I can't find the file, tell the user I couldn't find the file. If something else weird happens, like maybe permission problems or something, then I'm going to display a different error message.
Yep.
So the way you do that is after the word except, you actually specify the name of the error. Now, how on earth do I know what the name of the error is always the big question.
That's a very good question.
Well, you remember on the previous slide, I showed you sys.exe_info?
Yep.
Guess what that returns? The name of the error. So I actually will often use sys.exe_info as a programmer to find out the error. I don't often display it to the user. It's a trick I use to find out the error. And then I know the name of the error to trap.
Yep.
So that I can say, if that error occurs, this is the message I want to display. I'm going to tell them, hey, you're trying to divide by 0? The answer is infinity.
Yep. And beyond.
And beyond, exactly. So what I can do now is I can say except 0 division error. I'm just going to double check on that. 0 division error. Yep, got that right. And then instead of doing this sort of generic error message, I'm going to display a whoops, didn't mean to do that. I'm going to print a message that says the answer is infinity. And think of how nice that is as a user experience. It's not appearing as an error at all. I'm saying,
Right.
yeah, you want to divide by 0? I'll tell you the answer to dividing by 0. You try dividing 10 by 0. Whoops, I've still got the breakpoint. Get rid of that. We don't need to step through this code. Try this again. From beginning. 10 divided by 0? Sure. The answer is infinity.
Yep.
On the other hand, if you ask me, what is 10 divided by 2? Well, it's 5. So this makes it to the user, but it doesn't even appear as an error. And that's a really nice way to do things, if the user doesn't even see it that way. What you may want to do is, what I recommend when I'm doing error handling, is I try to handle as many specific errors as I think, the types of errors, I can predict certain errors. I might try to open a file and the file's not there. I try to do a division, I might end up dividing by 0. So if there's errors I can predict, I like to specify what to do for those specific errors.
Absolutely.
But there are errors I might never think of. So but I also include a generic except, and this basically will execute if any, so when my code is running, it will try and calculate the result. If it gets a divide by 0 error, it's going to jump to except 0 division error.
Yep.
And it will execute this code and exit.
Yep.
If it gets some other number, like some sort of data conversion error, or the number's too large to store inside a float variable or something like that, it's going to say, oh, I've got an exception. Jump to the except. Is it a 0 division error? No. Is it something else? Yes.
Yeah.
And it will go in order. So it'll check, it'll go, is it this error? Okay, then I'm going to do this. Is it this error? No, I'll do this. Is it this error? No, I'll do this. And then you have the, if it's anything else, here's what I want you to do.
Yeah. And, one other thing to kind of highlight, Susan mentioned, focusing in on the errors that you're expecting. And it is also worth thinking about if you are expecting something might go wrong, maybe test for it. We talked earlier about, 0, and just check for it rather than doing the exception handling. The other thing that I would mention is, again, going back to the module that we had prior to this about doing functions, is that a lot of this or all of this could wind up inside of a function. So rather than having all of that code right there, instead we could just put together a function that does that behavior and just gives me the answer back. Yeah.
Yep, exactly. It's a nice way of doing it.
Yeah.
So we've shown how to trap errors. We showed you the finally clause.
Yep.
The other thing that's good to be aware of is if you do put code after your try except as well, that code would also execute all the time.
Yep.
So if you have code that's not indented, right, because only the indented code is part of your except error handling, well, what's going to happen if I run this code is it's going to try to do this code. If everything goes well, it'll chug along, and then it's going to jump to the first line of code after my try statement. So it's almost the same as putting it in a finally.
Right.
There's really not a lot to choose between making a finally statement that does that and just putting it after your full try except. Except some people like the format of the finally.
Yeah, some people like the format, and the other big thing is, somebody asked earlier about raise. So, and I'm going to say this, and I'm going to try very hard not to get too advanced.
Actually, I'm going to, you know what? Give me 2 seconds, because I'm actually going to show, I'm going to kick someone out in a second of the code. So I'm going to show how do I not execute this line of code. Will that lead in?
Sure. Go for it.
Because I think I know where you're going. So let me show one more thing, and then I think I'll let you run with that.
Go for it.
Okay. So it said, so in this situation, with this code I have on the screen right now, you could put that print statement in a finally, or the way I have it on the screen, and it really isn't going to make a difference with
Right.
the code I have on the screen. Would you agree with that one, Christopher? For the code I
way
have
that it's
here.
right now, yeah.
Yeah, it really wouldn't matter for this exact code. It would not matter if I used a finally statement or I put the print message here. I'm always going to see the print message. This message
Right.
always displays. Now, sometimes though, when we're executing code, we do want to actually say, oh, wait, if that error occurs, don't keep going. Stop. So there is a function sys.exit, which you can use to say, get out. Or you can also, some people ask about raising exceptions. If you raise an exception, that'll also cause it to go, get out.
And that was actually the point that I was about to make,
Yeah.
was about raising the exception.
Yes. So if you either call sysexit, that's just a way of saying exit now. Or if you raise your own exception, which hasn't been handled, because if you raise an exception inside your except block, you haven't written code to handle the exception in the except block.
Right.
So that causes the code to go, I'm getting out. In that situation, this code, if you get the zero division error, when it hits sysexit, it exits, and this line of code will never execute. Now, what if I had a finally, Christopher?
Finally is guaranteed to run.
Exactly. So that's what the difference is between finally and having this line of code.
Yeah, and actually a lot of people have asked that. So it's good to highlight that the finally is guaranteed to run. And it's perfect, you know, and again, we've been keeping our demonstration simple because we're trying to focus in on the syntax, but if you needed to close a file or close a connection, that's where finally comes into play.
Yeah, even if you use something like sys.exit, the finally will always run.
That's it.
So that's the difference between this syntax we have on the slide versus putting that print statement into a finally. The other thing you could do, this is just, I want to show an alternative way of handling an error or sort of exiting, not executing certain code if an error had been raised.
Yep.
The other thing we'll sometimes do is we'll create a Boolean variable and we'll say, try running this code. And if an error occurs, we set a Boolean variable to true.
Yep.
And if it doesn't occur, we set everything went well, then we set the flag to false.
Yep.
And then after we've done all our code, we say, well, if the error flag is true, then
Exactly.
you know, continue executing.
Yeah.
So I mean, you can just write logic that basically says, if an error occurred, do this. If an error didn't occur, do this. And I'm just using a
Sure.
Boolean variable, setting it to true or false based on whether or not the error occurred. So this is just creative coding.
Yep.
Lots of different ways to tackle problems. If you look online, you'll find lots of other examples of different ways to handle exiting code as well. If you actually look at the code here, though, there's other code here that could cause an error. We have code here. We've been handling the error that can occur when you divide by 0. But Christopher, can you see anything else in this code that might actually crash at runtime?
Oh, yeah, if somebody entered in Bob, a few people had pointed that out. Yeah.
Yeah.
Or Wibble. I
Yes,
just like Wibble.
exactly. If somebody enters, when I ask somebody to enter a number and then I convert it to a float, if they entered letters or something that's not a valid number, then when I try and convert that to a float, which is a number that has decimal places, that code would crash too. So you might need to try except around first and second number. And I actually might do this separately. I might have one try except around the data conversion
Yep.
that handles the, hey, you entered non-numbers. And
Yep.
then if they do that, I say, well, try again. Whereas the divide by 0, I would handle differently. So you might end up with 2 try excepts in the same code.
And not only that, but you know, forgive me for kind of beating on this horse a little bit more, but you know, again, you could put that into a function. So I could create a function that says get number, and inside of that I've got that try catch, and I'm just going to keep looping until you give me a number. Once you finally give me a number, then I'll go ahead and I'll pass that back. So rather than having that try catch twice, we just put that off into a function and then
Nice.
call that function. Yeah.
It'd be a lot tidier, a lot easier to read. Because
Exactly.
when you start having multiple try catches in your code, it can get kind of clunky. So you're looking at functions initially going, I don't know if I'm ever going to bother with functions.
Yep.
This is the kind of thing where when you get used to it, you're going to discover it's going to be a lot tidier
Yeah.
and easier to follow.
We need to remember to say try except rather than try catch.
Oh, yeah, I'm sorry,
a
we've
couple
been
of,
saying it.
Yeah.
Our apologies. Yes, we both have spent more time coding C# than Python. So,
Exactly,
So
yeah.
there's some habits. By the way, the further you get into coding, the more languages you will find yourself learning and the more you will mix them all up.
Yep.
You don't make less typing mistakes the more you code. You make more because you start using the wrong syntax.
Look at the number of colons that we've missed on
Yes.
if statements and other blocks.
Exactly. All right. So as I said, we've got a lot of different situations that might raise errors in our code. You might be converting one data type to another. You might be opening a file, doing a mathematical calculation, trying to access a value in a list if it doesn't exist. All of these sort of things could raise errors in your code. How are you going to have any idea what errors are going to be raised? This is always a challenge. When I was coding, this is something I always sort of got stumped on. Number one, you can test it yourself. And when you get an error, use that sys.exe info function to get the name of the error. There is also, though, and there's a nice link here, a list of fairly standard Python errors. So this is a list of about 20 errors that you may want to catch, and it explains when they're raised. So that's something that's worth taking a look at after you're writing code to go say, oh, that actually could happen in my code. I should probably handle that error. So there is a fairly standard list you can use. The most important thing to do, though, is you have to test. That is really your best thing. First of all, so you get your code done, your first goal, your first test is just see if everything works normally. Don't start by testing error handling. Just see if your code basically works. We actually have an expression for this. We call it the happy path. Make sure the happy path works, right? Because it makes you happy. You're like, yay, my code works, before you deal with all the error handlings and the weird what-if scenarios. Start with, can you just basically get the code to work? Does 10 divided by 2 work? Yes. Okay, now that I've got that working, now let me try maybe entering incorrect values. That's a really common thing, because that's what's the likely scenario? User types in the wrong thing. So try typing in letters instead of numbers. Try 0. 0 does weird things.
And try the fringe cases. And this goes back to something that Susan really highlighted yesterday is, you know, if you're doing a less than 1,000, test 1,000. You know, go in and test the fringe cases.
Yeah, exactly. Enter a value in the wrong format. Enter spaces. So try some things.
Try to break it.
Yeah, well, but not too hard. Try to enter things that you think a user might do. They might forget to enter a value at all and just hit the enter key. See what happens. So try sort of typical things you think a user might do. That's the second thing to test. Once you're handling that, then start going into what else could go wrong. Start using your brain. Go, what if the file wasn't there? So then you try things like, what if the file's missing? And then you get into, now just try anything you could think of that might break it. If you've got the time, try negative numbers. Try entering 999999999.9999999 and just see what happens. So that's if you've got time. A lot of times, I'll be honest, we don't always get to that level of testing.
And you know, not only that, I'd be remiss if I didn't at least mention it. And again, this is an advanced topic, but there is a concept called test-driven development, where you actually write the tests before you write the code. And one nice thing about that is when you start getting into that, you can automate a lot of that. Remember, Python, one of the biggest reasons that people use Python is for automation. Well, you could automate a lot of that. Or just start feeding in random numbers and things like that to test it and go about it that way. So just, you know, just to mention it, put it out there, test-driven development and Python. So I'm done.
Yep, absolutely. Which is basically the concept is you have you write a program that calls your program and passes it the values you would use to test it.
Exactly.
That's what it is really when it comes down to it. It's a program that calls a program. With the values you would use for testing. So that when you need to rerun, you make a change, you want to retest it, you want to make a change, you want to retest it, and you want to make a change and retest it. You just call a program that calls your program with the right test values. That's the idea of automated testing. And when you get to more complicated code, that can be really powerful. All right, now the next question. Do you need to handle every single possible error that could ever occur anywhere in your code?
Absolutely.
No. What I would suggest is be practical about it. You can also write that generic error handler. The one that says if something else happens, try except. Then you can say if an except happens but I didn't think of, here's how I want to handle it. I'll be honest with you, once you get further into code and you write more complicated, you will discover that the time it takes you to write the error handling for your code may be longer than the time it takes you to write the code. We often talk about 80-20 rules in a lot of scenarios. There are times when writing the code that works for that happy path takes 20% of the time, and writing all the error handling code for every possible error handle situation of user enters the wrong format, user enters a 0, user enters a negative number. You know, takes 80% of the time. The way that I always approach it, you know, what errors should I handle, is it's the ones that are important, that you know absolutely have that generic. And if you're going to do something different because of the fact that the file wasn't there, or because of the fact that somebody gave you the number 0,
then go ahead and focus on those parts. But if you're not going to do anything different, so if you give me a 0 and I'm just going to print a basic message, sorry, something went wrong. And if I can't find the file and I'm just going to print out a basic message, sorry, something went wrong. And if you gave me a bad string and I'm just going to, there's no reason in the world to keep writing all those different error handlers. Just put together that one generic one and be done with it. So there is no need to write special error handlers for every possible error.
No, you don't have to handle everyone specifically.
Yeah.
So it is okay to be a little generic in your error handling. In fact, I used to have a function that I called when an error occurred to look at the error that occurred, and based on that would display the appropriate message. So I had a function called error handler that accepted sys.exe_info as a parameter, looked at the value and said, oh, if it's that error, do this, if it's that error, do this, that error, do this, and I just called the function.
Yep, there you go.
Now, how much error handling you also do does also depend on how the code's going to be used. If you are writing a system that's going to do air traffic control, I really, really, really hope you've got excellent error handling and you're handling everything, because I'm on an airplane on Saturday. If you're writing a fun little app that's going to tweet you when your plant needs water, I'll be honest, I'm not going to do a whole lot of error handling in that code, because, oh, what's the worst case scenario? Oh, the tweet doesn't go and my plant, worst case scenario, my plant dies. Little different worst case scenario if my air traffic control system crashes.
Yeah, exactly.
So got to be a little, so there is a bit of return on investment there. How much time to spend on it? How much does it, what will actually be the worst case scenario if your code crashes?
Exactly.
That should drive your decisions.
Yeah.
So your challenge for error handling.
Should you choose to accept it?
Write some code that will open a file and read the contents. Allow the user to specify the file name. Which means there's a possibility that they'll type in a file name you can't locate, so you're going to need to write error handling to gracefully handle the possibility of a user entering a file name that you can't locate.
Exactly.
So now you guys can gracefully handle errors so your code doesn't crash.
Exactly.
Now what's freaking me out here, Christopher, is this is actually our last official module, but we do have a couple of things to talk about.
Yeah, we do have a couple of things to talk about. I actually, you know, since I keep beating on that functions drum, I do want to hit that one last time. So I'm going to go back and close off one little thing. We saw a few questions about this, and since we talked an awful lot about methods or functions, it'd be worthwhile mentioning, because one thing, just to be explicit about it, is inside of an accept statement, could you take the error and just pass it over to a function? Absolutely, 100%.
So in my error handling, I could call a function and pass it the error message I got.
Exactly.
Okay, yep.
Yeah, absolutely, 100%. And that would be kind of very nice to be able to centralize. So if we come back to the code that I was doing earlier, you know, let's say that things like get names and print names, I want to be able to use that in a lot of different places. Well, what I could do is I could just take those. So all I'm doing is I'm taking code that we saw in the last module. Control-X cut.
You took it out. How am I going to be able to call it?
That's a good question. I'm glad you asked that. So what I'm going to do is I'm going to go back to Solution Explorer, a real quick right click, and I'm going to say add, right there in front of me, new item.
Okay.
I'm going to say empty Python file, and I'm going to call this helpers. That one thing that I love to do is create just a bunch of helper functions. So I just
like
call them
my great formatter, date formatter that I love.
Exactly, yeah.
Okay.
So I just simply copied and pasted that code. So it's the exact same code. Now I want to be able to call that.
Yeah, because I still want to use those functions from the other program.
And the way that we're going to do that is just by simply saying import helpers. There we go.
That just makes too much sense, because we've already been using import and sys and all those great things.
We absolutely have been. Now let's go in and hit start, and you're going to notice it's going to fail on me. It's going to say get names is not defined.
Okay.
Because yes, I imported in helpers, but I still have to go one step further.
Okay.
I have to tell it that get names
is
inside of helpers.
Because, I mean, it can't go searching everything everywhere, so you have to give it a hint as to where helpers is.
Exactly. Yep.
Yeah. We saw that. Well, we did that with sys.exe_info.
Yep.
When we were using the datetime functions and we imported datetime, we were doing datetime dot. So we've actually, that's exactly the same as when we're using the pre-provided modules.
That's exactly it.
So you can create your own modules.
You can create your own modules just like that. That's simple.
I didn't think we'd get to creating our own modules in an introduction to programming. That's awesome.
But there it is. Awesome. And you've got one last little bit.
I got one little thing I want to show you.
Yep.
I will, but I want to show you something really cool.
Yeah.
A lot of you have been asking, what do I do when this course is over? What's my next steps? You know, some of you saying, hey, is there going to be a follow-up to this course? You know, and maybe there will be. We have talked about it.
There's been a lot of requests for that.
So
it's something we'd love
we will look into it.
Yeah, you know, this is not a guarantee of anything.
No, we'll look into it.
But yeah, we've loved how popular this has been. So yeah, this has been fantastic.
Yeah, so we're definitely going to look into that. But even if that happened, it wouldn't be for a little while. Even if it did happen, it'd be in a couple of months at least.
Exactly. We have day jobs.
Meanwhile, you need to practice to get these skills down, to get more comfortable with it. I've given you little challenges at the end of each module that we have provided. Now I've got a real doozy for you.
Okay.
And I may even give you a second one. I might add it to GitHub next week.
Okay.
Sonal, thank you very much for these. An intern that I work with was kind enough to create 2 bonus challenges for you. And these are going to require you to pull everything together. They're tough.
Yep.
So the first one, and I love this one's awesome. Many adults can't understand text message abbreviations. And your challenge is to write a program that will take a text message and translate it into words that your grandparents could understand.
Yep.
So if somebody types in "so funny," LOL, ROTFL, then that would be translated to "so funny, I'm laughing out loud, rolling on the floor laughing."
Yep.
So the way this works, you're going to assume that there is a file that contains one column, which is your text message abbreviations, and one column, which is the translation. So it'll say LOL, laughing out loud, ROTFL, rolling on the floor laughing.
Yep.
You have to write a program that will let a user type in the text message, and you return back to them the translated full message. This is going to take a lot of work. There's nested loops in here, string manipulations. Now, the nice thing is, I have got you hints. So if you go to the GitHub, download the PowerPoint, you're going to see all kinds of hints in here.
Don't worry about the fact that Susan's just kind of bouncing through that slide, because now I'm going to show you where to go get that.
Yes, so you have this. So when you're ready, when you've got some time, this is how you really try and put it together. And if you get stuck, you've got the solution. Go look at the solution, come back. And the nice thing is we've broken it into steps in the slides.
Yep.
And in the code solution, it actually says this is step 1. Here's the code equivalent of step 1. Here's step 2 in the slides. Here's step 2 in the code. So we'll try to help you out, and you can follow that along. And even just learning how to read that code, you'll be amazed. If you can even understand that solution, you have learned a ton in the last 2 days.
Absolutely. Yeah, absolutely.
Yeah.
And so if you're curious as to where to go get everything from here, I've got 2 little AKA MSs on here, and we'll put both of these into the chat window. But number 1, this is the shortcut that you use to get to this course. This will be updated. A lot of people have asked, when is this going to be available on demand? Typically about 2 weeks. You'll get an email about it, but that link right there will always work. That will always get you to this course. So introprog-python. The second big one is all the codes and slides. We've thrown them onto GitHub. We've talked a fair amount about GitHub, but real quick, it's a great sharing place. A lot of open source projects use it. That's why we threw our stuff onto there. There's probably a little bit of cleanup work that we could do on some of the namings, which we'll go back and do. It's one of those things, doing live demos. Sometimes you kind of forget to be consistent there. It happens. So we'll do a little bit of cleanup, but the big thing that I want to point out on that GitHub is...
And on that GitHub, you'll see a button that says download zip file.
Yep, that's exactly what I was going to go for. Yep.
Follow that link, and you'll see a button on that page that says download zip file. You click that button, and it literally gives you a zip file containing all our demos, all the challenges, all the slide decks, everything we've covered in the last 2 days to help you out.
It's right down here. So if you take a look at my screen, right down there at the lower right-hand corner, you'll notice download zip. And so all that you would have to do is just click on that, hit open or save. I'm just going to hit open, give it a couple of moments, and then poof, there is everything that we've done.
Including, a summary of the challenges, solutions to the challenges, all kinds of great stuff.
That's absolutely it. All right.
And I think, my gosh, I think the only thing, we are done, but you're not.
Yeah, exactly. So a couple last little things.
And?
Yeah, a couple last little things. Yeah, you've got the challenges. You know where to go get all the source code. The last couple of things that I want to highlight. Number 1, find us on Twitter.
Yeah, please.
Number 2 is down towards the bottom of the screen, you're going to notice the last poll question. That's the eval. Please take, the 2 seconds to go ahead and choose an item on there. And last but not least, news. Susan, I want to thank you.
It's been a pleasure, Christopher.
This has been an absolute blast.
Thanks,
it's been
everybody.
A fantastic 2 days.
You've been
thank
an awesome
you
audience.
to everybody out there. You guys have been wonderful. It's been great doing the Q&A here, and hopefully, everything allowing, we'll see everybody back here at some point. But until then, thanks again. Fill out the poll. Find us on Twitter, and go program Python.
Have fun.
Cheers.